I also want to say, like, I'm talking about for gravity, how like gravity pulls matter toward a like central point, which is that's what a sphere is. That's what like that naturally forms a sphere. And the Earth is like also has a slight little like bulge, kind of like an oval. So it's called an oblate spheroid, but it's basically round. Every planet is like that, where it's kind of what I want to say oval. And also what I'm talking about is like lunar eclipses. When the Earth casts a shadow on the moon, it's always circular. And if like you could say that it's a disc, but then how do we have
No, we
like
don't think it's a disc.
what do you think it is? Like
Yeah, what's
Just
the disc?
we don't claim to know
He's
the
talking
shape of
about
the Earth.
that one Greek shit, I think.
Well, I've seen firsthand the Earth
Extended
in the
plane.
solar eclipse. Or was that the moon?
Right. So you,
I remember.
right, if the surface of the water isn't curving, then obviously it can't be curving Earth that's causing what you're seeing with the moon, right? And sometimes that shadow that you see on the moon, right, it should be a convex shadow, but it's concave shadow.
I actually don't know anyone in here who's a flat earther. Like, I cannot get information out of anyone who here believes in the
There's
Earth
a bunch
is
of
flat.
there's a bunch of
We all
people.
do.
Oh, you all?
Everyone in here's a flat earther.
Oh, okay. Well, can I ask a few questions then?
Of course.
Okay. How do you think hurricanes work?
High pressure systems, low pressure systems,
So,
right?
you know the difference between hurricanes between if they're above or north, not above, north of the equator or below the equator.
Yeah.
Things moving freely that are deflected to the right, but only if you're in north, and then it's the opposite for if you're in the south. That alone proves that the Earth is round. It can't do that on a flat surface.
Well, really,
And also,
like, okay, so what about this though, right? What if we actually measure the surface of water over distance and it's not curving? Then what? All right, that would debunk your hurricane theory.
no, if you put a little tiny grain of rice on a giant spear, it's gonna look flat from far away.
What, from
The only proof a
the
lot of you
grain of
guys have
rice's
that the Earth is
eyes?
flat is your eyes.
No, that's incorrect.
Yes.
Okay, so we have very, very good technology now that we can use to test for the Earth curvature that should be
And
there if
they're
the
all
Earth's a
saying that
globe.
it's curved.
No, every single test shows that there's no curvature. We can show you the tests, and then we can see your tests that you think exist that show curvature.
When you shake your head, do you hear rocks in it? Okay, so I'm guessing you've heard of the
Yes.
Pythagorean theorem.
Yeah.
Good. So
Are you
I
over
guess
13?
you understand that if you go 10
Hey,
kilometers.
kid, are you over 13 years old? You were old enough to be in here.
Yeah.
Okay, just checking.
Okay. So
Young
if you
Sheldon
go
looking out.
10 kilometers to the right, 10 kilometers to the left, and 10 kilometers back up, you realize that you'd be on a big spear, right? So a triangle on a big spear. You won't be able to do that on a flat surface.
Okay, show us who did that.
Show us what do you?
Wait, hold on one
Yeah.
second. Hold on.
So
You
what
want me to
you're
run-
saying
you want me
could
to run
work
10 kilometers?
in theory, right? But who's actually gone out and done what you're suggesting? Show us the test
Lots of
to
people.
back
Have
up
you
your
heard
claim.
of that one ship in Spain that
Name one.
went
Name
left
one.
and ended up the same way they started?
What was the name of the ship?
Let me see. Here's Ashral, that's the Greece guy.
This dude, he really said that I can't look left, right, and up on a flat plane. Is that what he said?
Yeah, something like that.
What the dude?
Neil.
You
right.
guys, I can't believe this. You guys are all flat earthers. It's like seeing an alien ship. Like,
No, there's
yeah.
hundreds of millions,
This is
hundreds of millions of flat
This is
earthers
real.
out there, dude.
yeah, that's
Yeah. I know it's
wow.
painful for you, right? But here's a
Yeah,
test in the side chat. right? Here's two tests in the side chat that
Another
are
reason why I keep
impossible on a
wanting to go
globe
to the
and
education
debunk the
system.
globe, right? So I'm giving you some tests, right? You still haven't provided any empirical
Why does
evidence at
the
all.
sun get lower?
What do
if
you
we were on
think?
a flat surface, right?
Why the okay? Do you know what perspective is?
Okay. Also, how would time
Well,
zones
that's
work?
it. Okay.
Done.
No.
Time
Like how would time zones work?
zones are a political construct. Okay, but if you're talking
But what
about
if
just
don't exist,
daytime,
bro.
nighttime, that means that's because the sun moves.
Oh my
Right, the
god.
movement of the sun creates daytime, nighttime, seasons, high pressure systems, low pressure systems, waves, wind. All of these things are caused by the sun moving.
Yeah, and also just so you know, hurricanes are not exclusive to a globe. I don't know why anybody would think that. You could have hurricanes
Oh
on a
my
flat Earth.
god. Oh my. Oh, I don't
Why
know
not?
what to say. Oh,
Yeah,
Nothing
you're gobsmacked.
wow.
claimed is exclusive
Wow.
at all.
That's.
Hey,
I have
hey,
nothing
Ray,
to
I
say.
got, I
I'm
got, I
actually
got a
speechless.
question. I got a question for you, Ray.
Yeah,
Right.
that's
So,
good.
all right. So, how does the globe spin? What causes it?
It's fucking spinning.
Yeah, the globe. You think the globe spins, right?
Yes.
What causes it to spin? Why does it spin?
The fucking sun.
You think the globe Earth spins because of the sun? How does the sun make
Yeah.
the globe spin?
The sun
How
plays a
does that
song.
work?
It's gravity.
And how does that make the globe spin?
Oh my gosh.
It's
I
a
can't
pull
believe you're like this.
not
Take a
rotate.
deep breath, Ray. You can handle this.
Yeah. So the sun is supposedly a gravitational force. It just pulls it towards its center. Doesn't make it rotate.
Yeah, so why is the globe spinning? And how did that come to be? And what keeps it spinning?
Like,
So you guys
that's
don't
an
even know
actual question.
basics.
You're asking me how it does
Okay, here's
something that's spinning.
let's all right, we'll go easier. We'll go easier with the question. Does the globe spin east to west or west to east?
West to east.
Hey, good job. Do you know the radius?
It just goes on its axis. I mean, like, I can't believe you're actually. How old
I
are
don't think
you?
you know what a radius is.
How old
So
are
you don't know
you?
what a radius? Do you know what a radius is? I'm
Yes.
43 years old.
Oh goodness.
Yeah.
She's having a blast. I wish I'm so jealous. Oh, I want to go back to
You
the
think
first
the Earth
time.
is flat?
Yeah, we've
Yes, they're
tested the
totally
Earth.
real, Ray. Just ask. You have to ask them questions, Ray.
So I just put two observations in the side chat. Right? If you want me to explain them to you, I can explain why they debunk the globe. Ray, you okay?
We're okay. I'm looking at them right now, and
Pick one.
yeah, I'll look at it.
Okay. Okay.
Yeah.
How about this?
Gotta-
How about this logic? Once is that you, Jesse? Shiny?
Yeah.
Yeah, good to see you, brother.
No, do your thing.
Section 1.
Hey, just quickly, Ray. Right. So, right, if gravity is pulling all of the water and everything towards the center of mass, do you think that we can calculate how much the water should be curving over a certain distance, like 20 miles, for example?
Whether when the clock and release action of the laser beam is carried out.
Sorry, I'm listening to this right now.
What is
Oh, if you want to check out one of the videos and get back to us on
No,
that, then I won't keep talking to you.
Let me see.
All right, I just think it's funny. It's like this person saying condescendingly, "I can't believe you think the Earth is flat." But in your ball model, you think you're flying at 1,000,000 miles per hour, and all you're doing is you're inside your house. So why the fuck do you think you're flying at 1,000,000 miles per hour?
Oh my god.
In non-linear vectors, by the way.
Yeah, that's
Everyone in there
probably more
actually
like 1.5 million miles per hour.
Like, what are you, nuts? Like, yeah, you go outside, the ground is flat. That's what everybody sees. But nobody experiences flying at a million miles per hour. But that's what the scientists decided that the globe requires. The globe doesn't
Yeah.
make sense unless you're flying at a million miles per hour. So do you think that's happening?
Yes.
All right, well, why?
It's there's even photographic evidence of the Earth being round-ish. Not perfectly round, but
Roundish.
Did you count the pixels to verify if it was perfectly round or not?
it's fucking mountains and shit. You think it's gonna be 100% perfectly round?
Do you
I mean,
think
you
if
only
you
best.
shrunk the globe down to the size of a cue ball, it would be smooth like a cue ball?
Maybe. I don't know. Yeah, I need to be around smart people again. This is draining me.
Struggling to keep up.
Right. So look here. He's
Oh, he's gone.
he left. Oh,
Yeah.
it's a shame.
Good job, B.
No. You did a
He's
good
doing
job
so.
too. You did a great
What
job,
the
Mario.
He
talent
could
for
get
real,
we
dude?
could give him Talon. We could give him like a
Dude,
participation trophy for sure.
I'm so jealous of a first-time Glober. That was beautiful.
Yo, my boy Knowledge is muted. Yo, I fuck with this dude Knowledge.
You want to talk
I
to
don't know
him?
Knowledge
why.
is being
All right.
rude.
I don't know why he
I'm
got
gonna
muted.
unmute.
No,
I
he
wasn't here
deserved
for it.
his mutes are deserved because he was being rude and calling people names and telling them they were stupid.
What else is
Oh,
new?
he's got. All right. You want to talk to Knowledge, Jesse? See if he's Knowledge. You there? You're unmuted, buddy.
I don't really know what to talk about. Oh shit. All right.
He probably won't mute up. He's probably chugging bong hits or something at the moment.
Me and Lats were talking about models before the group filled up.
Oh yeah.
We're talking about just models in general.
You don't
Cool.
need one to determine if something's flat, right?
What are models? That's my question right now. What are models?
Are you talking about like scientific models or just like a small version of an object?
That's yeah. I guess is that what you consider models?
No,
I'm
no.
asking.
There's different types. There's different types of models. Right? You could have a mathematical model. You could have a like a replica, like a little mini model of like a car or something or a horse or whatever. Or you could, yeah. There's probably there's a whole bunch of different types of models. So it depends what type of model that you would be talking about, I guess.
Okay. The Earth model, I think, is the one I do want to talk about. If you don't mind.
Okay, can you post that for us in the side chat so we can have a look at it?
Well, we've got all the models. We got the glow. There's actually depends on which one you cite, because like you cited the one with the radius. So like an Earth with a radius is only a spherical model of a perfect sphere. You can only make a sphere with a radius, right?
It's just an average, right?
make
It's only a tiny. It's 0.3% off being a perfect sphere.
Right, so you're assuming, right? So we can all agree
That's
that
what no. That's what they claim. It's just what they claim.
that's just a basic assumption of what the shape is.
No, they say it's an oblate. They tell us the exact radius, right, at the poles and at the equator, and it's just slightly different. Slightly different by 0.3%.
And then if you pick any other ones, it's literally just gets more right.
Yeah, it's so minute that when they calculate for drop over distance, they don't take that into account because it just makes like over a 20-mile distance or something. It doesn't really make much of a difference. It's like a point or something. It's like 266.4 feet, or at the equator it would be like 266.6 feet or something. Like it's hardly
it's
any
got to be so
different at all.
small, right? Like you can barely. I don't even think you'd be able to notice with the naked eye, because I think that's what happens when you take pictures of it from afar, of the Earth. But that's mostly the water at that level.
Yeah, just it fits. Like if you look at the blue marble, right? It fits in a perfect. If you do a perfect circle in Photoshop, you can just pop it right in there. Perfectly.
Well, it's going to be a perfect circle because it's level. Like most 70% of it's level, and then just like the Earth is so like the continents are only slightly curved above the water.
Yeah,
level
on a
above sea level.
right. If it was a globe, right? Yeah,
that's what forms continents. is the amount of land that's curved above sea level.
Yeah.
So that's what I'm changing my evidence to. We've directly measured the curvature of the continent.
How?
With theodolites.
Okay, show me one actual observation with a theodolite that matches a globe.
Yes. Well, okay, that's an unfair question. Like, you can't do that.
What?
You can't ask an impossible question.
You just said it's been measured with theodolites.
That's loaded.
No, it's not loaded.
Yeah.
What?
Hold on, I'm gonna get you.
You said that we know the continents are curved, right? Because of observations with theodolites. I just asked if you have one that validates that.
Yeah.
Not so you just have some numbers on a piece of paper, don't you? That you believe.
No. You said theodolites. That's what this is. So have you seen the
show
Great
us
Trick
one.
Survey? I haven't sent it to you before.
That sounds like a very reasonable
I've
question.
heard your arguments plenty of times, bro. I've been over all these arguments as well with other people. So if you could show me confirmation of any of the numbers in that survey.
Well, we're just talking about the measurement of the continent.
How did they do them? All right, so pick any of the measurements and show me how you validated one of any one of the measurements.
Okay, well, let's work on, what do you mean validate the measurements?
Well, it's just, if I just showed you some numbers on paper, right, you would say, well, how do I know that these are true and that this actually was taking all of the confounding variables into account and all of that kind of thing?
Yeah, that's why I sent you the Wikipedia page. That's the easiest way to start.
Right, but there's no observation listed on that.
The Great Tricks. What do you mean? It was a huge project. It was a survey.
Yeah, I know what it was. Right. I just haven't seen. Okay, so how did they do the measurement? How did they do the measurement?
With theodolites.
Okay, so walk me through the process.
They take a theodolite and then they take somebody with a mirror and they measure about every 50 miles, and then they get and they measure the distance, and then because they have to. Oh my God, I have to explain to you how theodolites work.
No, I know how they work. Right, I'm just gonna pick apart the test.
So well, wait a minute. I just want you no. You're not even picking apart the test. You're just pretending that you're being willfully ignorant about how theodolites work.
No, I know how they work. I'm seeing if you know.
Between distance measurements between 2 points. I shouldn't have to explain that.
Okay, so how did they?
That's not correct. You're measuring a vertical angle, not a distance.
Well, let's just take it easy. We're taking little steps at a time.
So you don't know how they work.
It's having a hard time.
So funny.
That's part of the theodolite because they make sure that the theodolite is plumb.
That's not distance. Plumb's not distance.
Well, yeah, when you want a distance measurement from one point to another, you want to make sure both points are plumb.
But you just got done trying to say he didn't know how it worked, and then you just said something wrong. So that's just fucking stupid.
No, what are you talking about?
You're already
you don't even know how the
theodolites.
You don't even know how the great theodolites work, Shiny. You've never read my piece of information. You never read my evidence.
You already butchered it.
No, I haven't butchered it. You're just interrupting me now at this point.
No, I'm not. I didn't interrupt you at all.
Well, then you gotta let me finish talking.
I did.
No, you didn't. You've been interrupting me.
No, I haven't.
That's not what happened. Why don't you get a real measurement?
You're just saying.
Why don't you get a real measurement? Everybody wants to look at a fucking telescope when the light is bending. He's like, oh, it's not where it's supposed to be. The light's bending. So go get a real measurement of Earth curve for once in your fucking life.
That's what the Great Trigg Survey is.
So how does a theodolite measure distance?
No, this is like elementary shit.
How does a theodolite measure distance?
What? How does a theodolite measure distance?
Yeah, that's what you said.
No, they measure angles.
You said that they measured. Yeah, that's what you said. You said they measure distance.
You can measure distance in miles between 2 points. Are you fucking like?
How?
Do you not know how map? Do you not know how?
Oh God, he doesn't know.
Whoa! You don't know
how do you get a distance from an angle? Can you tell me how you get a distance from an angle?
No, I mean, no. Now you're just asking stupid questions.
No, that's not a stupid question at all. It's a very valid
maybe
question.
Maybe we should like cancel this.
Maybe you should Google it. No, it's fine.
He's starting to melt.
We're not
don't melt.
You can Google how do you get a distance from an angle. Just Google it. It's fine.
All right,
we're not mad at you, bro.
You guys are okay. I mean, this is just going to be boring because now your questions are boring. My explanations are not boring. This is what the problem with you talking.
Did you Google it?
What's the question? You gotta tell me
You
the
have
question.
to know the height of the target when you measure the vertical angle, and then that correlates a distance.
Yeah, so you obviously don't understand how the Great Trig Survey
But
works.
why
You
wouldn't
realize
you
the
just say
baseline.
that? I mean, if you knew how
I
surveying
shouldn't
works,
have to say that, Shiny. I shouldn't have to explain to you how baselines
I'm
work.
sorry, but like I'm hearing a
That's your
conversation about
problem,
surveying and
Shiny.
like you're getting shit wrong, bro.
That's a you problem, my friend. So you're literally interrupting me and DJ having a conversation about models.
I don't care.
Is that your tactic? Just say people are interrupting you and not actually answer the question? Because DJ asked you the question first, and then Shiny asked. So, yeah.
Well, no, I'm getting gang. Well, I mean, it's hard to get a question out of people that are ganging up on you.
Look, we love
All
talking
right.
about surveying.
So
We
what
can
was
talk
the
about it
question,
all day.
Neil?
Let's talk about it.
What was the question?
All right, so
Yeah, vertical.
we were just
No. Like, how do we measure distance?
no. You were saying that the theodolites measured the distance, right? And then he called you out on that because that's incorrect.
All right,
And
I
then
corrected myself, and I literally corrected myself and said angular measurements.
That's right. Yeah.
Okay, so you have a theodolite set up at one location, and then what do you have set up at the second location?
I'm sorry, what was that?
What do you have set up at point B?
A fucking mirror.
A mirror. Okay,
It measures
so
angles,
you're going.
Yeah. So I corrected myself. It measures angles. Yeah.
Okay, right. And how are they accounting for the atmospheric conditions?
What they take a lot of measurements.
Okay, so how did they take the measurements, and where's the evidence of the measurements that were taken?
They measured. They took a lot of measurements over the course of a month at a specific time during the season, and with from both ways. They always go from point A to point B and then point B to A with the mirror and the theodolite.
Right, but the atmospheric conditions are constantly changing, right? Every second they're changing.
No, India doesn't. India is a tropical paradise. It doesn't change that much. There's a slight variation in season, but over the course of the month, as long as you measure within. Excuse me, I'm finished. I'm going to finish, but as long as you measure within 30 to 50 miles, it's easy to correct for refraction, environmental refraction.
Really? What? Okay, where's the evidence that India doesn't have changing conditions?
Excuse me. Have you ever heard of the fucking almanac?
Right, so it changes constantly as the weather fluctuates throughout the day. They have wind, right? They have changes.
They take measurements at the beginning of they take measurements in the morning and at night. I mean, this is easy shit. This is easy shit. You should already know. This is easy shit.
No,
you guys look dumb that I have to.
You're
explain
not doing
this.
well, dude. You're not doing well.
I'm explaining it, but you don't. It's sad that I have to explain this.
So how did they account?
When are you gonna get to the part where surveying proves Earth curve? When are you gonna get to that part?
Yeah, because the continent is curved. Because you can measure the angle is greater than 180 degrees.
Okay, show us one observation where they did that.
The Great Trig Survey is the compilation of all the observations, DJ.
Oh, so it's just trust me, bro. Is that it?
Excuse me. It's thousands of measurements, DJ. Like, get it through. Do I have to get it through your thick skull that they directly physically measured the Earth from one
so
point, from the northern point of
about,
India to the southern point of India?
You were complaining about knowledge spazzing out, and you said that he was being rude and that he should get muted because he was being rude, and now you're doing exactly what he was doing.
I disagree. You're just lying because you're losing.
No, I'm not losing.
Yeah, that India survey. If you actually look at all the observations that they made, they had to make tons of corrections that they attributed to instrument error, human error, refraction, collimation error, because the observations never matched the globe prediction. That's reported from the survey. So I don't know what you're talking about. They measured a globe. No, they didn't.
So if you want, wait a minute, shiny money. I've gone over this lots of times, but I'll go over it with you.
I actually read that stupid fucking survey.
No, shiny.
The angles that they need for the ball is literally held against the They have a calculation and an observation, and they're always different. The calculation for where you should see something on a ball on a globe with a radius of $4,000, whatever.
So wait a minute.
The observation is always different than the calculation. If you look at that survey, you'd know that.
He's just interrupting again. This is Shiny interrupting the discussion.
No, it's not interrupting him. Refutation. I'm refuting your dumb claim that they measured a globe during the India survey. No, they didn't. None of the angles comport to a globe. They put the observation against the calculation, and then they claim that they have to make corrections for instrument error, human error, refraction, and collimation. Go look it up, dude. I'm not lying.
Okay,
All
I'm ready
right.
to. Once he stops talking over me, I have a question for
No.
Shiny Money. Do you, Shiny, when you take measurements, do you want them to be correct? Yes or no?
Oh my god, what the fuck kind of question?
Can you answer correctly? A simple
You
question.
didn't listen to what he said
When you
at
take
all.
measurements, Shiny, do you want
I
them
don't
to
think
be
you understood what I
correct
said.
or incorrect? I'm
What's
just asking you.
You know
This
what
is
collimation is?
this is a new conversation, Shiny.
I don't
Let's see
think
if
you
you can
know
actually
anything
get
I
through
just
it.
said. You don't know what
Let's see if you
collimation
can.
is. You don't know what anything I
So,
said.
if do you want measurements to be incorrect or correct, Shiny?
Yeah, dude, they're
Say
only
it.
incorrect if you presume you're on a ball. You know,
Okay,
you
wait a
take a
minute.
measurement and it's like, oh my god, it doesn't matter. My measurement must be incorrect.
I'm going to open the question to anybody. Do
Yeah,
you
but
want
you're
your measurements
presuming
to
you're
be
on a
correct?
ball. So when your observation doesn't match your calculation, you say my observation's incorrect because I have to be on a ball. That's
He's
not
refusing
actually
to
what's
answer the
going
question.
on, though. Like, you understand that's stupid?
He's refusing to answer the question. Do you want measurements to be correct or incorrect, Shiny?
What a dumb thing. That is so dumb. Malformed question.
Does anybody else want to answer?
To what?
Do you want correct measurements or incorrect measurements?
Correct to what?
To being right, to being accurate.
It's not right unless it matches a ball. So your observations
You want
don't
accurate
match a ball,
measurements, Shiny?
So there's something wrong with your measurement because it doesn't match a ball, right?
Shiny, do you want accurate measurements or inaccurate measurements?
What makes the observation inaccurate? Because it doesn't match your ball? Like, do you realize what's going on? Do you hear yourself?
I'm schooling you, Shining Money, but we'll get there.
I think you're a fucking idiot right now.
Ooh, he's
you're
at
getting
Tommy
wrecked,
now.
Talon. It's not working out well
like
for
that.
you, bud.
Okay, see, I would like to talk to DJ because Shiny.
No, honestly, you shouldn't try to debate me. You should debate someone else, dude. I'm sorry.
Well, we go over the correction thing pretty repeatedly. So you literally think that corrections make something.
DJ wants to be nice to you. Okay, I don't want to be
do we
nice
want?
to you.
So when you do
it's
corrections,
it's
does that
4 a.m. here. I
correct
gotta be quiet.
the measurement? When you calculate when corrections are calculated, does that make the calculations correct or incorrect?
Talon, what are you comparing the observations or measurements to know if they're correct or accurate?
Excuse me?
What are you comparing the observations or measurements to know if they are correct?
To the Earth
as a
shape?
Yes, as a ball. That's what Shiny
as a
was saying.
shape. As a shape.
Oh my god, he sees where he was walking and then just kind of stopped and said derp. Like, maybe
excuse me, I said a shape. We're
well,
measuring
dude,
the shape of the
now you hear what you're saying.
This is I shouldn't again, we've gone over this lots of times, but we can go over it over and over again. But we are measuring the shape of the Earth.
The shape of the Earth, it didn't measure as a ball. So why would you say that it's an incorrect measurement because it doesn't match a ball when the observation doesn't measure as a ball? Why would you say that's incorrect?
I didn't say
why.
That's
well, that's what you're presuming. You're presuming the measurement is correct because it doesn't match your calculation for a ball. Okay, you get it now? You're assuming it's incorrect because you presume the ball, but in this measurement, this is when you're going to confirm whether or not it's a ball. This is the measurement to confirm if it's a ball.
The shape.
You don't have an observation of the ball yet.
The shape. We're measuring the shape of the Earth. The shape.
It doesn't matter what the fuck word you use for the surface. It doesn't matter.
So like
they weren't trying to measure the shape of the Earth in that. They weren't even trying to measure the shape of the Earth in that.
Angular measurements of the surface of India?
Yeah, they weren't trying to work out if the Earth was a globe and try to measure a globe, right? They were just model fitting.
What does that mean?
So they took their angle measurements, right? And then they applied corrections, and then they added that to their model that they were trying to fit it to.
They calculated a model.
Right. They had a model that they were trying to
took
right?
the
they
measurement.
had a previous model, right? They had a previous model that they were making predictions with. Okay. And then they were taking extremely rough, right, angle measurements, right, with extremely rough conditions, not accounting for refraction correctly at all. Okay. And then when the observations didn't match their predictions, right, they would discard ones that were too far off, and then they would keep doing them until they got some that went close to their predictions, and then they would use refraction and instrument error to try to fit it to their presupposed globe model, which they were
Yeah,
trying
exactly.
to
Well said.
fit it to.
Oh my god, that was the word. The end, like the end of that is just great. I love the end of what you just said there. Yeah.
Okay.
Because it just waffles out like that. You couldn't explain the
Oh
like.
my.
Okay, so what are they doing again? What are they doing with the model there again? Like I don't want to be rude or anything, but I just don't understand what you think that they did with the model.
Which model?
Because you were right. You're right that they disproved the 360-degree model. Do you know that?
What?
I agree with you there.
360-degree model.
You just admitted that they disproved the 360-degree model, and they found an
What's
oblate
model
spheroid.
what model is that? Yeah,
that's the oblate spheroid model. That's the model that fit.
Is the globe claimed to be an oblate spheroid?
Yeah, that's what the Great Trig Survey says.
And they debunked it.
Like we are not like I do not believe in 360-degree globe. I believe in oblate spheroid.
Shout out to Talon. That's a big step you're taking right there, bro.
What does that mean?
You just said they debunked the oblate spheroid model.
No. You literally just said the opposite of what I said. The
360-degree model. No. Listen on the live stream. You just said that.
Let's try that again, DJ. You said you can't just say the opposite of what I fucking said. I said that they had the 360-degree model and they disproved it with the measurements and they found an oblate spheroid.
What? That's
okay.
Do you think that previous?
Yes.
Do you think that previous to that they thought the Earth was a perfect sphere, and
yes.
after they did that survey, that's when the oblate spheroid was invented?
That's when they discovered the Great Trig Survey. Is when they discovered the oblate spheroid for the first time,
right?
By directly, physically measuring it.
Right. So you're on a topographical plane, which is not bending at the radius of 3959. You got oblate spheroid. You got flattened top. You know, you got a bulge near the center. Okay, so when did you measure a ball? What are you talking about? You still don't have your ball radius. You're like, oh, they measured the oblate. That means you didn't get your ball radius.
Right. I have had to change my evidence. Is that we only know that the continents are curved.
Mid debate.
Right,
that means
so
as far as direct measurements, we haven't done the bottoms of the oceans.
That's true.
It's true. So we can all agree. Like, I'm not going to try to say that we've directly measured the entire globe, which we haven't physically done.
All right. So just quickly. So when was that survey done? What year?
It was the 1860s.
Oh,
It took them like 40 years.
I just looked.
It took them like 30 years, dude.
Hold on a second. Okay, so look, I just looked up when was the oblate spheroid discovered, and it says that it was discovered by in the 17th century. Okay, and even in the 16th century, a French astronomer, Jean Richer, said that that's what it is, and it was in the 1700s, right? So the empirical proof came in the 1700s. The French Academy of Sciences sent out teams to Lapland to measure the physical length of a degree of latitude. Okay, so you're just full of shit, right? Everything you say is just made up bullshit.
No, what do you mean? The Great Trig Survey of India is literally on the list of shit that they did.
No, they already thought it was an oblate spheroid in the 1700s.
No, but all they could do was measure meridian arcs in the Arctic and then near the equator. So they knew that the radius was so that they knew it was a little flatter on the poles.
You said that before that survey, they thought the Earth was a perfect sphere, okay, and they debunked that, and that's when the oblate spheroid was invented, or whatever you want to call it, discovered. Okay, that's factually incorrect.
No, this all happened in the 18th and 19th centuries.
No,
17th
right? In the 1700s, right? What?
Yeah, you're very like.
The Earth was first theorized to be an oblate spheroid in the late 17th century by Isaac Newton. Okay. Theories include, right, in the 1600s by Isaac Newton and by a French astronomer, and then empirical proof came in the 1700s. right, with French expeditions. So, I mean, it doesn't say anything about the survey that you're talking about here at all.
Well, you should. I mean, wait. What are you talking about? Like, what are you looking up?
Okay, so when was the
Look
Earth
up.
discovered to be an oblate spheroid?
Well, that's just saying when it was first discovered, but it wasn't directly measured until they did the Great Trig Survey.
No, it says empirical proof came in the 1700s.
Right,
Expeditions,
that's
the
just
French
proof,
Academy of
though.
Sciences
But
sent
that was
out
just
teams to
proof of
Lapland.
meridian arcs. They knew that there was a little more curvature on the equator, but they didn't know that like the whole Earth, like, was an oblate spheroid. No, I'm kidding. Like they had, but but they didn't physically measure the oblate part until they did India, because India's on the equator. So like they got a
Bro,
physical
that's not
measurement
even true. That's
of
incorrect.
the because you got to think
Pierre
about
He's just
India's.
talking
Fougere
absolute
Whereas like
shit,
Pierre
dude.
Fougere claimed to
I'm
measure
sure they
the
did
obliqueness
I mean they
Bullshit.
did
in
every
France.
continent. They did
Oh
every
my god,
continent in
you're
the
just talking
1800s.
over the facts while you're lying. You don't know who measured the obliqueness? It was Pierre Fougere. Look it up. Pierre
1802. It was begun in 1802.
Why are you interrupting again when you don't know what you're talking about? You don't. All right, go ahead and keep yelling about things you don't know about.
That was the whole point. When
First time somebody claimed to measure any obliqueness near the equator was Pierre Fougere, or like however you pronounce that French. Bougere. Pierre. Pierre Fougere. Google that guy.
Isaac Newton figured it out in 1687 because of the
No, that's not a
theory
measurement.
of gravity.
Just presuming, Earth must be spinning, so it also must be oblate. Yeah, lots of people thought something stupid like that, but that's not a measurement of oblateness. Well, the first time somebody claimed to measure any oblateness was with the stars. They claimed that the stars weren't like declining at the right rate near the equator. Go look it up.
Yeah, I'm looking it
Sorry,
up right
when
now.
did
The
you
French
say?
Academy,
What did you just say, Talon? What did you say? What did you say? What year Newton? Something about Newton?
1687, according to ChatGPT.
What did he discover?
Theory of gravity, Earth's rotation. Since he knew Earth was rotating, it was probably squishing.
How did he validate?
Oh, because of he understood mass and centrifugal force, gravity.
Even according to the current astrophysicists, right? They say that Newton didn't know what caused it, so he invented something called gravity. They don't know what gravity is or where gravity comes from. There's 80-something theories of gravity, and none of them have any scientific validation through experimentation, right? They're just theories that are textbook definition pseudoscience.
Oh, well, now you're making claims.
Yeah, it's okay. All right, prove me wrong.
So, the Cassini family sent French expeditions in 1738 to check on the equator and the Arctic. That sucks. Can you imagine being stuck with the Arctic one?
So you can't show us a single observation that's been done throughout all of history.
We're talking about all the historical
No,
observations.
you're just talking about some, trust me, bro, numbers on paper. Imagine if we just came to you with some numbers on paper.
Bro, these people went to the fucking Arctic and measured.
They weren't trying to measure for Earth curvature. They were trying to. They already thought the Earth was a globe.
Dude,
they weren't trying to see if the Earth was flat or a globe.
All math is
Show us
numbers on paper.
Exactly, and if it's claimed to match reality, then you would have to validate that the numbers on the paper match reality.
Okay, well, you gotta let me do that. You're interrupting me.
You need to show me one test where they did that.
Well, that's what we're working on. We're talking about the French expeditions right now in the 1700s.
You don't. There's literally zero footage of them doing a single test.
Dude, the cameras weren't invented until like the 1860s.
Exactly. So it's just a trust me, bro story. Isn't there anyone that's
what the fuck
done
are you
one long
talking
distance
about, dude?
observation? You're just giving me stories from the olden days, right? Where they didn't even understand. They didn't even understand that you had to account for wet term and dry term when you're accounting for refraction. They didn't even know that back then.
Sorry, this is the history of from the National Oceanic.
Oh, okay. It must be true then, just because it's from the National Oceanic.
Sorry, it's NOAA. I don't
Yeah,
know what
well,
the
must be true.
no.
It must be true because NOAA, it's from them. Yeah, it must be true.
Yep.
Trust me, bro.
That's where they.
Well,
that's where
we can show you tests that were done in real time, live streamed,
Atmosphere?
where they accounted for the atmospheric conditions. Right? They did repeated tests from different heights. I can show
Atmosphere.
you high definition videos.
National Oceanic and Atmospheric Agency. Atmospheric Agency. Oceanic Atmospheric Agency. Yeah. Do you really hate NOAA because it's got sphere in the word or in the full
I
acronym?
didn't say anything about that. I said you can't just say the name of an agency and think that that's empirical evidence of anything.
All right, well, I'm just reading about the stuff they did before the Great Trig Survey. I got no problem looking it up.
Right, but they
North
didn't
America, they
even
did
have
1807. Started in.
they
So they
didn't even
started
have.
India in 1802. They were doing by
Who
1807.
cares? Show me any of that was done correctly.
North America.
Now all you're doing right now is just waffling on with bullshit. Is
It
there
took them
anyone
90
else here that wants
years.
to have a real conversation?
Do you know about the transcontinental arc of triangulation connecting the United States from the Atlantic to the Pacific? I bet you
Yes.
don't.
Yes, I do actually.
Oh, because it's on the National Geodetic Survey milestones.
Yeah, I know
You know
all
what?
about the
I mean, do you know what geodetic
Transcontinental American Arc of the Parallel survey. Yep.
Yeah, we're talking about geodetic surveys.
Right, where they take plane, right? They do plane surveying, okay, and then they model fit,
Ooh,
and they
model
didn't
fit.
account
I
for
like how
a
you keep saying
fraction. They
that.
didn't account for a fraction correctly, right? They only accounted for the dry term, which is not correctly accounting for a fraction, okay, and they only took two measurements at only two different heights of the temperature, okay, and they had observations that were wildly off, which they just threw away. So when it didn't match their model, they would just throw it away and discard it, and they would keep the ones that matched them predictions the closest, right? And then they would still not match the model that they were trying to fit it to, so they would then adjust it, saying that there was instrument error and certain levels of refraction, right? Like reverse engineering it. Oh, it was off by a certain amount, so therefore there must have been higher refraction. It's ridiculous.
And why? No, why did they do? Wait, I don't. They didn't do that though.
That's exactly what they did. Have you read the paper?
What do you mean? You're just making it up. You're just saying that they couldn't
No,
get it like a.
I have a whole channel in my server dedicated to that exact survey.
What channel are you talking about?
I have a server, right? It's like a giant library, and when I research things, I log it all in channels in there. And one of them was going over that survey that you just mentioned.
Oh, cool! I'm glad that my evidence is
Transcontinental
showing
Arc of
up
the
in your
Parallel
little
survey.
propaganda library.
Yeah, a lot of it's propaganda because it's globe information.
Wait, so you think they're cherry picking models? That's all you're saying.
Yeah, well, they're not. Yeah, they're just right. So they're just model fitting. It's reverse engineering. They're pre-assuming it's a globe before they even start the survey, right? And then they have a particular model that they're trying to fit the measurements to. So they'll make the predictions of what they're going to measure, right? And then they'll take that and then they'll adjust it to retrofit it onto the new model, right? On the updated model. Yeah.
How do they do that?
How do they do that? They take angle measurements, right? And they make a prediction based on standard refraction. They using 8 inches per mile squared formula, and they make a prediction on how much drop over distance there's going to be, right, on each observation. Okay, and then they take that, and if it doesn't match, right, then they'll put it down to abnormal refraction conditions and instrument error, and they'll throw it away. And they'll keep taking more and more close to what they want, right? And then they'll take that data and they'll adjust it, right? using basically like turning knobs, right? So they use instrument error and refraction as these little turning knobs to fit it onto a globe, right? Because there's not that much difference between a globe or a flat Earth over these distances that they're taking the measurements, right? So they only have to make small adjustments to fit it onto their geoid model, or whichever model they were trying to fit it onto at the time.
They had both more than one model where either the Earth is going to be spherical or it's going to be oblate. So they had multiple models, but they picked one out of the two. They didn't just they didn't model fit at all. They picked the one that most accurately matched the measurements, which was an oblate spheroid.
They had particular models that they were using. I can look at the exact name of the model, right? So they had a previous model, right? And then they're trying to make an updated model. But each of the models is just pre-assuming that the Earth's a globe in the first place.
It's not pre-assuming anything. It's taking the measurements and calculating the models. It's resolving. Because it's partial measurement. Because you're taking a partial measurement of something that's so huge, you can't take an entire measurement of it. And so we're still just having to use models. So that way we can.
Yeah, they were incorrectly accounting. They did. Okay. Well, do you think it's refraction exists?
Yeah.
Okay. Well, they didn't accurately account for that.
Yes, they did. They did that.
Okay, how did they account for it?
By doing it, I can say this. Hold on, let me just reset real quick. In order
So it's like an
in order to account for environmental errors in the measurements, they had to take the measurements within like 30 to 50 miles, and they had to do it over the course of a month, and they had to do it from both ways, and they had to do it at the beginning of in the morning and in the evening, and so that way they knew any change in measurements from the morning to the evening would account. Like they can account for refraction because they know in the morning.
What you want to say is atmospheric refraction causes vertical displacement based on the temperature gradient.
I'm sorry, I'm literally I was in the middle of talking. I can't.
Yeah, you've been talking a lot, man. We all hear you. Now here comes somebody else.
Well, we're having a conversation.
Yeah, I know, and it's in a room full of people that might also talk as well, so don't panic.
Shit. Well, it was a good derail.
It's an open panel, dude.
It's called atmospheric refraction, man.
Wait,
refraction.
We're accounting for refraction.
Refraction vertically displaces the image in the distance. It doesn't move it back and forth.
Yeah.
You know what I mean?
No, but you can take lots of measurements.
The observations that are taken in reality, you guys have to claim that the horizon moves back and forth due to refraction. Refraction only causes vertical displacement.
Right. That's
right.
The exact reason.
So if I post this image of the black swan, all right, what are you going to tell me is happening in this image? Let's find out. I'm going to post it right now. We're going to find out what you say this is.
Oh man, you guys, we've done the black swan before.
I can't post photos, but I'm sure somebody knows exactly where.
Let me think about my lineup for that one. I have a.
Why try to refute?
I have a library.
You don't have a refutation. You would have the refutation if there was one. You know.
I'll post it in a second. I'll post it in a second. I just want to ask him how taking multiple measurements throughout the day, right, is going to account for refraction. Because which one of those measurements are you going to take to put down on paper?
No, you average it out.
But that's not how you account for refraction. That would be inaccurate if you averaged it out.
It's a huge pain in the ass for
sure.
Yeah,
what if you have 5 days of consistent heavy refraction? Then your average could be where there's the most refraction. Like just taking observations over the course of 5 days doesn't tell you what's happening in the atmosphere. You know?
Right. So that's like they made a prediction on what they would encounter in the distance based on standard atmospheric refraction. Okay. And then they took their measurements and then they they worked out how much it was off by that. It's reverse engineering what they did, right? They were just reverse engineering based off cherry picked data, and they threw out all of the measurements that were too far off the globe.
Counting for refraction. Well, wait a minute. And counting for refraction ensures the angle measurements represent the Earth's geometry rather than distortions.
Did you read the screenshot? They didn't account for refraction at all. It says it right here at the bottom of the screenshot. It says
refraction.
It says refraction is not occurring. Like, right, it says non-specialized means within a normal range. They didn't that tells me right there they didn't do it. They didn't add in that calculation.
Wait, hold on a second. Let's see what brain rot here is talking about.
It's just being
what are you talking about?
He's being a fake flat earther. He's being a fake flat earther. He's not good at it.
Bro, every survey since the 1800s accounted for refraction. I don't know what you just read.
Yeah, knowledge. What survey are you even talking about here?
Oh, it's the laser test that you posted.
We're not talking about that, you dumbass.
Okay, I was just doing calculations. I just came back.
Good Lord.
But the calculations are in the side chat, but it's been debunked.
You're an idiot.
I put the right coefficient in, which is 0.13. When you posted, like, I have a screenshot of the temperature. The screenshot of
that's not how refraction works, bro. Sorry.
Air temperature is 7 degrees. The sea temperature is
just
7.
Just derailed the conversation and started just butchering
Dr. John. No, this is really not how refraction works. What you're saying?
Yes.
That sounds like something McToon said when he got dunked on and did not.
Light bends towards the denser medium, but when cold air is happening, it's sitting at the bottom. It's denser. That light bends towards it. Right, so you have to put in the coefficient in order.
I'm sorry.
To do
is the coldest air near the surface?
Are you stupid?
Is the coldest air near the surface?
The warm air. Like, what are you talking about?
The warm air is most adjacent to the surface. Yeah, that's right. Now you're thinking. Good job, buddy.
Yeah, the normal lapse rate in the atmosphere is that it gets cooler as you go up.
Like, dude, can you please remember reality before you just shoehorn in your stupid globe model?
But Dr. John D took 5 different... Shush. Dr. John D took 5 separate vertical... Yes, he did. He live streamed it, and he live streamed the measurements with the temperature
everybody's
and
back
humidity.
on the flat Earth, boys. Flat Earth gang, boy. Flat Earth gang, boy. Gang.
Yeah.
Yeah.
Anybody gonna get Zippy?
All right, guys. Snacks. Last call. This special. We got snacks. We got cheese. We got peanut butter. We got graham crackers. Got a little juice.
Appreciate it. Thanks.
Wow.
Yeah, so Globers have to say cold air bends towards the
yes,
like
does.
Near the surface.
Yes,
but near the surface, the air is the warmest. Congratulations!
Air,
now you know what reality is. Reality
that is dense at the bottom.
Why do I hear you talking?
The top, right? Light
but you realized you were wrong
like
5 seconds
denser
ago.
Medium, bud. That means the
laser but the denser medium is not at the bottom, bud.
If it's 7 degrees, the cold air sits slightly, beneath the
the cold air is above the warm air.
Yeah.
Yeah.
Well, the only time
near the surface,
you get
the warm. Yeah, bro. The warmest part of the gradient is the bottom, adjacent to the surface. Temperature decreases as you gain altitude.
The cold air is
welcome
the
to reality.
That sits at the bottom. The light rays bend towards the denser.
The air gets thinner. Oh my god.
Yes, it does. Yes, it does.
Hey, knowledge.
That's how refraction works.
Knowledge. That only happens. That only happens. You only have cooler air down lower. Right, when you have a thermal inversion, which is rare. When you have a thermal inversion, which is rare.
He knows he's
how
wrong.
Cold is it? Why does it say from the Flat Earth Society?
We hear that you know you're wrong.
The air temperature is 7 degrees, and the sea temperature is 7 degrees. That means that when you did this test, it's fucking cold as shit outside. That would mean
check
that
this out.
That
you're making
cold
a claim
air
right
is sitting
now.
below
I'm gonna tell you
the warmer air. That's what
I'm gonna tell you.
that means that
we heard your claim.
that means that the air at the bottom, which is the cold air, is the denser medium. So when the light goes
the air at the bottom is the warmest.
When the light goes over
coldest.
the water, it goes towards the denser medium, which is the cold air.
7 degrees. You said that but the water is 7 degrees and the air was 7 degrees.
Wait a minute. Why did you say refraction did not happen here when it did? The temperature proves it.
You don't know.
No, the temperature was.
You have to correct for refraction.
Yeah.
He did. He did. It's just.
He did not. If
yeah.
you look
the
at
problem
the screen,
here
look at the
is.
video, bud.
Hey,
It's the
retard, get on mute. Right. So this guy's completely retarded. It's like we have a retarded person in the chat. Right. It's crazy. Or a mental patient or something. Right. So Dr. John D. Okay. He took vertical temperature and humidity readings at 3 points, where he measured vertically in 5 different vertical readings, right, along the path of the laser. Okay, and he had uniform humidity, uniform temperatures at point A, point B, and point C. You can also see the laser going directly to the target all the way across the water. Not only that, he did 1 meter to 1 meter. He got a direct hit with the laser. Then he lowered the laser down to 0.7 meters and got a direct hit. Then he lowered the laser again down to 15 centimeters above the water. Right, he got a direct hit again, and he lowered the target on the other side as well. Right, this was all live streamed. He accounted for the refraction. He dismissed refraction being a possible counter for this. If you put it into any AI, it will tell you that refraction is not possible as an excuse for this to work on a globe. It says this cannot work on a globe. Because if the laser is just 15 centimeters above the surface, if it bends down at all, right, it's going to hit the water. It's not going to reach the target. If it bends up at all, it's going to be way over the target, right? But he got a direct hit. At point B, the laser should have been 15 meters above the surface of the water, and this was all live streamed.
Yeah, but you can have, there is refraction though. There's atmospheric refraction.
What causes it, Talon?
The atmosphere.
Ugh. How does the atmosphere cause it? You're kidding me, right?
Cold air is you know how like in a room the cold air, it's colder on the floor than it is at the, like hot air rises.
No, it's not.
Warmer air rises.
It's warmer down lower. It's warmer down. Yeah, hot air rises, so the warmer air is up. Okay. What's the normal lapse rate in the atmosphere? Right. Let's look it up. Right. Let's see what that is. Okay.
While you look
what
that
is
up,
the
I
normal lapse rate? I've just really quickly. I already got it. Okay. So the normal lapse rate is the average rate at which air temperature drops as altitude increases in the lower layer of Earth's atmosphere, the troposphere. It's standardized at 6.5 degrees per 1,000 meters, right? So as you go up, right, it's down lower because the sun heats up the ground, right? And then it gets cooler as you go up in altitude. This is the normal lapse rate. But Dr. John D took temperature readings, okay, and it was 7-degree water, 7-degree air, and approximately 70 to 72% humidity at all of the reading points. So you don't have the conditions for light to be bending, right? On a globe, you would have needed extreme refraction for this to work on a globe, right? Refraction coefficient of 0.99, which you probably don't know what that means.
No, you're making an assumption.
That's yeah. So do you want me to show you the readings? Do you want me to show you the test? Like, that's the thing. I can show you a high definition video, right? That was live streamed on 3 separate live streams at the same time, right? Him actually measuring and calibrating the temperatures beforehand. There's 30 videos.
Yeah, but it's cold as
right,
fuck. That means it's
related to this one up. Why would it bend a lot if there's no change?
Cold air is really high refraction.
Okay, which way would it bend if you have high refraction, bud?
Down, over and downward.
Why would it bend down?
It wants to go towards the coldest
down?
air, which is at the bottom. And so any air that it's like, oh my god, I want colder and colder air. It's going to be at the bottom. It's going to high. That's why the refraction is so high, because it's a lot.
What if there wasn't? There wasn't colder air at the bottom. He measured it. 7 degrees.
It's cold. No, cold air bends light more than hot air.
Hey,
Yeah, that's not even
retard, guess
necessarily
what?
true, bro. What the fuck? It's
Yeah,
the
what are you
difference.
talking about?
It's not.
No,
Hot,
it's
It's
the
not true at all.
warmer
It's
than light.
I've been
There's
listening to this
colder
guy
air
get
is
shit wrong, and I
denser.
want to respond now.
Yeah,
Fucking
go
shit,
for
dude.
it, bro. Go for
Dude,
it.
it's not.
Have an
It's
School this
not.
individual
clown.
It's not that hot
understanding.
air bends it more or cold air bends it more. It's the difference in temperature. It's the boundary between
Exactly.
the two different mediums. Depending on it's the difference in temperature between the two mediums that changes the angle, or reduces the speed of light.
Exactly. So it's about the change in the refractive index gradient, which is controlled by temperature. So light will bend towards the colder air, from warmer air to colder air. If you
Well,
don't
it
have a
runs into
change,
photons, run
shut
into
up.
molecules.
Shut the hell
right?
up, clown. You don't know what the hell you're talking about, right? Maybe you'll learn something if you shut up and listen.
Density. We're talking about air density.
Bro, you believe in
We're
Yeah,
talking
but
about
what changes? What density
Alright.
is
slowing
directly
down?
correlated with temperature.
What is
When the
slowing
temperature
down?
changes, the density changes. Right? Do you
What
agree?
slows down the light?
I know you didn't hear me because I'm destroying you.
We're talking
When
about temperature
listen.
changes, right?
Hold on, Talon. Check this out. Ready? When the temperature changes, does the density change?
Yeah.
All right. So the temperature gradient is directly density gradient, right?
So no, it's coldest at the ground, and then it warms up as you go up.
No,
Yeah,
it's
that's
not coldest at
that's
the
not
ground.
true. That's not reality, bro.
It's not. You think this is uniform cold? It's just
The
the same
air is
temperature
listen. I'm gonna
as
tell
you
you a
go up
fact
in
about. I'm gonna tell you
elevation.
a fact about how the Earth's surface works. They say, well, I don't know if this is exactly true, but this is what the globe model says. Sun rays hit the Earth. Earth is a quote unquote black body. It absorbs and scatters light. Therefore, what warms up the air is not the sun rays, it's the surface of the Earth. They say that the sun rays hit the Earth and the Earth radiates heat, and that's what warms up the air. Therefore,
Okay.
the air near the surface is the warmest. Otherwise, if sunlight warmed up the air, the gradient would be reversed. So that's what you need to realize about your dumb model. You guys say that the density gradient. Literally, the temperature gradient is the opposite of what you claim. Reality is the opposite of what you claim, bro. Just so you know.
Dude, when there's a fire in a room, are you gonna hit the ground and crawl out, or are you gonna walk through the smoke and die?
I don't know what that's about.
So like
But
hot
what I
air,
just said
hot air
completely
rises,
refutes your
dude.
dumb
There is
idea of what refraction is.
Are you saying that like hot air doesn't rise?
I'm saying that near the surface, that the air is the warmest, right? Which is going to bend the light a very specific way, which is not what the globe model claims. The globe model claims it's going to bend it the other way because the air is near the surface. But the truth is, the air is warmest near the surface. That's the fact. The air is warmest near the surface. That's the fact. That's how the science works. Okay?
Yeah, but
that's what reality tells you.
But 7 degrees is still cold as fuck. Or is that 7
It's
degrees?
about the change in. It's about the change in temperature, silly.
So
it's
like
not
the
about.
colder it is, if you're saying
Listen,
7 degrees.
listen. Shush! Don't make me mute you. Just listen for a second. I'll explain to you. Right? I've read a lot of papers on this. I'm not just making this shit up. Right? So it's about the change in the refractive index. The refractive index is primarily controlled by temperature. Okay, so if you're shooting a laser through 7 degrees, right? That's uniform. Okay, 7 degrees below the laser, 7 degrees above the laser, right? Or if it's 30 degrees below the laser and 30 degrees above the laser, right? It's not going to bend because there's not a gradient. Okay, it's only going to bend if you have, say, 15 degrees below the laser and 20 degrees above the laser, right? That kind of thing. Or it could be -5 degrees below the laser and -5 degrees above the laser. It's not going to bend. It only bends when you have a change in the refractive index. So if you have a look in the side chat, Dr. John D took measurements of the temperature gradient. Okay. And the water was 7 degrees. Okay. The air temperature was also 7 degrees. And he took different heights, taking the temperature reading, right? And it's 7 degrees, at 0.8 meters, 7 degrees at 1.35 meters, 7 degrees at 1.78 meters, and the humidity was basically uniform as well. So you don't have the meteorological conditions for the refraction in this case.
Well, no, I do because it's cold. Like it's 7 degrees Celsius. That's like almost
Did you
freezing.
not hear? Can you
That's
repeat?
dense air.
Can you still man what I just told you?
Do you think cold air? Do you think the colder the do you think that like okay, let's just assume that like you're a
No, no, no.
single cold mass of
Hey,
air. Does the light
hey,
travel in a
did you
straight
listen to
line?
anything? Did you just listen to anything I just told you?
Yes, I did. I was obviously listening.
Okay, what did I tell you?
Dude, I'm not gonna fucking repeat everything, but you ended with these readings of 7
No, no, no.
degrees
What did I
Celsius,
tell you about
8
what
degrees
causes?
Celsius, 8 degrees Celsius, and then it was 9 degrees Celsius. So that's a gradient of 7.5 above the water, which is the coldest. And then as you go up, the temperature increases. It goes to
Yeah, I
9
don't know if you
degrees.
heard what DJ said.
That's that's a change of 3 degrees, dude.
Can I?
Where
How
does
is
it
that not a
change? Where does
gradient?
it?
I'm sorry.
How is that
Where
not a
does it say
gradient?
3 degrees? Where does it say 3 degrees in anywhere in this chart? Where does it say
Wording.
that there was a 3-degree change?
Because it says in the water, invalid, apparently. Above water, 7.5 degrees. 0.5, less than 8 degrees or something like that. Greater than 7.5. So what is that? 7.8. So there's the gradient. So we're
Yeah,
we're
but
going up,
the
we're ticking
laser.
up by
Okay, the laser
0.1
is
degrees, and
placed.
then
The laser's
as we
placed
go
at the
up,
1 meter height.
point, another point. So we're going from 7.6 to 7.7 to 7.8. Oh, but it's 9 degrees. So now we'd have to do the
Doesn't say
algebra.
anything about 7.6 or
Oh my god.
7.7.
Dude, this is
Right. So the
hilarious. I
later,
love this is
dude,
like you're
shut
trying to
up,
use
shut up, shut up. Right. So the laser was placed at 1 meter. Right. So at 1 meter, we have a uniform. Right. So at half a meter, it's 7.5 degrees. At 1 meter, it's 7.5 degrees, and at 1.5 meter, it's 7.5 degrees. Right. It's exactly the same. Now at point B, right, at 0.8 meters, it's 7 degrees. Right, at 1.35 meters, it's 7 degrees, and at 1.78 meters, it's 7 degrees. So there's nothing there that would cause the laser to bend, right? And in the footage, we can see that the laser isn't bending as well, right? We can see the laser going the entire way across. Here's some pictures of it. Now, if the laser were to bend, it wouldn't hit the target, right? If it were to bend down, it would hit the water. If it were to bend up, it would go way over the top of the laser, of the target. So yeah, dude, you're just pathetic at this point.
I'm ready to talk about the first tile. I want to talk about how it says 7.5 / greater than 7.0 above the water. And then does that make the medium? So because I mean these numbers are so like why don't they just put the accurate, like why is it like all these greater than less than numbers? Why don't they just put the fucking temperature? Why is it greater than 9? So like I can do the math if you want me to, but right now it is showing me that it goes up approximately 0.5 degrees for every meter that you go above the water. Because when you say greater than 8, but less than 7.5,
the section of air that the laser's going through is uniform.
It says 9.0.
Because the laser's out.
I'm sorry.
Where does it say 9.0?
So where is that? What is the 9.0 at 2 meters? A height of 2 meters. The temperature is 9 degrees, or it's greater than 8.5 degrees. So that's a jump in almost at the very greater than 8 degrees and less than 9 degrees.
Right,
that's a
but
gradient.
At the height,
is that not a gradient
at
to
the
you?
height at the height that the laser was at, above and below the laser was the same temperature.
Okay, I want to understand why you're saying that.
Okay,
You're saying the height
see
of
the
the
1.0. So at the 1 meter, so the laser was 1 meter height, right? Right.
Okay.
So just right. So half a meter
you guys
below.
Didn't do 2 meters with the laser?
No, they did 1 meter, they did 0.7 meters, and they did 0.15 meters.
With the laser?
With the laser, yeah, with 3 different lasers, both ways.
Why didn't they do 2 meters?
Because when you get it down lower to the surface, right, there should be more curvature obstructing the laser.
Yeah, that does do that.
That in the test,
Yeah,
they
you
put it
can't
all
see
the
it
way down.
closer to the
They
ground.
put
you
it
can't see
down.
further.
Okay, so they put it down to 0.15 centimeters, right? 6 inches above the surface of the water, and they hit the target directly, right? There should have been a huge mound of physical Earth curvature in between point A and point B. So if the laser were to bend down, right? So for that to work on a globe, you would need extreme refraction, which is extreme downward bending light. If the laser was only 6 inches above the surface of the water and you had the light extremely bending downward, then it would just hit the water. It wouldn't hit the target because of the Earth curvature. If the laser was bending upward, huh?
It's a laser. Why would it hit the? Why would it curve down into the water?
Exactly.
Do you think lasers don't curve?
It would just. No, it would just only travel as far as. Like what? I'm sorry, I'm not understanding.
What do you think light
I
bending
understand
downward would do?
Like, there's two questions I have. Is like, why are you right against the ground?
Does light bend down or not?
Yeah, it does.
Okay, then why didn't the laser bend down?
It did.
Why didn't it? Then it would have hit the water.
Then it would have hit the
it
water.
bent down.
Yeah.
No, it bent.
It's like, come on,
down.
man. Come
No,
on,
it would have went. It would have went over the water and then bent down to hit the other side.
So it would have gone up
Nice
and then down.
Why would it go
up and then down, or what?
Over. No,
yeah, the laser is on a roller coaster. It's at fucking Kindakai at Six Flags.
Yeah, it would go over the surface as long as you keep it level.
Just because I think I'm on a ball, the laser
wouldn't really matter because the water is level, so I can see why it wouldn't hit the water.
But clearly, that's not what you see. Like, you don't see the laser bending.
Are you saying the laser's getting blocked?
No, it's not getting blocked, but it would if it was bending down due to refraction because you're assuming you're on a ball.
Oh no, it's uniform across the cold because like you're using the cold air as a high refractive. Cold air just has a high refractive index because it's like cold air is more dense than warm air. So if you're using cold air to shoot your laser, you're gonna bend it more because it's gonna hit more air molecules.
So that's where you're wrong.
How?
I wanted to explain this earlier. It's just you just got to give me a minute to break it down for you, because I want you to understand this. It's just I don't want to mess this up and be interrupted. But like if I have like a tank full of hot air, tank full of cold air, if the air in the tank is just consistently warm, like there is no change in temperature within it, the light's not going to bend. There is no change in the medium to bend it. The only bend is going to be like from outside the fish tank when it hits the glass and when it enters the medium of the hot air, and then until it exits the fish tank, it's never bending again. You understand that, right?
I disagree.
So what's causing it to bend if the medium is consistent?
The air is making it.
How about he validates that it's bending downwards in the first place? That'd be great.
The air is refracting.
He's still got to present lasers bending down in the first place. If he wants to attribute refraction to that bending, that's on him.
Well, that's the light.
But he still has to prove that it's bending. You don't do it in reverse. You don't say, hey, there is refraction, so therefore the lasers are bending. Nah, girlfriend. How about you show us the lasers bending first, and then we can use the scientific method and adjudicate the cause and effect relationship of said bending.
So I understand that we're like arguing over whether or not air or the light is going directly straight through air or if it's bending.
No, we're not arguing. You're about to present to us lasers bending down via one of these long-range tests, 10 or 20 miles.
Because refraction.
Yeah, hold on just a second, Matrix. Hold on just 1 second, right? Because we've been trying to get this one thing through to him and have him admit it because it's correct, right? So just quickly, Talon, we need you to understand this, right? So Jesse was just trying to explain to you, right? Let's say you had a tank of air and you're shooting a laser through it and it's warm air. It's 30 degrees Celsius. It doesn't change in temperature. It's all 30 degrees. You shoot the laser through it. The laser's not going to bend at all. Now, if we cool that air down, right, and it's all 7 degrees Celsius instead of 30, now it's much cooler. And it's all 7 degrees now instead of 30 degrees. the laser's still going to be going in a perfect straight line. It's not going to start bending just because you cooled the air down.
Exactly.
It's going to have a
Thank you.
higher
Yep.
refractive index.
No.
It bends more.
No, it's
So-
a change. You need a change in density. The change in density reduces the speed of light. So once it hits the fish tank, that's when the path of light changes. Not as it's traveling through the air and the air is hot, therefore the light's going to bend. That's not how that
It's
works.
going to keep hitting cold air, right?
That's really not how that works, bro. I'm sorry.
It's going to travel through cold air.
Listen,
Light
Talon.
traveling through cold
Listen,
air.
Talon. Listen. This is what it would do. Okay, right? I'll throw you a bone here. You are partially correct. Okay, so what would happen would be that the refractive index in the 30-degree air would be something like 0.000027 or something like that. Maybe 17. It doesn't matter, right? But just listen to the point, right? If you put it now to 7 degrees, it has a slightly higher refractive index. By now it'll be like 0.000029 or something like that, right? It would just be slightly more dense, so that the light would travel slightly slower through it, but it would still go in a perfect straight line. The only way it would deviate is if you have a change in the refractive index. Vertically, if you have a vertical change in the refractive index, then the light will bend towards the cooler portion of the medium, away from the warmer portion of the medium. Do you agree?
Hold on, wait a minute. I didn't hear all of that, but I'll say yes.
All right, all yours, Matrix. I'm done with this guy.
Sorry, I just want to know if, like how we're thinking about refraction.
The problem is,
I would love to say something about that. Okay, go ahead.
Oh, Shiny, go for it.
Yeah, so I wanted to give him like a story from a surveyor, right? So this is the truth, man. At night, they say that the light is more bent. They say at night that because like the air cools and reaches like an ambient condition, that the light bends more, right? That's how they choose to interpret it because they're on a ball, right? At night, things are lifted so high that they say that it's being refracted more because of the cold air. But the truth is that I'm telling you, the truth is that ambient condition is actually making it be so there are less changes in the medium. Like you're getting a consistent layer of a gradient now because the sun isn't creating like turbulence in the air. So what happens is at night, there's no sun, the air cools down, your ambient condition creates a consistent medium, right? So in my opinion, this means that the light is not going to bend. The globe, you make the observation at night, things are way like off from the globe prediction. Like there's like way too much vertical displacement. So they have to say, oh, the air got colder, so light is bending more. But then during the day, the sun comes out, heats up the air, and this causes
air. There's less air to refract. It's less dense.
But now you understand what's going on. Now you hear what I'm saying. There's two ways to interpret the observation.
I know, yeah, we're agree. I think you guys understand refraction, but you're not really like. It's kind of weird how, we don't like.
So in the globe model, you have to say that the light is bending a lot more, and in the flat Earth model, you would say that the light is unbending a little bit. See how that works?
Why do you think light's bending?
Light does
change of index. It has to change its refractive index. If the light follows one index and does not go into another, there is no reason for it to bend. So you seem to think light following picking a random number, a 20-degree temperature gradient consistently will bend it. This is false.
Right.
If it went 20, 19, 18, 17, then at the joins of each of those, it will bend towards the more denser. Yeah?
So does it slow down? So is the denser air slow
yes or no?
the light down?
Yes
does
or
the light
no?
slow down or speed up?
Go back. Yes or no? I need to know your tracking.
Oh my God. Like,
I don't
even... He's not going to help you. I asked you a question. I gave you a statement. Do you understand that light traveling through one straight singular temperature will not bend. It is when there's joining different densities. That's what is the causational mechanism. You do comprehend that, yes?
Is that what air is, though? Is air
You do comprehend that it has to be a change. You're claiming light is bending via magic. You need that index to change. If it doesn't change, the light won't.
So wait a minute. We're shooting a laser, okay? That laser is going through cold air. That air is very
It doesn't
dense.
matter what. Okay, just pick a number. Is the air the same temperature the whole way across? Yes or no?
Yes, 7
Excellent.
degrees.
The light will not bend.
What do you mean it doesn't bend? It's cold.
It's not to do with the temperature.
It's a higher refractive
Listen
index.
carefully. Yep, that's great. What has to happen is there has to be a change. Talon, stop talking. There has to be a change in index, not just a constant index. There's a difference. You seem to believe a constant index will perform an event. There has to be a change in index.
No, I like how you guys misunderstand this because you're thinking that like once it's
That's not a misunderstanding.
like
You're the one that's
atmosphere is a single
misunderstood, Talon.
temperature.
Talon, go and look it up, mate, before
Like
you make yourself look like a clown.
A mass of air is not a single temperature. It's actually like a mixture of temperatures.
You just claimed it was. In the example you gave, you just said it was. I answered as per your claim. 7 degrees.
Air has high refractive index.
Yes, a singular temperature will not have a problem. The light will go straight. When you are passing through, yeah, that's great. So this is why you don't have trouble understanding, is because you have the necessity to talk through the answer. When you have a change of temperature, that's when the fun starts.
Wait, brother, you too close to the mic. You got to back up from the mic.
No, this is normal, bro.
Okay, I got you.
Yeah,
So
it's a change in the it's the change in the medium that reduces the speed of light. Right? You can't just change the angle that the light is traveling in when it's not changing medium. What's going to cause the path of light to change when the medium's the same? The answer is nothing.
No, if the medium
you don't
is
have
cold,
a change in temperature, if you don't have a change in anything, then you don't have a change
it's
in the
not
path
just to
of light.
do with the straight hot or cold medium. Get that stupid idea out of your head. You have to have the light passing from hot temperature to cold temperature. That's what causes it.
Yeah. We have to figure out a way that we have to reconcile. This is a reconciliation point.
No, this is no reconciliation. This is
just
you need to do some
Google
thinking.
it point. Yeah, you got to Google it.
I want to go over this again. You're saying that
how about I say it like this, Talon? Shut up. Talon, zip it. How about I say it like this? If you're going to claim the lasers are bending down, how about you demonstrate the lasers bending down? After you've done so, then and only then will we look at the causational mechanism of your laser bending down. If you wish to personally attribute refraction to this, we'll entertain your thoughts.
Yeah, the
refractive. And remember, in order to get your laser to bend,
it doesn't matter, Shawnee.
You got to use
right.
one.
So if I want the laser to
Shawnee,
bend
the problem is he is using it in reverse. He is saying refraction exists, therefore lasers bending downwards. That is bollocks. He has to demonstrate the lasers are bending downwards first. So then we can attribute a causational mechanism to it. He has not done this. All he's done is refraction, therefore lasers bending down, without showing the lasers bending down.
I'm telling you, if I want the laser to bend down, I would use cold air.
So go and show it then. Demonstrate your laser via a 10 or 20 mile test bending down. Video or photo evidence, I'm pretty sure the majority of the panel will be quite happy with that.
Showing you.
You're putting the cart before the horse, bro.
This is basic facts that we would use a higher. You would use a higher.
Yeah, that's great. You're squirting. You're putting the cart before the horse. How about you demonstrate the laser bending down, and then we will look into what the causational mechanism is.
Do we want to do that? Are you sure about that?
We're
You
waiting.
don't have enough. You don't have any example because that doesn't happen in reality, bro. Can we just move on?
Knowledge
And can you stop
calculated it
claiming
for you
that?
guys. Knowledge actually did the refraction corrections on your.
Yeah, but knowledge hasn't demonstrated lasers bending down either.
Yeah, he
He's
did.
just a
It was
poor little boy
7.6 meters.
clinging to hopes and dreams.
Dude, it
Knowledge
was
is
awesome.
completely
It was so,
retarded.
it was super cool because you guys never actually calculate. I was always wondering like what the laser corrections were for refraction, but I understand now that just because it's
Yeah, that's
really
great.
cold.
Non sequitur. How about you demonstrate your lasers bending downwards, please? 10 mile, 20 mile test. I'm good. Either one, I'm happy.
Because
You
the
demonstrate
higher,
it bending downwards, and then we'll discuss what the reason it bends downwards is.
I mean, it's like 9 o'clock at night, dude. That's a stupid ass question.
No, it's not.
That's a you problem.
Question. Yo, Matrix. Dude, do you understand, like, when you fire a laser horizontally through the layer of gradient, you're in your Earth's surface. That in what you're saying, what you're chanting over and over again, that the laser would bend down. Do you understand that?
You think it's just
What
going to
you're
bend
saying
once?
happens on the globe model
You think it's just going to
would
bend
cause
one
laser
time and then
lights
go
to
straight?
bend down over distance
So when
and
it
then
hits
crash into
cold
the
air,
surface.
so when light hits cold air, what happens to it?
What the fuck?
If it's already in the cold air, fuck all.
When light is traveling through cold air, is it refracting higher or lower?
It's not.
Is it refracting?
Because it hasn't changed temperature. This is where you're coming unstuck. You seem to believe just because cold air has a higher refractive index, therefore laser will bend in cold air. This is a false. This is wrong. You are incorrect. It needs to change temperature. So where is it changing temperature? From warm to cold.
Well, this is a reconciliation point. You're making a claim.
No, you are. You're telling us refraction happens, light bends in perfectly stable air temperatures, i.e. cold.
A lake is not perfectly
But
stable.
Matrix, did you hear what I was saying before about how at night, you know, they say when they make observations at night that it's vertically displaced even more from the globe calculation because cold air makes light bend more, right? But if the condition of the atmosphere is ambient and there aren't turbulent conditions and you don't have a bunch of differences in temperature throughout that layer of the gradient, then you're actually getting less refraction at night. And what do you know? It matches the flat Earth prediction at night. But he doesn't want to
See, what
comprehend
he's
that.
arguing for, Shiny, he's arguing for refraction. Now, let's have it out. I've got no problem with refraction. There is very specific laws that dictate and you can calculate which way the light's going to bend and how much it's going to bend. Like Snell's law, for example. We don't have a problem with this, Talon. Nobody in here disagrees with refraction. But here's the kicker. We're not arguing refraction. You're arguing that lasers bend downwards. We would like a demonstration of this to back up your claim.
Okay. So we do agree that the refractive index shows that.
Not interested.
What do you mean?
Red herring. No, red herring. You need to demonstrate over a long distance test, lasers bending downwards.
Would be higher under colder or warmer temperatures.
Demonstration, please.
Like it wouldn't. Would you want if you wanted to
Talon, you're out of cards, mate. You have to put up a demonstration now. Your yapping won't do anything for you.
Timbo, come on. Wait, no, I'm sorry. Oh, Matrix, you're the one who's fucking doing the stupid show me script.
You're the one making the claim that lasers are bending downwards. I have no issue about your claim. I would like you to back it. So please demonstrate via photo or film a demonstration of laser bending down over one of these long-range tests.
I will say that time is becoming a factor, Talon. Like,
you're
gonna sit here and dance around the topic, man. Like, we are all at the same conclusion.
I mean, you guys are now just
except
asking
you.
you're doing the stupid. I'm gonna mute.
No, we're just asking you to back your claim. That's all. Nothing more.
No, I mean, you guys keep admitting that cold air, the light bends more in cold air, so that's where the W is happening.
No, I just
there's no W.
I literally just explained why that's not the case. I said that at night, the ambient condition creates consistent temperature through the layer of the gradient that you're making the observation through. You're making a lateral out. Your eye level is going horizontally through the gradient. You're parallel to the surface. Yo,
hey,
dude,
Shiny, check it out.
I want this to understand this. All right, go
FE
ahead. Oh, you're
Core.
talking to me?
FE Core, when they did their multi-stage test over Lake Isle and a few of the others, one of them, the temperatures were like 1 and 2 degrees. I would consider that pretty cold.
Consistent temperature through the way
the
of the
refraction.
gradient that you're making the observation.
FE Core, Lake Isle
I'm
and a few
using
of the
wait a
others,
minute.
one of them, the temperatures were like 1 and 2 degrees. I would consider that pretty cold.
Consistent temperature through the way
the
of the
refraction.
gradient that
Knowledge did it. This is what I was talking about with Knowledge. He's the one who showed you guys the refractive.
He didn't show shit. He's calculating something that he can't validate in the first place, Helen. Are you that dense?
Matrix, you fucking. I'm like hitting my limit with you. You're out of time on my patience.
Yeah, you're an idiot.
You want to have like a
you're
real
out
talk?
of patience with me because you're yet to provide and back up your claim. That's all I'm asking you to do. Back up your claim.
Or we can have a real talk, or you can bully me. But you're below me if you think that you can just push me around with.
Yeah, we've been having a real talk, but you keep sticking to a claim that you have no evidence of. So if you could just concede you don't have evidence, we'll move on.
Well, yeah, I do have evidence. The cold air.
No, you don't have evidence.
Provide it.
Bending down. No one's
Provide your laser bending down for your long-range test.
You just said, yeah, we do have that. Please provide it, dude.
We'll keep going over it because it's very simple. If everybody's agreeing that the refractive
no one's
index
agreeing
is
with
higher,
you. You've fucked up, Talon. You're an idiot.
Matrix, you're trying to bully me, but I'm Gold Jesus. You can't handle me. So you're going to either have to. You're not.
You are not Gold Jesus. You're a numpty. You have to provide a demonstration of what you're claiming is happening. You are claiming lasers are bending downwards. I've got no issues with your claim. I would like a demonstration of said claim. Once you've demonstrated that these lasers are bending downwards, you can then attribute whatever causational mechanism you want. Hot air, cold air, no air, snow. I don't really care. You could probably throw gravity at it, maybe even refraction. I'm not interested in your acclaimed causational mechanism. I'm more interested in you demonstrating the fact in the first place. So, Talon, now it's on you to back up your claims. You want your lasers bending down? Please provide either photo or video evidence of said claim over a long-range laser test. There's plenty to choose from. If you ask DJ nicely, he'll probably put about 10 of them in the side chat, and you can pick your poison. But don't come in here and tell the mods what to do or how to do it. That will not come out good for you.
The muting me just makes me look more right, dude. This is why I'm.
It makes you look like you're an idiot.
You're like everybody. We've been having a nice discussion.
Provide your test, Talon.
We've been having a nice
discussion.
You're at the
end of the wall now.
We've been having a nice discussion for an hour and a half. You're destroying it.
No, you're going around in circles for an hour and a half. There's a difference.
I kind of got to agree with Matrix, dude. Like, yeah, we're talking to you.
We've had a normal conversation. We haven't need to demonstrate each other's fucking dicks. This isn't some fucking dick measuring contest. But you're a baby.
Well, I'm just saying, like, we really.
If you guys want to call it, then just say no. Just say you want to move on. Just say you want to move on. If you're not ready to have a good discussion.
No, this is his coping mechanism, and this is his reverse burden. He wants you to move on so he can get out of it. He knows he's got nothing left.
I'm ready to have a discussion with Shiny. I'll talk to DJ.
I know.
I'll talk to you, Shiny. It's fine. I mean, I don't know what Matrix is doing.
Objection, Your Honor. Talon is tone policing. He's evading providing evidence of his claim that lasers bend down.
High refractive index.
Dude, you said lasers bend down. You said
cold air has a high refractive index than warmer air. That's the evidence.
Can you get the example of lasers bending down so we can just and you can see it or something, bro? Because you're just wrong.
How about we just put him on mute for a second so he doesn't interrupt because he's a clown? In one of the Lake Isle tests, I think it was the Lake Isle one, the actual index was bending upwards. It was going the wrong way.
Yeah, that's what I was. The whole time I'm thinking lasers actually.
The temperatures there during that test were very cold. So him claiming cold temperatures cause light to bend down, this is false because it was demonstrated and calculated in the tests that was wrong. So Talon, you have to learn that you've made a little mistake, bro. Cop it on the chin, deal with it, and show us your demonstrations of these bullshit lights bending downwards. If anyone else wants to take it up, pin his feet to the ground until he coughs up.
So I mean, he has one trick. He just threatens to mute me and then says I can't demonstrate.
You have one trick, Talon. You're a slimy little weasel. You always have been. You've never backed a claim yet.
Demonstrate. What do you mean? What is demonstrating, Matrix?
You are demonstrating the claim of your lasers bending downwards over long range.
No. How do you demonstrate something, Matrix?
By showing us either video or photographic evidence, as I asked for earlier.
No, that's a citation. I'm not. I don't have. I just
no.
knowledge.
I didn't ask for a citation. If I wanted a citation, I would have said, "Please provide a citation." I was after demonstration of your claim. Your claim is lasers bending downwards. So over these long-range laser tests, I just want you to demonstrate that this is actually happening.
Wait, how would you even like demonstrate a lasers bending downward at this point in a Discord server?
Take a photo of the bastard.
Like you guys have your own videos. Just post all the videos that you guys got of the lasers bending downward over lakes and stuff.
Well, they're not bending downwards, bro. That's something you've got to come to grips with.
No, that's the best part about this, is that you guys, your own evidence is just lasers bending downward through cold ass air.
Yeah, so look, we have countless amounts of videos. We have countless amounts of videos, right? Dozens and dozens of videos of laser transits. 0 of them show the laser bending down. Some of them occasionally show the laser bending upward, right? Dr. John D, who's done 350 plus hours of laser tests, he said that over the years that he's been doing the laser test, he's never seen the laser bending downward, not once. No globe earther has been able to present us a laser bending downward. We can show you a laser going straight, we can show you a laser bending upward, but you'll never show us a video of a laser bending downward over a long distance, over water or land. We haven't been able to find it, but it would have to happen 100% of the time that we do our observations for the laser to hit the target. Even if the air is cold or lower down, it doesn't.
I appreciate the laser tests, because I mean, I understand that you're attempting to make direct measurements, but you haven't corrected for refraction.
Yeah, he did. He took into account what causes refraction. Okay, and if you don't have a change in the density gradient, the optical density gradient, then the light's not going to bend, right? You would need to have an extreme change for this to work on a globe. You would need extreme refraction.
Oh, that's so bad though, because it, like, when you send it through, like, okay, this is the reconciliation point. Like, you guys think that cold air, the light doesn't bend, and then in hot air it doesn't bend.
No.
Let me finish.
You guys only think you're trying to say what we said.
Wait a minute. Well, let me finish. I'm gonna finish my point. You guys, I'm not really trying to steelman you. I'm just trying to understand. You're saying that light only bends when it travels through a medium that is a different temperature than the medium that it traveled to previously.
Yes.
Okay.
Good job.
Yep. That's what I've always understood, but you guys keep attacking me like I didn't understand, and I do understand.
Right. So if it's 7 degrees above the laser and 7 degrees below the laser's not going to bend as it travels through that, because there isn't a gradient for it to cause it to bend.
No, it's the atmosphere itself. The atmosphere itself is the fucking problem.
I want so badly for you to understand.
The atmosphere itself is going to make it bend more, because as it travels through cold air, it's going to travel through cold air again and again and again, and it's going to have a harder time each time as it slows down.
What would cause it to bend down?
Slow down because it's denser. The air is more dense. The air is a higher density.
What would cause it to bend down? What would cause it to bend down?
The air is cold.
It's cold above the laser and it's cold below the laser. Why would it bend downward?
It's cold the whole time.
Right. So why would it bend in a downward direction?
Because it's slowing down because it's a higher density.
Well, why would that cause it to bend down?
Because it's slowing down.
Slowing down doesn't. Why would that cause it to bend down? Just because it's slowing. Just because it wouldn't be slowing down. It would be going the same speed, right? If it's all 7 degrees, it's not going to start bending down.
Yeah, it is. It's 7
not.
degrees.
Look,
so you're going
I'm
to have a
going
lot
to,
of atmosphere to constantly have to deal with.
dude. Look, I wish you would get this right. If there was any atmospheric expert right in here that even was a globe earther, he would not agree with you right now. Look, here's a 6-mile laser test with a side view in the side chat. Okay, this is way less than 7 degrees. This is done in Alaska over a frozen lake. This laser's only 3 foot above the surface. It doesn't bend at all. It's completely straight.
No, I'm pretty sure it's.
Look at the image. Look at the image. Zoom in on it.
You understand that we see further at night. You understand that, right, Talon?
You think it's further at night?
Yeah, like if we're on a ball, like we see observations that should be obstructed by Earth curve at night. This is what they say is going on. I tried to explain this before, and then you pretend like you don't care. But this is really important.
Well, no,
surveyors typically take their observation like in the middle of the afternoon, like solar noon, when the sun has already like created turbulent conditions all morning. So this is what I'm saying. When the sun rises, this is when the air is subject to the most temperature differentials. This is when you're going to have the greatest lapse rate, you're going to have the greatest humidity, and then as the sun remains in the sky throughout the day, those conditions start to settle and become more ambient. It's more turbulent when it's going from cold to hot, right? And then,
yeah, we all agree.
Right. Okay, so check this out. So the observations that they make at night, you see too far. They say that light is bending down, making things appear higher due to atmospheric refraction. That's the claim, if you believe in a ball, that things are being lifted up because light is bending down.
You lost me at if I believe in a ball.
No, this is not. What did you say?
You lost me at if I believe in a ball.
I lost you? I'm sorry. Okay.
You were talking. You were talking about refraction going upward.
Let me explain this part again for you. We were talking about how the only thing that causes the path of light to change is the difference in temperature. If the temperature is 70 degrees, when it's 69, the path of light is going to slow. It reduces speed, and that reduces the angle, and that displaces the apparent position from its from its actual. There's a physical position and there's an apparent position. When the temperature changes, right? So when it gets colder, we see the image get lifted up. Like literally, people set up cameras, like Andrew Thomas Young in San Diego. He set up cameras, and as the sun went down, the observations in the distance began to lift up. They were vertically displaced up as the sun went down, as the temperatures got colder. So there's two ways you can interpret this. Either the light is bending more, or it's unbending.
What?
There's literally two ways to interpret it. You understand that?
No, I don't understand.
Okay, I'm sorry. I tried.
No, I'm still. I'm still with you. I was just lost track of the light. Yeah, you were saying that light is bending up after sunset.
It's depressing that Hippo's got more of an attention span than this idiot.
I think he's wasting our time on purpose and rage baiting us.
I'm talking to Shiny. God damn, you guys are so mean.
You're not talking to Shiny.
What? This is a brand new. What I'm breaking down. This isn't something people are just. This is totally this is totally niche. So I'm
you're
not
talking about the Earth.
You're
talking about the warm air being against the Earth because the sun just went down, and so you can take all kinds of cool pictures because the warm air will.
I'm saying that the light is getting unbent at night because the sun warms up the air, creates a turbulent condition, and this bends the path of light more. During the day, we have sinking refraction. Light is bending up, making things in the distance appear lower. In the globe model, you say light is bending down, making things appear higher. I say at night, the ambient condition actually decreases the difference in medium, in the gradient. because the sun going down, it makes the air stabilize. The gradient stabilizes, becomes ambient, and you have a consistent temperature. And that's when we see too far. It's when the light is not being bent. When you don't have all these turbulent conditions and changes of temperature because the sun is out and you have steam, you have evaporation, you have refraction, you have right near the surface, you have sinking refraction. But at night, you don't. You have nothing. You have the straight through that cold air. And what do we see? We see too far. We see beyond the globe.
Under the solar death ray. But first, to illustrate the power of the solar death ray, I aimed the funneled sunlight at a rock, and the solar death ray immediately began to eat into it.
DJ.
The directed energy coming through the solar death ray caused the rock to splinter, and there were rock fragments flying all over the place. And watch what happened next. The solar death ray split the rock, so I was super curious what would happen to titanium, which is one of the toughest metals on Earth. I aimed the convergent sunlight at the small titanium cube, and it got really hot and really bright. Titanium can be dangerous and produce a lot of heat when it comes.
Hey.
TikToking.
Hey. Oh, is that coming through my microphone? Oh, sorry
yeah,
about
definitely. Okay.
Just learning about
really loud and
death
clear
rays.
too. The quality was.
Solar convergence. I love that guy. I love the death ray. I love the solar death ray.
Yeah, it's like my mic setup is like a virtual thing, so it plays it through. Good quality. Yep.
Are you an AI robot just TikToking?
Yeah.
So Talon, you hear what's going on there? Interpretation.
Okay, we got distracted by the solar death ray.
You need me to repeat it?
Yes.
Fuck me, dude.
DJ,
no,
I got no. Actually, I took a note. I took a quick note. I typed. Wait, what the fuck? Oh, actually, I typed a bunch of bullshit. Oh no, wait a minute. Where the fuck? Ambient condition increases the difference of refractive index. Something about
I'm saying at night when the air settles, you have less differentials in the temperature gradient. There is less changes in the medium, which means less refraction. At night, we see too far. That's when there's less refraction. During the day, there's more refraction. On the globe model, when during the day and things appear lower, the globe model says, oh, that's exactly what we're supposed to see. There's no refraction happening during the day in the globe model. That's fucking ridiculous. That is one of the most ridiculous things the globe claims. It's just what the fuck, man? Come on, get out of here. You're calling that ambient. You're calling that no change in the medium anywhere when you got the temperature gradient and the lapse rate and the wind and everything going on in the atmosphere. And you're like, yep, no refraction right there. I see it where it's supposed to be. And that's exactly what surveyors do. They go out at 12 p.m. and then they see a little bit of drop over distance, and then they jump in the air. Yoo-hoo! No refraction. It's exactly, and it's not even where the globe calculates. It's actually higher than where the globe calculates, at all times. There's never enough drop for the actual radius. That's the truth. Everything is always lifted. There's standard refraction. Atmospheric refraction is always vertically displacing the position of things in the distance, no matter the conditions of the atmosphere, no matter the time of day. Nothing fucking matters on your ball model what's happening in the sky. No matter what, the atmosphere is refracting things in the distance, no matter what is going on in the atmosphere. That's ad hoc pseudoscience. That's what that really is. And if you don't get that, then I don't know what the fuck you're doing here. You got to figure that part out, dude.
We don't have a mutual we need a mutual understanding. It's a reconciliation point. We have to reconcile our facts.
You got to catch that part. You got to catch what's go over your head, man.
That was a lot. That was a good gish gallop, though. I like it. I'm trying to stare at your name just so that way I can pay attention.
Is my mic okay?
It's not bad.
Don't let this one go over your head. In the globe model, light bends more at night. But because the sun goes down, you have less differences in temperature in the medium. You have an ambient condition, so light will bend less. You have less changes of medium, light will bend less.
What does that mean?
We see too far at night. Literally, that's the fact.
Where do we
The
see too
fact
far?
is,
Like, how are we seeing? What do you
if
mean
we're
too
on
far?
a globe, things are vertically displaced more at night. Like we see further, things are too high.
Tell
That's
me more
Andrew
about what
Thomas
you
Young.
mean.
That is a constantly referenced study by Globers. The Globers that give a fuck about this shit, they talk about Andrew Thomas Young. And he made the observations like as the sun goes down, things start to lift up. So what does that mean? Either the light is bending more, like you have more looming, or you just have the unbending of light. You get to pick your poison. And honestly, the globe is so fucking stupid. I don't know why you would drink that. Like that's some Kool-Aid shit, bro. What are you doing? So I actually would like to find this paper I keep referencing. I'm going to find this Andrew Thomas Young paper for you, and it's going to explain all the types of refraction if you really care.
It's just the different. Okay, so we know the difference between uniform air and changing air density with height or distance.
Mm-hmm. In the globe model, they say that distance is more refraction. Yep.
So the further the distance, the more the air density changes.
That's what the globe has to insert because the observations don't comport with the calculation. They insert their type of refraction that they would need if you're on a ball because you don't see what you should see if you were on a ball. Yeah, that's actually what's going on in the science. You know, you're reading it off the page right now. I hear you.
Okay. Well, wait a minute. You just said that the Globers do that, or so is that okay? Is that not okay?
I'm just saying that it's as simple as this. The observation does not match the globe calculation. It never does. It never will. In the globe model, it never can. You can never see things where they belong on a globe in the globe model because you always have your standard refraction. You know, it's always there, so you'll never see where things are predicted to be on a globe. And that's your model.
And yeah, my model's awesome. I have a cool, awesome globe model.
Yeah, I bet the model you're thinking of right now is actually not the globe model though. You're thinking of something else.
I'm thinking about. Well, I'm looking at the like air density and. Oh, we're trying to add the refractive index.
You understand the thing about like the two interpretations, either the light is bending more or less? You understand that part?
So if the refractive index is uniform, light travels in a straight line. If the refractive index changes from place to place, as it usually does in Earth's atmosphere due to temperature and pressure gradients, light follows a slightly curved path.
Yes. That's what we've been telling you this whole time.
Yeah, that's why I've been. But the in
Good job,
Earth's
Talon.
atmosphere,
I'm proud of you, man. See, you're
due to
catching it.
temperature. But
He's
wait a minute, the
catching it, bro.
second.
You
No,
hear
no,
it?
no. I've been telling you the second part. The temperature and pressure gradients curve the light, so you can
Right,
bend
but
it.
if
You
they
can shoot
if
it
they're
over
uniform,
You can
if they're
bend light.
uniform, yeah, if only if there's a change vertically in the
No.
temperature and pressure.
No, it changes it's changing through the atmosphere. Slightly. Depending on the temperature. Higher is for cold, lower
Yeah,
for
in
Right,
that
so
case, oh god, I'm
look,
gonna
if
have to
it's
go
the
through this
same
whole letter.
temperature, look for the 50th time.
Wait a
If it's
minute.
the
No,
same
for the
temperature
50th time.
above the laser, right? If it's the same temperature above the laser and below the laser, right? And where the laser's going through, it's not going to bend. If it's colder above the laser, the light's going to bend upward. If it's colder below the laser, then the light's going to bend downwards. If it's the same temperature above and below, the light's not going to bend at all.
And yeah, Talon, whatever you were reading,
Yeah,
like over
that's in
distance,
a
light
vacuum.
bends more.
That's in
Yeah,
a
you said
perfect
before.
No, in a
That's only
vacuum,
in a
it just
vacuum.
goes in a straight. No, in a vacuum, it goes in a straight line.
Right. In a perfect medium.
Yeah, or in a uniform medium, it also goes in a straight line.
But like a perfectly uniform glass does the same thing. It has a huge
Yeah, like or
refractive index.
water. If water is the same temperature, it's going to go in a straight line. And then if you add something to change the refractive index gradient, right?
But
Then it's going to bend
but like
downward.
as you travel through water, does the temperature stay the same or does it often change?
It depends. Depends on the conditions.
The distance.
No. If you've got a fish tank of water, it could all be the same temperature.
And then if you have an ocean,
it's going to get cooler as you go lower.
Well, yeah, there's no light. Can only travel so far as it's going down.
Mm-hmm.
So, like, what's the difference between a uniform medium and a non-uniform medium?
One of them's a gradient, and one of them doesn't have a gradient. It's
And which one is the atmosphere? Which one is the atmosphere?
Depends. You can have a uniform gradient in the. You can have a uniform refractive index in the atmosphere, or you can have a gradient depending on the conditions at the time.
No, I'm talking about the fucking Earth, dude. Like, do you think my shit?
Me
Do you think
too.
our shit is fucking? Dude, I live in Chicago. Do you think my fucking gradient's ever uniform?
No, okay, so the standard lapse rate, okay, the normal lapse rate, this is what happens in normal everyday conditions. I read this out earlier. Okay, I'll type it in again. Like, what is the normal lapse rate? Okay, and I'm going to read it out one more time. The normal lapse rate is the average rate in which air temperature drops as altitude increases. Okay, so temperature drops lower as altitude increases. So it's warmer down lower and cooler up higher.
So where do you think the light's going to go?
Towards the cooler air.
Right, and what happened? Where's the cooler air?
Higher.
Wait, where's the cooler air?
Higher.
Cooler.
Higher up.
Cooler.
Higher up.
Yeah, there's a temperature gradient.
Where does
Temperature
cooler air
decreases
go?
with altitude.
In a
Colder
gradient.
air is above.
When is this? When is this happening?
Temperature decreases with altitude. Colder air above hot air.
Holy shit. You think
normal?
Wait a minute.
The normal conditions in the atmosphere, right? So the normal lapse rate.
Like this like thick.
The normal lapse rate, right? In normal conditions, the lapse rate is the average rate in which air temperature drops as altitude increases. 6.5 degrees per kilometer. That's how much it drops on average per kilometer as you go up. Decreases.
Also, it's this whole time you keep saying the air refract, the air refract. It's the water molecules temperature in the air. They claim that it's the accumulation of water that refracts the light. It's not the air.
Well, that's when you do the laser test over the lake, which makes even more water vapor increases the refractive index, which makes it
water vapor decreases the refractive index.
Oh my god, are you serious?
Yeah, because water vapor molecules, right, are less dense by 40 to 60% than the dry air, nitrogen and oxygen. Less dense means lower refractive index. That's what that adds to the reason why we never see lasers bending downward, because you have more like wet air, they call it, lower to the surface because it's constantly evaporating. So that's lowering the refractive index. Even if the temperature's lower down there, it will lower the refractive index.
That's exactly what they say. They say the evaporation layer is causing the refraction of light.
Okay, I confirmed it. ChatGPT. The humid air is slightly lower refractive index.
Yeah.
Drier air. Okay. And so
therefore light bends up, making things appear lower because you have hot near the surface.
You had a relative, yeah. I mean,
you understand? Like, it's so simple, man. It's so simple. Warm air near the surface.
Yeah, I'm sorry. Why do you think
down. That's thinking refraction. Google all these things you're googling in this conversation. Google sinking refraction.
Humidity has a much smaller effect than temperature or pressure, though it can still matter for precision measurements.
Google sinking refraction.
All right, I did it. I'll read it out for him. All right, I wrote, what is sinking refraction? Sinking refraction is an optical effect where distant objects appear lower than normal or drop below the horizon. This happens because of changes in air temperature and density. So basically, it goes on to tell you that when you have a normal lapse rate or lower air, warmer air down lower and cooler air up higher, light will bend upward towards the cooler air, and that will make things look like they're sinking. So a ship might look like the bottom of the ship is missing behind the horizon.
Okay.
And it's not actually missing, it's just a refraction effect called sinking.
Very simple to understand. See,
Just
he gets it, bro.
The scientific term is refraction. Sinking makes no difference.
Oh, there's different types of refraction: sinking, looming, towering.
These are informal,
stooping?
not scientific.
That's the other one.
Stooping, yeah. And
yeah, then they got the
you got
mirages.
the main ones.
You got superior
So why
mirages,
is the air
inferior mirages.
Right, okay, so it is not the air sinking that bends the light. It is the density gradient created by the sinking or cooling air that changes the refractive index and causes refraction.
Yeah, temperature is the main thing that controls the refractive index.
So it's atmospheric for refraction caused by a vertical gradient in air density and therefore a refractive index.
Yes. There you
yeah.
go, man.
Okay.
There you go.
I'm glad we got somewhere.
Right, atmospheric refraction. That's
Yep.
what I liked. That's my point. That is my part of my facts and my.
So check this out. Now let's do a little backtrack. Right, the sun warms up the Earth. The sun warms up the Earth's surface, and then the air near the surface, that is the air that gets radiated first. It'll be the warmest air. That is where the light bends down, near the surface, and that's exactly where your line of sight is traveling. It's along the surface. So that's where things are going to bend down.
Hey, I'll show you something, Talon. Have a look in the side chat. Here's a cool little test. Right, so because this person's got, okay, so they've got this little object on the ground, right? So they've just got their flat floor in their house, and they've put this little object on the other side of the room. You can see the yellow at the bottom and the white bit at the top.
Oh,
now, if you have a look at the red thing on the left, they've got 4 different heights with the temperature reading. So if you have a look, we can see the yellow bit and the white bit. So we've got 19.7 degrees down close to the ground, and then 20 degrees up higher. All right, now what they do is they open the door, right? Because it's winter and it's really cold outside. So what they do is they let some air in, some cold air in from outside. All right, so here's the second image. Okay, now you'll see what happens is the bottom of the yellow thing, right, completely disappears behind the horizon, even though it's a flat floor, right? The bottom of it completely disappears. And now if we have a look at the temperature gauge, now we've got 17.4 degrees close to the ground, very warm, and we've got 10 degrees up higher, right? So the light that's bouncing off the object is bending upward, and it's making it look like the bottom of the object is sinking and missing behind the horizon, even though it's just a flat surface.
Thank you, DJ. Appreciate you.
Cool.
And thank you, Talon. This is a good convo.
All right, it's freaking 5 a.m. here.
Yeah,
My wife's going to give me a dirty look when I go slide into bed.
See if there's any other Globers. Any other Globers here? Have a good night.
Catch you guys later.
Have a good one, bro.
See, where's Lats? Lats isn't here.
Dude, there are no more Globers. You know why? Because that shit is stupid to believe in.
Aww. You guys kicked. Oh, it just sucks. He was being rude.
You know there's no globe. That's why there's no Globers.
I love globes.
But shout out to you, man. I'm trying to find the exact article Let me get this pulled up. Yeah, I got it right here. Boom. This guy thoroughly goes through different types of refraction. Really want to understand what I'm saying is what this guy fucking did. Right here. Boom.
Opening door. I just love how it's like. I just love some of their shit. It's so stupid.
But do you believe that it's possible to make something appear obstructed bottom up using refraction, like maybe just affecting the medium?
Understanding astronomical refraction. What is astronomical refraction?
Oh, maybe I need to find the exact article I was thinking of. Hold on.
Differentiating the radical.
Oh, yep. Sorry, wrong article. 1 second.
Really?
Andrew Thomas Young has a bunch of stuff. 1 second.
This is
I think usually the difference is distinguished by light that originates outside the atmosphere versus light that originates from within it.
T-dub.
Like, so, or not that has originated necessarily, but that is being affected by refraction within the atmosphere. So, like with your terrestrial refraction, where the light's, has a original source, but it's bouncing off things and then affected by the atmosphere, rather than entering through the atmosphere from the vacuum of space and being distorted at that point.
Where's this paper about refraction?
I'm not. You guys have been beautiful. Record Club Jesus loves, especially loves T-Dub the most. It's the most adorable one.
Oh, I found it. Yeah. Took me long enough. right, y'all. Good looking out.
So has it gone quiet in here, or something wrong with my? Okay.
there's a lot of it's made very beautiful. It's fun. Talking about his tackle session. That's Grandpa, almost moved out. That right there. Okay. It's fine. That's the law. If you have to take it,
Are you guys mentally sane today? Can I ask a question? Why do you trust your observation when it comes to no, why don't you trust your observation when it comes to observable curvature, but you rely on science to explain why we see curvature? For example, the boat experiment, where the boat goes, you know, like the hole disappears behind the horizon. Why do you then start bringing up atmospheric refraction and all that scientific stuff? Like, I think that you observe that it's flat, right? You say you observe that the Earth is flat, so you know it's flat, but you observe the curvature, and then you start talking about science. Why is that, fat cock? Anyone care to engage? Or am I too much for you guys? Hello?
My bad, bro. I was eating. I
Worm,
had no idea what you said. You said something about
are
people
you?
talking about like atmospheric refraction and shit.
No, your background's a bit loud, but are you a flat earther?
Um, no, not really. I'm like an
Oh,
earther. I believe it exists, but I don't know what it's shaped like.
I muted that person. Okay, so you're not a flat earther. Okay, W. Any flat earther cares to answer my question or rebuttal? AI
I don't know if
overlord.
I'm a flat earther. Honest, I could be. Do you think I should be a flat earther?
I mean, if you want to disbelieve science, then go ahead.
Well, I
But
don't really care too much about believing or disbelieving it, but do you think
okay,
it's
I
like a
respect
good
that.
way
Worm Wizard, let me give you a few thought-provoking questions.
to?
If
Okay.
the government was trying to hide the shape of the Earth, couldn't they just delete this chat and make sure no flat earther could speak?
Yeah.
Okay, let me ask you another question. If NASA is a government agency and the government prints money, why does NASA need to make money from lying to you about space? Does that make sense to you?
Yeah.
How does it make sense to you?
Because they're a propaganda tool and a media company in part, no?
No, I just brought up specific argument, the money argument that NASA, because a lot of these guys claim that NASA is making like billions of dollars lying to us about space. So I'm saying if they're a government agency and the government funds them, can't the government just give them money?
Yeah, but they have to have
But
the
what?
appearance of competence, no? Like Amtrak is a government program or like a government
No.
infrastructure.
You're missing the point. If the government and NASA are in cahoots on a grand conspiracy to lie to people, why does money need to change hands?
Probably to create a record of cooperation between these two entities.
Is that the best answer you can come up with?
No, but you would have to pay me to come up with a better answer.
Because there isn't a better answer. Anyways, any flat earther care to jump in? AI Overlord, I know you're ready to speak. Just speak. Okay, so I'll just entertain Worm for longer then. Okay, Worm, do you know a guy named David Weiss, a flat earther?
I've heard his name come up a few times, yeah, but I don't really remember.
So he's like the god of flat earth. Like when you Google flat earth, this guy pops up. He's been doing flat Earth since like 2012, right? And he told us, so he told us that if we go to Antarctica, the military will be there. It'll be a guided tour. You can't see anything. But if you were able to go there,
Yeah, actually, yeah, I went to Antarctica on like a research vessel like quite a while ago. I was
so
part of
yeah,
my university research, and yeah, that was pretty much exactly what it was.
yeah. So that wasn't the point. The point was he said there would be a military guided tour. We wouldn't be able to go there, anyways. So he proclaimed that if
Here, my speakers are bugging out on me. I'll be right back. I'll put you back on. My phone is always up on that dog shit. I don't know what the hell's going on. My fault.
why can't two people converse? Like, I don't get it. Thank you for the unmute, I guess. Yeah. So yeah, Wizard, this guy. Listen, bro, I get it. You believe everything's a straw man. Okay, we get it, Fire Judge. I mean, like, do you have any other like argument than saying straw man, fallacy, fallacy? Anyways, so
What?
Worm.
My bad, bro. My phone was bugging out. I didn't mean to leave on you like that.
No, you're good, bro. I was muted anyways because I was bringing up a crazy point to a person who's considering flat Earth, and they want you in their cult, so they don't want you to prove it. Anyways, David Weiss is the god of flat Earth, right? And he said that if we were to go to Antarctica and observe a 24-hour sun, the Earth has to be a sphere. It has to be a globe. So you understand me so far, right?
Yeah, I get what you mean.
So we did just that. And even after presented with the evidence of the 24-hour sun, instead of David Weiss changing his mind, he still is spewing flat Earth rhetoric online. Why do you think that is? Do you think that? Do you think that's a person looking for the truth or a person defending their identity or trying to make money?
It's definitely a bit of the second and the third here, but I don't know
Appreciate it.
I don't
I
know
appreciate it.
enough about flat Earth to debunk or vindicate his claims.
He's
But
not
I
a
think
flat Earth or flat Earth judge. He's undecided. So I don't see why you're lying. Yes, I just called you a liar, and you are, and you're a bully. Yeah, he's a fencer, and I'm getting him prepared to not enter your cult because flat Earth should be dead. Mm-hmm. So yeah, it's a bit of the second and the third. It's because he wants to make money and he's made flat Earth his identity. Is there a possible chance that that's what every single person in this chat is? A person controlling their identity? The answer is yes.
yeah, I mean that much is plain to see. Like obviously that's the purpose of this server.
So that would mean that flat Earth isn't a truth-seeking club. It's a what? It's religion. It's a religion, dude. Don't join it. Stay far away.
I mean, depends on the pay, I guess, and the other incentives.
Saying say it.
No.
Nah.
No. I don't.
Not
I
again.
know so. I know like some of the stuff he did. I read portion of his book, but it's like I guess like even though like that's like reinventing the wheel pretty much. Like reading his stuff is like the stuff we've come up with now is way more sophisticated than what he did. So it's like, why would I read him? It's like reading a caveman. It's like it makes no sense. Even though like he makes a lot of same arguments we did, but
Right.
he has some historical references like how far south you can see Polaris from. So he said it's been recorded to have been seen from I think 20 degrees south, which is pretty fucking far south.
Yeah, that's a bit far.
There should be a fucking 400-mile hill of water between him and Polaris.
Right. Yeah, a big giant hill. Yeah, of water. Not
So you think that he's archaic and like not as like advanced as like today, like as like your stuff today, basically? Would you say anything that
No, because he has observations and experiments. What like the equipment he used is, it's end of the 18th century equipment. They didn't have as good manufacturing processes, right? They didn't have instruments where they had as high levels of precision, right? Like that's what I'm saying. I'm not saying there's anything wrong with his methodology. It's his equipment that's ass. And that's just because of the time, right?
Right. And would you say anything that he said is wrong, or would you say like all of it's right?
I don't know. I haven't read enough of his shit to say if he said anything wrong ever. I'm sure there is some shit that's wrong.
Right. Got it. Just
I'd be quite shocked if he wrote a whole book and there wasn't one wrong thing in it.
Yeah, even if Indio wrote a book, there's going to be one wrong thing in it. I'm sure.
Yeah, I'd write the end, and it wouldn't be.
Yeah, it's not the end. Did anybody ever title the end of the book, "This is not the end"? I don't know. You should do that, Indio. Damn it.
This is the end. I used to call into this college radio station at like 5 minutes before they'd shut down and be like, play the Doors. Like, it's too long. It's a 12-minute fucking song. We can close in 5 minutes. Play it anyway.
You should write a book, though, honestly.
Yeah.
I got way more than a book. I got tens of thousands of audio hours. I have a whole plan, man. There's a plan. Don't worry.
10,000 hours of audio, man.
More than that.
So on the Flat Earth YouTube channel?
Yeah.
It's on there. It's around. You find it.
All over, man.
All over, bro.
Yeah, he sent me a big one, which is the CERN scientist.
Yeah, I did. You the good ones, bro.
That's not our channel. Our channel is 24/7 Flat Earth Discord.
Yeah.
Oh, right. But
there's like
what's
two
your
of those
comment?
channels.
But
and we
go ahead.
We have some simultaneous. Yeah, we have some we have like two 24/7 Flat Earth Discords because we also We haven't been back here in a while, but we also hang in what's called the English Hub, which is a server for people trying to learn English, the politics server, and the politics and religion server. We got guest rooms where we're like, okay, we're like the #1 channel in your freaking servers.
Yeah,
even more than your regular shit.
We go over there.
All that audio, we have audio going back like freaking probably like 7 years, 24/7, like literally. Like, okay, so someone like copyright struck the channel for a while, and when they copyright, all those videos are right now they're hidden, they're made private. When they copyright struck the channel, we were at like something like over 3,000 videos. We're on episode like 3,000 or something, and that was like 2 years ago now. So if we actually kept the count of episodes, we're probably at like episode fucking 4,300 maybe. So we're talking 24 hours. So 4,300 episodes, 12-hour episodes.
12-hour.
So like 2,000 days worth.
Yeah, easy, bro.
That's a lot.
Yeah, we're talking full days. When I say days, I mean the 24-hour day, not fucking daytime.
That's right. Somebody mentioned the other night, what's up with this stupid clock thing that goes from, it has, two 12 o'clocks and two 10 o'clocks and two 1 o'clocks. Who came up with that shit? And I was like, I never thought of it like that, because I have a 24-hour clock right in front of me, and it shows 24 hours. And it's like, why aren't all clocks 24 hours? And I thought it was a good question.
It could be.
It should be, right? I think that's there to confuse people, India.
Military clocks are.
Well, military is, but they're not confused. They just take orders and go. 1,300 hours, be here. Okay. They go. But everybody's clock should be 24-hour clock, man. It should be, what time is it in Australia right now? Hold on. It is, let me see. Gotta get a little closer, man. My eyesight's not what it used to be, bro. All right. Right here, right now, in Australia is, it's 18 o'clock. Yeah. The sun is
18
setting.
o'clock.
Yeah, it's 18, man. On a 24-hour clock, man. It's 18.
18 o'clock.
Right. Yeah, I know that sounds stupid, right?
6 p.m.
Yeah, where I'm at, it's 23:45, whatever that is.
23. So you're in California, the West.
Yeah, California. So it's 23. 11:45, right? But that's 23:45, man. Right? Isn't that the right time?
That's military time.
Yeah.
It's 2:48 a.m. for me.
So military time uses 24-hour clock.
It's 0-100 there.
So anyway.
Hey, give me some more shit if you want, dude. I'll drop a. So a lot of globalists don't like this fact is that the coordinate system, latitude and longitude, are not actually coordinates on the ground; that they're actually coordinates in the sky.
Good old Polaris.
Yeah, they don't like that. You can't, because it like, imagine like the whole world is cloudy. You don't know where you are. You're lost. How do you figure out where you are? You can't see the sky now. Think about it. How do you figure out where you are? Using just the ground. Using just the ground.
You have to know where the sun rises and sets, and you
gotta know what time it is.
And you gotta know what time it is. You gotta know what time it is.
You gotta know where the stars are.
Well,
otherwise you have no clue where you are. You're lost. You're completely lost. You can't figure out your latitude. There's no way to figure out your longitude. You need the sun for your longitude, and you need the celestial equator for your latitude. You can't see those two things, you're fucked.
Right.
Now, you could probably see the moon, and if you knew where the moon should be relative to the celestial equator, or where the sun should be relative to the celestial equator, you could probably figure out where your latitude is, but you certainly at least need the time. And that time comes from the sun. So if you can't see the sun, you're pretty much fucked.
But if you can just see when it starts getting daylight, you can guesstimate, about what time it is pretty easily, bro. And that's not difficult at all.
Depends on the time of year.
Yeah, of course. If it's winter or summer, but yeah, if
I find the sun rises and sets. It takes longer in the summer to rise and set. Like,
right. It takes much longer in the summer for sure. I love summer. Damn, good time of year. You guys enjoying your summer? I hope so. But
yeah.
It's 99 degrees today. In 2 days, they said it's gonna be 67.
Get out of here! No way.
Yeah, way.
Dude.
Yeah.
Okay, you got to report back and tell me that happened. I've lived in Vegas for 4 years, and we would get days like that. It'd be like 82, and the next day it'd be like 55, and you're like, "What the hell just happened, man?" Damn. So yeah, it happens. I'm not saying it don't.
I know. I'm gonna go from sweating balls in super humid 99-degree weather to fucking wearing an overcoat.
You got your freaking hoodie on. And you're like, what the hell?
Yeah, man.
Hey, 67's not that bad, bro. I mean, I can handle that.
Yeah, I know, but it's a change that makes it feel colder than it really is.
That's true. We get that a lot here in California. The sun goes down and it like temperature drops like 10 degrees an hour sometimes, and you're like,
"What you are all bitching about? Seriously,
damn, we're bitching."
At the moment, for me, it's 48.
48? Get out! No.
In Fahrenheit.
Celsius.
No, in Celsius, 9.
It's 11.
Oh, dude. Poor baby. You're cold in Australia for once.
It's funny. I've been here 20 years, and I still go by American. Like, oh yeah, it's summertime. It's really cold during the summer here.
So, like, when it gets super cold, you like put up your Christmas tree, like just keep the tradition.
That's the thing. Yeah, it's like California here, man. It's like, well, not really. It's like California in the summer here. Yeah. I mean, Christmas.
Coldest I've ever been, where I live, it got to -5 Celsius, which is 23 Fahrenheit. That's the coldest it's ever been here.
All right. That's pretty cold, but it's not like...
It didn't stay like that. It got that's what it got. It was like about 4 o'clock in the morning, 5 o'clock in the morning. That was it. All the rest of the time, it's normally on the positive side of.
It's well below freezing, man. Well below. Yeah. Fahrenheit.
India.
Summertime, she's normally about 42. And that's about 107 for you guys. That's pretty normal for us.
Yeah. Hey, we got a new cat up here named Cat. Super interesting guy, man. Got some good questions.
Yeah, I got a lot of questions.
You're looking at. He's been looking into it hard, man. And Indio's giving him some background stuff. I've given him some stuff.
Yeah, he's gotten a crash course.
Got a crash course in high-level PhD Earth physics, astronomy. Yeah, we're
crash
covering.
Course for most of the guys that come in here, it's their cognitive dissonance crashes head first into a brick wall.
Well, we're at a different level here, Matrix. We're at the PhD level, and he's getting it, man. He's like, okay, let me look at this, let me look at that, let me check it out. I'll get back to you. It's good stuff. Thanks, Kat.
I mean, are we still running the event? Oh yeah. So look at the event title, Matrix.
Globo Challenge, debunk or crash out. I reckon there would have been a few crash outs.
Yeah.
That's cruel. It's like
brutal, man. Well, welcome to Earth. We can check it out. Fire's hot. Airplanes fly flat and stationary. I talked to a bunch of pilots myself. Yep.
Really? You spoke to pilots about?
Yeah, I've talked to 15 pilots in the last 10 years. Every one of them say, "Yeah, man, we just treat the Earth's flat and stationary," and that's it.
Yeah, they have to, dude.
They have to.
It'd be impossible to fly.
In fact, the airplane manufacturers are all on the same plane because they, even in their own documents, they admit that all the calculations to construct this flying object, you have to use flat and stationary Earth in order to do it. Period. And there's like 28 documents we've run into, that I've run into over the years, that state that right there in the diagrams of the planes and like of the missiles and anything that flies on Earth. It has to treat the Earth's flat and stationary. Period. Otherwise, your calculations are fucked. You're done. You're toast. It's not going to work.
So did they use the azimuth? How do I say it? Azimuth projection, whatever it's called.
Equidistant map. There is a map that it's programmed into like commercial airline navigation systems that is a azimuthal equidistant map.
Yeah.
I forget the name of it.
They have flight charts.
Yeah.
And the flight charts, depending on where they're flying, they're kind of like made for their route. Planes don't really fly point to point. They have these things called flight corridors. So there's domestic and international flight corridors. When they fly someplace, they fly to the flight corridor and then fly within it to get to their destination. So, map, and they kind of don't use a map. I mean, I'm sure they could, but like, they're pretty much on autopilot.
Really?
Almost,
well,
yeah, almost literally.
You think about the guys that flew in like World War II or Vietnam, whatever. They didn't have the
The World War II map, World War II air route map is an AE map.
That's right.
You've seen it.
Mm-hmm.
Is a what map?
An AE map.
We just shorten azimuthal equidistance to AE.
Oh, okay, got you. I see what you're saying now. Yeah.
AE map.
AE map.
Yeah.
So they used AE maps during World War II.
Correct.
Damn.
Mm-hmm.
The evidence just keeps stacking.
It keeps stacking. It's called a preponderance of stacking at this point. Yeah.
Yeah, it just makes you wonder, like, why do they keep just trying to change that? Like, why just maintain this over and over? It's like it's a bit exhausting. It's like,
look in the chat.
Oh, there it is. That's the map. That's it. Is that it? That's it.
Yeah, that's it.
Yeesh.
Yeah, that's what they used. World War II, right there. Boom. That's the world in 1943, 1942. Yep.
Yeah, says polar azimuthal equidistant. Equidistant. How do you say it? Equidistant.
Equal distances. Equidistant.
Equidistant projection.
Yeah, but you have to remember that this isn't a map of the world. It's a projection of a coordinate system. And the system of coordinates is a celestial sphere. So they correlate the celestial sphere, which is also in motion, and the timings and all that shit. They correlate the positions to positions on the ground. So basically, say I'm at some latitude and longitude. Philadelphia is a good example. Someone brought up the other day. So it'll have a coordinate, and that coordinate says, by looking in the celestial navigation, the nautical almanac, it'll say, on this day, such and such a time, if you look up in the sky, you'll see a star in this position. And if you're somewhere else, you'll see that same star in this position. That's it. That's all it is. It's no more complicated than that.
Oh, okay.
angles to this star or that star angle, depending on where you are. You look
at a
up
certain time.
at certain time. You look up, see an angle to a certain star, and that's your position, right? Is that where we're going? Yep. And then we made the map from all that. From all of that, the map was made from different positions and angles. Is that where we're at, Indio?
Oh yeah, that's exactly where we're at.
Okay, just checking, just double check. I like to.
So what's the map of the Earth then? If that's the like
Depends on the
based on
purpose.
just seeing everything. I want to see everything.
That's a question from where?
From where?
The middle of the Earth.
You're gonna be New York.
I guess the middle of the Earth.
Middle Antarctica.
I don't even know where that is, bro.
Where the fuck's the middle of the Earth, bro?
Antarctica, I guess.
North Pole, Equator. I mean, where do you want to see it?
No, that would be the middle of the coordinate system. That wouldn't be the middle of the Earth.
Oh, ain't that something?
We're using the stars as the coordinate system, and if we center that at like what we think, wherever we think Polaris, what's under Polaris, that's our center.
Yeah, exactly.
That might not actually be true. That it is the actual center. The whole thing could be completely asymmetric. How the fuck do we know?
How could you possibly know? Right? I mean, there's no way to know that for sure.
And there's actually no evidence there's any place on Earth with Polaris directly above it.
That's a whole interesting phenomenon that nobody's been to the North Pole to shoot straight up and catch Polaris. Nobody.
Yeah, I told you guys. There's a National Geographic did a video. Like it's called like something like going to the North Pole at night or crossing the Arctic at night. They get to where they think the North Pole is. That's what their GPS says. 89.9 degrees. And they just happen to get there on the equinox, so they can't film any fucking stars. Bummer for them, right? They just get there on the fucking first day of daylight.
No.
Yeah, I'm dead up, bro. I'm dead serious, dude. They got there on the equinox, the first day of daylight at the North Pole.
Right.
How unlucky. Oh.
Yeah, how unlucky.
Those bastards, just horrible. It's horrible luck, man. It's horrible.
And they could have pointed their camera straight up and said, "We're right under the freaking North Star."
It's almost as interesting as NASA lost all the telemetry data for Apollo missions. You know, oops, my bad.
I see. So, show me some maps. Do you have any maps that you can show me? Because
well, I think that one that's in the chat right now.
Think about maps is that they're use specific. All maps are specific for what they're going to be used for. You couldn't navigate the Earth with just a map. Like, say you want to sail New York to Australia, how are you going to get there with a map?
I don't know. How would I?
You can't. It's not possible. You'd use celestial navigation, which we just covered.
Right.
You wouldn't use a map. You use the timing of stars when they're positioned in the sky. You'd use a sky map. And then you'd sail under some star.
And what about like?
Just for the record, they did this technique before a globe concept ever existed.
Right, and so how did like Christopher Columbus get to like how did he confuse like the Americas?
Well, he was lost. He was lost, and then he hit the Gulf Stream and smashed into Cuba. Well, that's what happened. Tell me that ain't what happened.
Tad.
He got lost, hit the Gulf Stream, and then smashed into Cuba.
Yep.
Well, he didn't smash into Cuba. And he almost died of starvation, and they had to help him out and give him a bunch of food so he could sail back. And he's like, Oh my God, there's so much shit to steal over there. Let's go back.
There's a bunch of cool stuff, man. They got like gold and silver, all kinds of cool stuff.
Yeah, they're just hiding all their gold, man. We know it's there.
I thought he sailed first to El Salvador or something like that.
Mr. Columbus was lost. He was using the wrong size globe. He was using Ptolemy's globe, which is 10% smaller than Eratosthenes' globe, and he was lost.
Oh, okay. And isn't it funny? Like the sailors had like fear of falling off the earth and stuff.
No, that's a myth, man. No one ever thought that.
That's a total troll. 100%. I mean,
that's your kindergarten. That's your kindergarten teacher trolling you, man.
Right.
There's no record of anybody ever thinking they were going to sail off the earth, ever.
Nobody ever said that in all of human history, except for some kind of manipulation of people's thought patterns or something. It had to be a psychological thing, man, at this point. It's like, hey, if you sail here, if it was flat, you'd just fall off, man. I've run into in India, Bong, you guys have all run into 100 people, 100 minimum, that have said that. Like, really? Where does that come from? It comes from when you were taught that about the globe in school. If the earth is flat, you'd fall off. That's it.
You know, it's ridiculous, man, because you'd fall off, and nobody's ever fallen off, so it's got to be ridiculous. They never tell you where you'd fall to. Like, where are you going to fall to, buddy?
Well, you're going to fall into the vacuum of space, Indio. I mean,
yeah, that's right. And then what?
And then
you sit there? Like, how far do you fall? You fall to the speed. Oh, you fall into a black hole, probably.
There you go. Fall into, like, the abyss.
You fall into like a black hole, and there's a black hole above the earth, and then you just spit out the other one, and then like keep falling forever.
Dude,
like Portal, like the video game Portal.
I wish we knew what we knew now, and we're in 5th grade talking to our astronomy teacher, or science teacher, whatever. All right, what are we falling off into, man? Where are we at?
Dude, I only had one science teacher that knew any science, to be honest.
What did he know?
He actually did experiments and shit. The rest of them were just clowns that read the textbook.
Oh, okay.
Going back to school, knowing what you know now, I can guarantee you every single one of you lot will get suspended for being a pain in the bum. Seriously.
Oh,
get
bro.
out of there.
I'll be expelled.
Be arrested. Out of there. Go and stand in the corridor.
Bong's right. Okay, Bong's right. Arrested. Okay, we're talking multiple felonies.
Federal charges.
Yeah, federal. Yeah, they're taking it federal, man.
How old are you? I'm 17. Not old enough. How old are you? What was the one 18-year-old in this school?
Yeah, it would. Dude, I wish we could just go back to 5th grade or 3rd grade or whatever right now. Damn.
Hey man, well, I'm getting ready to go to jail. I'm about to go talk to some, my peoples, the Samoans. I'm getting ready, for some kind of hostile reaction. Scary.
You think so?
I gotta do it. I know.
They're not gonna welcome you, man. They're not gonna welcome you with open arms.
I'm hoping they are. I'm hoping the old ignorant ones that would be hostile are too old or dead. And I'm hoping it's my peers that are left that'll be open minded enough to hear me out. Yeah.
Dude, I'll pray for you, man. Seriously.
I know. Thank you. Yeah.
No, actually, Bong, to be fair, I'm gonna pray for them.
Exactly. Exactly. They know not what they do. Or what they believe in. That's how. Yep.
Yeah, dude. No, everything we told you, you just barely scratched the surface. Because we can go on and on and on. living in salt flats, the Knickerbocker radar, the fucking airplane that flew fucking from Europe to Brazil and the stars didn't change. Like, there's so much shit, dude. We have endless amount of shit. Literally, endless.
Satelloons, I got that covered. I got Satelloons covered.
So the difference between flat Earth and the globe at this point is we have empirical evidence and they have TV shows. So really what it is, all they can ever say is, Dan, someone took pictures of the Earth, look at the screen. That's all they can do. And we say, yeah, we'll go outside and go find what's up, whatever is pictured on that screen, go actually find that outside. You can't. Go find that curving water outside, right? Because that's where it's a picture of you outside, right? And they take a picture of the Earth. That's the same Earth that's outside my house, right? So I'm gonna go out there. We'll see if they actually took a picture of what the fuck's out there.
Right, and I'm gonna ask you like one more. I'm generally just asking like for your commentary because like I look at the channels too. Like I'm not just like ignoring that, but like satellites, right? Is it a balloon that they attach and then like it like they like kind of LARP about it or and like use something else? Because reading this memes like satellite wreckages always come with the moon attached.
They admit without a doubt 100% that there are satellites on balloons.
Hello.
You can check it out. I've seen the launches. I've seen the crash landings.
There's also I'll post one in the chat, man.
Yeah. But yeah, satellites on balloons is not something that we just made up out of thin air and like all satellites are on balloons. That's, a bit of a stretch. But without a doubt, there's satellites on balloons, man.
Yeah.
And
obviously, we can't prove every freaking satellite is on a balloon, obviously.
The Samsung space selfie. Oh my goodness, Indio, tell them all about that one because that's my favorite, bro. That's my favorite.
Well, I got the Planet Veritas video, dude, where he has from the like I think it's the Finnish or no Dutch Space Launch Center, like their spreadsheet. That's all balloons.
Yeah, every one of them was balloons, right? Yeah,
every one of them, like 100 at least.
But yeah, the Samsung space selfie satellite balloon crash is in my favorite debunk of are satellites on balloons or not. Yeah, well, here's direct evidence.
So this guy that what I just posted, this guy, he's not around no more, Robert Bizzano. Hopefully he's still alive. But Planet Veritas is the name of the channel. And so in this live stream he did, he goes over classified documents out of Chile where they like a satellite supposedly crashed and it was just a fucking balloon. But the US but it was officially a US satellite. Okay? So that's one thing. Then he has like there was a National Reconnaissance Office. People that worked there that were old, right, and they're retiring. They did something called the Living Witness Program, where the people would recount what they did for the National Reconnaissance Office. And this guy caught balloons out of the air. And the terminology they used then and still used was these are satellites. That he was catching satellites out of the air. So they would fly these high altitude balloons. They would be at 120,000 feet. They'd float around, take pictures of the Soviet Union or whatever. And then when they came back around to like America or whatever, they would fly up with an airplane. They'd punch a code into their airplane and the balloon, they'd have an explosive charge that would pop the balloon and the gondola would start falling. They'd catch the gondola out of the air, reel it into the plane, and then land and then process the film and all that shit. Okay? And then the next piece is the spreadsheet of freaking all the balloon launches that they do at this. It was I think it's called Grange Space Launch Center. I think it's in Norway or the Netherlands or something.
Yeah,
part of the it's part of the ESU or something, or
Egrange.
ESA. Yeah, Grange or Egrange.
Yeah.
Yeah, so it's part of ESA. It's that's the European Space Agency, and they have a spreadsheet that he downloaded from their site, and it's all fucking balloons. And then the last part of the video, is them launching a balloon, launching a quote unquote satellite with 3 gigantic weather balloons.
Damn. All right. So
In fact, that in that thumbnail right there, that's a balloon. That was Project Echo or something like that, Echo 1.
And
that was supposedly a freaking Mylar balloon that they orbited with a 1,600-mile orbit around the Earth. Now, I don't fucking know how they did that. But whatever, dude. Orbiting balloons, bro, like that's crazy shit. And this is the first satellite they ever launched. Well, the first, Explorer was the first satellite, but this one was like the first satellite that was this was supposed to be a telecommunication satellite where they were gonna bounce radio waves off of it and communicate. Yeah.
Yep. Bounce the signals off of the balloon and communicate with it. How about that? Echo 1 and Echo 2. Check those out, man. Those are gems in my opinion. But Samsung, man, that's my favorite.
A lot of this shit ties into the military industrial complex. So the first communication satellite that wasn't like this, that was like a repeater satellite with hardware and shit, that got funded by Lyndon Baines Johnson, who was a Texas senator, right? So he forced a lot of crap through, because you gotta think, you have government funding these projects in certain states, right? And this is called pork barrel politics, where they try to get a project funded in their state. So Lyndon Baines Johnson, who became the president of the United States after Kennedy, whatever happened to him, advanced the space program. This was his thing, because all that shit's in Houston, Texas, right? NASA headquarters, Houston, Texas. All their shit was in Houston, Texas. So it's a big boondoggle, basically what it is. It's a grift. All this shit's a grift. That's all it is. It's a gigantic grift to fleece taxpayers of money.
Right. It's
to keep really smart people doing useless shit so that they don't fucking kill people. Because you don't want really smart people sitting around going, "Who the fuck do I stab next?"
Right. And they, how much money would they get? Like $20 billion a year or something?
That's like a day. It's more than that a day. It's like 50 billion or 50 million a day or something. Could be 75 million. But NASA? That's not the whole story. Yeah, NASA. They spend like 50 million a day, but that's not the whole story, because that's just the budget. That's just a allocated budget. They have more streams of revenue than that.
Yeah, I bet. A lot of money.
Yeah, so they sell merchandise, right?
Yeah.
How much do you think they make from that?
In a year,
people running around with NASA T-shirts, sweatshirts, hats, right?
Probably make like 10 million a year, maybe. I don't know.
Off of hats and T-shirts, I'm sure it's way more than that. But the point is that they issue a comprehensive annual financial report, and their revenue is way higher than what they get in the budget, because they do other things. They license out facilities. They film. They have the world's largest fucking green screen, which they license out to Hollywood. Yeah, NASA owns the world's largest green screen. It's a Michoud. Which is a heavy vehicle launch center, but they don't make heavy lift vehicles. They have a giant green screen there instead. It's in Michoud, Louisiana. Pictures of it. There's news articles about it. It exists. There's no doubt it exists. They filmed the 3 ninjas there. They filmed Wolverine there.
Louisiana. So you said?
It's in Louisiana. Michoud. It's Michoud. I'll post a video about that shit too.
Jesus, this shit never ends. All right, so green screens, balloon satellites. So what do they do? Like, what's the actual technology then if it's not satellites that are doing this stuff? Like, what are they actually using?
There's no ball in the, there's no ball in the way, so they don't have to do anything. So so this is the last thing I'm gonna do before I leave. I'm gonna tell you about this. In 1918, there was a guy in Australia, in Sydney, Australia, that was an amateur radio person. Now this is 1918 when radio's brand new. Nobody knows anything about it. It's a brand new thing, right? So we're talking about like Marconi has just started, and like he's trying to even convince people that it's a fucking radio is even worth doing anything with. It's this guy. So it was being used by the military. So a guy in Australia, he heard German on radio broadcasts. And he was like, holy shit, I'm hearing Germans talk. Well, how am I hearing Germans talk? In Berlin. There's a big ball Earth in the way. I shouldn't be hearing that. Well, lo and behold, they didn't care that there was a big ball Earth in the way. And they built a radio tower in Cornwall, England. And they built one in Sydney, Australia. And they talked to each other from 10,000 miles apart. Now, there should be a fucking 2,000-mile hump of fucking Earth between them that the radio waves can't get around. So this is in the beginning of radio. There's no repeaters, so that's not an option. It has to be line of sight, or nearly line of sight. Now, when I say nearly line of sight, that means the radio waves probably ducted, like radar. So that when I brought up the Knickerbein, the Germans in World War II invented a radar system of bomb. It was a system for bombing. So they had two stations in Germany, and they shot a radar beam across England. They crossed each other, and when their German bombers were in the intersection of the beam, they would know to drop their bombs. Well, they're both more than 300 miles away from the UK, and the airplane would have to have been flying at an altitude of 12 miles, right, in a World War II propeller bomber, which isn't possible. So there's actually a documentary on this called not on this particular one, but on weapons used in World War II, and they did talk about this. The actual scientists involved in it, right, that they didn't they knew something was happening, but the Earth was a globe, so there's no way they were doing it this way. And they tried to get the military to investigate it, that how they were accurately bombing, and what is this radio system they're finding in downed airplanes. And we have two pilots that are talking about using it, saying how didn't know they're being recorded. And then what ended up happening is one of them renegade scientists was like, fuck you guys, I don't care if the Earth's a globe, they're doing this. And went right to Winston Churchill himself. Winston Churchill said, okay, you can investigate it. They gave the guy a plane with a bunch of special equipment to detect the rate frequency, which they did, and then they tried to jam it, and et cetera, et cetera. But the fact is that the system shouldn't have worked if the Earth was a ball. The radio communication of 10,000 miles shouldn't have worked if the Earth is a ball. And I mean, and it goes on, dude. It goes on and on and on. It's endless. The evidence for a flat Earth is endless, dude. It's endless. I can just go on forever, dude.
I know. That's what I like to hear, because it helps me build a foundation a little bit. It tells me a lot more. It makes me question more, and that actually leads to more a better worldview for me on this aspect.
This isn't even a matter of questioning, right?
Yeah.
You have your experience of the world, and at some point in your life, someone came along and said to you, Earth is a ball. And you probably said to yourself, well, it sure don't look like a ball. And they said, well, it's a ball that's too big to see. But trust us, it's a ball. And then they said, you're spinning. And you were like, well, I don't feel like I'm spinning. And they were like, well, that's because the Earth is spinning so slow you can't feel it. And you were like, okay, I guess I'll believe that too. And then they told you there's a vacuum, and there's planets, these balls, in outer space whizzing around in the vacuum, and you're on Earth, and that's also whizzing around the vacuum. And you're like, okay, well, why doesn't the air fuck off into outer space? And they were like, well, gravity holds the air, and contrary to the fucking gas laws. And you were like, okay, I'll believe you. So it's not a matter of even being skeptical. You've accepted, like, people just accept the idea, right? It's presented to them, and they choose to believe it. It's literally nothing more than that. It's not denying anything. It's like you're presenting with a story with fuck all for evidence other than trust me, bro, and you choose to believe it. You either trust bro or don't trust bro.
Yeah.
I choose not to trust bro, okay? Like, I just, like...
Yeah, I don't trust him either.
You're trying to tell me that my experience of the world is some sort of fucking giant illusion. And I refuse to believe that until you actually show me rock solid, and I mean rock solid, evidence that this is the case. Meaning measurements that the surface of the Earth is curving, because that's the only way you can have a ball is with a curving Earth surface. Measurements of the Earth being in motion, and a demonstration that you can have gas pressure without a container. Okay? None of these things can be shown. They can talk about it, and they can conceptualize about how it could be shown. Well, what are you waiting for? Right? Go do the test. Go do the experiment. Because when we go do the test and go do the experiment, what's shown us by the Earth is that the Earth is not curving on the surface, that the Earth is not in motion, and that you can't have gas pressure without a container. That's what the evidence actually shows. But the globe Earth is a concept. It's a mental model that people have adopted as some idea as a reality. But that idea doesn't exist out there in the physical and natural world. It exists in the minds of men. And that's the only place it's ever been, and that's the only place it ever will be. It'll be a concept shared between men about how the Earth is a globe. But nothing out there, no quality out there in the world where it actually exists.
Right. And yeah. So, okay. So the 1918, there was an Australian, and he heard the German talking.
It was Marconi, right? It was Marconi.
Yeah, Marconi. Okay, and then this was from Brown. This was from England to Sydney, Australia, 10,000 miles away. And then there was they shouldn't have happened because it would be land in the way in the globe, right? And then
yeah, 10,000 miles. That's like going from the North Pole to the South Pole.
Right. Yeah, that's
right.
fun. That's really fucking
You
fun.
got a radio on the South Pole, and you're like, "Hey, you're talking to the North Pole. How's that happen?"
Yeah, because it's
there's no satellites. This is 1918. There's no satellites. There's no radio repeaters.
Yeah. Okay, and then
how do they do it? Like without satellites? The whole idea of satellites is that there is a big ball of Earth in the way between 2 points. If there is not a big ball of Earth in the way of 2 points, then you don't need a satellite.
Got it. That's exactly right. Yeah. All over. I'm just writing down notes, and I got everything down. And then there were 2 stations, and then the Germans shot a radar beam across England.
It's called a Knickerbein.
Knickerbein?
Yeah, it means crooked leg in German. Hold on, I'll get you something on it.
And then you said the airplane altitude of 12 miles.
Yeah, World War II bombers flew at like 23,000 feet or something.
Okay. 23,000 feet.
Maximum, but that wasn't actually their bombing altitude. Their bombing altitude was 7,000 feet.
Okay.
Hey guys, if I may interject just quickly, Indio, don't people ever come to you about with the radio broadcast stuff and say, oh no, they're just bouncing signals off the atmosphere or some shit?
The ionosphere, yeah. That would be a plausible explanation if they didn't do this during the day.
What's the difference back then versus now? Just their knowledge of the so-called ionosphere or something, or
ionosphere is post hoc. It's ad hoc after the fact. So they did it, and then they're like, "How could you do that?" Well, they must be bouncing off of something in the sky.
Okay.
Yeah. There's no evidence for it. It's just they have like, what else are they gonna say, that the Earth is flat? Like, that's the other option.
So they didn't actually discover it. They inferred it and then just run with that, as opposed to, there must be something. Let's go check it out, and then there is something.
Yeah,
they
it's
don't
just
do that.
inferred from the fact they can do something that should be impossible.
Okay, so they don't actually go up there and say, "Oh shit, there is this thing," after we discovered that, or we thought it might be here, and oh yeah, it is here.
I think the ionosphere was developed in like the 30s. The idea.
Okay.
But like the radio transmissions were like in the 1918 and shit. So it's like 15, 20 years later. But even if they say it's the ionosphere, that doesn't even work. We can assume there's an ion layer. Fine, that's not a problem. If you use the ionosphere, it has to have all sorts of novel properties, like negative refraction, which they say it has, which is fucking no evidence for. But let's just even say it's true. The ionosphere would cause, so the result of what they say, their theory, their hypothesis is, the ionosphere moves around. So on the day side, the ionosphere is lower than on the night side. So when you do daytime transmissions, they'll bounce off the ionosphere, but only for a max distance of like 800 miles. But at night, they can go some fucking infinite distance. I don't know, bounce around the Earth 1,000 times. Who knows what they say? But the nighttime transmission would say, hey, this is plausible. But the daytime transmission, it's not plausible. Because it can only go 1/10 the distance. And this is when he heard German. Was during the day. All day. Okay? So that excuse, it just don't fly.
So during the day, it's an 800 miles restriction?
Yeah, about that. If you go on the FCC website, which is the Federal Communications Commission, it has articles about skywave propagation.
Got it.
Probably a link in one of these places, because like pretty much everything I'm telling you, they're in one of the information channels, probably.
Yeah, I'll have to look. I have to like rifle through everything and like look very closely and see if they have it. And if not, I'll just go, just find it online. And at night, it's an infinite distance, so it wouldn't work.
I mean, effectively infinite distance, because they'll say it don't. I mean, there's no evidence for the infinite distance, but they'll just say it, right? I'm just saying it. Like, this is kind of like devil's advocate, giving like steel manning their argument and saying, "Hey, this is the best argument they can make," and that still fails. So that's typically what I do. It's something I do. I don't straw man people. I steel man them. I steel man their argument and then say, "Okay, with your best possible version of your argument, it still don't work."
Yeah, that's a very solid way of arguing. It's like it's very very honest way. But let me see. So
well, I only care about what the truth is. I don't really have. I'm not like stuck on this flat Earth thing.
Yeah,
I booked it. Look, it pretty much goes like this, and all the time I've been doing this. Some globe earther says something. I ask them what the evidence for it is. They don't know. I go look it up. I find that the evidence is absolute bullshit. Either the claim doesn't match what's actually observed in reality, or what the claim matches what observed in reality, but they don't even use a globe to even get that in the first place. For example, they'll say things like PNS waves show that the Earth is a ball because the waves travel and avoid the core, or some bullshit. But then if you look how seismic waves are modeled from the data, they use a hyperbolic geometry. In the model, they use the hyperbolic wave equation, and as such, automatically, just from the fact you're using that type of equation, you're going to get that result. So They're not confirming anything. They've taken data, they've stuck it into the model, and the model spits out some result. But they didn't. That's not an observation. What did they observe? Oh, the ground shook. The ground shook at all these different places at all these different times. We're going to take those variables, we're going to stick them in a model, and then we're going to. So they use what's called a Poincare disk model, which is basically it's a hyperbolic wave equation. I'm just using this as an example of like when you look further into it, people will say this confirms a globe, and then you look and they don't even use a globe geometry in the first place. So how could it ever possibly confirm a globe if they're not using globe geometry?
So okay, so hyperbolic geometry uses like what kind of model does it use? Like, what is it based off of then? It's like flat Earth, or
no? It's called a point. It's a simplified model. So they're imagining that they took a slice of the Earth, like sideways slice, and that the wave propagated from a point, like so you have a circle, and then you have points within the circle, and the way a ray would travel about that is hyperbolic. So distances go exponential at the edges and are different at the center, and are like so it's almost like a distance formula. So like how you measure distances within the coordinate system changes. It's kind of hard to describe, but they have like this Poincare disk model that's been around since Poincare, which was at the end of the 19th century. They basically use this simplified model. But the point isn't that they're using a simplified model. I'm not even bitching about that. It's not even a bitch. I'm just saying is that it can't confirm the globe if there's no globe in the mathematics.
Yeah, I see what you're saying. So it slices up like a part of the Earth and like
a lot of these things. So eclipse predictions. You probably assumed it too that they use a globe mathematics to predict eclipses, and then people say, "Well, eclipse predictions they can be predicted down to the second. They confirm a globe." They're presupposing that they got that prediction from a globe. Here's another one: sunrise, sunset times. They don't use a globe to get those. They use something called the equation of time. Right? If you look at the formulas, there's no globe in the mathematics. So how can the eclipse or the sunrise eclipse prediction confirm a globe when there's no globe in the math? They're modeling some other shit. This is what I'm talking about. No matter what I look at, no matter what any globers ever presented to me, upon further investigation, the way they thought it worked was wrong, and the way it actually works has nothing to do with a globe in the first place. They just thought it did. They just thought it did. Like this happens, bro. I'm telling you, this happens all the time. It's not like I haven't had to say it lately because I just stopped saying it because I got sick of saying it. That's not a globe prediction. You just think it is. And they're like, what do you mean I just think it is? It is a globe prediction. Blah, 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 blah. Then I will get the sources and I'll show them. Okay, there's no globe in this. And then they gish out or fucking crash out or something. Right? So they have a fucking psychological breakdown because they're convinced that like every observation aligns with some globe model and that someone is freaking like has like a globe 3D model in which all these things is being like mathed out from some sort of globe. None of that shit is. They're not using a globe for any of this crap. GPS doesn't use a globe. It uses something called Earth-centered, Earth-fixed coordinate system. It doesn't use latitude and longitude. It'll display it to you as latitude and longitude after geometric transformation of the coordinate system into latitude and longitude, but it doesn't use a latitude and longitude to find your position. Okay? So that's another one. GPS confirms the globe because they looked on their phone and they saw latitude and longitude, thought latitude and longitude are points on the fucking ground, and then made this whole bunch of leaps of logic to say this proves the globe. They don't know how it works, and if they did know how it works, they would know that the way it works is the geometry of the coordinate system that the GPS uses has 3 coordinates, up, down, and easting. That's not latitude and longitude. Then they take that up, down, and easting, do a geometric transformation, and display it to you as latitude and longitude. Why? It's not like they're useful to you. It just makes you feel good because you're familiar with it.
Okay, so it uses geometry of the coordinate systems, and what's the 3 points you said?
Coordinate systems are arbitrary. They're completely arbitrary. You can use any coordinate system you want for anything.
Yeah, is that why they can spoof like your location? Like if they wanted to, I've heard that like they can mess your
yeah,
location.
like GPS spoofing. That's nothing, dude. Like that's fucking. You can do that for like $300 or something. GPS is a passive system. You know that, right? It's a passive. It's not two-way communication. A GPS quote unquote transmitter. People think it's a satellite. Tell them think that. Fine. You think that? Fine. But the transmitter is just a beacon. Just sends out signals repeatedly. Right? And your receiver picks it up. And the information in there is how far is the satellite away from me? How long did it take? Not even how far. It's how long did it take the signal to get to me from the time it transmitted it to the time I received it. And if you have a bunch of satellites or transmitters that your receiver picks up, then you can use something called trilateration to figure out where your position is within some degree of certainty. But that position is calculated on a tangent plane in Earth center, Earth fixed coordinates. Now, from that, they can extrapolate. You're standing on a globe and it's underneath you, and then this globe thing underneath you, they can transform your coordinates into latitude and longitude. But there's no globe required for any of this, and it's not anywhere in the math. So this is another thing. GPS uses a globe. People just think that. But it's not true at the technical level of actually the way a GPS functions.
Okay, so it's a GPS transmitter is a beacon that sends out.
Yeah, it's a passive beacon. It just sends out a repeating signal.
Signals, okay.
Here I am. I sent this signal at frickin' 2:00. That's it. You're like, I picked that up at 2:00 plus 2 milliseconds. Oh my God, the speed of light's 300,000 meters per second. You're fucking 1,000 miles away from me.
Right.
That's it. That's all it does. But it will take a bunch of these sources, right? I'm 1,500 miles. I'm 3 feet. I'm fucking 30 miles. I'm whatever. And then you can take circles, right? You can take a circle from each point, and the distance is the radius, and draw a bunch of circles, and where they overlap, that's where you are. Called trilateration.
Yeah, tangent to the Earth fixed and for Earth center. Is that what you said?
Earth center, Earth fixed. This is on a tangent plane. Okay. So if you type in ECF diagram in a Google or whatever, hit Google Images, you'll see a ball with a little square on it, and on that little square will say XYZ or up, down, easting. That's the actual coordinate the GPS receiver uses in the device. Doesn't use a globe. The globe is it was an addition after the fact.
It's a post-diction.
It's not it's just an addition after the fact. Okay, we have a plane. We know where he is on this plane. Okay, let's stick a globe underneath him. Where is he on that?
Yeah, just put a globe under there, and it's like, yeah, we're on the globe right now. That's how we're doing.
Literally what they do, dude. It's literally what they do.
That's funny.
But that's not how people think of it. They think like the thing is calculating latitude and longitude, and I don't know what people think. I just know that it doesn't use a globe. People think it does, and this is, look, man, like you've seen how complex this sophisticated this topic is. There's like points, and points is like octopus. There's points everywhere. But the thing is, no matter what a globe earther has brought up to me in 8 years, upon further investigation, the way they thought it worked is not the way it actually works.
Yeah.
Yeah, I'm writing down a lot of shit in there. They make up like I just hate to say, they make up a lot of shit in their head. They like it. I call it filling in the blanks. Like they're told, hey, there's satellites in space, right? And there's this device that tells you where you are, and no one ever told them, hey, it uses a globe to work. They just said, oh, global positioning system. It must use a globe to work because there's satellites and I have a receiver. And they just fill in the blanks that inside that receiver, it's doing mathematical calculations on the surface of a globe. But it's not. They just filled in that blank, dude, because they just imagined it to be that way because it would make sense to them. Well, it would make sense if, like, the global positioning system uses a globe in the mathematics. That makes sense. Sure, it makes sense, but that's not what they're doing.
Yeah, you know what this makes me want to do? It makes me want to get like a sniper and shoot a satellite out of the air and see what it is. Like that's what I want to do. Just see like watch what it like what it is like see like what it's using and like what it carries. Because that really annoys me when I see those things and like I'm like, what is this?
Well, here's another thing. No, man, it's late, man. I should have went to bed. So, no human being has ever observed an orbit of anything ever.
Yeah.
Ever. No one has. Right? So you can look at the moons of Jupiter. They go left to right, and then they disappear. And then they appear back where they started again. They go left or right, and then they disappear. And they go left or right, and then they disappear. And that's all you ever see. You don't see an orbit. Okay? Look at the moon. You don't see the moon orbit the Earth. Look at the sun. You don't see the sun orbit the Earth. You don't see any of the planets orbit the sun. Right? You don't actually see any of that shit. You don't see satellites orbit the Earth. So you got to think, no one has ever observed the full orbit of anything ever in the history of humanity. But everybody thinks as sure as shit that orbits, certainly, they fucking definitely exist. And if you don't believe in orbits, you're obviously a fucking delusional fruitcake. Well, who's the delusional fruitcake? The guy that doesn't believe in orbits because no human being has ever seen one, or the guy that believes in orbits even though no human being has ever seen one?
Right. All right. Well, I'm gonna let you go to bed. I don't want to keep you awake. You know, I know you got to get your rest.
Yeah. Well, I got to get up and it's gonna be like 2 hours now. I actually have to leave here in 2 hours. Fuck. Okay.
Holy moly! You traveling?
Well, I just got to go to a doctor's appointment. It's fucking super early in the morning. I got to go. I got to go like 7. But it's going to take me an hour to get there, so I have to leave at 6. So if I went to bed now, which is 4, I'd get 2 hours sleep. That would be if I could just jump out of bed and start moving, which I can't. So I probably have to get up 30 minutes earlier than that. So that would give me an hour and a half sleep. I can do it.
You have a strong will. You're very smart. You know, you got a strong will, so you can do it. And I appreciate you helping me and on this. This is very interesting stuff. Like I haven't gotten this deep.
Yeah, dude. I hate to brag, dude, but like on Discord, like the Flat Earthers on Discord, this is like the pro league. Every other platform, I'm on X and I'm on Facebook. Well, I don't really use Facebook that much. Only like the server. We have a server Facebook page. And I use that. But like on X and like TikTok and all the other, those fuckers are amateurs. And I hate to say it, there are some people that are on Discord in that, but like the flat Earth, like I hate to say this word, community or whatever you want to call it on Discord, because we actually like have debated this topic more, just because of the platform, the way it works. So we've been churning people for fucking years now, right? I've probably debated, I don't know, it's got to be at least 10,000 people on this topic easily. But if I was on another platform like X or fucking TikTok, after like 5 or 6 years, I might have debated 500. So it's like, it's just the platform. So we've advanced this idea way farther than they have. Like it's same with like on YouTube. Like those people, like on YouTube, they don't really interact. Yeah, they have debates on YouTube about the topic, but they don't really interact with people on a regular basis. right? Like their chat or whatever, and even that is so limited. So we've debated, we have looked at all this, fucking data, and like I've debated PhDs in cosmology, physics, all that. Everyone, like almost everyone here has. We've debated professionals, academics, you name it, pilots, surveyors, geologists, fucking botanists. Like you pick the fucking profession. We've talked with them about it. Astrophysicists. And
yeah, that's exactly my point.
But here's the funny thing is, doesn't matter. They're in 9th grade, sophomore in college, PhD in physics. They all have the same answer. I don't have that information. Magic Science Guy does.
Right. They always appeal to
What
authority.
I mean by Magic Science Guy is they always think that there's somebody out there that has the evidence, right? Okay, they'll make a claim. You go, what's the evidence? Like, I don't know. I'm not a scientist. And if they are a scientist, they go, I don't know. That's not my field of study. There's some other guy that knows. Okay, so we're looking for the other guy. If you know where he is, the Magic Science Guy that has the information, the evidence that confirms the globe, we want to find him. We're looking for him. Okay? If you find him, send him this way. We're looking for Magic Science Guy.
Yeah. So they appeal to authority all the time, basically.
Yeah. I mean, like, no, it's just like, yeah, I mean, you could call it appeal to authority or appeal to credentials or whatever.
Yeah.
But basically, it just boils down to they don't know, somebody else knows, and they believe that somebody else knows, and that's why they believe it. They just believe there's somebody else with the information, and they trust that it's out there somewhere. The only times we debated somebody and they're like, they say something, and then we ask them how they know that, and then they have to look it up. Like, why did you believe it before you had the information from which to base a belief on? You auto believed it. I believe this thing. Okay, what's the evidence of that thing? I don't know. Let me go find it. So you believed it before you had the evidence. You got it? Like this isn't outlier shit. I'm not talking about like strange, weird fucking people. This is the vast majority of globe earthers. They believe something, and then when pressed, have to go find the evidence for what they believe. And then they find the thing, and then it doesn't even say anything that corresponds to what they believe, or the evidence is contrary, or it's just like some other fucking anti-flat earther saying some other bullshit without evidence, right? So they'll link a page that just makes the same claims they make, but on that page actually has no evidence for those claims. These are normal. This is normal par for the course shit that we deal with. Like this topic isn't close. We get in a debate like it isn't close. Like it's not a close debate. It's not even remotely close. That's the fucked up thing.
How many people laugh at us and then boldly claim and confidently claim that the moon phases are caused by Earth's shadow?
Ha! How about gravity being caused by the rotation of the Earth?
Oh my gosh. Crazy.
Yeah, we've heard that many times. Or the sun is a burning ball of fire. Or mass is the amount of matter. Or gravity is something falling. Or any number of things, dude. It's just crazy. Yeah, they think eclipses are moon phases. That's one of them. That's a pretty kooky one.
Jeez. So, have you had a guy that's like your toughest opponent, like on here, or has everyone kind of been? Oh, okay.
The only thing that's tough to deal with is like sophistry and shit. Actually, like just dealing with the facts of the matter, that's no. There's no challenge there because they don't have the facts. So it's like, what's the challenge? The only thing we have to deal with is like that's challenging is like dishonest people, people that lie, people that straw man, people that do all sorts of like debating gimmicks, debating tactics. Right? That can be tough to deal with if they're like a clever debater, because you can be a good debater and have no facts and prevail, right? If you're against a weak debater, right? So you can prevail just on bullshit. So we have those type of people try to do stuff. There's a whole group of people. They're called debate bros, and they have all these debate gimmicks. They'll just try to debate any topic, literally, and their thing is to debate. They don't know. They try to win debates not knowing anything about the topic, just using debate tactics. Like one of them is to do a bait and switch immediately in the discussion. That is to state a position, the other side states a counter position, and then in 1 or 2 sentences, somehow co-opt and take their position and get them to argue against their own position that they initially did.
Yeah, they heavily rely on their opponent not having a complete understanding of formal logic and debate. Yeah.
Yeah, but they try to do the bait and switch where they get the person to argue against their own claim.
Right. So that's like.
So that's the difficult shit. It's not the fucking facts of the matter. That's easy.
So the subterfuge
for other
basically.
I'm a freak.
We get people to do that without even trying.
Yeah, I know. We could do that without even trying, bro. Dude, just like a run-of-the-mill Glober, he'll come in here and within 3 seconds they'll be fucking throwing their own authorities under the bus and contradicting themselves. It's actually quite humorous. We actually have events. This is an event, but we run events. It's called Under the Bus Show. And the thing is, see how long it takes, any Glober that comes into debate, see how long it takes them to throw Neil deGrasse Tyson or Bill Nye or somebody one of their heroes under the bus, because all those people have said stuff that contradict their idea of what the globe is, right? Oh, I saw a freaking Earth curve from an airplane. Well, Neil deGrasse Tyson says you can't see it even from 128,000 feet. Oh, fuck Neil deGrasse Tyson. He doesn't know what he's talking about, right? They'll throw their own dude under the bus in 5 seconds.
That's insane. That's the thing about basing your science or your beliefs off of a false philosophy, I guess you can call this, or whatever you
that's
false.
What it is. Yeah, that's exactly what it is. So
yeah,
if you think about it just from a logical standpoint, because the globe has no sense evidence, right? No perceptive evidence. You can't go out into the world and deduce it's a globe. I ask these guys sometimes, if nobody told you the Earth is a globe, would you have figured it out yourself? And no one's ever said yes. They all say no. That means there's nothing in that physical natural world that they've ever experienced from which they would ever deduce that the Earth's a globe or infer it. That is completely based upon word of mouth. Now, so you're starting from a position of you have no actual physical evidence of the claim. So the only way to advance that is to presuppose it. So the presupposition alone, the very fact that they start the claim with an assumption, means they can't prove it. Right? They can't prove it from the get-go because it's assumed. Okay? So just like Eratosthenes, his experiment to so-called measure the assumption of the Earth, or measure the circumference of the Earth, to do that, he has to assume it is a globe before he does it. He could do the experiment before that, but it's his conclusion can't be reached without assuming he was measuring a sphere in the first place. So all globe claims contain this, where they have to assume there's a globe in the first place. Well, this is affirming consequent formological fallacy. No globe claim can be maintained logically because it has no axiom from which to start. And an axiom, in the sense of logic, is something that's self-evident. It's not self-evidently a globe. So you have to start from that assumption.
Right. Makes sense. You have to contrive that. Yeah.
Yeah, you could start with an assumption and presupposition. That's fine, and you can go on to believe whatever it is you fucking want to believe. But you can't prove it deductively through logic. That actually is the case. But we're at the state of being in this society where it's the Earth is a globe it's unquestionable truth. Right? So, just to tell you what happens is they start with an unquestionable truth that only fucking retards think is wrong, And then within interacting with us after 5 minutes, they're showing that all they have is a fucking belief based upon a presupposition that they can't prove. And they fucking go out of their minds, dude. They fucking crash out. Because they went from a fucking goddamn existential fucking certainty to fucking I don't know in 5 minutes. If you probably polled 100 people and you said, what is the thing you're most certain of in this world? They would probably say Earth's a globe.
Jeez.
Yeah, and they don't know that at all. Like, even a little bit. Yeah, that's the state of affairs. I mean, I am going to get off. It was nice talking to you. And I gave you a lot of information, and I realized, like, you probably got, I can't even believe you lasted that long. I gave you more than any freaking human being could probably possibly digest in such a short period of time. So, you know, take it in bite-sized chunks. You know what I mean? Don't choke on it.
Yeah.
Typically, when I go on a roll like this with somebody, they can't last, dude. So kudos to you for fucking even putting up with it for that long. I could keep going for another fucking 4 hours. I can dump so much fucking information on you that your fucking brain will turn it to fucking gelatin. Well, it already is kind of gelatin, but I mean actual gelatin. Like strawberry gelatin.
Yeah, it's all going into my subconscious, man. I'm absorbing everything. It's all coming in.
Yeah, there's a lot of shit. But this is a multifaceted topic. There's history. There's science. There's experiments. There's observation. There's philosophy. There's psychology and sociology, and there's a lot of things all tied into this. There's tentacles everywhere that go into like almost because in the modern day, the idea of the Earth's a globe is the foundation of existence because it's where you are, right? So this is like, how can you answer any question about life if you don't know where you are?
Right. Yeah. That's exactly what I want to do. Like, I want to figure all this stuff out and be fundamentally solid on everything. Like, I don't want to have any gaps, you know?
Yeah, dude. And like, seriously, we're not saying, hey, believe us anything. That is definitely not the case. We're not here to convince anybody to be a flat earther. That is not what we're here for.
Right.
Like I just gave you, I gave you a bunch of information that you did not have before.
Exactly.
Now, you can actually make an informed decision about what to think, right? Or maybe where you should go from here. Maybe what they're telling me the Earth's a globe isn't true. Maybe what can I do to test that? What can I do for myself to actually verify what they say is true? Justify my belief in what they say by going out and doing some test, some experiment, long distance observation, laser test. I mean, I didn't even get to the Bolivian salt flats. The Bolivian salt flats are just, that's the end. Like, the Bolivian salt flats are a 43,000 square mile salt flat that when it rains, it fills up with like 3 inches of water. But when it fills up with 3 inches of water, it makes like a perfect giant fucking mirror. Okay? Now look in the chat. I want to show you something.
Bolivian salt flats. Got it.
Yes, the Bolivian salt flats. Now, what happens when you see the reflection of a curved mirror? It's distorted, right? The image is distorted.
Yeah. Okay. Yeah. It's like those it's like when you go in the circus, right?
Watch this video. This is the Bolivian salt flats. This is how undistorted the mirror is.
You just put that in the lobby, India.
Oh shit. Yeah, thanks, dude.
No worries, man.
Let's see.
Okay, yeah, it's in there now. Now this video is gonna blow your fucking mind. Blew my mind when I saw it.
So it should be distorting, right?
Yeah. So what should happen is that the reflection. So you got the reflection and the sky, right? So you got the sky and the reflection of the sky. They should not be symmetric. You know what I mean by symmetric, right? So they shouldn't be mirror images of each other. One should look a little different than the other one. should be distorted. Like the spacing should be different. So what the spacing should be is as you look further and further up in the horizon, the reflection distances relative to the sky should be compressed because the Earth curving down from you is less surface area. So it's projecting on a smaller surface. That means it can't look the same because you're looking at less surface area than the sky.
Wow, that's crazy. And what would a globe earther say when they see this? What would they say?
There's some things globe earthers don't respond to. They don't respond to shit like this.
They just say no. They just say like no.
Just change the subject, man. There's some observations that are so fucking crushing that they just change the subject. This is one of them. So they won't talk about the Bolivian salt flats. There's some tests that were done on a frozen lake they won't talk about. They won't talk about some tests that were done at Salton Sea. There's a bunch of them. There's a bunch of them that they just change the subject. And they just like, because it's like, bro, like I told you, there's psychology and sociology involved in this. People's identity is linked to the globe. So you take that away from them, it's like, what do they have? They have to reevaluate their entire fucking life. And they're not ready for that. So they'd better to just ignore it and move on and fricking go through a crisis right here on the live stream. Like,
right. They'll appeal to a derivative, right?
Well, we've seen
they'll appeal to a derivative. Yeah, because instantly they'll be like, but then how do eclipses work? Right? It's like
no, that's not the real crisis. The real crisis is, I don't know anything is true. I could be a brain adjuster.
Oh, absolutely, yeah. Then sometimes after they've accused us of doing that, like, you know what I mean? Like, because we'll question like, well, how do you know that that's a real photo from space, right? How do you authenticate that? Oh, well, how do you know anything's true? How do you know anything's real then? It's like,
have you seen your brain? You haven't seen your brain, so how do you know you have one?
Right.
Oh my gosh. Is that really what they say? They say stuff like that all the time?
Oh, bro. We call them, we have a nickname for them. We call them the 99%ers. So check this out. We had a streamer, a guy named Mr. Sensible. He actually flew like a high altitude balloon, take a bunch of photographs, thought he proved the curve of the Earth. He came in this chat and debated AB. Okay, he's a dude. He's one of our members. So he's live streaming while he's debating AB. Okay, and AB asked him, because he's like, he said something like, well, I can never be 100% sure about anything. And AB's like, well, are you talking on Discord right now? He's like, I don't know. I can't be 100% sure of that. And then he goes, well, are you sitting in a chair? Do you know if you're sitting in a chair right now? Now, this dude is live streaming while he's sitting in a chair. And he's like, I don't know. I don't know if I'm sitting in a chair. Okay? So this is where their mind has to go. That if the Earth is not a globe, nothing is real.
These are not the droids you are looking for.
These are not the droids you're looking for.
Exactly. Rumpus even said he'd sign himself into a mental institution if he had to accept that the Earth is flat.
That's crazy. Like, I guess people's realities really are that tied to this stuff. Like, I'm not even like, design our own tool. Even when I was younger and I was like taught this stuff, I never really like attached myself to that to the point where I would be like imploding because somebody told me that it's not true, like about globes and stuff. Like, I don't know how people are that like attached to this stuff. Maybe it's because like a sci-fi, movies or like Star Trek.
I mean, I think that's the difference though. Because I wasn't attached to the globe, even though I knew a lot about, like, you know, modern cosmology, science, and all the shit. I wasn't attached to it. So when I saw something like the Chicago skyline from 52 miles away, when I saw that video and them saying it's a mirage, and me going, "Well, that's not a fucking mirage. That's not what a mirage looks like," right? And that's what started me down the road of investigating it. When I investigated, I wasn't on like. I didn't care one way or the other, like which one it was. So, like, it didn't matter to me.
Yeah. Yeah, that's exactly. It's like I'm like a guy who just like accepts the truth. I don't look for coping mechanisms or try to find like a way to like escape the truth. Like I just accept what it is. Like if I see it in front of me and I just accept it. Like I don't try to like make up lies or cope about it, because a lot of people do that for some reason. I guess they're just so like they're scared to be rejected by society, maybe, or I don't know. Maybe they don't like the fact that they're not conforming. I have no idea, but it's not easy though. I will say that much. If you're like someone who's accepting the truth, it's very difficult because you're kind of a pariah, a social pariah sometimes at some points, because you have to accept certain things that most people won't accept.
I think it's more like a claustrophobic feeling, like a existential dread. Like not knowing. You know how?
Yeah, that's
Yeah,
exactly
the
what it
fear
is,
of not
man.
knowing, something like that. Yeah, it's terrifying.
Existential
It is.
dread.
It's existential dread, dude. Yes.
So like not knowing something.
You've never heard that term before?
Yeah.
No. Yeah. What is it? What do go on a little about it?
It's almost like facing your own mortality. It's like that.
Really?
But instead of you like facing your mortality as in you might die, it's more like you're afraid that you might live.
Wow.
Well, we're
afraid of being alive, dude. I might live, and it might not be a globe that I live on. Ah!
Yeah, it's actually like your whole life you grew up thinking and believing that we knew what we knew. You know what I mean? So it was like that being taken away in an instant, and then you're just left with this emptiness. This this panic. You know what I mean? Of holy crap, what is it? What am I? What, you know what I mean? It's like it all comes back like you were wrong
Yeah,
about
like
everything.
yeah, a
Like,
perception of you have a perception of your
yeah,
own existence and how you exist and where you exist and all those things.
yeah.
Everybody does this how they operate in the world. But like imagine like the foundation of that is wrong and you have to like you but the thing is that's like the foundation of like your entire everyday life of everything you do. When you get up for work, like where you kiss your wife, like everything is based upon you made all your life's choices based upon that. Then you find out that one of the frickin' pillars of that crumbles. Now what? Right? I made all these choices for the wrong fucking reasons, based upon the wrong things. Now, like how you perceived yourself, like your self-image, that's destroyed because it was based upon a fucking false idea. Right? That you're a fucking human being on an infinite, on a little speck of human being, right? Big Bang, evolution, all that shit. But you're on a ball in a uncaring near infinite fucking vacuum, and you expect a dust in that. To some degree, you don't matter, and you're not special, and the Earth's not special, and nothing about existing is special, and the sun's going to blow up in 4.5 billion years anyway, so who gives a fuck? Okay, you go from that to, oh, fuck, dude. This shit does matter. I am special. The Earth is special. All this shit's important. It's all created. And I just fucking wasted 50 years of my fucking life.
Yeah. But it's like if you believe in God, it's like the idea of being separated from love. From yeah, you know what I mean. From the thing that gives you that comfort. You know what I mean. When you go to sleep, you can sleep. Because you're comforted by security. You know what I mean. Knowing God exists and love. So imagine being separated from that forever. Something like that. That kind of dread. When it comes to like an atheist or a person who doesn't know or doesn't believe in a creator or God.
I think I see what you're saying. It's like someone
It's
who's
like finding out you're
annihilated.
adopted or something. Imagine finding out you're adopted. That's like a soft version of that, right? Even like finding out you're adopted isn't even as bad as like being a hardcore glober and then finding out the Earth is flat. It's even worse. That sensation is worse than even finding out you're adopted.
It's like I'm assuming it's like a nihilist.
It would be more like you think like all the books that you've ever read, all the TV shows you've ever saw said you weren't adopted, and then they're all wrong, and then you find out you are adopted. It would be more like that.
Yeah, that's a good way. That's a good way of putting it. I like that. Because like if you accept this stuff, you're like this globe stuff, you have to be a nihilist in a sense, right? Because you believe in all these theories and we're gonna die in 4.5 billion years or whatever, and everything means nothing. We're on a ball spinning.
Because
all came about by chance.
I've been telling them this recently that like their whole they've adopted a philosophical worldview without knowing it, and that's the Copernican principle. The Copernican principle says that the Earth holds no unique place in the universe, and it's just like everything else. Which is why people come in here and go, "Well, there's balls in the sky, and if the Earth is like everything else and not unique, then Earth must be a ball in the sky." Right? Real simple. That the logic is flawless. The problem is the claim that Earth is not unique. Like, where'd you get that from? Right? That's a philosophical evaluation, right? That's not like there's no evidence for that. You have no idea if the Earth is unique or not. But actually, your evidence is the Earth is unique because only here is life. And
that's right. Not even in their own paradigm is that true.
Yeah, certainly.
Yeah, I think that's a good point. Yep.
So what do you guys think? What's your opinion about what's out there? I mean, around us, you know?
I got cows and shit like that around me.
You think it's just terrain, endless forever?
Nope, we have air pressure, so it doesn't go on forever unless there's a million of these places like us, and we're all underneath the same thing or in the same place. That's the only way it could go on forever in your mind.
Because I see this life as as I think it's the creator's experiment. So I think it's something to do with this place that we call Earth. So I'm not sure. So that's why I don't tend to believe it goes on forever.
I say it's like a horse race, and then once the race is over, they clean up the track and they straighten it all out. That's why they flood this place a bunch of times, because there's like something going on and they're betting on it.
Oh, what about the rising sea level?
Oh, that's not true.
You know, well, you know the Black
Sea,
for example.
Yeah, it's not true.
Yeah, how are you going to prove? You have to prove that, and you haven't even proven that to yourself. So you're just believing here. Now we don't accept that what they tell us. Difficult to validate.
There is proof of a massive flood. It's not accepted, but there is proof.
Everybody accepts there's a flood. They're digging buildings out still. How could there not have been a flood?
I'm gonna send you a video about this flood.
Yeah, you're talking about rising sea level, you said. I don't accept that, is what I'm saying.
Yeah, we don't have that, that's for sure.
I mean, I don't know what to ask you, actually. Look in the chat, this is about the the flood thing. Very interesting, I promise you. But this is not to do with rising sea level. I feel like I want to ask you something, but I don't know what.
Have you seen all the pictures where they show the sea level at a certain location in like the early 1900s and then recently? And it looks exactly the same. There's a lot of comparison photos like that. But there are also some places that seem like they're sinking a little bit as well.
Excuse me for eating. Today at work was out of the ordinary day, let's say. So now I'm coping with some KFC, which I never do, but
Where are you? Where are you in the world? Europe, Middle East?
Yeah, Europe.
Europe. Okay.
Yeah. Don't eat fast food, by the way. It's very bad, trust me.
You can't say anything if you're eating KFC about health advice.
Well,
I don't think there's been a time where I ate KFC and then felt really good about myself afterward. I don't know if that's ever happened.
Yeah, that's
so that tastes so freaking good, but then the aftermath.
But I never eat KFC. This was an exception.
Yeah, no, I get you.
I used to eat a lot of fast food, and I lost a lot of weight, and that's why I know I had some issues. But
Mark J just posted a cool image, which I'm gonna pinch.
Yeah, I see. No, it's like the Black Sea. If you look at it, you can see it had an original shape where it was deeper. You can clearly see.
It's not an ocean, is it?
It's not an ocean, but it's connected.
Okay, no, it's not. It's not an ocean, is it?
No.
Right.
Do you believe in asteroids? That some asteroids hit the Earth sometimes.
No.
Not in the mainstream explanation for what they are and where they come from and that kind of thing. Definitely.
Yeah, and then you got your comets and your meteorites. I've never touched one of those. No, you know.
Whatever they're called, I don't know.
I have no acceptance of any of that stuff at all at this point. None, zero. And it doesn't prove the shape of the Earth, by the way.
Just rocks falling from the sky. I've seen one video of that.
No, I don't accept that rocks are falling from the sky. I don't accept that at all. I think they're man-made events. That's my feeling. I don't believe that the Creator created the Earth.
Saw that movie. Yeah, there's no such thing as sky rocks falling.
Yeah, it's just no
okay,
way.
What about that video, the Russian video, you know, where the guy...
Yeah, it's a Russian video. I know the one you're talking about. Again, it's just, fakery. That's what that is. It's fraudulent. Or they could have put up a weapon and it exploded. That's all that was. It's just very clever. Hollywood.
Exactly, Jin. Well, yeah, not even that necessarily. I can't remember the exact details, but it was found out later on that they were testing some kind of new type of weapon or something like that, something along those lines.
Yeah,
just around the time that happened.
In the Tunguska, where it landed, it does look like a nuclear bomb. But,
or just a bomb of some kind or something like that.
Not nuclear, but some kind of bomb.
You know what I mean? Yeah.
Yeah, but, and it had that blast. That's why it leveled the land where they fired it off at. Simple, man.
Yeah, but I'm asking because I'm convinced there was what's the word? Huge cataclysm. There was a huge flood that they keep talking about in many cultures, and I'm trying to understand what caused it. And There is evidence of that in Africa and in Middle East. But so I don't know if there was like a comet or something that hit in the Mediterranean Sea.
No, it was done on purpose.
It was something else that could have been.
No, it was done on purpose. Yeah, it was done on purpose. And they did, and it happened so quickly. That's how everything, lots of things turned into stone that were actually alive.
Back then, like how intentionally? With what?
Yeah, you keep the mud temperature the same as the air temperature for about a year, and everything underneath it'll start turning into stone because they'll just start turning the minerals. They'll start turning into stone.
Okay, but what about the flood? The water flood? I mean, sorry, but how does this connect with that?
I don't think anyone knows for sure.
Then it's unflooded, and then everybody starts digging out those buildings again. Then they move into them and say, look, it was founded in 1853.
Okay, another thing that I think might have happened is when the the Gibraltar Strait, when Spain, what we call Spain, right, and north of Morocco split, because they used to be together because continent split. When they split, the water from the Atlantic Ocean started going inside Mediterranean Sea, which Mediterranean Sea used to be a lot smaller in the area where it's visibly deeper and darker on the map. So when this water started coming in, I think this is what caused this massive flood in north of Africa and Middle East. That's why they talk about in the Bible also, and in Islam and other stories, other cultures. I think that's probably what happened.
Well, okay, so if you have cultures all over the earth describing the same event, then it cannot be local. It is the entire earth that was flooded. And that's what we have as evidence that the flood was worldwide. So what causes that? I don't know. The texts give stories about it. It's up to you whether or not you think they're plausible. But I mean, as far as the Bible is concerned, it says the fountains of the great deep burst forth and the windows of heaven opened, meaning that you had water coming in from both the bottom and the top, filling up the contained environment. And then the waters receded, meaning at some point somebody must have pulled the plug, it drained out, and now we have the sea level that we have today.
Interesting. The places where I hear being talked about the most is from Islam and Christianity, from these areas where I think this event took place. But because it happened here and it was so devastating, I'm sure the story will have spread throughout the world. Because
I'm not talking about the story. I'm talking about the evidence. The evidence is that the entire earth was covered with a lot of water, and that a lot of silt and a lot of material and a lot of sand and a lot of trenches were dug, a lot of rain fell, and it was a lot of water, and it's everywhere, all over the earth.
Interesting. I have seen a video where there were what are they called? These shells, I think they're called, from the ocean, from snails. Yeah. From snails on top of a mountain.
Yes, and I've seen this with my own eyes. So I've been at an elevation of somewhere around 8,000 feet, and up on the top of a mountain, I found these seashells for myself.
It could just be that these rocks from the mountain were at sea level a long time ago. But
well, if the sea level was higher, that's fine, but that means that water was at least at 8,000 feet.
No, I mean that the mountain was smaller to the point where there was
no mountain. Okay, yeah, that's a possibility. I mean, I'm not going to say that's not possible, but either way, that mountain was covered with water at some point.
But then there are some these seashells, snail shells, whatever. Some of them are inside rocks. So if it takes so much for a mountain to rise up, then I guess by that time these shells, I guess they wouldn't just remain on the surface. They would just like fall, going, all over the place under the rocks, stuff like that. I'm not sure. So yeah, maybe you're right.
Yeah, I was elk hunting in Colorado and I found these seashells. So it's interesting, could the mountain itself have been at a lower elevation at one time? Sure, that's possible. But no matter what, it was covered with water. So whether the water was 8,000 feet high or the mountain was 8,000 feet lower or whatever you want to call it, this is a worldwide event.
Have you seen the place where they think that they found Noah's Ark?
Yeah, in the mountains of Ararat, whatever, which I think today is like a modern day Constantinople or Istanbul, or kind of in that area, or Nepal, kind of. So
no, it's in Turkey, I think, or Syria or Turkey.
Okay. Well, whatever they think they found, it'd be fascinating to see what it is they think they found.
Hi.
Hello.
Yeah, it's in Turkey, Mount Ararat. But in the beginning, and always, for me this seemed weird and ridiculous. But I just heard that apparently they scanned the area, and the scan looks like it has some type of like iron and materials inside it.
Well, that's probably not Noah's Ark then, because Noah was only working with wood, as far as we know.
But honestly, to me, this doesn't look like Noah's Ark. I mean, it just looks like rocks, honestly.
Yeah.
So it's probably just rocks.
Probably a ship. Probably a petrified ship. Yeah. Could be. Not an ark. It could be a petrified ship.
You're saying that wood can become petrified? I didn't know about that.
Everything can become petrified.
From what?
I told you how you do it. Go look up how to petrify something, and you'll see. You put it in mud for, I think it's 86 degrees, and air temperature above it needs to be 86 degrees, and it needs to be that way for, 6 months. And that's how they turned a tank into stone. There was a tank that got stuck in the mud. I forget where year. Anyway, they went back to get it. It was just a rock in the shape of a tank.
Oh yeah, petrified wood. I heard of that.
Yeah, that's what the NASA astronauts gifted as the moon rock to the Netherlands. That turned out to be petrified wood.
And the guy said it's not it's not a rock from the moon, right?
That's right.
And then they were like, "Oh, okay, never mind this guy then. Don't listen to him." No, I mean, I'm open to believe that the Earth is flat. It could be flat. Just the fact that people are interested in this subject, to me already tells me there's a huge possibility. But I'm open to believe that the Earth is flat. But I've always, not always, but since before, sorry, even before this being interested in this subject, I've already found out that the moon landing was fake.
Yeah, definitely. A lot of people that believe that the Earth's a globe know that the moon landing was fake. right? It's not necessarily a flat Earth proof or anything like that. But when we go out and actually test for curvature and don't find any over huge distances, then the Earth can't possibly be a globe. That's what's been done. It's been validated that there's no curvature over large bodies of water, like 40 kilometer distances, for example, that would have to have over 400 foot of curvature. Right? There's no curvature
hold on.
at all.
I have a screenshot here. I think I deleted it. It was from a Facebook reel from that guy, I don't know, Sterling, whatever his name is. And he posted some pictures where you could like see a curve. There was like a line of these tall electricity towers going above the sea or ocean. And you could see like them like forming like a curvature.
Yeah,
these towers.
That's just an atmospheric effect that can happen sometimes. Okay, we've got footage on different days of that same place with the same power lines where we can zoom in all the way across and see that they're completely flat, and we can actually see the buildings 30 miles away on the other side of the lake. It's called Lake Pontchartrain. Okay, that what we're seeing in that picture is called an inferior mirage. It causes things to look like they're doing exactly what you're seeing in that image. It's just a rare atmospheric effect that can happen. And we can replicate the same thing on a flat floor inside a house. Okay, I could show you a demonstration where you see the exact same thing.
Please show me.
Yeah, I'll pull it up right now, actually. Just give me a second. I'll be like, 30 seconds. I'll have it ready. So what he does in this one, it's just done inside on his flat floor in his house. And he puts some blocks. He lines up some blocks across the floor. Just a second. All right, here it is. So he lines up some blocks across the floor, and he puts the camera down close to the surface of the floor. Okay, and then all he does is manipulate the temperatures in the room, the temperature and the humidity. And then all of a sudden, it looks like the row of blocks starts to curve, just like you see in that Lake Pontchartrain image. Right.
Did you post something?
Yeah, I'm just about to paste it now.
Okay.
Just a second. Okay, so this person does hundreds of these at-home tests. Right. It's called a YouTube channel called Sky Free. Really good channel. Okay, and what you'll see is that he set up some blocks across the floor. And on the other side of the floor as well, he puts a red light as well. Okay, so before he manipulates the temperature in the room, you can see the red light. And then once he manipulates the temperature, you'll see the red light actually looks like it disappears behind an apparent horizon that just gets created from him manipulating the temperature gradient in the room. It looks the same as what we see in the Pontchartrain image. Now, also, if you have a closer look at that Lake Pontchartrain image where it looks like they're curving, you'll see obvious signs of miraging, right? You can see a mirroring effect, and I'll show you an example of that right now, like a close-up. And also, there wouldn't be that much curvature like that even if the Earth were a globe, right? That would mean that it would be like a tiny Earth.
That's a good argument, actually.
Yeah. You would never see curvature like that. Like that would just be like a little tiny mini globe. Look, here's another example someone did just on their flat floor with cans, just showing it's the same type of effect. And here's another image that shows a inferior mirage over a flat bridge. And it looks exactly the same as what we see in the Lake Pontchartrain.
Right, okay.
Okay, the next one that I'm posting, this is a side view of the same thing. The same lake, the same thing. Now, when we look at it from the side, when we can't have that miraging effect from the side. So we look at it from the side and we see a perfectly straight line.
Louisiana, yeah.
Yep. So here, the side view one just kills it completely. But here's another one. Okay, so here's a close up. It's like zoomed in, and you can see the mirroring effect. It's a miraging effect. Now I'll show you the same thing happening on a flat bridge. And Drace just posted one as well where it shows like on a normal day where you don't have that mirage taking place. We can see just straight across like normal. And then the one I posted underneath, what you'll notice is when the camera gets pushed down closer to the ground, right, it's looking through like a gradient of heat. And it looks, you have a look at the left railing on the bridge. As he puts the camera down lower to the ground, you'll see that the left railing on the bridge goes from looking straight.
So it's about heat?
Yeah, it's about like the way that the light travels back to the optic. So when you have really hot air down lower and cooler air above it, the light will always deviate towards the cooler air because cooler air is more dense. Okay, so it will deviate a little bit towards the cooler air because it has a higher refractive index, and it's going to make things in the distance look like they're sinking down, like they're displaced downward.
This sounds more relaxing. That if the Earth is flat, it just sounds more relaxing.
Yeah,
it's creation, mate.
Look,
you don't have to worry about
a globe spinning
getting
at millions of miles per hour in all these different directions through space, or a nice stationary Earth.
You don't have to worry about asteroids coming to get you.
Great point.
You know,
and it sounds more realistic, actually.
Yeah, it matches exactly. Like what they've done is they've replaced everyone's common sense with a bunch of nonsense. Like we experience that water, a large body of water needs to have a container and that it's flat on the surface when it's at rest. Whereas they've convinced people that it just looks flat, but really it's curving. And they tell people that
actually just now, right at this second, it's the first time I understand this point about the water. That, yeah, I mean, I don't know. I feel like it wouldn't just stay like that, like stick. But then I don't know.
Well, this is what we can do, and this is what we have done. We can go test for the curvature. Now, if you have let's say we have a 10-mile lake. Okay, it's 10 miles across the lake, and I'm standing on one side of the lake, and you're standing on the other side of the lake, right? This is just a hypothetical. Okay, I shouldn't be able to zoom in across that lake and see you on the other side, because if we calculate how much curvature there should be over that distance, there's about 22 meters of curvature over that distance if the Earth were a globe. Okay, that's 66 feet is about 22 meters approximately, something like that. So I shouldn't be able to zoom in. Say I'm 6 foot tall, you're 6 foot tall. I zoom in across the lake. I shouldn't be able to see you unless you were over 66 foot tall. Like let's say you were 70 foot tall. I would just be able to see your head or something like that, like a little, right? That's like more than a 6-story building.
The island?
Well, no island, just a lake, like a 10-mile lake, just with water. I'm on one side of the lake. You're 10 miles away on the other side of the lake, just standing on the shoreline. And the only thing that's in between us is water.
Do you know about this guy from Hawaii? This flat earther.
I've seen some observations from Hawaii where he can see things that he shouldn't be able to see if the Earth were a globe from a long distance.
Yeah, he films the Oahu Island. You know that video?
Yeah, I've seen the video, yep. I think Jin CBR1 shares that video.
I don't know if he was zooming in. I don't remember. Yeah, but I haven't seen his other videos. But he should make a video, because that's the perfect location. He should buy a better camera and make a video zooming in. Just curious to see. I'm curious to see what kind of, like, how like I just want to see something at sea level on the other island, like a human or something, or a store or something like that, you know.
Yeah, I'll show you. I can show you one right now.
Sure.
Right, I'll show you a good observation that's done over the ocean. Okay, so just a second. Okay, so the person that's doing this observation is a very smart guy. His name's Dr. John D, and he has a PhD in spectrometry. Okay, it's got another name as well, spectrophotometry or something like that. Anyway, he went out originally to try to debunk flat Earth by doing long-distance observations and laser tests.
I love those.
And he actually became a flat earther in the process because he was able to see huge distances. Now, this is one of his tests that he did. So just a second, I'll just bring it up. Yeah, definitely. Because he's a professional when it comes to optics and things like that. So anyway.
I'm a truther, man. I'm a truther. That's the thing about me.
Yeah, I mean that's what our channel's all about, is just, you know, truth. Showing people, hey, have a look at this information and use your own logic and common sense and analyze it critically and come to your own conclusions. Okay, so here is an observation. Okay, so he set his camera up on the shoreline at the beach. Right, this is in the United Kingdom on a very, very nice, clear and calm day. And he sets his camera up at 1 meter high on a tripod.
How far away are these things?
Okay, so these things are windmills, like a windmill farm. It's called Rampion Windmill Farm.
Mm-hmm.
And the closest windmill is 8 miles away. And the furthest one on the right-hand side is 11.2 miles away.
What is this thing in the back? It looks like a building or
That's
a boat.
a ship. It's a boat. Yeah, there's a boat out there. And he tracks the boat as well on the shipping radar, on the ship tracking radar. And that boat's about 14 miles away, 12 point something nautical miles. So that's about just over 14 miles away. But anyway, concentrate on the...
That ship is 40 miles away?
14 miles away. So I'll show you some information about the ship. Yeah, we can focus on the ship, actually. It's 12.1 nautical miles, which is 13.9 miles. And it's actually called the Shetland Trader. So he looked up the ship. So I'll just post a few screenshots of the marine tracking, just so you can see the path of the ship and where it was. Okay, so the height of the ship above the water is approximately 7.2 meters. Here's some screenshots.
Can you repeat the last thing? Sorry.
Yeah, so the height of the ship,
okay,
the deck of the ship, is 7.2 meters above the surface of the water.
How many meters?
7.2.
So the top of the ship is 72 meters.
7.2.
7.2 meters, okay.
Yep. Okay, so let's have a look at how much it should be hidden by behind the curvature of the Earth. Okay, so here's a screenshot from an Earth curvature calculator. Right, so I'll just explain what it says on the Earth curvature calculator. Okay, so it says eye height, 1 meter. So that's the height from the camera. Okay, and the target distance is 22.3 kilometers, which is 13.9 miles.
Just 10 kilometers, please.
Yeah, okay. All right, cool. So the camera height's 1 meter high.
Yeah.
The boat's 22 kilometers away.
So that the camera is 1 meter plus the height of the person, or just that 1 meter?
No. Just he's got it on a tripod. Yeah, he's got it on a tripod, and it's 1 meter above
so 1 meter from sea level. Okay.
That's right. Can you see the screenshot that I put in the side chat? It says Earth curvature calculator. Yeah. So on the right hand side is the measurements on the calculation with metric.
Mm-hmm.
Okay, so it says the target hidden height should be 27 meters. Okay, so that boat the boat would have to be 28 meters tall, and then you would just be able to see the top 1 meter of the boat sticking out from behind the horizon.
How tall is the entire boat?
The entire boat is about 7.6. Can you see the graphic? Right, there's a picture of the boat there. I'll just post a couple of pictures of the boat. Some more information about the boat. Yeah, this is the boat. It's called the Shetland Trader.
23 feet.
Yeah, it's got it in meters as well.
So 27 meters is this is the height.
That's how much. No, 27 meters is how much that boat should be hidden behind the curvature of the Earth. Right, so you shouldn't be able to see the you shouldn't be able to see the boat at all. If the boat was like 30 meters high, then you would just be able to see the little top of the boat, right? Like the top couple of meters of the boat sticking out over the horizon. But we can see the whole boat, basically. It's a little bit blurry, but we can see the whole boat.
Yeah, what about this reflection thing this guy is saying?
Reflection? Refraction? Yeah, we can. So, yeah, refraction. Okay, so we have an extremely clear day, and we have minimal refraction on that day because we can see everything perfectly clear. So we know we don't have any crazy effects going on. Okay, so
what is this refraction thing?
Refraction is when the light deviates a little bit when you have a temperature gradient.
And it just conveniently makes things look like it's
so when you've got like people that try to debate against flat Earth, they'll just kind of say refraction makes the Earth look flat, basically.
Because someone said the same thing for the Oahu Island, which is 90 miles away.
Yeah, it's the only thing they can say. So they think that they've got like a magic word that they can say, which most of them don't really understand much about. Okay, and they think that because they say the word refraction, therefore they say that the light's bending, and that's what just makes the Earth look flat in all of these observations. Like anyone can go and do these observations. Okay, and every time you do them, you can see so much further than you would be able to see on a globe. And some of these people that try to debate against flat Earth, like for a hobby or whatever they're doing it for, they don't have an explanation for it, so they have to come up with something. So they'll say that the way that the light's bending is just making all of the water look flat. They'll say, this is what they're saying. Really, that boat isn't there. Okay, really, that boat's hidden behind the curvature of the Earth, and it's not visible. It's geometrically obstructed behind the curvature of the Earth. But because of refraction, it just makes everything look completely flat, and all of a sudden you can see the boat. So if you were to like shoot that boat with a sniper rifle or something like that, right? They say that the bullet wouldn't even hit the boat; it would go straight through it because it's not really there. They say it's just an illusion that we can see the boat. It's the dumbest thing. It really is.
Oh yeah, by the way. Oh yeah. I was gonna look up how far away can snipers shoot. But yeah,
that was just a hypothetical. That was just a hypothetical. It's like 4 miles is the longest shot. It wasn't a literal statement. It was just an imaginary. Like if you
but maybe
shot it with a missile. Let's say you used a cannon or something that could shoot that far, ballistic missile. They'd say that it would just go straight through the boat because that boat's not really there. They say really that boat's hidden behind the curvature of the Earth. Okay, but this is the problem. Okay.
They say that the bullet is going above the curvature if you also shoot that far, or yeah, like a rocket. If someone shot a rocket They're going to say that the rocket goes.
If they this is what they're saying. This is just just a hypothetical example. Let's say somehow you were able to shoot a laser or something, whatever, a missile, a laser, at the boat that we can clearly see. They're saying that boat's not really there. It's just an illusion. Really, that boat's not there at all. It's just refracted up, and it's not really there. It's just an illusion.
So what about an actual laser experiment? I heard there was one or something.
Yeah, sure. So
do you have some proof of that?
Yeah, we've got tons of laser experiments that have been done, but I'll show you.
Show me the furthest one.
Yeah, I'll show you one of the furthest ones right now. So just give me a second, or give me like 15 seconds. I just got to pull up the information about it. So I'll tell you a little bit about it while I'm just finding this. Okay, so this is a group called FE Corps, and it stands for Field Engineers Corps. It's a bunch of field engineers from Europe, and they got together and they spent about 1,000 hours and about $30,000 building an extremely high-tech, high-powered laser beam. Okay, extremely high-powered laser.
Mm-hmm.
So, and they did a test. Well, they did a whole range of tests, but the longest test they did was 40 kilometers over a lake in Europe. All right, so just a second, I'll just pull up the test. Okay, so what they did was they set the laser up at 1.5 meters height above the surface of the lake, and then they had a target 40 kilometers away on the other side of the lake that was also 1.5 meters height. Okay, now if the Earth's a globe, you shouldn't be able to shoot that laser across the lake and hit the target, because there would be a huge amount of Earth curvature over that distance. Right, just a second, I'll just pull up the test. Okay, so they recorded all of this. So we've got a 1-hour video where they go over all 5 of the laser tests they did.
How far away is the target?
40 kilometers away.
Okay.
Just a second.
And they're saying that how fast they're saying you should stop seeing something on the other side after the curvature. How short? Just 4 miles or when?
Well, what they're doing is they're setting up the laser level. So that means that if you picture a ball, okay, picture a globe, and then the laser sitting on top of the globe, and the laser's level, like it's horizontal, and it's going to shoot the laser beam straight out. Okay, so the ground underneath, right?
After how many miles the globals are saying this should happen? How many miles?
Okay, so this is how it should work. If you had a target that was about 90 meters high, and on the other side of the lake, 90 meters high, then the laser would hit the target 90 meters up in the air if the Earth was a globe. Because there should be about
at the tallest point.
No, so if okay, hold on a second. I've got some diagrams and stuff, so I've just pulled up the test here. So it's easier if I explain it with.
No, like if you have a target that's 1 meter tall.
Yep.
After how many miles do you stop seeing this target completely? If it was a globe, according to what they're saying.
Oh, okay. It's 1.5 meters high, so you would stop seeing it at about 2.5 miles, about 3.5 kilometers away, something like that.
Only 3 kilometers, you stop seeing it completely?
Yeah, that's where the horizon would be. That's where, and you wouldn't be able to see anything beyond the horizon. Yep.
Yeah, that's ridiculous.
So if you're 6 foot tall, this is what they say. If you're 6 foot tall,
anybody knows this is not true. Anybody knows this is not true.
Yeah, it's exactly. It just exists in mathematical form, right? In reality, it doesn't work because we can shoot a laser over 40 kilometers and hit the target.
Okay, that's
all right. So here's the test. Yeah, got it here. All right, I'll just post it. It's probably something you can go over in more detail later on because it's an hour long video, and there's also a Google Drive link and they have a 180-page PDF document where they go over all of the details for the test. But they hit the target on all 5 of the tests. Okay,
I remember the video, but I haven't watched it.
Yeah. So there's like 90 meters of missing curvature. I'll just put some diagrams, just so you can. The diagrams have the numbers written down.
Tell me in this video where I should click to see the test or the light hitting a target. What minute?
Well, they do 5 different tests, so it depends which test you want to look at. I recommend probably
all of them.
Watching the
Or
whole.
any of them.
Yeah. What? Yeah. I probably recommend watching all of them. But it's this is one of the more technical tests because this is a team of engineers and they get into extreme technical detail about everything because they want to cover all bases, if you know what I mean. There's other laser tests that are more simple to follow along with if it's the first one that you're going to be looking at.
Well, they're explaining a lot of stuff, but I want to see the result because obviously not gonna watch 1 hour right now.
Yeah, the result is that they hit their target at 1.5 meter height, 40 kilometers away. If the Earth were a globe, that target should have been hidden behind 90 meters.
But why does it bend like that at minute 13:25? At 13:25, it rotates up in the air. Why? What is this?
Let me have a look.
13:24. Oh, I see. It's like a reflection.
Yeah. I think that they're trying to I think they're testing the equipment and that kind of thing, making sure they're leveling it properly.
No, it's something to do with the water. Look at the other stuff in the picture. All the lights are like a mirror. I don't know. It's like I don't know, water reflection, I guess, or something.
Yeah, what he's showing there is.
Oh yeah, they're pointing in the water.
The laser is being pointed at an inferior mirage, and when it hits the mirage, the laser is deflected upwards, and you see a reflection of the laser.
Oh yeah, I can see now in the night picture. Yeah, I can see now. Okay. So this here at 13:25, 13:31. This is the result right here. This is when they're hitting the target.
No, this is a 50-minute video. The test at 13 minutes was them just doing a test, setting it up, and the conditions for the test weren't good that day because there was an inferior mirage.
Okay.
So they continue the thing, and that's why it takes 50 minutes because it's they documented the whole process.
You guys really want me to watch the full video, huh?
You don't have to do it right now. You can do it some other time.
So yeah, this is kind of what it comes down to. There's tons and tons of these laser tests that people have done in all different weather conditions, different locations, all over the Earth. Okay, and they're hitting their target consistently, where there should be hundreds of feet of curvature blocking the laser from hitting the target in all of these, but the laser's always hitting the target. Then when we're doing the observations, we shouldn't be able to see what we're seeing in the distance because it should be hidden behind the horizon. It should be blocked by the curvature of the Earth, but it isn't. Okay, and the globe earthers don't have any tests that show the opposite of that.
Yeah, it's also not what we want. You said earlier before DJ or whatever. I don't remember who was talking before that. That do we want you to watch this video? No, I don't want or need you to do anything. This is about what do you want? Will this video land for you? Will these observations and these tests work? If not, just tell us up front. Say, hey guys, it doesn't matter what's shown in this video. It won't change my mind either way. It's not evidence. It's completely irrelevant. So we know to move on to another observation, another measurement, another practical demonstration. Rather than just like barking up the wrong tree to get that squirrel, let's just move on because there's something else might land.
So Elio, I've got one more really good long distance observation, which also has a laser test in it. If you want me to present it quickly, this is probably one of my favorite ones.
Just give me a second. I'm watching the moment where they say they hit the target.
Yeah, sure, I'll go for it, man.
But I'm not understanding what they're showing here.
Yeah, that's why you'd have to sit down and watch the whole thing from start to finish, so you know what point they're up to, and so they can explain what they're doing step by step.
There should just be one person at the end filming the impact. You know?
There is. But it is one of the more technical laser tests, so it's one of those ones that you have to sort of sit down and pay a lot of attention to the whole video, because it's like step by step. And they're doing 5 different laser tests in the video, so you got to make sure you're understanding which one they're doing at which point. That's why I was suggesting a different one. I probably should have shown you a different one. I can show you a different one that's much easier to follow along with. It's way less technical. They're just shooting a laser over a 21-mile lake and hitting the target. Simple as that.
Let's see.
Right. They also do a really good observation as well. Okay, so have a look in the side chat. It's just uploading. Okay, so this is the Great Salt Lake in Utah. Okay, and what he's doing is he's zooming across a 21-mile section of the lake. Sorry, 33-kilometer section of the lake. Okay, Logical Observations just posted the full video to it. But don't worry about clicking that just yet, because I'll just show you some screenshots out of the video, some clips out of it. Because it's much easier than watching the whole video. But save the video for later. Okay, this is the camera that he was using here. It's a Nikon P1000. It's one of the most powerful zoom cameras that you can get. Can you see the picture of the camera? Elio.
Picture of the camera, yeah.
Yeah, you can see it?
Yeah.
Okay, so that camera is set up at 5-foot height, which is 1.5 meters height.
Mm-hmm.
Okay, and he's going to be zooming across to the other side of the lake. Okay, so here's a picture from like Google Maps, just showing you where he's standing and showing you where he's going to be looking across to. So you can see a yellow line. He's going to be, that camera is right at the top of that yellow line, and he's going to be zooming in to see if he can see the shoreline on the other side of the lake. Okay, he's got a buddy over on the other side of the lake that's taking some footage, so we can see what it looks like where he's going to be zooming into. Okay, so this is what it looks like 21 miles away over on the other side of the lake. Can you see the picture of the shoreline there?
This is the picture zoomed in?
No. This is his friend that's on the other side of the lake where he's going to be zooming into. I just want to show you what it looks like on the other side of the lake. So when he zooms in, you can see what it looks like over there. Okay, take note of the big giant beach on the other side, and then we can see a big giant white tower in the background. Just take note of that, because
this tower, yeah.
Yep. Okay, so now I'm going to show you the zoom footage. All right, so here's a screenshot of the tower and the beach shoreline from the camera that I posted the picture of. Okay, so this is from 21 miles away, and he did it during the daytime, and then he did it again during the nighttime, because quite often the globe earthers will say, "Oh, you need to repeat these at nighttime where there's less refraction." Okay, so he repeated it at nighttime, and once again you can see that it looks exactly the same. In fact, it's even maybe a little bit more distinct because we've got the lights as a reference. Okay, so just a moment.
And that's how many kilometers?
33.
Wow.
34 kilometers away. So over that distance, there should be 293 foot
I'm gonna
of
save
curvature.
this video.
Yeah, it's a really good video. So over that distance, there should be 100 meters of curvature.
Bro.
All right, now have a look at these pictures. All right, so here's a close-up of the beach and the tower again. Just a second, it's just uploading. Sorry, my internet sucks. Okay, so this is just a close-up of the beach and the shoreline and the tower. Now, this next image is the zoom footage, just a screenshot from the zoom footage. So what you'll notice is that we can see everything pretty much just the same. We can see the bottom of the tower. We can see the shoreline below the bottom of the tower. We can even see the lights reflecting off the surface of the water.
What about the previous image, the one during the daytime? Sorry, I wasn't paying attention.
Oh, the daytime one? That's just a close-up. That's just a close-up.
Oh, okay.
Yeah, just so you can see what it looks like from close-up. Okay, so over
From
that
the guy
distance,
who was there.
Yeah, exactly.
Okay.
And so that beach should be hidden behind 80 meters, just over 80 meters of curvature.
Mm-hmm. And this last one in the nighttime?
Yeah, that's from where that camera's set up, 33 kilometers away.
33 kilometers.
Yep.
And what are these things at the bottom? These are houses or what?
Yeah, it's like a mining
buildings.
Yeah, it's like a little mining
They're at sea level, yeah.
You know what I mean? No. This isn't at sea level. This is over the Great Salt Lake in Utah.
I mean, yeah, it's.
Oh, look. Yeah. Oh, you mean the tower?
No, the buildings. They are.
Oh, yeah. It's not really buildings. It's kind of like.
They're not on a hill or something.
No, I'll show you exactly what it looks like. I got some more pictures of it here.
No, like I'm saying, like they are down, so it's good.
Yeah, here's a few more pictures.
Yeah.
All right. So this is just some random pictures I found on Google, just so you can see. Oh, Overfences just put the Earth curvature calculator screenshot in the side chat. Eye height level, Overfences. Eye height level, yeah, you got that right. So the horizon, right? This is what it's really about. So the horizon should be at 4.3 miles away. Sorry, kilometers. That should be the maximum distance that you can see the water. Anything beyond it should just be visible beyond the horizon. You know, if something's hidden behind the horizon, you would just see the horizon, which is the line where the sky and the ground meets, and then the tower, the beach, everything else. The beach should be completely hidden, and you should just be able to see some of the tower sticking out over the top of the horizon. Now, this is how far away the horizon should be. Right? I did a diagram, and I drew the black line across it. Okay, so that's at 4.37 kilometers, which is 2.7 miles. Okay, that's where the horizon should be. So that's the maximum distance.
What's this thing at in the far left? That's where the buildings are. What?
Of which image are you talking about? Sorry.
This last one.
Oh, the last one.
I don't understand what this line is supposed to mean. I understand what
the
the
black
horizon
line
is, but
the black line. Yeah, so that's where the horizon should be. Okay, so when he's looking out, so hold on a second. I'll just post another.
No, I mean, where is he in this picture? Taking.
Oh, he's at the bottom of the yellow line. That's where the camera's set up.
Taking a picture towards
the
in the
yeah,
picture.
towards the other side of the lake. Here we go. Look, this is just to show you.
At the top of the image.
Yeah. Have a look at this one. This one will explain it just fine.
Oh yeah, I understand.
So he's shooting right across that distance, but the horizon, if the Earth's a globe, the horizon should be at 4.3 kilometers away, which is where the black line is.
I mean, even if it was a globe, it's ridiculous that that's where they're saying that the horizon should be. I feel like even if Earth was a globe, the horizon should be like somewhere like, I don't know, 100 kilometers or something.
Most people think that. Yeah, most people don't realize how much curvature there should be over a pretty small distance. Usually when we say that there's 22 meters of curvature over just 10 miles, which is 16 kilometers, sorry. 22 meters of curvature over 16 kilometers, they're like, that can't be right. And then they go look it up and it's like, yep, you can go look it up.
That's what happened to me. That's what happened to me.
Yeah, it happens to everyone. It happened to me too. I was like, that doesn't sound right, you know,
it sounds
because
like low effort, you know?
Mm-hmm.
Low effort.
No, the horizon is it's never at that distance, ever. Like, I've never seen one observation in the last 8 years of looking into this where the horizon's even close to that. We can always see the horizon like at least 5 times or 10 times further away or more than, you know, in this observation, you can't even see a horizon at all over the whole 21-mile lake. It's just flat water over the lake.
Well, I never thought I was gonna become a flat earther.
Yeah, me neither. None of us did, bro. Every single one of us thought it was ridiculous.
When it comes to 9/11 or moon landing, from the beginning I said, yeah, this is probably fake. But with flat earth, it's been years and years of, I thought it's ridiculous. But here we are. But you know, this camera, from this experience, is it like one of the most sophisticated cameras, you know?
It's a Nikon P1000. It's a Nikon P1000. They cost about $1,000, $1,200, and they have 125x optical zoom, which is far beyond what any other consumer grade camera will have. So it can zoom in like really, really, really far.
They should put this camera over the Oahu Island in Hawaii.
Yeah. Well, we have observations from all sorts of different places. We've got hundreds of these observations, and some people, what they do is they upgrade the camera and they fit it with infrared. So that means that it cuts through all of the haze and refraction and things like that, so you can see even further. So people are doing footage with the infrared cameras, and they're able to see even further than without it. And people are taking these types of cameras up on planes, and they're able to see things that are 1,000 miles away that should be hidden by miles of curvature. There's a guy called Jay Tolan. He takes about $15,000 worth of camera gear up on a plane, and he does observations, and he can see things that you shouldn't be able to see by such a huge amount. It's crazy. And he uses like infrared.
Now I regret that I didn't pay attention when I flew with the airplane. I didn't pay attention to look over the window to notice
or to fly from an airplane too.
Because I remember it goes, and inside the clouds and then it flies over the clouds. So before it touches the clouds, I should have paid attention to see what it looks like.
Yeah, I mean, I've done a ton of flights, and I've done a ton of flights, and you just see a completely flat horizon from any trip that I've ever been on. I've flown over Alaska at 40,000 feet, and you just see a completely flat horizon. Now, that's not proof that the Earth's flat, because apparently, even if it was a globe, you wouldn't see curvature from that height anyway. It just further backs up that we all experience the Earth as a flat plane, right? Even people that believe it's a globe still experience it as flat and stationary. They just believe that it's a globe because that's what they got told while they were growing up. And then they've been shown pictures by NASA and things like that. And they see it in the movies and TV shows and all that sort of thing. So they just kind of have a belief system that the Earth's a globe. It's kind of like a tradition. It gets passed down.
So who's doing this? Is it like an occult or one world government, something?
Well, I think it's kind of like a tradition. It's kind of like information that's passed on as true. And most people are not going out and doing the testing. Most people are just taking it for granted that it's already confirmed. It's already been confirmed in the past sometime that the Earth's a globe. But once you start digging into how the Earth actually is proposed to have been, like that it's a globe, you'll start finding it is actually cult leaders, like mystic cult leaders like Pythagoras. Okay, I don't know if you've heard of the cult of Pythagoras, but he's the first person that's credited with saying that the Earth's a globe, right? And he didn't go out and measure the Earth or do any calculations or anything like that. They worshipped spheres. They thought spheres were the most divine shape and that the Earth must be a sphere because of that reason. So
what about all this so-called science? I mean,
yeah, there isn't any.
Looks like it's
math. It's calculations. It's calculations that are based on assumptions. Like if you go onto Google right now and you type in who measured the Earth, who first measured the Earth to be a globe, it's going to come up with an ancient Greek guy that they can't even prove existed at all. And there's no writings left at all of him. They'll say that what he did, Eratosthenes, is he calculated the circumference of the Earth by measuring a shadow angle. Okay, he pre-assumed that the Earth's a globe, and then he made a few other assumptions, and he did some calculations based off those assumptions, and he just calculated that the Earth's a globe. And he's the one that's credited with calculating the circumference value of 40,000 kilometers for the globe. But it's a myth, right?
Let me add to it, because it's logically fallacious. It's circular reasoning. Like you said, they pre-assume the Earth is a ball, and the shadows would look like this on a ball, and then the shadows look like this, therefore the Earth is a ball. We still do this today. We have children going through doing this fallacious exercise over and over again. However, the Chinese also did this during the Ming Dynasty, but they started with the assumption if the Earth is flat and the sunlight acts like this, the shadows would look like this. We see the shadows look like this, therefore the Earth is flat. Circular reasoning doesn't become logical regardless of who uses it for whatever purpose.
Wait, this video is interesting. Let's see.
So guys, like basically you think like in the Cold War, the space war was like fake. It was like just a big
yeah, it was propaganda put on by NASA, and ironically 3 months ago Trump named them a spy agency instead of a space agency. Now they have a new classification as an intelligence agency. Now they're a spy agency. What do you think of that? So all the way back then they were putting out the propaganda and everybody fell for it. See?
If you look into Project Paperclip, you'll see that America recruited Nazis after the fall of Germany, and most of them went to NASA and the rest to the CIA. the Russians also got their share of Nazis, and those Nazis ended up heading up their fake space program.
I mean, that's what intelligences are. They are just spies. They've always been that way, even in medieval times.
That's what you get. That's what you get for your information nowadays. So you can listen to them, or you can listen to yourself and know the Earth is flat. And since you know it's flat, you'll be able to tell when anybody's lying to you in the future.
But I'm just saying that the country where the intelligence are, their own country calls them intelligence, but for the other countries, they're actually spies or assassins or saboteurs. But my point is, they've always been that way. That's what, yeah. That's what ninjas were. Ninjas were basically just what the CIA is today. Or saboteurs. Every country calls them something else, but it's the same concept.
Yeah, well, I come from Vikings. We didn't have that shit.
Vikings. I'm sure Vikings may have some spies or assassins.
No. Like weak men, no likey. And I come from a country as well that we don't have an army nor a spy agency.
Do you guys believe that the Earth have an edge?
Wait, what country is
You're
that
extra quiet today, Bryce.
Yeah, I'm probably not speaking directly into the mic. I'm sorry.
What country doesn't have
I'm from
an
Iceland.
army, bro? Oh, Iceland. Oh, I mean Ireland. Yeah.
Just quickly to respond to the guy that asked about the edge. Yeah, we're not claiming to know the shape of the Earth. We're not claiming an edge. And we absolutely don't claim that the Earth is a flat planet floating around in the heliocentric idea of outer space. Okay, so we're not making claims to whether there would be an edge or not, or anything like that. What we're talking about is when we measure the actual surface of the Earth, and there's no curvature over very vast distances, in where there would have to be curvature if the Earth were a globe.
Oh.
Yeah. It's not like flat is not a shape, it's a descriptive term for a surface, especially in this context. So they tell us that over 70% of the globe is covered in water. Okay, but when we measure the surface of the water over large distances, there's no curvature. And that's repeated over and over again in all different locations, completely validating that there's no curvature present. So if there's no curvature, then you can't have a globe.
Okay.
Yeah. And then we've got a ton of tests, laser tests, infrared footage, long distance observations, mirror tests, all sorts of different tests that we're showing people. It's like, hey, check out this information, have a look at the tests. And the good thing is people can go and replicate these tests themselves, so they don't have to have faith or trust or anything like that. It can be something that can be obtained as actual knowledge, like a measurement. You can know for sure that there's no curvature.
I'm grateful for this discussion tonight. I've seen heard very interesting things. Thank you, bro.
Oh, no worries, man. I appreciate having someone like that.
It's 3 in 2 days, by the way, DJ.
What was that?
No, a lot of people are like in the position that you're in. When they're shown this information, a lot of people are waking up to the truth, basically.
I mean, for me, like I said, doesn't bother me. Nothing what people think. I mean, it's I have no problem with accepting that it's flat, so don't really care. Like, the thing is, people are just afraid and scared. So I'm not like that because I'm actually passionate by truth, especially hidden truth, conspiracy theories. I'm passionate by.
Most people really care what other people think, and that's actually the tactic, or one of the best tactics that they've used against Flat Earth, is not to try to address our actual arguments, but try to make it that it's socially unpopular to believe in this, and that Flat Earthers are just tinfoil hat wearing morons. Okay, so people won't even want to get involved in it because they're scared of being ridiculed.
Yeah, that's what I mean by scared. Yeah, that's
it's a smart form of propaganda that they actually use to try to keep things like this away from people.
That's why I say that people are afraid.
Yeah,
I'm not afraid. Like all the people can laugh at me and say I'm a flat earther. It really doesn't bother me, you know. It's just zero effect on me.
It's changing a lot. It's changed a lot. Quite often, people are much more like, people have heard about it. A lot of people are much more accepting of it, and people that you wouldn't even know are flat earthers, you'll find out, oh shit, I didn't realize he was a flat earther, and then you mention it, they're like, oh yeah, I know all about that. I've looked into it. But a lot of people don't talk about it, with their friends and family.
Yeah, I think the biggest mistakes people do when they realize this is they get sometimes overzealous with it, and they start trying to push it too hard, and that can push people away. But anything can do that. You get too into veganism, you get too into carnivore, you get too into workout, you get too into chess. Doesn't matter what it is. If you're super passionate about something, and if you don't know how to rein in that passion a little bit so that other people feel comfortable, you can push them away. And
too much
can kind of inspire passion in people because there's a lot of stuff to discover. The world opened up, and there's a lot of unknowns that are interesting to look at.
But I've always been what's the word?
Truth seeker.
Maybe outsider, truth seeker for sure, but maybe outsider, the black sheep. You know, like I've always been different than others, not just for the sake of it, but I've noticed, like, you know, when people, I don't know what example to give you. You know, when there's a joke and everyone laughs, but you feel like you want to put a different type of reaction, right, to that joke, like with an emoji reaction, for example. I've always been that way because I like to express myself truly, the way I truly am. I've always been different, and
yeah, sounds like you don't easily go with the flow and like to find your own path.
Yeah.
That's a valuable person to have in society, because otherwise, if everybody were following the same path, everybody would be like a lemming running off a cliff.
I know all the change starts from one person. I am that person. I believe it. I'm not afraid to say, hey guys, this is wrong. And I have done it in real life. In a large social group, I have done it. You know, not afraid to do that. Because I really don't care if people say I'm wrong or I'm weird or crazy. I have no problem. I've been used to that my entire life. It's who I am. You see, this is the type of people who learn about these things, at least at this stage, when it's not mainstream. This subject, for example.
Most people that mock and ridicule Flat Earth and defend the globe, they really don't they don't know anything about the globe anyway. They don't know any of the basics, and they don't know the Flat Earth arguments. They, in their heads, have pictured a flat disk floating in space, and they think Flat Earthers are a bunch of crazy people, like I explained before, thinking crazy things that's just propaganda, like Australia doesn't exist and things like that. They think Flat Earthers actually claim these crazy things, which they don't. And quite often when they come in here to try to debate with us, they get a rude shock because we can expose really quickly that they don't really know anything about the globe, and they don't know anything about our arguments either. So they kind of have no ammunition, and they don't realize that until they've already come in and engaged with us. So then usually they'll turn to like mocking and ridicule, or they'll just run away, fight or flight basically. But yeah, it happens every day in here.
Yeah, time. Excuse me. Time. Time solves everything, and I would say that time is a powerful thing because, for example, like people have believed that the Earth it's a globe their entire life, and when they hear that some people believe it's flat, this concept is so ridiculous that they find it ridiculous. They find it ridiculous, and so they start to believe these people must be crazy. How can they believe such a ridiculous thing, such a concept that's so hard to imagine, And so that's why they start laughing and stuff like that. I think it's ridiculous. That happened to me as well. But then, after the funny stuff goes away, and it's been 5 years, 7 years since you heard about these things, and then you're like, okay, but these people are still talking. They keep talking about it. They're still going. Okay. So okay, let's hear what they have to say. Like you can laugh about it, but then if people are still talking about it, after a long time, you're like, okay, let's see what they have to say. Like you see people insisting. They're like, hold on. Is there actually something there?
Yeah, it's funny that they do have trouble imagining it, even though it's exactly what they experience every day of their life. Quite often when they come in, they'll say, oh, we're too small to see the curvature of the Earth because the Earth's so big. And then we'll say, oh, so you experience it as flat then? And they'll be like, oh, no. I'm like, but you just said that you're too small to see the curvature of the Earth. So therefore you experience it in your basic reality as flat. And they cannot, their ego or their subconscious or something like that will not let them, even say that it could be flat. Even though they just admitted that by saying that, oh, we're so small and it's so big, so we experience it as flat. And you say, so you experience it as flat. They're like, well, no. It's kind of crazy. And same with the motion of the Earth. Okay, so we'll say, do you experience the Earth as your base reality as motionless? They'll be like, yes, because it's so big and we're so small, we can't feel the motion. So you experience a motionless Earth. No. It's kind of crazy. Like nearly everyone's kind of like that. Everything that we're claiming is exactly what everyone just experiences, right? Water needs a container. It's flat on the surface. The Earth, we experience it as stationary. These kind of things. It's just
they tell you their true experiences, and then you're saying, oh, so that means this thing, and then they're saying, oh, that must imply another globe. So of course, then they become defensive because of fear.
Yeah, definitely. Here's another crazy one. We'll say we see the sun move across the sky. The sun moves across the sky. On a globe, when you're watching a sunset, this is what they're telling you is actually happening. They're saying that that sun's not even moving from your perspective, and you're spinning backwards away from the sun, faster than the speed of sound, faster than a 9mm bullet, right? And it just makes it appear like the sun's setting. Whereas the flat earther will just say, yeah, the sun's moving across the sky. They've put everything backwards. Everything that is common sense, they've told you, you cannot trust your senses. You need to trust what we're telling you. And all your senses are wrong.
Yeah. And I mean, this is according to the... Give me a second. according to the globe model, they're saying that there is this gravitational field, or what's it called? This atmosphere, right? And the Earth is spinning fast, and going fast, but somehow the trees and everything are not flying away, or the wind is not pushing them super hard. And they're saying it's because of this atmosphere, which is like a protection field. But if that was the case, I would expect to see some type of like millions of clouds, like levels of clouds, or level of some type of stuff, not necessarily clouds, or something, some type of like roof stuff that would make it seem like there was this atmosphere protection against the wind, the speed of the planet is going in the universe. But if it's flat and the sun is just clear and the clouds are just chilling, right? That makes more sense. Because the planet is not traveling
some days
super hard. That makes more sense now.
Exactly. It's just we have wind because of pressure systems, because we have temperature differences, and it causes pressure systems. And sometimes we'll have wind going easterly. The next day you might wake up and then the wind's going westerly, and then you might have a southwesterly, and it's just depending on what's happening with the pressure systems. Meanwhile, we can balance rocks. Have you seen those people that balance rocks? They're balancing, like, making the craziest rock sculptures by balancing all these rocks on top of each other really high. And meanwhile, they tell us that the globe is spinning at 1,000 miles per hour. It's orbiting around the sun at 66,000 miles per hour. It's chasing the sun at 480,000 miles per hour. And that whole system.
How did they even measure these things?
It's all theoretical, conceptual. That's what it is. It's a theoretical concept, a mathematical concept, whatever you want to call it. It exists in like mathematical formulas and things like that, not in reality. There's a ton of assumptions baked in to what they're telling us.
Yeah.
It all starts with the R value, the radius value. It's baked into all of the math behind the globe, and that's the radius value. That's what we can. That's the easiest thing for us to go out and test in reality, because it means that the curvature would have to be there, right? These long distance observations and laser tests, they also debunk gravity, as gravity is explained in the globe model. Okay, because the gravity dictates that that everything is being pulled towards the center of the globe, towards the center of mass. That means that the water would have to be curving at a specific rate for gravity to exist. If the water's not curving, that means that gravity isn't possible, because if gravity is real, it has to be curving at that specific rate. It must be. So everything's going to come back to those prerequisites, or those pre-requirements for the Earth to be a globe, which is the curvature. It's the bendy water that they show us in the NASA pictures.
Interesting.
Yeah, it just so happens that the one thing that would like actually confirm all their claims is impossible. Right? It doesn't exist and returns a nil result. And they just conveniently have all these excuses why that is. Right? Giant paper mache made, and you can just poke holes, it falls apart.
Would be flat. Are you a Christian, DJ?
I'm not really religious. I don't really follow any particular religions. I do research into Christianity and that kind of thing. My wife's a Christian and my mom's a Christian. But yeah, I'm looking into it. I'm learning about things. That's that's not something that I really use when I'm talking about like this topic. I'd rather empiricism.
You seem very open-minded.
DJ, can I ask you a question?
Yeah.
Yeah. So, are there any other planets?
Yeah, Earth. Like when you say other planets, you're assuming that the Earth is a planet, and
yeah. So
what we're talking,
like, is Earth the only one surface like that is flat, or are there any other planets that are also flat, or
like the
moon? We believe in other planets at all?
Yeah. So this is. Let me explain it, because most people, when they hear about flat Earth, their whole life they've been taught this globe model where you have a big giant vacuum of space, and then you've got all of these big round planets and suns and things like that, and that we're on one of those planets. And when they hear about flat Earth, they try to replace the globe planet with a flat disk or something like that. That's not what we claim. We can't try to insert the flat Earth inside the globe model, right? You could probably think of the Earth more like the floor, and then we've got celestial bodies in the sky that we've been fed a big giant story about our whole life, about this light that you can see up here. This is Mars, and it's X distance away, and it's in a vacuum, and it's made out of this and that. And then this other one is Uranus, and on Uranus it rains diamonds and blah, blah, blah. Like they'll tell us a big story about all of the lights that we can see in the sky that move in cycles. Okay, but we can't really confirm any of that. It exists more as a model. Okay,
what about
we all see
telescopes?
Yeah, we can zoom in on them, and what we see, even through the best quality telescopes, let's use Mars as an example, we see a little blurry red, round-looking circle in the sky, but we can't really confirm exactly what medium it's in, what size it is, what it's made out of, etc. We've been fed a story about it, but we can't really confirm the specifics about it. It's going to be something that you're going to have to speculate or make a bunch of assumptions about. So we don't try to explain things that we can't empirically validate. This is the logic that I would use. I would say that if you can measure your floor flat, right, it doesn't matter what's going on above your floor. It's not going to make the floor start to curve. So if we're more about testing the actual surface of the Earth, and then whatever's going on up in the sky that we can't actually empirically get to test, we try not to speculate about it. I mean, it's fun to speculate, but we don't know for sure.
Okay. Then
but you could pretend. Question. I mean, like, yeah, you could, like, in the heliocentric worldview, where they tell you that it is impossible for things to be flat. That kind of runs in contradiction with their own model, because they say anything is possible. Like, you've got Asgard out there. You got Star Commander. Thor. You got Middle Earth. All these like globalist fan fiction. Terry Pratchett, Discworld. You got Dark City, the movie graphic novel. So for you to say, hey, my understanding of the heliocentric model is that all things must be balls, that's a very poor read and misunderstanding of what they're trying to present.
Okay. Yeah, I got it. The question is, why do they need it? Why do they need like the whole complete lie about the globe and about the round form of the Earth? Why do they need that? What is the purpose of the lies?
I don't think most people are lying, to be honest. I think it's more tradition at this point, or something that's taught at university as fact that doesn't have any empirical evidence behind the foundations of it. Most people that are teaching you that the Earth's a globe, like scientists, professors, that kind of thing, they're just regurgitating the information that they've memorized from the textbooks that they had to memorize at university to get their degrees. And most of them have probably never even questioned that core mathematics and whatnot behind the globe.
Mm-hmm. But the thing is that there were people in space, right? So they're aligned. Everyone who've been in space, they're aligned, right?
So they're lying about that. Then.
No, I knew that the moon landing was fake before I even started learning about Flat Earth. It's clearly fake.
Yeah, you kind of know they're lying because they said so. They told you
the guy Bert Sibrel. Bert Sibrel, this is the best guy about the moon landing and all these things.
Bart Sibrel, yeah. Yep.
Yeah, Bart Sibrel, an interesting character because he doesn't really like flat earthers. So it's a good source to use because he's not a flat earther. He thinks flat earthers are CIA without exception. He thinks a modern flat earth movement is brought to by the CIA.
Yeah, he thinks that because every like people like he's met. How can I say this?
But we don't need to go into it.
He's frustrated because
hold on.
He wants to be taken seriously. That's
we don't go into that because you don't need flat Earth to discuss how Richard Nixon in the 1960s faked that stuff. That can be fully contained within the globe worldview.
So he believes the Earth is a globe, so he's frustrated because people believe he's a flat earther. That's his frustration.
right. It's like Ken Hovind. He wants to be taken seriously about his stance on evolution and all those things, right? And then that's why he poo-poos flat Earth as well.
Yeah, there's also a chance he may have been fed poor flat Earth arguments by someone as well, and just got his whole perception of it completely skewed from the start.
Yeah, and that's why he concludes that therefore it must be CIA to mess with him or something.
Well, he might have interacted with some guy who gave him the impression, and that's what he's basing it on. But he's stereotype judging everyone as that. But
yeah,
I mean,
anyway,
I can understand.
He doesn't look into it.
I can understand. He has a lot of good argumentation and spent a lot of work on debunking the moon landings, and you kind of don't want to taint your legacy if you've done so much work if flat Earth turns out to be wrong. So, like, I understand him not wanting to spend too much work on that and going off onto a tangent into this aspect, and I respect him being in his own field, if you will, of research. I don't want to force anybody to accept the truth. They will just come to it when he finally sees information from a source he'll accept.
No, that's the thing. All these people that are talking about other conspiracy theories, or people who are talking about anarchy, because I'm into that. All these people, because the subjects they are talking about are already hard to digest, or hard to accept, or seem controversial, they don't need this flat earth stuff. It's gonna make it even more difficult to get the word across for them. You know, so that's the reason why.
I mean, why not push the boundaries though? Or why stop at that, right?
Me, for example, I would push the boundaries, but Cyber is. I mean, I guess he's trying to make a living out of this, and it's just in the eyes of the people, this will make him seem ridiculous and stuff like that, because that's people's perception.
That's what I said. He wants to be taken seriously, and generally there's a stigma attached to flat Earth, which involves us just being crazy conspiracy theory.
Yeah,
that's just outlandish, right?
He's trying to get the moon landing hoax understood by the general public, and he doesn't want any kind of negative bias to prevent them from being able to see his evidence. So he's trying to present it in the best way possible. Kind of like how we kind of like to just talk about flat Earth, so we can present the arguments and just the arguments, and people won't get hung up over their bias of like, I am vegan, or I'm a carnivore, or I'm a this, or I'm a that. We just want to talk about flat Earth.
Yeah. Well, we experience something similar within our community, right, where we have people wanting to talk about ice walls and the outer ponds and that sort of thing, right, and domes and a specific cosmological model, right, and then, and we're disattached from that to a large degree, right, and we kind of don't want that stigma attached to us about what we're talking. We're talking about pure geometry, right, and what can be empirically demonstrated, right.
Yeah, that's why I don't.
It's a similar thing.
Yeah, that's why I don't blame Bart Sabrell for not going into flat Earth. Like, it would be cool if he went into it because he does good research, but I'm fine with him doing the research that we can use.
Yeah, and I think about him is because he's talking about moon landing. The thing is, already when people are saying that the moon landing was fake, other people just automatically assume you're a flat earther. So that's why he had to say, he had this strong reaction.
Well, they shouldn't do that because people were talking about the moon landing being fake the day it happened, people were rolling their eyes like, "This is Richard Nixon. God, like, what's next? What, like, really, dude?" So they don't need flat. This is it's kind of like a red herring. Because I first found out about it by questioning the Apollo program. I was on the server that had, well, this is years ago, as a Facebook page about the moon mission being fake, and they started calling me a flat earther, like a flurman, a flat earth vermin, if you question the Apollo program. And eventually, after hanging out on the page long enough, I realized they were a bunch of neo-Nazis. They want to dehumanize anybody who was shit-talking the Apollo program, because in their worldview, they saw the Apollo program as a righteous vindication of World War II Germany. So when you come there and say, "Hey, I think the Apollo program's fake," what they actually hear is something completely different. That you're like shit-talking like their perfect world, their utopia.
Yeah.
And that's kind of what people hear when you start talking about, we didn't go to the moon. They're not hearing, like, where you say the earth is flat or we didn't go to the moon. What they're hearing you say is, God didn't bless America with a moon mission. That America was, make America great again. That high watermark of American exceptionalism, the Apollo program, that never happened. America was never great. That's what they're actually hearing. They're not listening to the data about, like, where's the telemetry data, where's the blueprints for the lunar rover, all that stuff, all the evidence about how the Apollo program was faked. They're not hearing any of it. It's going right over their head. They just hear you say over and over again that God didn't bless America. That God, America is not the shining beacon on the hill. America is not 60 years ahead of all other nations.
It's more than America. Really it's the whole world. It's all of humanity took the giant leap for mankind, and that's why it's so personal to all of them, because we're the most advanced right now. We could go to outer space. Don't take that dream away from me.
Yeah. My question is, what is all this money that NASA's taking? What are they doing with all this money?
Yeah, you saw the Apollo program virtually ushered in the Minuteman missile, the intercontinental ballistic missile. That's what it was. The whole kin caboodle was a weapons program, which this because Eisenhower, the guy who signed it into law, NASA signed NASA into law, he says, "Hey, I tried to stop," I'm paraphrasing, "I tried to stop the military-industrial complex. I failed. Now it's on you guys to do it. You have to stop the military-industrial complex. I failed." Then his vice president, Richard Nixon, runs for president. And for one of the first times only in all of U.S. history, a vice president doesn't endorse his own, or his president doesn't endorse his own vice president. So thank God Nixon loses to Kennedy, and it prevents what was going to happen. But then Kennedy's assassinated, and Richard Nixon wins anyway. And then you get the Apollo program, and then you get weapons of mass destruction on a global scale. That's where that money went. That money went directly into developing intercontinental ballistic missiles. You know this too, because all the countries that boast space programs, all 7 of them, all have exactly the same military capability. Intercontinental missiles. There isn't not one single, it's 1-for-1 correlation. So they're all in on it. They go, "Well, hey, you can't tell your populace that your space program's fake, because I'll tell your populace that it's fake too." They're all in on it. They know that they want this spending, they want this military spending, they want to hide it from their populace, and they all kind of do a wink and a nod behind closed doors and pretend Like they're boldly exploring space for the betterment of humanity, and they're not.
Well, it's weird because I remain with the impression that both cyber believe that China's and Russia's or both space programs are actually real, unlike the US or something like that.
Yeah, I really
like
don't know.
He believes.
I stopped watching Bart Sabel when he started weaponizing the YouTube reporting system. It would go through, flat Earth channels and just mass report for copyright infringement. At that point, I checked out. If you're going to weaponize victimhood like that and pretend like, it's nothing. The guy's worthless.
Yeah, that's not well.
Yeah, useless at that point. Like he became the enemy he thought. The CIA would love to shut down Flat Earth, and there he is doing CIA's work for them, while claiming we're the ones who are CIA. The guy lost the plot. It's quite embarrassing, but really it goes to show you that we don't need to talk about the moon mission. Let the globalists hash it out. They can sit there and argue about who got to the moon first and whose Sky Daddy blessed which space program. Here in this channel, we talk about the Earth, the surface of the Earth. All the rest of that stuff is peripheral content that really kind of leads to nowhere, like a bridge to nowhere. Because if they faked it or if they didn't fake it, it doesn't change the fact that the Earth is measured, observable, and practically used as flat. Government today could come out and say, we faked it. And give reasons why. Say we're stuck in a Cold War, we had to develop weapons and all of it. Complete like Bill Clinton's book, like in his memoir about one of the things he came as the president, and he looked at all the data and the information for the Apollo program, and he was stunned by the lack of content there showing that there was an Apollo program at all. And he said he had a kooky neighbor that, like I can't remember the neighbor's name, but he used to talk about that the moon mission was fake, and he's like, what a kook. And he's like, wow, but now as president and having full access to all the classified information, he didn't see anything there that really convinced him it ever happened at all.
Interesting. I'm very curious. I know this is besides the subject, but just yes or no, do you think the 9/11 was a controlled demolition or not?
Yeah, that's another peripheral topic. You don't need flat Earth for that topic. The conspiracy type stuff. There's going to be people there's going to be people who think all kinds of things about it, and it doesn't match. Won't match. You could go down the list of flat earthers, and it'll probably match the same swath of anybody. Like if you were to say and just go through a swath of all people of people on the globe side, or just a general population, and just say, hey, I got some questions about 9/11. That's
no. That's not what I mean. I was just curious if you are.
Yeah, that's what I'm saying. That I'm telling you that it's irrelevant. It's completely irrelevant to the topic. It'd be the same thing asking me like, "Hey, do you believe pineapple belongs on pizza?" And I could give you the answer, but it would be the same probative value.
No. I just wanted to, because I sense this feeling that you guys are like me.
Yeah, I would say there's probably nobody like you. You're like unique in the world, or one of a kind.
It's true. But I guess I was just curious about your guys' way of thinking. If you came to the same conclusions, how similar we are, basically.
Yeah, you got people on the globe side who also think that it was a conspiracy theory. So you don't need that topic. This topic, yeah. So it doesn't match. it's one of those things where it won't work. You'd be like, like, hey, how many people here speak English or something like that? It wouldn't go anywhere. It just doesn't work. That question, that line of questioning, doesn't go anywhere. It's like it's either a bridge to nowhere or an abrupt dead end that you have to turn around and go back the way you came. It's like, I wonder how many flat earthers use Discord or something like that. Like, what, cat and dog people, or complete non sequiturs that don't matter one way or the other. But the only reason why it matters when you start talking about demographics is some odd reason the astronaut corps is 100% Christian conservative, without exception. Every single one of them. So you talk about, shouldn't there be some sort of mix or balance? Like, shouldn't the astronaut corps somewhat match the general demographics of America? Well, no, not at all. What they do, they call it the right stuff. Christian conservatism, in their worldview, NASA's worldview, is how you become the best of the best, the cream of the crop. That's step one. Are you a Christian conservative? If not, well, you don't have the right stuff to be. Your dreams of becoming an astronaut are over before they even started. Now, that's a good probative question. Why? Why is that the case? See, they like to pretend like, oh, flat earthers are all these bigoted, hypocritical, homophobic, whatever Neanderthals. Really? Have you seen the federal government? Have you seen NASA? And you think we're the bigoted, exclusive people? That's really the only way you want to look at this, and you want to find something that's not like the other. So when you look at a flat earther, they're going to be about equal to the general population in all senses, except they kind of know about heliocentric and geocentric and have looked into it. Most people don't. They don't even care. Jay Leno used to do a thing called jaywalking, where he would walk up and ask random people on the street just questions, just basic questions. In one of them, he did like a heliocentric model questionnaire, like how many planets in the solar system. People said everything but 9, like 28, 3, 40, 60. They asked people, what galaxy is Earth in? People wouldn't have no idea. What's a galaxy? An F-phone
I've
galaxy.
heard people say like, Mars.
Yeah, the one was the guy that gave him a hint. I'll give you a hint. It's a candy bar, and the dude said Mars, like a Mars bar. And he's like, well, no. Well, Baby Ruth? Like, he started listing every candy bar but the Milky Way. Yeah, it's like, they had, I could find the video. They had a Jeopardy thing about, like a real estate agent, real estate solar system. And they just brought up really basic questions. Like simple, like questions where like, this planet is known for its big red storm. Or something like that. But it's okay because you can hang out in some 70 different moons. People are like, Mars. They go, nope, no one's got a guess. And everyone's like, nah, I got nothing. And then it's like one of them's like, this planet is icy cold. Make sure you bundle up. And it's funny to say its name. And the dude's like, Earth. Or whatever. I don't remember the exact verbiage. But they went through 5. These are supposed to be double Jeopardy. Like, people smart as shit. And you couldn't get even basic sort of comedy heliocentric questions right. And like the guy who won a bunch, I can't think of his name right now, like Pat something or whatever. Was it Pat Jenkins or whatever his name was. He was the one who was hosting it. And he was giggling as they're getting these questions wrong. And at the end, he's like, I guess astronomy isn't your guys' strong suit. And they all started giggling. I guess not. So that's the demographic you'd be looking for, is how come the general population has no clue that Earth is a third rock from the sun? That there's 8 or 9 planets, depending on how you classify Pluto. They couldn't even name the planets in order. They can't tell you how many continents there are, how many oceans there are, what the size of Earth is, what the axial tilt is claimed. They don't know what causes a solar eclipse or a lunar eclipse. They don't know what causes moon phases. None of it. They know absolutely nothing about it, but they'll come in here and tell you photographs from space prove the Earth is not a flat. And you ask them, well, sure, who took the photo? What year was it? They don't know that either. But they're arguing from absolute complete ignorance because they saw a YouTube video that said flat earthers are dumb. That's it. That's the whole story. And you get questions in here about, like, why would they lie? Is the moon flat too? So we got enough content. Basically, I know it's kind of a ramble. I went on for a little bit there. I got a little long-winded. But the main point is we don't need to go into peripheral topics. There's more than enough content to just stay on Earth, on the surface of the Earth.
Yeah, it's surprising even just how many people think that Katy Perry floated around because she'd escaped the gravitational pull of the Earth.
Yeah, man. They think that they go up and then they pop through like a little, like a shield, and then all of a sudden they're in space and they're floating around.
Yeah, I talked to this dude, atheist, who identifies as a Satanist for some reason. Got pissed at me for whatever reason, and started telling me about how things float in space because it's zero gravity. So I'm like, that's interesting, because I was told they're following the curvature of time and space, but Earth keeps moving out of the way. And he's like, oh, yeah, that's just some dumb flat Earth speech. So I start pulling up citations, multiple back-to-back citations about how under modern understanding of physics, that they're following the trajectory of time and space, link him videos. Then his response was to just start porn bombing my DMs.
Guys, do you think my voice or the way I speak is annoying?
Yeah, it's an irrelevant question too. That's so subjective that it doesn't matter. So people would say yes and people would say no, and it wouldn't matter.
Maybe there's something I can change, or maybe
no, you don't need to
my
change
accent
anything.
is super annoying. I don't know.
No, you don't need to change anything at all. You're perfectly you.
Okay, thank you.
If somebody has a problem with your voice, good, bad, or otherwise, that's 100% inside themselves. You can't change or affect that. If they try to blame you for that, then they're emotionally dysregulated. You can't be responsible for someone's subjective take about what your voice sounds like. If you want my answer is no, absolutely not.
Interesting things I've learned today. I'm gonna be telling this information to other people as well.
Yeah, my take on that is have them approach you. I've noticed, like, in the days of yore, like 2018 time frame, I used to talk to a lot of people, like IRL, and it really went. You never know where someone's at. So what I do is, like, I'd wear like a flat Earth T-shirt. I would have like like a bumper sticker on my car that says "Research Flat Earth." Let them approach you. So then they're ready for the conversation, instead of you just saying, "Hey, have you heard the Earth is flat?" Because you don't know where someone might be in headspace, and some people react very weirdly to this information. Like they might just crack, like completely crack. It's so like they might really have a lot of ego driven into the world being a globe for some reason. They a lot of people don't explain or take questions on it. My take is that some of them have this idea that their life is so horrible that they think that sooner or later they're going to travel to space and everything's going to get solved. So they could just be right on the edge, and you say, "Hey, have you heard the Earth measures flat because of laser tests?" They won't hear a single word. They'll just hear you say, "I'm here to kill your dreams of a better life." And that's what they'll respond to.
Yeah.
So I'm just saying that use caution, use a lot of wisdom and caution. And, it's kind of hard to like drop this topic on people's laps because they're not ready for it. That line from the Matrix, some of them are so hopelessly plugged in, so hopelessly dependent on the system that they will fight to defend the same system that enslaves them. I mean, see the way people react violently over a parking spot for, like holy crap. You see a little league game arguing over some teenage umpire, maybe calling a ball a strike or, calling a ball fall. I mean, just think that's how they act. Because they're on this high caloric, low nutrient diet. Their brain really isn't functioning well. And that's another thing from Richard Nixon, that sugar added to food, the high fructose corn syrup. So you don't know. So I know I'm harping on this, but be cautious. Because you have no idea where somebody's at. And this topic can be very triggering.
Oh, sorry, hot Mikey.
What you got to do is find a way to flat smack someone. So like my uncle is into the fluoride. So I showed him a video of astronauts telling kids to swallow their toothpaste. That's all it took. It wasn't like I needed to talk about, NASA bloopers and ISS. Just show them like a random kiddo asking an astronaut on the live stream, "How do you brush your teeth in space?" And the astronaut's talking about swallow your toothpaste. That's all it took.
Oh wait, they said that.
Oh yeah, totally, dude. Another one I flat smacked because they thought that astronauts are the cream of the crop, the best of the best. Like astronauts are so advanced, multiple, like interdisciplinary doctorate degrees. Like when God made them, God broke the mold. They're one of a kind. And I showed them a video of Don Pettit playing with eggs on the ISS, talking about Angry Birds and all kinds of dumb shit. And it wasn't NASA's YouTube video. It was like someone else had clipped it. Then like my family member said, "Well, that's a gag. That's not that's not a real astronaut. That's complete garbage. Why would you show me something that's obviously some sort of dumb flat Earth skit?" So then I'm like, okay, well, sure. Well, here's I pulled up Don Pettit on NASA's website, and I'm like, here you go. Here, this is the same guy. They shifted the goalpost. Okay, well, sure. That looks like him. It's a celebrity impersonator. And I'm like, what the hell? So you're saying that flat earthers can make skits using celebrity impersonators. And they're like, yeah. So by the grace of God, the video is posted on NASA's own website. You could still to this day just go to NASA's official YouTube page, type in "Angry Birds in Space," and there's Don Pettit acting like a complete other moron. And that's all it took. Once he saw this supposedly cream of the crop the spokesman for the astronauts, supposedly the best of the best astronauts, the longest lasting, the longest serving astronaut who's done multiple commands, all of it. When he saw him talk like the guy can barely tie his shoes, that's all it took.
Yeah, so the evidence matters, but also the state of mind of the person receiving the evidence matters also, because if the state of mind is that this is ridiculous and they want to make fun of it, then it's not the right moment to show any evidence.
Yeah, there's a video of amateur rocket being shot up into space, and you can clearly see a curve, but these guys just always change the subject or ignore it.
That means it will be also on the ground, if you can see
start
from
with
the
the whole
rocket.
like, Bigfoot unicorn shtick.
Yeah, that would be the curvature that we're asking for the measurement of that no one has. That
Okay,
curvature.
you can see it, like.
Okay, so why can't you measure it?
So, are we trying to disprove flat Earth, or are we trying to prove globe Earth here?
Well, they'd be the same thing.
There's
wouldn't
two
they?
sides.
In order to disprove the flat Earth, you would need to prove a globe because.
Okay, so
flat
where's
Earth
the
is just
where are the globe
observable
tards?
reality.
Are there any globe tards in the call?
Yeah, we're just speaking to a few of them. Okay. No, the first guy was cool. What is it, Mansky? He's a big time globe head. He's been coming here for months and just like sideshow Bob walking on rakes 24/7. But the first guy, who was that? Because he could actually hold a conversation. So we've not got someone from the flat Earth side who can pick this up. Who's on PWN? Setu? DJ?
I am, but I may not be for very long.
Dre?
What I would say is that if that imagery that Mansky's talking about is indicative of a sphere Earth with a radius of 3,959 miles, and when we go to a 20-mile lake, or we look across a 21-mile body of water, we wouldn't see clear to the other side. There would be a horizon at about 2.7 miles, and a curvature drop of about 260 feet at the other end. But that's not what we find. So sorry. The imagery.
Can we set aside the curvature drop for a bit? Because I'm presenting here a photo of the Earth, and you're saying that it's been manipulated. Is that correct?
I'm saying that if it is indicative of a sphere Earth with a radius of 3,959 miles or a circumference value of around 25,000 miles, then when we go to a large body of water like a lake and look across 21 miles of surface of water, we wouldn't see clear to the other side. There would be a horizon at 2.7 miles and a curvature drop of 260 feet at the other end. But there isn't.
That's just a statement that you made now.
Yes, correct. So any imagery that's presented to you as some kind of evidence or a claim that it is representative of the Earth as viewed from a very far away, and it comes with those values of this Earth's size, its radius, its diameter, its circumference, then when we go to a large body of water like a lake, and we look across 21 miles of surface of the water, we shouldn't see clear to the other side, but we do. So therefore, do what you will with that imagery. Think about it as you will. If you want to just rest your faith on that unverifiable image, that's on you. Right? But meanwhile,
Well, you've got to actually explain the steps.
Yeah, sure.
You can't just tell me that because I'm looking at a circle with some kind of radius that this needs to happen.
Right, so if that is the Earth and its surface is curving, then there's geometric consequences, right, to what we will see and what we can measure on the surface here on Earth, right? Meaning there's a curvature rate to it. So roughly 8 inches per mile squared. which means over a distance of about 20 miles, there would be a curvature drop of around 250 feet. Do you understand?
Right.
How much drop
Okay.
is there? How much drop is there?
I'll go to the Earth curve calculator. Got. I don't know how to use this in conjunction with the image. Whatever.
Because if the Earth doesn't curve as much, that means it would be an even bigger globe.
True. Look, if you're just looking at the image, if it was, for the sake of argument, not touched at all, right? No Photoshop has been altered. They just took it off, like they printed it as soon as it was taken, right? Nothing happened to it. Would that mean we live on a sphere? If the image was true, mind you.
The correct term, I think, is oblate spheroid, but yeah.
Hypothetically,
so the image,
if it was true, it'd
has
be true.
been changed.
If the image was true, the Earth would measure accordingly, curved. However, besides doctoring, there's a very simple explanation, and that they used a wide-angle lens which curves horizontal lines. So if you look at the video, early on when they're close to the ground, does the horizon appear curved? If yes, then this is a wide-angle lens.
I don't know. I don't see a video, and I'm not talking about a specific image. There's lots of images of Earth.
Yeah, and we've gone through you're welcome to try to find one. We've gone through thousands of them, and we have hundreds of ones that don't have a wide-angle lens, and they show flat horizons.
Can you show us that?
According to the math, the ISS is too low to the ground to have the Earth curved, and so they need to use wide-angle lenses to make it appear curved.
Can we all agree that you believe that the image is doctored?
No, I didn't say it was doctored. A lens effect does not mean the image is doctored.
What about an image like without a wide-angle lens?
I'm not. You have to show me a specific image for me to claim it's doctored or not. Okay? It doesn't really matter because the surface determines if the Earth is curved or not. And so, if you have an image showing a unicorn in your backyard, and then we go to your backyard and there's no unicorn, I am not obligated to believe in your image. Do you understand?
I can't actually send anything in the chat. I can't send an image.
So you don't understand?
No, I do understand. I'm trying to send an image and I can't.
That may be an issue of just being too new to the server, so you might have to, participate more in chats until you level up, and then they'll grant you that access.
Right. So, do half of you believe that the images are doctored and half of you believe that it's using a wide-angle lens? What is the actual consensus on this? Is there a consensus?
How would there be a consensus on multiple images? Each image is specific to that image. We don't have an imaginary consensus. We're not a cult like the cult you come from. We're not a cult like the cult we left. We're just the people who left your cult, okay? Get it through your brain.
Okay. You can also decide that none of the images are indicative of a globe, that they're either wide-angle lenses or doctored. They're not mutually exclusive. I'll just send DJ the image, whatever.
There's many potential causes for the images. You like us can simply.
This is the most
test
standard
the
image. I
images.
didn't like.
I understand. I'm just saying any image that contains the globe in it, you can just go test it yourself. Does the reality curve like the image is presenting to you? If it does not, the image is not true, regardless of how it was made.
Right. So, okay. Some images are made with a wide-angle lens, and some are doctored. Can we agree on that at least?
Yeah, sure. NASA admits they like. We have a link here for you from NASA to graphics designer working for NASA who created the blue marble image. They freely admit that they doctor some images and create some images. Many people believe those images are real images. There are other images they claim are real images, and we simply test the surface. So we don't care what other people claim when they don't have any evidence backing those claims. The evidence comes from reality conforming to your images or not. If reality doesn't conform to the image, then the image clearly isn't true regardless of how you derived it. You could have created it through an AI. Whoa. That doesn't mean it was like doctored by a human or using a wide angle lens. There could be other methods made to create images like what was he called again? Math Powerland. One of the earlier flat earthers. He claimed to have worked for NASA making paintings, very realistic paintings of globes, and he ended up making a comedy routine after he stopped working for NASA, and was like, "Is this a painting or a photograph?" And he had globes, and he made fun of this because he was and ended up becoming one of the earlier flat earthers because his paintings were so realistic that people believed they were real pictures of actual globes in outer space. But we're not making claims about the entirety of supposed space pictures. We're testing those claims. The pictures themselves are the claims, and we're testing the claims. Do the claims hold up in reality? And they don't. That's the simple.
I'm not doubting any of that. Okay. I'm simply saying, all right, let me put this as cleanly as possible. The images could have been painted, doctored, photoshopped, created pixel by pixel, manually written in a text editor. All right? It doesn't matter. An image as of 2026 has no value whatsoever. It is not proof. All right? Alone. But let's say, for the sake of argument, that an image was not doctored, it was not painted, it's not fake. All right. For the sake of argument, all right. If the image was actually real, taken on a spacecraft outside of Earth, right? If all of those things were true, never mind that you don't believe in them. Just say that they were.
Yeah,
the one I just posted.
If all of those things,
I haven't finished.
Were true. Okay, sorry.
All right. If all of those things were true, and you just take any random image like the one I sent you, right? That would indicate that we're on a sphere, right? But I know you don't believe all of this.
No problem. If we assume all of this is true and we went out into outer space and we saw the Earth as a ball, the Earth would measure as a ball on the surface. It doesn't, so your hypothetical doesn't make any sense.
Right.
And your image doesn't make any sense.
What's wrong with it?
Well, on one half of the ball, you have Africa.
And that's a problem. Why?
Well, on the other side of the ball, you have North and South America, Asia, Europe, Australia, Antarctica, all the oceans and seas surrounding.
So?
That's why it's a problem. Think about it, sir. Use brain.
On the other side, we have too many things. I'm pretty sure if I went on Google Earth and I can get this exact perspective and everything will be fine. In fact, I'll look right now.
Well, then you have the same problem with Google Earth.
WebGL is not supported on my browser. That's great.
Senator, this stuff seems to be going in one of your ears and out the other. Good luck to you, dude.
Hello, guys. How are you guys?
You just told me that my image makes no sense. Out of the blue.
How are you, bro?
I'm great.
Yeah, it makes
Where are you
no
from,
sense
guys?
because this is not something.
Where are you from, guys?
Sense. Sorry. I'm
Where are you from?
him real quick, and then I'll okay.
No. Respond to me.
Yes.
Quick.
Yes.
Where are you from?
No. First, I'm responding to him, and then I will respond to you. Don't make me mute you. So it doesn't make any sense because what you experience is a flat, non-rotating world. You see the stars and the sun move in the sky, and you experience the world as a locally flat plane. That's how it's described, that's how it's mathematically used, that's how we function and use the world we live in. However, there's this belief that the world curves beyond what we can experience, and that special people can go outside the globe and experience it as a globe. Meanwhile, you, the plebs, cannot. And so you just have to believe in the superior people, and then you are enlightened because you are part of the religion of the globe. So we don't buy into that. We actually go out and test their claims, and their claims fall flat.
Unintended. I'm kidding. Yeah, I just realized that I was gonna make a different point, but then I fucked it. I'm sorry, but I don't follow with this whole religion thing, right? With the globe people.
Yeah, it's a globe religion. If you didn't know, the globe religion started as a cult within Pythagoras as a secret doctrine of the Pythagorean cults, and then spread into the mystery schools of Greek, ancient Greek, and our whole current worldview is built on this ancient mystery cult and their secret doctrine. And that's what everybody's been programmed to believe, even though they don't have actually any evidence. All the supposed evidence for it is just logical fallacies, and that's why they removed logic from your curriculum so you didn't understand how you're being manipulated. And then
they removed logic from the curriculum.
Yes,
that's
they
not true.
essentially removed logic from the curriculum. You only get a primer and a slight education on it if you go into philosophy, but even then, it's drowned out by all of the different aspects of philosophy. Back when we had the trivium and the quadrivium, logic and rhetoric were some of the primary things that they taught children, and so they were better equipped to identify logical fallacies. Meanwhile, we get taught Aristophanes, for instance, if Earth is a sphere, shadows would act like this. We see shadows act like this, therefore the Earth is a sphere. This is circular reasoning, but because it's dressed in math, it's dressed in authority, people don't realize.
That's what I've been trying to get at with my whole sphere photo. The point of the sphere photo is not about proving the existence of a sphere from just a photo. It's about getting you to acknowledge that you believe in someone that is oppressing us, controlling us, and feeding us false ideas.
I don't need any belief in that because I can just go out and measure the world and see that someone's not telling me the truth. For I don't know his reasoning for not telling me the truth. Maybe he's just confused. Maybe he's a dumbass. Maybe he inherited this lie from some other guy who might have been malicious. I don't know. I am not them, but I can test the fruits of their labor. I can test if the Earth is actually curved or not, because we have access to the Earth.
You can't be making this whole thing about us not being taught logic in school, about a cult created in ancient Greece, about them wanting to control you, and then just go on and be like,
"Oh, them wanting to control you." That's you putting words in my mouth.
Well, not you specifically, but it was said in this voice channel earlier.
Yeah, that's because we're not a cult like you. You come from a cult where there's a unified belief that you have to believe. But we are an independent group of researchers who all have different opinions and beliefs. However, the only thing we share is the empirical, scientific, and logical necessity of reality. And so we teach each other logic. We go through science and physics. That's what we care about. We care about the empiricism, the measurements. If the Earth were measured curved, we would all be Globers.
You just can't do that. You can't call me, you can't say that I'm in a cult started in ancient Greece and then say you're just an independent group of researchers. You can't have it both ways.
That's just how it is, because we are not a cult. We don't have a unified belief system like you do. You have one, and you are here policing for your belief system because you have a cognitive dissonance when being faced with the idea that your belief system could be wrong because you were raised in cognitive ease. You were raised with the globe being in all of your programming, all over entertainment, in your education, and you were never presented any alternatives. You were presented this as it was a concrete reality, and so it shaped your ego and your worldview as you think you live on a ball. You think there's outer space and other balls you could go to, and maybe aliens out there, and it creates this whole worldview for you, where you're like random accident of the universe.
If it's so easy to understand, or maybe not to understand, but if it's so observable and measurable and provable that we are in a flat Earth, then why is the consensus different? Why is flat Earth a minority and globe Earth the majority?
Because there's billions of gullible people just like you.
It's actually very easy. In the 1800s, there was a resurgence of flat earthers. In the 1700s, there was a resurgence of flat earthers, and there's always an opposition to this, and that's because the cult, the secret knowledge, the holders of the secret knowledge, we know how the world is, and if it's not how we thought it was, then we were wrong. We were telling everybody things that were wrong, and it's hard to accept that. That's sunken cost fallacy. So there's just human psychological reasons when people get caught up in beliefs. You can see this around any belief, like Scientology or any other thing, where people believe something so hard that they just don't look at reality for what it is. They try to insert their belief into everything, and when it doesn't matches, they just find some excuse to try to make it match, and that's what we keep finding. We wanted to believe the Earth was a ball. None of us wanted to be a flat earther. Okay, it was we most of us who came to this wanted to debunk them, and so we were like, okay, yeah, let's go out and test it. We're like, we'll figure out one way or the other, and just confirm the globe again and again and again until the flat earthers concede. However, what we did was confirm that the Earth isn't a globe over and over again, and eventually we just had to scratch our heads and be like, okay, like, who do I talk to? It's far easier to convince people of a lie that than to convince people that they've been lied to. And I don't really expect you to believe me or us. I just want you to think about your own beliefs, and then be critical of your own beliefs. And then, as you're out and about, and you can look out over the sea or whatever, and you can see, wait, I can see way too far for the globe, and that might cause some interest in science and logic and reasoning, and you might dig into this and figure out that the Earth isn't a ball, but it requires you to find it within yourself the desire to actually search and learn and test these things, because nobody's going to give you all the knowledge. You think the people who want to maintain power would give you all of the knowledge when knowledge itself is power?
See, there you go again, making claims about people holding the power for themselves. Like you just said that. You can't unsay
no, bro. No, this is just basic human psychology. I'm not claiming a grand conspiracy. I'm just saying there are people in this world who have narcissistic tendencies. There are people in this world who have sociopathic tendencies. There are people in this world who are greedy. There are people in this world who are selfish and don't care about humanity. Like, there's many people who do, but the naivety of humanity and most people is to think there's no bad people in the world. There's no bad people who want to keep an advantage over you. And I don't presume to know who those people are. All I know is that I can test the surface, and the surface doesn't match what they told me.
And everybody knows there's corruption in government.
Yeah, my sister says everybody knows there's corruption in government, and we can quote her on that. I mean, it's not hard to imagine that some people are malicious, and I'm not saying that the whole globe idea is a malicious plot. It could be, but it could also just be a massive misunderstanding, and people building on that misunderstanding because they believe in the authority and the accolades of the ones before them. They think they're standing on the shoulders of giants.
Or it just could be true.
No, we measured the Earth and it isn't a globe, and so it cannot be true.
Look,
If
the
it's
two
so
main
true,
reasons.
if it's so true, why do you and this printer guy resort to illogical circular reasoning and just wishful thinking?
We don't see it as illogical, wishful thinking. We see it as logical and reasonable.
Okay, give some logic. That's not your. No, dude. Let printer flounder. But he's demonstrating his own illogic. Have you not been listening, Matthew? What has printer? What argument has printer given that's logical?
I'm not. I don't want to like butt in on their.
Okay, well then be
Let's
quiet.
let them continue. Okay.
No,
Yeah,
don't be
it's also
quiet
not
just because this
logical,
guy
Matthew,
told you to.
It's not logical, Matthew, to say that circular reasoning is logical because you believe in it. That's so far from logic. You are a teacher, bro.
The two main reasons you've given me as to why people actually no, that's a lie. There's a lot of reasons you've given me as to why people don't believe in flat Earth, is because Well, I'm just gonna list them all. That's the way they grow up with. That's what's been taught at school. It's cognitive dissonance to change your ideas. It feels bad. You don't want to feel like you're wrong. And that's also what the cult feels. That's why they don't want to change their ideas, because they're also going to feel bad.
What? The first part was all good, but what the cult feels, I don't remember saying. I don't remember personifying a cult. Yeah.
Oh no, you did say I was in a cult, and you did specify that it started in ancient Greece.
Yeah, I call the globe religion a cult. Yes, that's correct.
And then I asked why the cult hasn't changed its views. You said that they didn't want to feel like they were wrong.
Yeah, that's called the sunken cost fallacy. Like, once you start doing something, you prefer that to have been the right choice rather than the wrong choice. And so humanity generally has this bias where you try to keep up with a broken relationship, even though at the start you should have seen the signs that this was never going to work out. It's just basic psychology.
You know, that's difficult to argue with. To argue that these points are invalid would be really hard, because it is hard to change your opinion.
Listen to them rationalize. Crazy.
I don't even blame them. Like, it's tradition. We were raised in this. Like, you see this all around the world with other kinds of traditions. People are raised in this. It's really hard to just let go of your tradition, the thing that you feel like is a part of who you are. It's very familiar, the globe. Like, we were all raised on sci-fi, on the TV. Many of us had rockets and globes in our cribs.
My quick rationalization is noted.
Yes.
You know, there's a lot of aggression towards globe
No,
people.
dude, don't be a snowflake. I don't listen. I pity the fool.
No, come on. You've got to agree.
No, dude, I was once just as brainwashed as you are.
See, you're calling me brainwashed.
Okay, I'm calling myself previously brainwashed. That's what you're not hearing.
No, you said you're just
You're
as
looking
brainwashed
to be
as you
offended
are.
by everything. Don't be.
I'm not offended. I'm not actually offended. It's just
okay. Good. Then move on with it.
Yeah. Maybe. Never mind. Forget about that.
So, Printer, shame on us for being.
He's showing you his perspective, like just like I was showing you my perspective. Like, from my perspective, having left the globe belief, I felt like it was like a cult. And now interacting with the people from the globe belief, it feels even more like a cult because of how they react and how triggered they get just by the idea that some of their foundational ideas about how the world is are wrong, because they put so much faith into this whole system.
Yeah, we don't want to stereotype you, right? So we'll try to avoid that. This is what we've gathered from countless conversations and even being introspective ourselves about how we've behaved when we first encountered the information. So we don't want to project that onto you. This is just what we've observed. that the globe belief is devoid of any empirical or logical foundation. And everything that tries to defend it usually is from a place of either anchor bias or, yeah, I don't know, wishful thinking, just a desire to stay on that side for whatever reason. I can't divine anybody's reason for wanting to hold a position that is devoid of empirical evidence or logical consistency.
But they have that illusion of logical consistency or internal consistency within their model. And because they don't understand what a reification fallacy is, they think the model represents reality. And so, because they never were taught deeply logic and how fallacies are so they could identify them, they end up just accepting these things, and especially because it was taught when they were so young, it creates a foundation when they were too young to actually question it. So when you get further in schooling, you're already building on that foundation you assume is true, and if you question it or you don't write the right answers, they fail you on the test, and so it becomes a very programmed machine that pumps out people who believe certain things, and then you find out over time, working in your field, that a lot of the things they taught you in school were outdated, and we're actually moving in this direction now. And so uh, the school creates a certain idea in the general public, even though, like, we get a lot of people in here who think Newton, for instance, still works and is a thing that is believed within physics, when it's a convention that's already been falsified within actual physics. But most people don't know that because they don't go far into physics. They just hear the popularized things on TV or on TV shows and form their opinions based on that.
I mean, look, I'm kind of back here into a dead end because there's really two sides to the flat Earth theory that I'm aware of, and one of them is the experiments, and the other is that uh, that we've been raised wrong, that we've been taught wrong, and all this other stuff. And we can't really seem to agree on any of those. We can't agree on gravity. We can't agree on the drop-off thing, the drop-off distance. I don't even really.
Well, we have no problem agreeing on gravity with many globers. The problem is most globers don't know anything about gravity and don't know that Newton's been debunked, Einstein's been technically debunked, and so they have 79 new theories within the highest levels of academia concerning gravity. There's like 20 different ones that are competing, and are some of them at the highest levels, and some of them are like modified Newtonian dynamics or modified versions of Einsteinian or quantum gravity or holographic gravity. So there's a bunch of different theories right now about what gravity is, but it doesn't change the fact that flat or globe, uh, we all have a downwards vector and things fall. That's just what happens. The effect is the same regardless of your imagined geometry. Gravity has never been a problem. We can even use Newtonian or Einsteinian gravity with flat Earth. All you got to do is change the mass distribution underneath the ground, and it will work the exact same. So the effect is the same regardless of the geometry. The assumed cause has really nothing to do with the geometry.
So there is gravity. Like
well,
we're not.
Yes, there is there's
an effect.
G. Yeah, there's little g, the effect. We all observe that. Everybody does. Uh, there's a problem here with languaging in that people call little g, the effect, gravity, but they also call the cause, big G, gravity. And so when you have the same name for the two different effects or two different things, like big G isn't really an effect. It's just an assumption about what causes the effect because they can't test the assumption. And that's why we end up with so many different theories because they can't test it.
If I can add to that, Andreas, quickly, there's also an issue in the language when it comes to the claim about, oh, it's proven because we've done an experiment to prove it, right? Wherein in this sort of experiment, in this context, what they're calling an experiment, it would basically be a measurement or a test, like a test of sorts, whereby, they drop a thing, it's in a vacuum, okay, they measure the density of this thing or calculate it, whatever, compare that with the surrounding medium, and then they drop it, and then they time, the time it takes to fall. They call that an experiment. You know what I mean?
What's wrong with that?
There's nothing wrong with that setup. It's you're measuring the time it takes from point A to point B. Perfect. You have all your things sorted out. You have your control variables and shit like that. The height, the density gradient, not gradients, differential, et cetera, et cetera. Right.
The confusing measurement with experiment. Measurements are perfectly valid forms of gathering true knowledge, or because they translated science is now knowledge and not the correct application of the scientific method. So you can call it science within that perspective. However, it's not doing an experiment as much as it's just trying to measure something and control the other variables that could affect the measurements.
Yeah.
Right on. Yeah.
There's also contention.
There's also if I may, right? He asked, "What's the problem?" The problem is, again, like I said before, and like Dre started off by saying, there's a problem in the language. If you go around saying, "I did an experiment to prove gravity. Look, I dropped my phone. There's gravity." Okay. Versus, I did an experiment to test what causes water to boil. Those are two very distinct, areas of inquiry, number one, but also the setup to actually get a result, right? The results are very different, right? Not to mention the process of achieving that result. So to call them or to label them as being, worthwhile being put under the same umbrella is faulty. But we do it kind of colloquially anyway. Go ahead, Tita.
I mean, they're two different experiments, aren't they? Why?
Oh, then
no, one's not an experiment.
One is an experiment, one is an observation. So, like, you can observe a measurement and you can measure something and get good information out of that. However, an experiment is something to establish a cause and an effect, or cause to an effect. And so you start with finding an effect in nature, like things fall. And so you presume, like, what's the cause of falling? And you might think, well, if I scratch my head and jump, that makes things fall. Retarded. But that would be your positive hypothesis. And when you try that, and it doesn't make things like fall that didn't fall before, then you realize, well, I proved the null hypothesis. I proved that my presumed cause wasn't true. I was just imagining some garbage, and it had nothing to do with what was happening. And that's why the scientific method is so valuable, because you presume the cause, and then you manipulate that presumed cause to see if it has an effect. If it has an effect, like in the case with the water boiling, you heat the water and it starts to boil, you have proven that heat causes water to boil. But when you just measured something falling, you did not prove the cause of that thing falling at all. You just measured something fell. And then if you then take that measurement of the thing falling and then make a bunch of assumptions and mathematics and create a whole model, you can create 79 different models of gravity through different mathematics based on the same effect, but because you never had a cause to test, you can't validate if that cause was the cause of the effect. Does that make sense?
Sorry, I lost you. That was too long. Could you like simplify it a little bit? What was your main point?
Let me try. Okay. In one context, you're literally manipulating a thing that you are supposing is causing the other thing to happen. Right?
All right.
Right? You literally manipulate the temperature, keep the pressure constant, whatever, and you see that eventually the water boils. Okay?
Okay.
In the other.
Right? And in the other, you're not manipulating shit. You're just dropping something.
Just observing the effect.
Yeah, and you're measuring how long it takes. You're not manipulating the thing that is supposed to be pulling the thing down to see if it actually pulls it down. Or changes.
How would I
Also,
do it correctly?
just quickly, that leads to an assumption that this, whatever the reason for your object falling, has an influence over all matter, right? But observably, we don't see it influencing gas.
Yeah, yeah. So from this, you can extrapolate out and assume a bunch of stuff, and that's where the storytelling starts to come into play, right? So like, whereas if you could, for example, say, okay, the mass of the Earth is pulling the thing down towards it. That's your hypothesis, right? That would be the variable responsible for the effect. If you could, hypothetically, manipulate the cause, i.e. manipulate the mass of the Earth, and witness a variance or a change in the rate at which things fall, right? Let's say, I shrink the Earth, in half, and I witness the acceleration of the thing downwards cuts in half, say, just for example, or I reduce it by 90%, and the rate goes from 9.8 to 0.98, right? Cuts that in 10. Shit like that, right?
But even if you could do that, right, you still haven't. You've just demonstrated that there would be a relationship between an object's size or its density or its mass or whatever, right, versus the density or the mass of some other object, right?
Yeah.
You still haven't really established what that interaction is exactly, because like Einstein came along and said, right, without the experiment, well, Newton was wrong. There is no like force or field emanating from the matter just because it's matter and grabbing onto other things and influencing each other that way. No, he says there is no interaction between those objects at all if there was no space-time.
Right on.
So he's got a third variable involved now.
Yeah. There's a lot more to it, right? But what I outlined would serve as a good stepping stone in that direction, right? Whereby
shrinking the Earth down.
I'm just giving you a silly example, dude. And the whole point is you can't actually do that.
Well, exactly. Right? Is there an experiment I can do?
In this context, no. Because supposedly the Earth is responsible for this thing, or the Earth's gravity is responsible for this thing. Well, the mass, I should say, which causes the gravity. So there's an assumption that those things are intrinsically linked. Right now, implicit in that assumption in the first is that there is a giant mass, for example, in the heliocentric model, floating in space in the first place. Okay, that's the kind of sneaky motherfucker that you kind of just have to ignore or just absorb and forget about. Okay,
there's an experiment you can do for specific gravity.
Right. Yeah, there's stuff that you can test, dude, in this fashion that we're talking about. This is one such that you can't in this sense. So it's as if, over time, it was recognized that you can't really do that in that sense. So the rules of the game, say, or the rules of the field kind of like, adjusted or they laxed a bit, So as to allow this, context to be enveloped in this field, and okay, we can't really fully experiment the way that we know we should, but fuck it, we're just going to do it anyway this way with the rules relaxed and still, qualify it as being science. It's almost as if that's what happened. I don't know. Seems like
they freely admit this at the highest levels of academia. They'll say, like you'll ask Neil deGrasse Tyson, "What is gravity?" and he'll say, "I don't know," because at the highest levels, they're like, "We don't actually know what gravity is, but we have a pretty good guess, and we have calculated the effect, so we can like model it and do all sorts of things with it, and it's useful. But as to proving the effect, it's super difficult. First of all, uh, like he was trying to describe to you earlier, but at the same time, our current theories of gravity don't actually hook gravity into the small things like the kinetic molecular theory doesn't use gravity. Uh, a lot of our basic science on the super small scale just doesn't use gravity. If we were assuming gravity, like all matter would start to collapse in on itself. If we were coming from the matter itself, uh, so it's kind of hard to understand, and that's why Einstein came up with his bending and warping of space-time, and because now you have a bending and warping of a conceptual medium, and you can't measure it and you can't test it. Uh, all you got is the effects, and so uh, the medium is just meant to conform to the effects, and that's why it works so well. But uh, when it came to like distant galaxies and star clusters, Einstein didn't work anymore because the galaxies were turning too fast and the galaxies appeared too old for the Big Bang and all sorts of things that made the current cosmology kind of fray at the edges. And so we have a lot of people exploring the fringes of cosmology today. Uh, we are just the people who are checking the foundations to the cosmology, and once the foundations shift, the whole thing shifts.
All right. So what I've gathered is that dropping something and measuring it, not a valid experiment, not real science.
No, it's not a scientific experiment. That's right.
Yeah, it's not a scientific experiment. It's a valid means of you could measure something dropping, and it could be a valid means of gathering information, which could be considered science.
So what is the actual consensus on gravity? Does it exist or not?
Sorry. Printer, can I ask you something? Are you at all familiar with the scientific method, like formally?
Starts off with making a hypothesis, I think, and do an experiment. There's like 7 steps. I can't really remember them now.
Okay. So I guess you learned it a little bit in high school, did a couple things, and then had to talk because you changed fields or something.
I'll Google it now. I'll just refresh my memory.
Go for it. And then let's walk through it. Right. If you guys, if I may, you guys, I don't want to interrupt. I want to ensure that Printer understands why we're saying what we're saying here.
Make an observation, ask a question, form a hypothesis, run an experiment, analyze the data and draw conclusions, share your results, repeat the scientific method.
Right on. Okay, cool. So in the context of you take your phone, you drop it, what do you observe? Or excuse me, you take your phone, you suspend it in the air, and you let go. What do you observe?
I see that it falls.
Okay. Second step.
Why does it fall?
Yeah. So what do you propose is the reason why it fell?
Form a hypothesis. Fell because of gravity.
Okay, cool. Does it go into more detail what the hypothesis consists of?
All right. Fell because all for all objects. I forgot the name for it. All objects act upon each other with the force at any distance.
I was asking, in that outline that you have there, does it show you the constituent parts of a hypothesis? Maybe research that quickly.
It says for my hypothesis. Wait, I need a
Just Google Google definition of a scientific hypothesis. Let's say.
A proposed explanation for a phenomenon. It must be based on observations, and a scientific hypothesis must be based on observations and make a testable and reproducible prediction about reality in the process of beginning with an educated guess or thought.
Perfect. Okay. Does it say anything about the variables? Sorry, guys. I don't want to.
No, I don't see anything.
Okay. Well, basically, your hypothesis, the setup requires your proposed cause for the thing. Okay. And then you have your observation, which is the effect, which depends on which depends on the supposed cause. So you have your dependent variable, the effect, influenced by the supposed independent variable, the cause, right? That you get to control or manipulate throughout the experiment to see if it affects the result. Okay.
Right.
Independent variable, dependent variable, and then you have a single one or a set of other variables that you want to maintain constant. They call them control variables. That might be influencing this entire thing that you try and, to the best of your abilities, control for. Okay.
Right.
You'll find that online everywhere. You might be botching it a little bit with some terminology here, but you get the gist. Okay.
Okay.
Perfect. So in this setup, with your phone, you observe your phone falling. What would be the independent, dependent, and control variables in the setup?
The independent would be the fall speed, I guess, or fall time, and the control variables would be,
or even just the sheer. Sorry. But even just the sheer fact that it falls.
All right. The fact that it falls, its weight, size, atmospheric pressure around it, elevation. I guess those should be all remain constant.
So the weight you can maintain constant. You can probably do it in a vacuum, so you can maintain the air pressure. Humidity also, because it's in a vacuum. Humidity is 0, right? Et cetera, et cetera, et cetera. Okay.
All right. I don't see a problem until now.
Okay. Now, what about the supposed cause, the independent variable?
Well, that's my hypothesis, isn't it? I'm testing it now.
Everything that we've outlined is defining the hypothesis. Okay. There's one critical thing, right? You already said it. I just want you to see the key into the whole. Okay. Right. What is the cause of the effect, supposedly?
Supposedly, it's gravity.
Wonderful. So there's your independent variable.
Right.
Experiment. What's your setup? What's your method? What are you going to do?
I am not going to do this right now because I'm going to break my phone.
No, I'm not saying drop your phone, dude. Okay.
Yeah.
Like outline it, right? You got a plan for this shit, right? Okay. I want to figure this thing out.
All right. I'll drop it from 1 meter. All right. And I'll place a stopwatch next to me, and I'll press start as I drop it. How's that?
No, I'm not saying do it, dude. Okay, but now check this out. Now it seems like you've changed the supposed cause.
Why have I changed it?
Okay, so in the hypothesis, if the supposed cause is gravity, right? The Earth's mass pulling it in for whatever reason. There's bending warping space-time, or there's some invisible three-toed gnomes pulling down your phone with lassos or something. Who knows? Whatever. Okay, whatever. If that's the supposed cause, but here you are not necessarily manipulating that supposed cause or that supposed variable, but instead changing the height at which you drop your phone, right? You're basically implying that the height is responsible for the gravity. Because that's all you're changing.
What do you mean I changed it? I didn't change it. It will be 1 meter the first time. It'll be 1 meter the last time.
Hold on. Let me just, can I bounce in here real quick? Brother, you said that your supposed cause is gravity. So we've got all of our controls. The height is the same. The temperature is the same. The air pressure is the same. Everything is consistent. So now we need to perform an experiment to get the dependent variable to occur. So you have an object. And I don't know what this object is. I don't even know what the observed natural phenomena was in nature, but let's just say we have an object. We're trying to make it fall because the falling is the dependent variable. That is the thing that is observed. So now you have to
the independent variable.
No, the dependent variable is the observed effect. It is the effect. The falling of the object is the thing that you saw, correct?
So you disagree with the other dude because he told me that was the independent variable.
No, he did not.
You misheard.
The dependent variable is the thing that we're trying to cause in the experiment so we can verify our independent variable.
Yeah, fair enough. Yeah, the dependent variable depends on the independent variable. Right? The effect depends on the cause. Go ahead.
You say gravity is the cause of the thing falling. So now we have all of our controls, we have our object. The next thing you need to do is vary and manipulate the independent variable. In this case, you would have to find an environment that you can add some gravity and take some gravity away to see if adding the gravity makes the thing fall or take away the gravity and it does nothing. Right? So, what is gravity and how are you going to manipulate it?
Why would I have to change gravity?
Because that is the thing that you said is going to cause the effect. So you need to add the gravity to get the effect that you're looking for.
I'll go to the ISS and I'll drop it from there.
Holy cow, dude. What are you talking about? Gravity, what is it?
I've answered this question like 50 times already.
Yeah, well, what is it?
I'll give you my standard response. It's the force that is applied from every object to every other object at any point in the universe.
That's a vague description, and it's just describing something that we don't actually observe.
Did you ask me what gravity is just to disagree on me on it? You already knew what I was going to say.
No, I actually didn't because we get different. Why are you freaking out, bro? I'm being very calm with you. I don't know why you're getting so excited. Do you think you could just take a deep breath? For crying out loud. So, you are describing this is a description of something that, read it off to me again. What is it?
I actually didn't read it from anything.
Oh, so you made it up on the spot. What did you just describe? What is it?
All right, I'll read it off of Google. Gravity is the law that every object with mass attracts every other object in the universe in proportion to each mass and inversely proportional to the square of the distance between them.
Okay, great. So what you need to do is get us whatever that gravity is and put it in this experiment to see if it causes things to fall.
You asked me to change the variable. You didn't ask me to personify gravity and put it in the experiment.
Dude, you're the one that has personified it. You're the one that has given it this vague description, even by Google. So we have to add whatever it is that you think is causing the effect. In this case, what is it? Mass? Or is it an attraction of mass? Okay,
Yeah.
put that in your experiment, vary that, put it into the experiment, and see if you get the effect that you're looking for.
Yeah, Printer, nobody was asking you to change the variable. What I was highlighting to you is that you implicitly did change the variable simply by changing the height. Because apparently the height is now.
Hold on, wasn't I just told to change gravity in order to verify the experiment?
No, you're not following along very well. What I said is the independent variable is the thing that you would ascribe the causal mechanism to, the thing that makes the other thing fall. You have all your controls. Nothing is changing. We're trying to make the effect, the falling, occur. You said it was gravity. I asked you, what is that? And now you're saying it's some kind of force having to do with mass or something. Okay, well, that force, how can we put that into the scenario to make the effect that we hope will happen? How can you add that to make the effect happen? The dependent variable. How can you make the falling occur? So you're going to put in what? Mass? Or maybe you're going to put in a force? Well, which one is it?
Define put in.
I'm saying apply this to the object that you want to fall.
You want me to apply gravity to my phone?
Yes, that would be your independent variable. That's what you declared.
And what would I apply mean in this context?
That's what I'm asking you, because you actually
you told me to
even
do
know.
it. You have to define it.
Yeah, I'm not the one here that's supposed to define gravity. You are. I don't know what it is. You have described it to me in both your words, and then you gave me Google. So how do we get this into the experiment to make the thing fall?
That's what I'm asking you.
No, I'm asking you. It's your claim.
Well, my claim is that I don't have to apply anything. Gravity is just there.
Oh, so now it's just there. So you're just decided to declare on your own volition that this is why it's happening, even though you can't make it happen in an experiment. That, my friend, is
I
pathetic.
made a hypothesis, and then I confirmed it using an experiment.
You performed no experiment. You did not apply an independent variable. You said it's always there, and that's why it happens. That's a baseless assertion fallacy, and it's ridiculous.
Yeah, Printer.
If it's not all,
check this out. Okay, this ruffling of the feathers that's going on. Okay, this is you internally starting to recognize the difficulty of this whole thing and why you can't actually do this. As we stated before, okay, you're coming to the recognition that you can't manipulate the supposed cause of the effect. So then you, as you just said, like not 10 seconds ago, you basically just declare it's there anyway. Follow?
How would I, all right, let's say I didn't declare that it was just there. Would I have to change it or not?
If you want to actually explore why the things are falling, you have to come up with a reason, right? A supposed reason, and then demonstrate that supposed reason actually affecting it. Period. It's very, very simple. In this context, obviously you can't, because you can't manipulate gravity hands-on. You can't manipulate the mass of the Earth to demonstrate whether it's going to have an effect on the rate of things falling, or the speed, acceleration, whatever. You can't actually do that. Therefore, it does not qualify as being scientifically experimented on. Period.
So I do have to manipulate it in order for it to qualify.
That's the whole point, dude.
Well, I asked just a few seconds ago if I have to change it.
If you want to change the entire, hold on. Change as in alter the value, like manipulate the variable itself, or do you mean basically change the entire experiment, swap in a different supposed cause from this one? What do you mean?
Change the value.
Change the value. Yes, you have to do that.
I have to either come up with a different cause or change the value of gravity.
Yeah, you can suppose anything as being the proper reason, so long as you can manipulate it and demonstrate that it does or does not have the effect. So you can outlaw if you suppose something, you demonstrate that it doesn't have the effect, then it rules out that this is the cause, and then nobody else has to bother checking it again if they don't want to. Right? So there's value in null hypotheses, too. Right? But you actually have to have the test, or the experiment, I should say. It has to be a valid experiment, where you actually do manipulate the variable. In this case, you just can't in the first place, as you are coming to grips with reality about it. You can't in this case. So it doesn't
Well, if it's not gravity, then what is the effect? What is the cause? Sorry.
Fantastic question. And guess what? Everybody's wondering the same fucking thing.
I have been wondering since the start of this voice chat.
Mm-hmm. But you also came in storming that, oh, you know it's the Earth pulling shit down because of the maths. Right? So you either don't know and are wondering, or are certain and not wondering because you're already certain, or you're in the middle somewhere, or you think it might be this because, I don't know, you're biased in that direction. You were told that ever since you were a kid. I mean, we all were, right? It's not an attack on you personally, right? But these are the facts, man. It's an open question. Even as Drace mentioned before, I think. Neil deGrasse Tyson said the same thing. We don't know. Next question.
Wait, so you don't know either?
Of course not. How the hell would I know?
No one in this voice channel knows why the phone is falling.
Homie, did you not listen to Drace not 10 minutes ago? Outlining that there are currently up, what was it, 70? In the 70s, okay? Number of different competing extensions or whatever to Einstein's theory.
So that, all right, well, that clears up your position. That's really all I wanted to know.
That we don't know? I'm surprised that hasn't been.
I wanted.
Yeah, I'm surprised that hasn't.
Clear up your position.
Yeah, and we're not making claims about that. We're just trying to show you that the people who come in here storming that they do know don't actually know. But they say it anyway. And then we inquire about these details, and they're like, they don't know. So their arrogance, slowly subsides, and they're like, okay. Sometimes they just leave and come back and argue the same points again and again and again, But at least, it seems like you're coming to this realization, which is good. Now, if we're wrong, okay, I'll caveat all this with this. But if I'm wrong on this, and we're all wrong on this, okay, I want to know. Okay? So come back if you find something.
That is not what I already stated. That's not gravity.
What?
Sorry, what?
Well, you said come back when you find something, and it's clear that there's something that I've tried to tell you that it is.
Yeah.
You haven't accepted, so I need to find something else.
Yeah. I get that. Yeah, if you come across something, right, something novel or whatever, feel free to bring it to the panel.
Now, the biggest problem that you're going to be bucking up against is that there is no exclusive downward vector for all matter. So these are more circumstantial observations than they are anything else. If you take an object and you put it in a medium, it may go downward. If you put it in another medium, it may go upward. This is what we observe, but we cannot actually give you concretely a cause as to why these things happen. They just do. It's almost like a law. We just observe it. We can't really explain why. This is just what happens.
You're talking about water now, right?
I'm talking about any medium. So you can take an anvil. It will fall downward in both air and water. But then if you put it in mercury, which is a liquid state of metal, then it will float in mercury. It will go upward.
What's your position on buoyancy?
Buoyancy is something that we observe, but the term buoyancy actually begs the question of gravity. What we do observe is specific gravity, which is objects in mediums where they are less dense go upward, and when they are more dense, they go downward. That's what we observe.
I mean, that's true. So why not? All right, never mind. Well, I still have more questions. For example, why do you believe in this dome?
Well, there's no belief in the dome. The evidence for any kind of container, we don't say dome, but a container for the gas pressure is required to have the gas pressure in the first place. Now, you say somebody here told you about a dome. Who was that?
That was you.
I didn't say anything about a dome.
I mean, the container. I called it a dome.
Okay. So there's a container for the gas pressure that we have on Earth. This is not disputable. We have gas pressure. The requirement for gas pressure in physics is containment.
Does it go under the flat Earth as well?
What do you mean under?
I mean, if let's say the container was like obeloid thing or whatever, is there no up and down of the flat Earth? What I'm not getting.
Well, as far as we can tell, the Earth itself is horizontally oriented. That's how we experience it. Up and down is the same for everybody. So it is a horizontal plane. What its complete construction is, I have no idea. I have no idea what the entire, realm looks like overall. But if we have gas pressure, then it must be contained.
Gas pressure. Why is she asking about buoyancy now when it was addressed a long time ago? I don't remember why. Activities that are around it. Okay. The dome exists because of gas. I'm going to Google gas pressure. It's caused by the force
First of all,
by gas molecules colliding with the surfaces of objects. Although the force of each collision is very small, these refer. You were going to say something?
No, I mean, if you're going to call it a dome, that's fine. I don't know if it's a dome. There's a containment.
You don't know what shape it is?
I have no idea. What would that matter? We have the gas pressure. It could be a cake top for all I know. I don't know.
But it can't be a cube if the.
Bro, the thing is, we don't have a replacement cosmology for you. We are not a different belief system to believe in. So we just have measurements and evidence and logic that proves the old belief system false. So we don't have a replacement for you. So asking us about the edge of the world or how things work that are unknown have no relevance to our actual arguments or points.
I still think it's worth talking about.
Well, fair enough. We would begin to,
yeah.
If you're going to speculate, we're going to go ahead.
Yeah, exactly. I wanted to say, if you want to speculate, we have speculation Sundays where people can speculate about why they think this works or that works, and we'll be like, well, how do we prove that? And if there's no way to prove that, nobody's going to believe that. We don't believe things willy-nilly here. We try to be empiricists about things. If we can't measure and prove it, there's no reason for us to even entertain it normally.
The curiosity
You can't really
in
prove
trying...
this dome, can you? You can't
No, we
see it,
can't.
you can't measure it, you can't test it.
Sorry, friend. The dome that you think exists, because you keep using the word dome, the evidence for the dome is the gas pressure. The container itself, the gas pressure is the necessary antecedent, or the container is the necessary antecedent for the gas pressure. You cannot have one without the other.
Yeah. So,
but there is a downward force.
Yeah, no,
there
that doesn't affect gas though. That's the problem. If you take gas and you release it, if you take two bulbs and connect them with a valve, you have gas in one bulb and vacuum in the other, and then you open the valve, the gas will expand into the available volume, and it will not be impeded at all by any imagined gravity. And so this is the second law of thermodynamics. This is the most simplest demonstration. I have a recording of Richard Feynman saying that this is the most basic demonstration of the second law of thermodynamics. They claim we live in a vacuum, an ever-expanding vacuum. That means the gas would just continue to expand into the available volume and be gone. And then the next layer and the next layer and the next layer until you have no air on the earth. And then the entire ocean would evaporate. And then you would have no air, no liquids, and everything would die. That's the globe in a nutshell. It's violating natural law, which we can demonstrate here on Earth, where gravity is supposed to be the strongest, and it does not impede gas at all.
The reality is that the story behind the Earth being a ball within this vacuum is that however many billions of years ago, this ball Earth was cooling and off-gassing. So all of that energy, heat, gas that was leaving the surface of this ball would be leaving and filling the available volume of the ever-expanding vacuum, meaning no pressure of any kind would have ever been developed in the first place.
Let's say that I accept the container, all right? No strings. What's around it? Is there matter around it, or is there nothing?
How would we know that?
Yeah, just
choose any one. Is it not one of those two things?
No, this is not multiple choice speculation. You're asking us a question that we cannot confirm. Why would we even speculate on something so silly?
Two things.
No, bro, this is not pick your own cosmology day. We're not just willy-nilly deciding what.
Can you just humor me and do it?
No.
Can we just humor you and make up a new cosmology? We can do whatever we want if we wanted to do that. We have done.
I'm not asking you to make a new cosmology.
Well,
that's exactly what you're asking us to do.
There's plenty.
No, I'm simply asking you to. Sorry.
Yes, you are asking us to make a new cosmology, and there's plenty of flat earthers who have done that. We are not those people. We are empiricists. So making up beliefs and imagining things are true is not what we do. We like to test. If those people can bring to us their imaginations, and we test if those imaginations are true, and if they're not testable, we don't have any reason to believe them.
Yeah, we're not going to create a fantasy. Wait. So you're presenting a false dichotomy. You're giving us two options, neither of which you could even possibly verify.
Yeah.
No, we're not going to engage in false dichotomies with you. Sorry.
I don't see why this is such a big deal. I'm simply
Would
asking
you
what's around the
do
container.
this anyways? What is the point? Why would we do this for you? Why are you asking us to speculate about stupid shit?
It's
Yeah, look,
stupid shit.
this is because you didn't learn logic well enough in school. You didn't realize that you were making a false dichotomy, and you're asking us to be illogical. And we don't want to be illogical, so we refuse.
You don't want to imagine what's around the container.
No, this is not a place for us to imagine things. If you want to imagine things, go to one of these, places where people think that their dogs are cats. Imagine whatever you want. We're not going to engage in that. It's pointless, fruitless, time wasting.
Yeah, anybody can imagine anything outside of the reality. You can imagine there are ponies, there are leprechauns, you can imagine whatever you want. We don't want to imagine anything, because if you start imagining things and believing in a certain imagination of yours, because, oh, I like this one, well, that creates a bias. That creates tinted glasses that you now look at reality through, where you try to match reality to your belief. We don't want to become biased like that. We don't want to taint our clear eyes. We want to see the world for what it is and let the world tell us what it is based on what it gives us, not based on our imaginations and trying to match the world to those imaginations.
So there could be anything there. There could be ponies. There could be whatever. We don't know.
We don't know, yes.
That I was not expecting so much backlash from that question.
We get this all the time.
Right, how about this
annoying.
one?
It's annoying
Why
because we
is
get this all the time. Let me just finish this. We get this all the time where people tell us, what's beyond the end of the earth? And the same idiots are telling us, well, the earth is a globe because air moves around a tree. We're not making claims what's beyond the known earth. We're just making claims about the surface of the earth that anybody can go out and test. And we're not even asking you to believe our claims. We're just saying, maybe you should question your claims and go check them.
so anything outside the Earth is off limits? Is that what you're telling me?
Anything outside the earth, we don't know. Like, it could be many things. If you actually started to research this and look at all the different ideas of the different flat earthers, we're the conservative flat earthers who stick only to the measurements and the empirical and the logic. And so you can't come to us with some retarded idea of how you think the world works without evidence. However, there's millions of flat earthers in the world, and
I didn't even present an idea. I simply asked you what's out there.
Yeah, that's why I'm telling you. There's many of flat earthers in the world who have imagined how the world is beyond the known land masses. And if you look into that, there's many interesting tidbits you find within it. However, you'll notice that they all have a belief they're trying to push, because aspects of what they believe are not verifiable. We like to stay within the verifiable. So you can explore this topic and find what you're looking for, but we're not going to do that for you because we don't do that here.
Right. So, like, you just don't care about anything outside of the Earth, like the moon, the sun, the stars, nothing?
Oh, we care about all of that stuff. We just are not delusional enough to think that we know what that is without enough data to determine what it is. And so that means that we can look at all of the different speculations about what it is without having a bias that makes us go like, oh, I'll dismiss this out of hand because it doesn't match my ideas. And so we can look at all of the ideas and be like, well, there's problem here, there's problem there, there's problem over there. But they had some interesting ideas over here, they had some interesting data over there, and so the more data you have, the better idea you can have about the world. But there's always going to be a problem with you don't have enough data, and that's the position we're in right now. We can't make you a map. We can't map the whole world for you. What we can do is measure the ground, and anybody can do that.
So a consensus can only be reached if anyone can perform an experiment on it.
Yeah, essentially, if you can make it so that it's completely logical, you have evidence to support it, and like, yeah, then you can get people to have a consensus on it. Problem with the current consensus is we have a bunch of fallacies, and people have a consensus on the fallacies, and then they appeal to the majority because many people believe the fallacies. That's just stacking fallacies, and we don't do that here. We like to stay empirical. Give us the data, or we'll just ignore the claims, because the claims without evidence can be dismissed without evidence.
But it is true that everyone has to be able to perform the experiment, right? Within reason.
Essentially, yeah, that's basic empiricism. That's repeatability. If you can't repeat the experiment, if it's something that you have this special fairy dust that allows you to talk to the fairies, and that's how you know all this stuff, and we just have to accept it because you have the special fairy dust, and we're not allowed to get any special fairy dust, then that's not acceptable.
So if I was a millionaire and had access to a special hot air balloon that allowed me to go above 70 kilometers, let's say, and I just kept going up, and I reached the container, and I made some measurements about it, and I came back down and told everyone, that wouldn't be enough because no one else can do this. I'm the special fairy that can tell people whatever I want.
Yeah, you claim you have this special technology. Of course, that's a pretty absurd example. With
hot air
balloon, because we have sent up all sorts of balloons of all sorts of types, and we know how high they can go and where they stop. So it's not reaching any imagined dome yet, because we can't get high enough. We just have not been able to go high enough. They claim the ISS, for instance, is circling the Earth, and we get these pictures, and we see this Earth curve in the pictures. But if you look at the math, the ISS is so close to the surface, it only sees about 3% of the surface, and so it has a horizon line just like you and me, that's circular around the craft if it were at that height. And I don't know that it is at that height. That's just the height they tell us it's at.
So where is it then?
I don't know. I didn't put it up there. I can't verify its position.
But it is somewhere high up.
No, don't. Not sure how high it is, if it even is there, because there's many different ways of spoofing its position. So you could see something in the air and you think it's the ISS, but it could be many different things, and we have no way of determining which of those things it actually is, if it is. So usually
I find this problematic because not everyone can perform experiments. Not everyone can perform every experiment, especially the expensive ones.
Oh, I agree. Like it's not reasonable for you to expect someone to perform every experiment for every single thing. You can watch many experiments if you want to understand something. You don't have to perform all of them yourself. You can watch other people perform them, and then. But if you're gonna try to like build on that or make claims on that, then your experiments you would need to do experiments to validate that. Like I am writing a optical framework, for instance, a scientific paper essentially, and before I publish it, I'm even though I have a bunch of data collected over the years from other sources, uh, I'm gonna make my own data to go with all the other data uh, before I publish it.
Even though you have your own data, you're going to make your own data to go with the other data before you publish it. How is that helping anything? You can't, like, that's not allowing me to do the experiment for myself.
The for instance, the optical framework. When you create something like that, what you want to do is, and that's what I did, is you make it falsifiable. And so people can go out if they want, try to replicate your findings, and if the findings don't come out that way, then you have falsified the framework. And most scientists and most people don't allow for this and don't give this opportunity because they are scared of their funding. They are dependent on this. I am not. And so I don't care if I'm wrong. If I'm wrong and somebody proves me wrong, I'm happy because I learned something new. Just like I went into this flat earth thing, I wanted to prove them wrong, but because they showed me that I was wrong in my assumptions, I was like, okay, I'll test this other thing because I'm not going to believe you. I don't believe anybody. The world informs me of what I believe, and so I'm not subject to the manipulations of other people.
You said that they can falsify you if they want. How are they going to do that?
It's very easy. For instance, when it comes to the globe, they tell you that the horizon should be X far away based on the geometry. And then once optics got more advanced and we started seeing far smaller things with larger optics and zoom capabilities, we suddenly started realizing we were seeing 10 times beyond the proposed Earth curvature, which we assumed was the geometric limit or the horizon. And so after that, they started saying, oh, well, the horizon's apparent. Well, there must be refraction causing the light to bend around the globe and making it appear flat in all observations up to the horizon. And then beyond the horizon, that's where it starts to curve, boys. It's somewhere we can't detect. That's where we start to see the curve. But it always looks flat up to the horizon. And we can see way too far, so it must be refraction. Problem is, they never actually tested that, and they just kept on assuming that the light was, whenever the observation didn't match their presumption of the globe, they would just bend the light to make it match. And so it became an ad hoc excuse to save them. And so I proposed a simple test because visible light refracts at a certain rate. Infrared light refracts at a lesser rate. And so the two wavelengths don't refract at the same rate. And so you can take two cameras, one calibrated for infrared, one calibrated for visible light, and then you can observe the horizon with those two cameras. And in the visible light camera, the globe predicts that you would see further in visible light because the light is bending around the globe, making it appear flat so you can see so far. However, infrared doesn't refract as much as visible light, so it wouldn't bend as much, wouldn't allow you to see as far. So you have a prediction for the globe. You see further in visible light, less far in infrared. And then for us, We don't need Earth curvature for anything. In my optical framework, I describe every single refractive effect over a flat surface. It's very simple and very easy. So for us, infrared refracts less, so it causes less ray loss. So when the bottom rays of objects in the distance get refracted down, if those rays hit the ground, you're not going to recover those rays, and so the bottom of the object will be occluded or will be obscured. That's just the light hitting your eye.
Right. So you need 2 cameras for this setup. Or
Yeah, that's to falsify my framework, and because what I've seen through a bunch of other people using infrared cameras and people taking pictures is once we use infrared, we actually see further because infrared cuts through the haze and allows us to see further, and it doesn't refract as much, so we have less ray loss. And so that's the inverse prediction if the Earth is flat, is that we would see further with infrared, less far with visible, which is completely the opposite of the globe. And all of the data I've seen so far seems to support the flat Earth position, or that we see further with infrared, and that's why all of the world record long distance photographs are all taken in infrared.
Right. Well, here's my problem with this take on experimentation. It's that you don't trust isolated experiments that can't be replicated. And that sounds like common sense, like why would I trust that? But let's say that you were the one performing the experiment. And the experiment was you go build some device and you go really high up and you find the container, right? And you see it. Or you don't see it with your very own eyes. Maybe it's made of something like, I don't know, that you can't see. Then you come back down and you try to publish your findings. But no one else can do this. No one else can build this experiment, and no one else can falsify it unless they have giant wads of cash just lying around.
Yeah, but I don't have giant wads of cash. This doesn't require giant wads of cash.
Your experiment doesn't. But
you're inverting it, because the Globers claim that you require giant wads of cash to get things into low Earth orbit, and even Werner von Braun and Elon Musk claim that to get to the moon would require multiple rockets to refuel in orbit, which didn't happen with the moon landings, for example. So it's clear that that was a lie, because they didn't have the fuel to get to the moon, according to the space experts.
Moon landing cost billions of dollars, though.
Did it?
A free experiment.
Yeah, and who got all that money?
It was used to build the rocket. Right, and it was financed by the American government. Ironic. Anyway, that's besides the point. My point is that if someone actually did go up and touch the container, no one would believe them because they can't replicate the experiment.
Well, they should be able to replicate the experiment if someone can go and do that.
Why? They don't have the capacity. They don't have the money.
How did they do that? How did they do that? What technology did they use to do that?
They used a hot air balloon. Or alternatively, a rocket.
So, like, why isn't other people testing it? Like, if
anyone can make a hot air balloon
result, we need to figure out why he's getting a different result from everybody else doing it.
I didn't
Everybody
even
else,
imply that they
like,
you.
This is kind of like with the flat Earth. Everybody else is doing it, and they're finding the Earth is flat. Meanwhile, there's this one guy who claims that he has done it with the same equipment that like everybody else is using, but somehow he found it.
I'm trying to. You're not really getting my point. I'm trying to put you in. I'm trying to make you put yourself in the perspective of someone that actually goes and does this. That actually builds a rocket and touches the container. And then comes back down and no one believes him because they can't also build a rocket. And I'm trying to get you to see that there's a problem with that. You can't expect all experiments to be replicated by anyone.
No, I agree with you. There's a giant problem with that. Someone claiming to have done that, and then claiming that when he did that, he debunked observable reality. That's a problem. Why would you
What do you
believe
mean
that?
debunked? What do you mean debunked observable reality?
Because the guy who, in your example, the dome in your example is the globe Earth. In the globe Earth, they claim they have so much money.
No, it's not the globe Earth.
Into
It's the
outer
container.
space. No, bro, it's the same analogy. The analogy is the same. In your example, the container is the globe Earth. They claim they have the power and the money to go and verify the container, the globe Earth, but nobody else can go do that. And then when we go actually and test the ground, which should be curved like they claim, because they have the secret knowledge, it isn't curved. So we know that they are not telling us the whole truth.
I'm sorry, am I wrong that you claim that there is a container that causes gas pressure around the Earth?
There is containment of the gas. We don't know how that containment works.
Okay, so let's say someone wanted to try and find out. So they build a rocket and they go up.
Yeah.
Right.
They go up and
they either see it or see something
else. They can't
else.
go any further, and then what?
And then they come back down.
Yeah,
and try to tell people about
they
it.
couldn't get any further. They didn't find the end. So how did that help?
What do you mean they couldn't get any further? You yourself said you don't know what's up there. Why are you assuming now that they couldn't get any further? What does that even mean?
Because that's how rockets work. Rockets push off things.
Okay. I don't think you're getting my point here.
I get your point. You're imagining that what if you're imagining what if somebody went up to the sky and touched the imagined end point and then went down and told everybody, well, I have the secret knowledge of the end point of the sky, and nobody believed him.
Yeah.
Yeah?
Okay.
Where are you going with that?
I'm saying they should believe him.
Why? Because one retarded guy who was hallucinating on shrooms and believed he did all those things, claimed he did those things. Why should we fucking believe him? That's called being naive and gullible, buddy.
Well, relax.
You need to actually test his claims. If he claims that you can go up there and you can do this in a hot air balloon and people go up there and they can't, then you know he is bullshitting you. Just like we go out and they claim the earth is curved and we go out and test it, we know they're bullshitting us.
Nothing that has been said up to this point has pointed me to think that you can't go and touch the container. What's stopping you from going higher?
rockets push off things. So, like, if you take a rocket and make it push all of its exhaust into a completely vacuous chamber, the vacuous chamber will fill, and it's not until the gas hits the wall of the container that the rocket moves forward.
No, that's not true.
Oh, we have evidence of that.
No, you don't. That's wrong.
Oh, we have.
I'm sorry, but when you throw something, you're gonna get immediately pushed back before that thing hits any wall. You can try this for yourself now by throwing a bottle.
Are you in a medium?
Yes, I'm in air.
Yeah.
That doesn't disprove anything.
Oh, you're pushing against the air.
All right, and so is the rocket.
Yeah, you're claiming the rocket's in nowhere.
No, I never made that claim. I simply said that rockets can go up.
Yeah, and eventually the air gets so thin that they don't work very well. And so there's different types of nozzles and different things they do to try to make them work better and go higher. And that's why you have ballistic intercontinental missiles. However, there's a limit. You can't go pushing off nothing.
You can. It's Newton's third or first, I don't remember, law of motion. I can't prove it because I'm on Earth. To prove it, I would have to go to space.
Yeah, unfalsifiable nonsense.
No, it's not unfalsifiable by you. You're saying that it only happens because I'm in a medium.
You could not prove it. That means it's unfalsifiable. You cannot.
I can't prove it by your standards.
You have to go into Narnia through the magic closet to talk to the lion and tell me he's real.
Wait, what?
All right. Rockets have the same effectiveness no matter where they are because it doesn't matter that they're pushing against the air. As soon as you throw something, you get an equal and opposite reaction. That's one of Newton's laws of motion.
Yeah.
And that's true. It's measurable. It's detectable.
We've all heard this claim. However, we have not seen any evidence that this is true, that you can push off nothing. And so far, many people have tried to do this. Mythbuster tried to do this. Cody's Labs tried to do
this.
Mythbusters. Yeah, and the problem is...
you can actually do this. I forgot about vacuums. Put yourself in a vacuum and do it.
Yeah, every time they do this, we watched all these examples. Every time they do this, every time, the exhaust from the rocket repressurizes the chamber, and you don't get movement until you have pressure.
What do you want me to do? Build this now?
No, I don't want you to do anything. Like, I am not asking you to do anything. I'm just answering your questions. Like, if anything, I just want you to be critical of your own beliefs. Like, I don't care if you never turn into a flat earther. Like, you might realize that, well, they're not telling me the truth about the globe. Like, there's contradictions here. I don't want to accept that. Like, you might get to that point, and I'm perfectly fine with you even being a completely zealous glober. Like, I don't care what you become. Like, I don't care what you believe. I'm just here to help you if you want it.
Neither does science.
Yeah, and I love science.
Me too.
So how high has the highest rocket gone, just out of curiosity?
Well, the claim is it's gone to the moon.
All right.
And what? The highest?
What's your opinion?
Well, I don't have an opinion on that because I don't know. I don't have opinions on things I don't know.
So we don't know
Is
how high
God
the
real?
highest rocket has gone. That's very convenient that we don't know how high they've gone.
Yeah, right.
Well, like I told you, I know how high they claimed it has gone. However, I don't actually know. There's a difference between belief and knowing. So I could believe that what they're telling me about how high they've gone with a rocket, or I could just be like, well, I don't know how high they've gone with a rocket. They've told me this high. What's
Why
wrong
don't you
with it?
believe them? Don't you have a reason to not believe
I don't
them?
have any reason to believe that.
What? How would you believe that? In what world? Like, what would you have to be there on the rocket?
Like I told you earlier, there's no reason to believe they've ever shot a rocket all the way to the moon, because according to Werner von Braun and Elon Musk, Werner von Braun said they would need 3 of the rockets that they used to get to the moon, 1 to get into low Earth orbit, and 2 to ferry the fuel to refuel that first rocket so it could get to the moon. Elon Musk said he would need 15 starships just to refuel the spacecraft to get to the moon. So logistically, they never could have gone to the moon. But then we take all of the supposed images and evidence that they've gone to the moon, and we look at the different perspective of the images, let me find the link. I'll find the link for you. This is a.
You said that it takes 1 rocket to get into low Earth orbit?
Yeah, essentially. It uses
All
about
right.
98%, 95% of the fuel to get to low Earth orbit.
And how high is that?
It's claimed to be about. How high is the ISS? Fuck, I need to look that up.
120 miles.
Yeah, roughly.
See, that's interesting because of like maybe 2 hours ago, that's how long I've been here. I don't know if it was you, but people told me that you can't go that high. No one's ever been above 60 miles.
Nobody's saying they went that high. This is what is alleged.
Yeah, the NASA crew and the ISS crew claim to have gone higher than that, but no commercial flight has gone higher than 60 miles, and that's Bezos and crew.
Flight? You mean like in an airplane or any?
No, like Bezos had his penis rocket. He shot Lady Gaga up there and William Shatner, and then William Shatner was like, well, it looks flat from that height. And then the old lady who was like, I'm super disappointed that I couldn't see the Earth curve.
Okay, so how high did they go? Or you don't believe them? You don't
I'll give you
how
Neil
high.
deGrasse Tyson talking about that just a second.
Very serious scholarly discussion going on here.
Yeah.
Yeah, until you entered into it for itself.
Right. So we just don't believe anyone who says they've gone high. Not hot air balloon, not Bezos, not NASA.
Bro, it's not about like what you don't believe them. Like William Shatner and the lady who went on the flight said the Earth looked flat from that height. However, like Lady Gaga says something different, but like she's crazy. And here's hostile witness Neil deGrasse Tyson on Bezos going up.
Oh, by the way, you didn't ask, but I'm going to tell you. Do you know how high up above the Earth he was?
No.
So if you take a
63 miles.
Oh, yeah, say right. So take a schoolroom globe, and that's how high above it is he? So he's about 2 millimeters above the surface of a schoolroom globe. So nobody has seen the curvature of the Earth from that height. I just want to make that clear.
Just curious as to why. Why do you want to keep this this ideology, this concept?
Oh, why?
Yeah.
Because, like, okay, so again about models, like when you make the globe model, like it doesn't explain everything. It explains the weather, explains the moon,
There is no globe model.
yeah, I mean, yeah, there is. And the
No.
sun's at the center, it orbits around the sun. The moon orbits
No.
around the Earth.
We have to be careful about the terminology that we use. It's only a concept. It's a mathematical concept. There is no model.
So is a model meant to be? I thought a model was just like a visual representation of a idea.
Well, yeah, if it's a die-cast model of a Ferrari, then yeah, it's a smaller representation of an actual thing. But in this case, because the actual thing doesn't exist, it's purely mathematical. It's just a concept. And besides, if we're talking about science and scientific models, then there would have to be experiments being performed, which there are not. So this is only conceptual in the mathematical sense.
You have to have to buy an energy. You have to have an ID in America.
To what?
To buy an energy drink.
Do you have to have an ID? No, but there are some energy drinks that recommend that people under 18 do not purchase them. It'll say it on the can.
Yeah, like a line. Red line is monster, by the way. Hard.
Is he cutting out for anybody else, or is it just me? Beanie Weenies, you're cutting out. I don't know why.
Okay, there we go. That should fix it. Yeah, it was like Red Line. Red Line is monstrous. I've heard horror stories.
Red Line or Red Bull?
Red Line.
Never heard of it.
It probably got banned because it's genuinely like it might kill somebody. It probably has killed somebody.
So when it comes to the heliocentric concept, you are more comfortable with a mathematical concept that in reality does not exist because it answers questions for things that occur in nature?
I mean, yes. Like it explains why the things happen. So.
Well, see, explanations are worthless unless they have demonstration. So an explanation in this case would be a just so story, or kind of like a fairy tale that someone would tell you. Like Santa Claus, you know, like you see the presents under the tree, so your mom and dad tell you that he came in the middle of the night down the chimney and put them there. It's the exact same thing as the globe. You see an eclipse, they create some kind of elaborate story about where you live and space and all that, and show you how it could happen, and so you buy it. So it's essentially the exact same thing as Santa Claus, although in reality, none of that is true.
I hate that I see the analogy. I don't want to say good point because that all sounds crazy to myself.
Well, I mean, you know, digest it. But like I said, this is all purely mathematical. It's just conceptual. But you have to go to the actual Earth to see its, you know, geometric properties. You have to measure it. That's reality.
Yes.
The flat earthers are the only ones that are saying things like, I don't know. Like if people come in here and go, well, how do you explain how eclipses work? Ultimately, I don't know why the moon gets darker and the sun gets darker at certain times. I have no idea. There's no way for us to test that. But we do know in reality that the earth is measured to be flat. So the best we can say is, I don't know. You know? I don't even know what the sun and the moon really are. They're light phenomena in the sky.
Oh, yeah,
I see what you see.
Yeah. Is that like the universal view of like not universal because like obviously you can have like different people different thoughts, but like is it the main view of flat earthers that you generally don't assume what you can't know, like you don't know what the sun and moon are?
I would say overall, no. I think it's going to be the vast majority of people that consider themselves to be flat earthers that are going to try to come up with another just so story as to how it works. Those of us who kind of hang around this particular server, the 24/7 Flat Earth Discord 2.0, we do our best to make sure things are empirical, so that we don't just go making up stories, because I don't want to replace the bad story that you already have with another bad story.
It's not an attempt to do that anyway. It's not an attempt to explain every single little thing that's happening in the universe, right? It's an evaluation of the surface geometry. That's it. Plus, well, it's not that's it, because we evaluate other aspects about it, like it's claimed to be moving, but we don't sense that. Nobody measures it, right? That's just an assumption based on philosophical preferences. And we scrutinize the idea that we exist as an object floating in an ever-ending void. Never-ending void, sorry. So while we're not presenting an overall cosmological viewpoint per se, we do scrutinize the one that already exists, which does claim to answer, oh wait, what is it? Only 6% of the physical universe. That's what did Neil deGrasse Tyson say? We're 96% dumb or 94% dumb or something.
Probably.
And other theoretical physicists and astrophysicists have said, yeah, we really don't know shit. But then people come in here so confident that it's all true. Why can't you guys just deal with what we actually are claiming and not the things which you claim, and then demand we also make a claim about those things? We're just pointing out that the surface isn't curving. There's no measurement of it, and any attempt to measure the surface results in nil curvature. But we're so small. That's not my problem. That you think that we're on a big ball that's so big that it just appears and measures flat. It's not my problem. It measures flat. Get over it already.
I mean, that's it.
Yeah, I forgot that's one thing I meant to do. I meant to find a paper that does measure the Earth is flat, because there probably exist some that do like claim we measured the Earth flat. So I wanted to find one of those and bring them to you. See what you say about them.
I'll give you something. Yeah, go. Type in like a country or a state, like Florida, right?
Yeah.
Topography. Florida topography. Enter. There is a English something topography. It's a great site. They have the topography measurements from all of the surveys done all over the world, and it's mapped out for you.
Yes.
So the coastline, I mean, 0 is what color it is. Elevation above 0 is the color it is. Red is the highest. So you can kind of figure out elevation from there, and it's basic. Same thing as a 3D model, right? If you flattened it out the other way, you have you got a sim at that point.
Assume what?
Well, I mean, 3D simulator, like flight simulator, helicopter simulator, you take the topography, right, from what we've actually measured, and it just, instead of being on a flat screen, you lay it down like it's supposed to. Ta-da! You have the starts of a 3D simulator for literally anything.
I don't get your point.
Well, the topography shows the coastline of Florida being level all the way up from the top to the bottom.
What do you mean by level?
I mean, there's no deviation.
Okay.
But that's your mean, right? That's your mean sea level. That's
Right.
what it is when the water isn't moving.
That means sea level is equidistant center of the rate.
Oh my god, that's why they use sea level. I don't. That just clicks for me. That's why they use sea level.
The tide goes out, the tide comes in. The average between them is the mean.
Yeah.
That's your level. That's your zero.
Yeah.
From zero,
distance from
now
the
you're
center of the
looking.
Earth.
Elevation is upwards, right? And deviation is downwards. Now you have a zero. You start off with a graph, and then you go from differential leveling all the way down the coast, and now you're checking to see whether you have elevation upwards or deviation downwards. And that's all you need. All you're doing is going back with the differential leveling tools and fact checking the guys who actually did the survey in the first place, which is absolutely great. Go do it. You'll be in here on my side in no time.
Perchance.
Well, bro, I have a background in commercial construction, commercial plumbing, concrete, entry access. We did all kinds of different stuff at different times. Using surveying equipment is number one thing for most major commercial construction companies. Differential leveling. I guess, does that help you with your questions, Being Toasty?
Yes. Ooh.
I mean, I got guys in other places that have been in the debates a bit longer on the globe side, and they're trying to use differential leveling as if they're measuring height, breadth, depth, width of anything, right? There's no actual measurement there. They're just getting an angle. And an angle doesn't measure in inches or millimeters height. Doesn't do nothing. So it's not a... It's just a sidebar that they think makes, their imagination reality.
Well, if you have an angle measurement and a measurement of distance, then you can calculate the height.
That's a whole nother thing, like looking at something off in the distance and trying to get something. There's still your level. You drop your plumb bob, you make your horizontal, you have your baseline, which is your horizontal. So it's not like you have some kind of curvizontal line that just wiggles and squiggles as it goes off into the distance.
Oh. Yeah, but on the globe, they call level is like curved, right? So if you use the word level, globe earthers will just think you're talking about level in relation to a globe.
That's true, but they don't use it like that. So when, like, for example, measuring the heights of mountains, they establish sea level, extend the horizontal line out from there, imaginary, of course, but they level their theodolite, the horizontal, and then gauge how much that mountain, right, is above that horizontal. So all their calculations of the heights of mountains are wrong if the Earth is a ball. Every single one.
Well, off in the distance, yes. But here's the thing. I see them using terrarium aquariums. I don't see them using globe aquariums. I've never seen a globe aquarium in my life where they can get water to stick to something that's round all the way around and with fish inside of it, right? So I've never seen a globe aquarium ever. Only seen terrarium aquariums, which is what we have here, terrarium. Which, I mean, some people would call it a flat Earth aquarium, basically, because you're dealing with a box, which is all flat earthers say that the reality is just an area that we exist within that's contained. I've had fun with this one, right? Where is the globe aquarium? Where's the aquarium where you get water to stick to something that we suspend in the air where the fish can swim around this ball of water?
I mean,
Super curious.
the way they explain the water sticking to the globe is not gravity.
Yeah, that's how
Okay,
you would
so then
explain
you should be able to make something then that does that, right? If we know what
No.
does what, we should be able to recreate it on a micro scale.
Hold on, sorry. I thought about this for a while, these flat Earth arguments, right? That we should be able to make a ball and spin it and make water attached to it. Remembering, because we always forget that we're on the Earth and that we're going to be pulling the water down because that's the direction that the water's going to go. So whatever force is applied on the Earth is going to behave and act upon the water that we're trying to attach to what?
Exactly. You have to isolate your experiment from the rest of reality.
So, as
hold
our
on,
friend
I'm not-
just said, within
I'm not
that
doing the
argument,
spinny
the
part.
reason why the water goes down is because of the gravitational attraction or whatever, because it's a sphere.
Right, but you're talking about being able to recreate something. So
Yeah, but
whether
you
or not
can't on the Earth.
right, but that's a presumption that we've still yet to get proven, right? That's the problem.
No, it's not a
we're having.
presumption. I'm pointing it out. You've poured the water because the water goes down onto what? A ball, and the water is still going to want to go down and can't adhere to the surface that it's on that you're trying to get it to stick to because the water's going down because water always wants to seek its level, doesn't it?
Right, but what you're telling
the
me,
ball too wants to go down.
Yeah,
the Globers don't know what causes water to stick to something, is what you're telling me, because then they
No,
should
he
be
just
able to
said it.
recreate it.
In his idea, it would be gravity. The reason why you do it with your basketball is because the basketball doesn't have enough mass.
Okay, let me rephrase this. If you know something does something, then you should be able to then recreate its environment or its action, right?
Yeah,
So then,
but the environment of the Earth would impact the experiment. This is why you would have to go out of what is called a gravitational field to do this experiment, where only the gravitational effect of the ball would be acting upon the water. How you're going to get water in a vacuum, I don't know, but this is how you do it.
Can't do it in a vacuum. I can do it in liquid, and I can't do it while the ball's spinning. But so this is theoretically. Like, it works in principle. Okay, I haven't done it, but if you have like a substance, alcohol substance, right, and it's of a certain viscosity and density, right, and you get a solid object which is of the same density, place it in that liquid, and then you could theoretically inject another film of oil that's of a very close or exact density around that solid object, and then it will form a sphere. So you'll have a sphere of liquid around a solid object within a medium of liquid, another liquid. So it's not in a vacuum and it's not spinning, but it's getting closer, right? There you go, Glovers. I've given you a tip there.
there's a lot of things, but the problem is what I'm asking for shows that they don't know what they're talking about when it comes to any of this. Because if you can't do it, then how are you able to explain it if you can't recreate it? Like, this doesn't make any sense. Either you know how it works and you can make it happen again, or you don't know how it works and something's being made up, right? Because it's like
one of the
you can't tell me you're an
can't-
expert. Well, you're an expert, right? Expert gunsmith, and I hand you my rifle and it's having problems, right? But you don't know anything. You never went to classes. You never did anything. But you told me. It doesn't help me, right? I still have a broken rifle. if you can't produce results, then you don't really know what you're talking about.
We can't produce gravity because we don't have the mass on Earth to make gravity work.
Well, that's just an excuse.
How is that an excuse? Because the theory requires like such magnitude.
Magnetism or magnitude?
Magnitude. It requires like literal planet levels of mass and magnitude.
Well, now hold on. I have to correct you. This is not a theory. This is a mathematical concept again.
Huh?
Gravity, just a mathematical concept.
Well, in this category,
Dude,
yes.
there are
In
people
the category
flat
of
Earth.
reality, it's just defined as weight.
It's a little too simplistic.
The
There are
amount
people
that something weighs when it's put on a scale is more complicated for
Like
you.
gas? Like gas that's going upward? How much weight does that have?
Well, that's dependent, though. You're trying to now push things more dependencies, and I mean,
No.
technically, us having a measure has dependencies too, but gas has its own. We're dependent on the pressure.
Yeah, but weight is definitely not gravity.
That's not what my. Hold on. My American Standard English Dictionary from the 1700s says that's exactly what it is.
Well, I could care less what the dictionary says. How much does the gas weigh?
That's not the debate.
It isn't?
No.
Isn't weight exclusively a downward vector measurement?
Right, but gas doesn't really have what you would call mass, but it has weight.
I don't
and a
even know what
vector.
mass is.
Has a pressure vector.
Me either.
It has a direction of force, right?
Yes.
The brick has only one direction of force, doesn't it?
It can. Yeah, I mean, yeah. At rest.
Yeah. Unless you pick it up and throw it at me, for example. But if you were to let it go, right, it would only have one vector of travel.
Yes.
Gas that's got energy given to it by temperature goes in all directions. Its potential pressure vector is omnidirectional. Mr. Han, you've bugged me already. Are you trying to join the conversation?
No, he's trolling. He's just here to make a bunch of noise.
So what's weight?
So go
Is
on.
that gravity?
So yeah, where was that going? So continue. The brick has one directional.
Yeah. Somebody said weight. That's
Yeah.
what gravity is.
No, it's
That's
effective
the
gravity.
definition. Well, that's
Gravity
the
is not-
definition that we define as an effect. Yes, it's measurable. But the cause isn't gravity. That's the effect, right? So the cause still is yet to be determined, which proves my point. Nobody really knows what they're talking about.
The cause is determined of gravity.
What is that?
How do you hijack the effect to be the cause of itself, bro?
Hold on. What is that cause that's been determined?
The cause is simply the presence of mass. I'm pretty sure it's simply the presence of mass. It works.
So just the existence of mass itself.
Within the fabric of space-time.
There you go. Yeah. So the existence of mass itself, which is distorting the fabric of space-time, causing the objects that have a straight path to curve.
Yes.
So to prove this, we would have to take some mass, right, whatever that is, still undefined as far as I'm concerned, and then get some space-time and see if it does indeed curve it. Now, where can we find this space-time at?
Everywhere, I
Oh,
guess.
Me.
Well, okay. Go ahead,
We
Jedi.
have a problem.
In mathematics.
There you go. Only mathematical. So not in reality do we have any
Okay.
space-time.
I get that now. What is it? Oh.
Now, I've heard this before recently. People are telling me that this space-time is all around me, but I have not yet seen a sample of it, or anyone told me what color it is, or how much it weighs, or if it's a tweed fabric, or if it's more like I don't know, cotton. What kind of fabric are we talking about here?
I don't know. I don't exactly know like the real world analogy for it. You know what the theory of space of the fabric is? There's a theory that Neil deGrasse Tyson said. Obviously we can all trust him and we all love him. He said there's a theory that it's just a bunch of tiny wormholes.
Yeah.
Right. So that has it carries as much water as a fabric.
Can we have wormholes on a flat Earth?
Yes.
Three.
You know, I just thought that was interesting, so I just wanted to mention it.
Earth wormholes?
Earth what? No, wormholes.
You guys don't know the history of the term flat Earth, huh? It was originally coined by a glober trying to henpeck somebody into a position that, well, they just didn't believe in the heliocult model. That was it, right? Just didn't want to join the religion. So you got to label your opponent the disbeliever, but you have to name him to attack him, right? So you can't just attack somebody that goes, you're crazy. Can't prove that.
Yeah.
It was 1915, I think, when that was coined. It's just people that are from Earth, basically. Earth people, Earthers, whatever you can call it. It's just Earth. I mean, if you don't have a globe, right? If there's no bending and warping of anything, like the distance between objects or a concept of time, which is a measure in forward. I mean, what do you got?
Like wormholes.
Right, but that's in the weeds, man. Like, how does that explain anything?
I should have left the word worm out. I should have just said a lot of holes. You might have understood what I was saying there.
Oh, puns, yes, puns.
Oh, God help me. It's not good for my...
What do you need help with?
I'm in Minecraft and being beaten to death. Please tell me that worked. Oh my God!
Yes.
No! I keep big cobwebs! No! Oh, that's tragic.
Needs to be some kind of prank prayer or something.
No,
that is kind of a...
I genuinely get that scared when I'm playing Minecraft.
It is kind of amazing, though, right? We understand what holds something to something that we don't have proof of, but then we can't do the thing that we say exists, even in a small scale. Like, that blows my mind, because I have a construction background, and I'm a tinkerer. I like building stuff.
Yeah.
So if I can have it big and not small, that really doesn't make any sense to me, because I got a big engine and a small engine. Got a big pump and a small pump. Like,
yeah,
how do you have a big thing, but then you understand, right, the concept and how it works, the amount of things that go together. It's not just mass that causes what you guys are saying is real. There's more. You haven't even touched.
It is. It's the amount. It's the presence of like how much mass you cram into one place, and then the stronger, the more mass you cram into one place, the stronger the gravity is. You can't do an incredibly dense object to measure to do a reasonable warpage experiment on Earth.
Okay, so you're telling me there's no magnetic field then? Okay, cool. Whew. Earth doesn't have an electromagnetic field or a magnetic field? Like,
what does that have to do with gravity?
What does it have to do? That is a very good question, finally. Actually has a lot if you look at it. Because without it, most of what you know wouldn't exist.
Without the field, what happened to that guy? Without...
You think the device you're using doesn't have a field?
Yeah, but I know magnetic fields are incredibly useful, but like, what does that have to do with gravity specifically?
Some people say it's the cause of why things appear to.
Well, you have static, what I call static cling, which others call a dielectric plane. It's all about the same.
It's all to do with energy, more or less energy, potential energy. The actual environment of our systems contain a lot of potential energy, discharges, static discharges, lightning, and so on. Other electromagnetic phenomena high up in the sky as well. So some people suggest that the way that our reality operates is primarily electromagnetic.
Interesting.
I'm not saying that's what I believe or whatever. I'm just saying that's what some people suggest.
Well, I mean, it's a big proponent here. My compass would stop working. So it's like either it is a factor or it isn't.
But obviously it exists. Now, I don't think anybody would disagree that it obviously exists. We've all held compasses, right? It's just what it does.
Hold on, it still hasn't been related to gravity. Either that or I missed it.
No, it's not, because there really is no connection as far as we can test that magnetism of the Earth has anything to do with the vector of, whether things go up or down, as far as we can tell.
Oh, okay. I thought one of you was claiming that it was. Okay, never mind.
No.
My bad.
Well, everybody's in a different spot, I guess. So I have a different understanding of things than maybe somebody else, or maybe we say them differently. It is what it is.
Okay. But yeah, no. I get why you don't get it because you've been working your whole life with like stuff that works. Like, no, I'm talking like, you know how you said like, oh, you have big pump, small pump, big engine, small engine, like it all works. And if you have an idea of like, oh, why something works, you should be able to do that on like pretty much any scale, or like at least on a smaller scale.
Well, I can make lightning in a box. I can make storm clouds. Hell, I can even make a storm in a decent sized box.
What are you trying to make that we can't make?
Gravity.
Okay, so what causes gravity? We've been through this. You need an awful lot of mass to distort the space-time. If we're to believe that story, right? So in that story, basketball doesn't have enough mass.
Yeah.
It's like saying we need an awful lot of energy, right? An awful lot of electromagnetic energy to create an electromagnetic field as powerful as the Earth. We don't have the amount of energy that's within the core. I'm just throwing shit out there, right? But it's the fact that within this idea of gravity, they can't create the amount of mass. That's why they need things that are really big. We call those things like moons and planets and shit. Or they have to be outside of any other gravitational influence. So a small object, even though it has a relatively small mass, can, on a local small scale, attract or distort a straight line of another object that has got mass in its deformed space-time fabric field. So you have to remove away from the Earth. So in their idea, to answer this question, I've got to make a planet in space or take a small amount of mass away from the Earth and gravity. This is why they like to tell stories about going up in the sky.
Right, because when you can't explain something, you fly away.
Yeah, you tell stories of lands, mythological. There are talking lions and so on. Yeah. It's all theoretical, right? The concepts exist, the mathematics exist, because we say that, what should we call it? We call it mass. If there's a lot of it, there's a lot of energy there. So energy, the energy is there to distort the space-time fabric, which we can kind of say causes this phenomena to happen. It doesn't actually cause it, but I tell you what, we can make a good mathematical that kind of explain the day away. That's nice. Mathematical concepts are great like that. We can get lost in them, as Tesla was kind of pointing out 150 years ago.
Right, but space isn't a mathematical concept. So in order for this ideology of Einstein to even be accurate, it would have to be something that's bendable. But like, okay, I'm sitting here and there's another chair. It's 3 feet away. How do I bend the space between me and the chair without having to move?
You create more mass somehow.
Black hole.
Well,
which is even
hold
more
on.
mass.
I'm just trying to bend the space. It's the distance. So
Yeah,
I'm trying
yeah,
to
it's
bend
like,
the distance to make it
what
closer.
bend?
How do I
Sorry,
do that with?
Dave, it's like you're almost there. What
I don't
bends
think
space?
you can't do that with gravity. That's like
Hold on,
wormhole
dude, please. What
theory.
bends space in their ideology, right? What bends it?
Mass.
Yeah, cool. So when you're in your chair and your friend is in your chair, how do you distort the space between you so you fall towards them? Well, you need more mass
Or
in their
they
idea.
start eating.
Yeah. Time to order from Domino's, right?
Yes. Technically, actually, you could just hold the pizza and that'll be the same thing. Or wrap it around yourself. Oh no.
Is it mass or density? Or is it both?
It's the amount of mass in one space. So like both density, really mostly density.
Well, see, this is why mass, as far as I'm concerned, is undefined, because what is mass? Is it weight? Because weight is weight. What is mass?
Yeah, weight is the effect of gravity on mass. Mass is just physical matter.
Whoa. Physical matter. So physical matter attracts physical matter.
Yes, yeah, honestly, pretty much.
Okay, and how has anybody ever proven this?
My favorite term, mathematical models.
Okay, so it's only conceptual then. It doesn't exist in reality.
The mathematical models are proven by reality. Like we can cross-reference them with like.
No, that would be circular reasoning. That would be affirming the consequence.
Could you, for example, get enough mass of gas where the mass of the gas would stop the expansion of the gas?
There would have to be a point in the middle of the gas, like in the middle of that like cloud, that's so dense that it does pull all of it.
Yes, this is the problem, right? It's going to need, the only way that you can even talk about density is with volume, right? And to have a volume of gas, that you're going to need a density and you're going to need a container. So my question is along those lines, right? Where you need a container to stop the gas expansion, can you have, theoretically, an amount of gas which will stop entropy taking place?
What's entropy again?
Entropy, that, in simple terms, the spreading out of energy and stuff that holds energy, like gas.
Okay.
So gas always wants to expand, right? If there's an available volume for the gas to expand, it will over time expand into that. The only restriction is the space. The container. If you've got an infinite space and you've got some gas inside a container,
container to the infinite space, the gas is going to spread out. And eventually, over whatever period of time, it will spread out into all of that space, eventually. So is there an amount of gas that you could have in a space that when I open the container that's surrounding the gas will not expand into that available space because the amount of mass that's in the gas?
You couldn't just release the gas because that would be very unlikely that it just suddenly becomes so dense. Or you could place like not the gas itself, not really.
No.
That'd be extremely hard.
Yeah, because the gas has got energy, which gives the gas going. It has constant collision with other gas molecules because that's all that there are in a hypothetical environment is all large space. So because of those physical collisions, the kinetic energy is going to make a consequence the gas spread out. No amount of gas is going to stop entropy taking place. It's thermodynamic law, dude.
Yeah.
So Jupiter, an uncontained ball of gas in the vacuum. That can't be real.
Oh my god, I studied this. What's Jupiter's core?
That explanation of what Jupiter is definitely can't be real, because then Spaceballs would be real, right? Everything would have to have its own container, and every other thing would have to have a separation of containers.
Mm-hmm. To have balls of gas in the vacuum, those balls must be physical surrounding the gas. Vacuum. Without the container, the gas is going to spread out. Doesn't matter the amount of gas that you've got, that's just going to make the problem worse.
Hey, what's up, guys?
What's up?
Standards.
I would like to join the conversation if that's possible.
Yes, please.
Oh my god, your voice is deep.
Nope, that's wrong. Wrong.
What wrong?
You wouldn't have to have
That is the wrong voice coming out of the right microphone.
Sorry, what?
Sounds like a voice changer.
No, this is my
Seriously
voice.
though, you wouldn't have to have separate containers.
100. All right, cool story, Beans. I'm trying to make a point, Beans. I don't need 500 people to talk about my voice, all right?
I think they're talking about me, man.
You don't? All right, cool.
Yeah.
Anyway,
you
you don't need
probably
separate
two of us.
containers. Oh, fuck, dude. All right, Smiley. Chose poorly. All right, so you don't need separate containers.
Oh, that's S.
Period.
Okay, hold on.
You could,
Let's do this
it could be accomplished.
Go on.
All right, listen, I'm going to make my point to completion. Thank you, everyone.
I know.
All you need is something to stop the expansion of the gas. That could be a liquid. There could be a liquid between all of it, and each pocket of gas is contained within the liquid. So that wouldn't be separate containers. It would be one.
The gases would be contained within the physical liquid.
Right.
Yeah.
Now, that's not to say you couldn't use language to say, oh, that's kind of like separate containers, but, you know, there's connotations and denotations. So when people imagine separate containers, you know, when you say that just casually, they're going to think, oh, each object has to be encased with some other object, like a dome or a glass ball or whatever. But that's not true.
You bring up like a bubble, right?
Yeah.
Yeah, cool. Yeah, you're right.
A bubble is contained gas inside another medium.
Yep, 100%.
Right?
Yep.
Now, you could argue then, well, all the bubbles must be within the medium that medium itself is contained, sure, but you don't need distinct separate containers for each pocket of gas. Okay, make sense?
Yeah.
No, because I mean, it's not really. No. I mean, the way you were defining it there, AI, it would just be that each different material is a container in reference to another material that's different. So they would just that's just how you would define a container then.
Yeah. Within, I'll bring this up quickly. Within PV equals nRT, we solve for pressure, which is force over area. The area is just described as a physical boundary for gas to press against. So that just invokes some kind of physicality. That can be a steel wall, or as AI is pointing out, liquid. still physical.
Right, now that also bears on this point, which is one of the arguments that I think made a list about bad arguments, which is gas pressure requires a container, therefore the Earth can't be a globe. Now, that's not a good argument at all, because you can have globes inside containers.
Yeah. Okay, so you can't have gas pressure without a container, so therefore giant gas planets can't be spheres?
Oh yeah, you're not going to be able to get away with that. You cannot have if you can't have gas pressure without a container. Earth is flat. How's that? Gotcha.
What? How does that?
Gotcha,
how does
bitch.
That right, but I could show you an object of any permutation of shape. Well, it's easy. I could just show you a container with another object inside it, and then I could just have three different shapes: one a ball, one a cube, and one like a, let's just say, a flat cooking pan. There you go. I now have three different shapes, which the container doesn't change the shape of the object inside it.
Yeah, but then the Globers are going to have to start conceding that they've been lied to because they're not being told that they have a container around the globe, and they won't do that.
Well, wouldn't it be more pragmatic for them on their side to just say that space isn't a vacuum; it's actually just a hyperliquid? So not a superfluid like some people have postulated in the past, but they'll make it even fancier, like a hyperliquid. So the liquid is actually transdimensional and space-time conventional. And all these weird words they'll come up with, and it'll work mathematically.
Yeah, they probably will do
that.
something like that.
That was funny.
We still flat smacking bean toasted? Bean toasted is like day 3 for you or something?
4, I think.
Day 4. That's cool. Well, when someone's been here for a few days, I like to ask them to summarize some things they've learned since they've been here. Could you tell us a couple of things or a couple of points that we've made that you've learned since you've been listening?
Also, hold on before you do that. I'd like to point out that rotations have started because it's the new year. So all interns are now rotating and CDPs are rotating. So he might be on rotation. That's why he's been here 4 days. Anyway, go ahead.
I have no idea what that means.
It's okay. Coder does.
Flat earthers aren't lunatics, basically. They're not, honestly, not completely lunatics. Most people probably still think you're lunatics from back in like space disc days when everyone.
What have you learned, sir?
When everyone thought, oh yeah, my bad tangent. So you guys only observe. You guys only say what you observe, or you guys at least, not everybody. You guys only say what you observe, and if you can't have absolute proof, not just like, oh, this is probably or this is most likely at 99%. No, if you can't like see it, like physically see it with your own eyes, the level of proof, you guys don't.
Okay, so we hold to empirical evidence, you're saying?
Yeah.
And would you say that's a good standard, empirical evidence? Isn't that good?
Yeah, but I think also like if something is 99% probable certainty, and you have like good amounts of proof for something and like math that checks out, I think that also is good.
So then the Earth is flat. If you got 99.9% Earth is flat, then it's flat, isn't it?
Well, empiricism is the basis of science, and you're saying that you've learned that we go with empiricism. So yeah, we go with science.
All right.
What else have you learned?
What else have I learned? Just like random oddballs of like no, because again, you guys, let's say that.
What's like? How about like what's an argument? Like best proof of the globe or best proof of the flat Earth?
Oh, your best proof of the flat Earth is that you physically have never measured a curve.
Not
we
just
measure
us.
it flat.
Anyone.
In other words, we measure it flat, right?
Yeah, our argument isn't just that we've never measured curve; it's that no one ever has, right?
Yes.
So
remember, I said that to you the other day. Sorry.
That's
Did you?
Fine.
Sorry, go on, Jedi.
Yeah.
No, I just wanted to be clear, right? So we don't measure curvature. So if the line isn't curved, we measure it what?
Flat.
Cool, awesome. So we measure it flat. Sorry to interrupt. Carry on.
No, I was just gonna say, because the other day I made that point to you. I said, well, we're pointing out that no one's ever measured curve, and you were like, well, I'm sure someone has. Did you ever go and have a look and find someone who had?
No, I was busy playing my phone.
Okay. Well, don't waste your time. No one has.
What should I search up? No, because there's gonna be a paper where someone claims to have. I wanted to bring that.
Yeah. Oh, don't get me wrong. I mean, I'm sure a load of people claim, or people claim that other people have, but no one actually has, is the point. So yeah, people might claim it, but people can claim all kinds of shit. It's about what they've actually, what can be verified and repeated.
Oh, yeah.
All right, so we're empiricists. There's no curve. What about the globe? So since you've been here, you've heard a bunch of globe believers come in and talk to us. What's the best globe argument that you've heard since you've been here?
Actually, I can't remember any of them. I can't remember any of them to the point where I don't think a glober has come in while I am in.
Yeah, that's right, isn't it? The globers actually don't have an argument. It's even worth remembering. Crazy, huh?
I guess.
I think they'd have something. Oh, well, good for you, Beans. Sounds like you're going to figure this out. Good luck.
Or chance.
So what are you thinking now? What stage are you at? Like, what stage in your research are you at? Are you looking for curve? Are you trying to debunk flat Earth? What are you trying to do?
Oh no, I'm not researching in my spare time. I come here to listen to you guys, and that is basically it. Because lucky I have better things to do, like play games.
Really not.
Honestly, I'm on my break right now after studying for like uni in Mosque. So I'm just like kind of enjoying myself, honestly.
Yeah, that's fine. That's fine. But I mean, you're coming here because you're interested in the conversation. You obviously find discussion about the nature of reality interesting. So you must have like some idea of where you sit. I mean, are you still 100% believing you live on a globe or what?
Like 80.
80%. All right.
Like 80.
We can work with 80.
What?
We can work with 80.
Yeah, I guess you can work with 80.
Yeah, he's only 6 months away.
What piece of evidence would you say is making up the largest percentage of that 80% confidence? Is there
the massive model that explains everything?
A massive model that explains everything.
And I'm saying model as in like as in you could like build the solar system. Like I mean like that type of model.
What kind? Well, what kind? You mean a kind of model that doesn't actually exist in reality, that's not been made, or do you think it has been made?
Yeah, it has been made. Like that. Like that's what I'm saying. You could build the solar system.
Could you post the link to that model in the chat?
You want me to like buy you a
like the globe model, whichever the model is that you're saying gives you the most confidence in the globe? Could you post that in the chat?
Okay, well, there's not gonna be one that covers everything. I'd have to like post multiple, but yeah.
Oh wait, so right, so you don't have a model. You've got loads of different models. Is that what you're saying?
Oh no. Simply because no one would have made like one massive thing that I can just send you. Like
why? It should be simple.
It would have to, but you're saying, but they would have, the model would have to explain everything to be an accurate description of a model of the Earth that explains everything, right?
You could make the model, but like you could make the solar system, and then you could like make the Earth. Like you would have to use a program to do this, but like you could make.
Okay, so help me understand what it is then, because you're saying the thing that makes you most confident is a model, but now you're saying it's a whole bunch of different models. What models are you talking about?
So yeah, so you could like you could make the solar system and like describe
a solar system model. What kind of model do you mean? Like a computer one, like an image, or like a physical model, or what?
you could do the system on all three, but to make this like massive complete model that would show everything, you would need to use a program, like because no one's making this.
Okay, well, which one did you see that gave you this confidence in in the realness of it? Which one are you talking about? Or are you kind of just thinking that there is one and you've never really actually seen it?
I don't think I'm explaining myself well enough.
Okay, well, this might come as another shock to you, Bean, but this model that you think exists somewhere that is good evidence for a globe does not exist.
Hold on, let me just at least do something to illustrate what I'm saying.
Just like that curve.
What happened, Bean, is that they've told you that the Earth is a globe, and that's what reality is for so long that people start to think that things only make sense in respect to the globe. You just feel that way right now. That's not something you have proof of. It's just like a side effect. They just tell it to you for so long that everybody says no, reality only makes sense if the Earth's a globe. And then you ask them to point to reality, and they're like, well, I don't know where it is.
Look at your predicament now, right? You're 80% sure because of a model that explains. That's your predicament.
Hold on, I got the link. It's actually a game, so that works. Where the hell is the share link?
Like Universal Sandbox or something?
Precisely. Oh,
okay.
I hear you chuckling. What is it? Yeah.
So if you you sound like a smart guy. I'm not joking. Like, it sounds like you can understand that looking at Universal Sandbox wouldn't actually tell you in any way that is what reality is. Like, you could make a sandbox imagining a totally different setup, but with the same observations mathematically. You know what I mean? Like, you could have the things being larger and further away, or closer and smaller. And from your perspective, for what you're observing, it would all look the same. So
actually,
how would that representation specifically tell you that's the correct representation, just by the representation? And in that case, is it justified that would be a main convincing point for it in your overall 80%?
Yes. I want to Okay, so for me, this works because what is it? So I can make this. I can go. I'm not gonna not universe sandboxes and throwing the Earth at Mars, but just you load into universe sandbox and there's this whole system. I could look at Earth and look at the weather, and I could tell you how it works, and I could go to a star in the distance and tell you how that works, and then
but someone else could build another model that explains all this stuff, and it would have different distances and sizes, but mathematically it could all work out the same in terms of the observations of the sun, moon, and stars. So how would you know which one's real?
The ratio would be the same.
Using theories other than gravity and nuclear fusion for stars. You're saying that?
I don't know how that would tell you whether the simulation that you're looking at or the model that you're looking at is correct, because again, you would just be speculating on those mechanisms, saying, well, the reason that the sun's moving like this is because of gravity. But again, that's just an explanation you've given to it. It's not something that is really telling you the truth of it.
A Cyclone, I could provide an example. On the internet, you can Google this. People have created, out of the math, not a solar system, but a lunar-centric, call it solar system, where the moon that we observe is actually stationary. The Earth orbits it, and all the planets that you'd find in a solar system are also in orbit around it. And this would be indistinguishable from what we observe in the night sky.
Yeah, and that's a great kind of example as to what actually happened with the Copernican revolution, with the Copernican system, where he essentially took the observations that have always existed of the sun moving and said, well, what would it be mathematically if the sun wasn't moving and the Earth was the thing moving. And you can just backwards engineer that mathematics and say, well, look, the math works out, but that doesn't mean it's true. Do you understand?
Yes. Okay, this is the counter argument to my argument. Send the moon. Send the moon model. If there's a link to it.
Send in the moon model.
Yes.
Same phenomena can still take place underneath a stationary Earth, and the phenomena are just taking place in the sky. The Earth doesn't have to be in motion to observe things go by. Should really become a poet.
Yeah, and funnily enough, this is what all those big astronomers throughout history have said themselves. They've said, well, this is essentially just a philosophical position that we're the thing moving around the sun rather than the sun moving around us, because you could justify both positions with the same observation. Like, they actually say this. So just having a model that says it's one way wouldn't prove it any more than us saying, well, the Earth is flat because if you imagine the Earth's flat and the sun's moving, therefore the Earth's flat. Right? That's not proof. I mean, you could say it could work that way, but you're not actually interrogating physical reality to prove that it is the case. That's why we go after curvature and motion and all this stuff, yeah, rather than just models, which, like we've said, you could come up with a model to explain it in a million different ways, I'm sure, if you thought long enough about it.
Okay.
I think up until now, right, up until recently, we all have this, right? We only think there's one way to explain reality. The Earth being a sphere and the sun at the center, blah, blah, blah. We think this is the only option. And any other idea has been really far removed from any logical thought process that we might be able to entertain, because this is the state of affairs. So you've never been allowed to think of any alternatives, dude. Same with all of us, right? We still struggle with the same things that you're struggling with right now. Well, if the Earth isn't this, then what is it then? How do we explain these things? Primarily the things that you're trying to explain, the things in the sky. But ultimately, you're coming across the same questions that we've all got. That's why we're sitting here trying to let you know that we don't know. The best model that we've got is the Earth is flat and stationary underneath the sky. That's about it.
Yeah, that's a good point. It's like we've been intellectually boxed in when we think about the Earth and our reality by this globe story that we're given as a young person. So we find it difficult to take ourselves out of that and imagine other possibilities, even though there are countless possibilities. And it's something like that Crit says, which is through history, let's say we've went through 1,000 models and we've arrived at the globe at 1,000 and everyone's like, great, this globe model number 1,000 is the correct one. We're just saying, no, it's still not correct. We're on to like 1,001. So we're not actually that far apart. You see?
Excuse me, my dad was talking to me. I don't know if you want to repeat that.
I was just adding to Jedi's point that if you look through history, it's basically been the case that we've had like 1,000 models for what the Earth is and what the sun and moon and stars are, what reality is basically. You've landed on 1,000 like we all had. We're just now saying no, that's number 1,000 isn't correct either. It's something else. So we're not really that far away. We've just projected one more model.
Do you have like a link to that moon explanation? Because that's actually, I really want to see that.
I'm driving. I don't have a link handy, but I just Google it.
Fair enough. Lunar-centric model. That seems easy. Lunar-centric model.
And see, I think speculating on the nature of reality is a very healthy and human thing to do. And I think it's wild that people basically have to come to
a flat Earth chat to have that kind of philosophical freedom of expression. You might be the type that's done this before anyway, but I think most people haven't. It takes for them to come here to then be like, huh, what if the moon was at the center of this whole thing? You know? Because yeah, most people just take it for granted. It's a globe.
Ugh, my nose.
Well, we know it's not a globe. So you got any questions at this point, Bean? Or any other new people or globe believers in the chat who want to ask the question? Feel free.
Please tell me
Yeah,
there's
while you're
another
waiting,
globe.
while you're waiting, bro, in the heliocentric model, the sun isn't even the center of the solar system.
Excuse you?
Things
What?
things don't revolve around the sun. In fact, they revolve around this address I'm going to post. I'm going to post an address in the chat. I'm posting an address in the chat.
If you say like stupid lane or something, I'm gonna
search up that address and it'll give you the answer.
Is it the Barry Center or something?
Exactly, it's the Barry Center.
That's
what?
Yeah, you didn't know that? Now you know.
Yeah. I'm so confused.
Do you know what the Barry Center is?
No.
Okay, so it's, if I'm correct, AI, it's the sun is also moving around itself and being disturbed by other planetary activity, mainly Jupiter. It's like not completely the center of the sun. I think it's the same with the relationship between the Earth and the Moon within our idea. It's not actually the center of the mass of the sun that's the center of the universe. Oh, sorry, the center of the solar system, not universe, solar system. I think that's right, AI. Please correct me if I'm wrong.
So you're telling me the center of orbit, is that correct to say? Just so I understand. The center of orbit of the solar system is the Barry Center.
Yeah.
You're joking. No, you're joking, because then how would the planets would then rotate around Earth?
The planets rotate around Earth? What?
No. If the Barry Center was the center of orbit or mass of gravity.
Well, they say it's like you put a bowling ball on a bed sheet and you spin them all around, and they're eventually going to fall into this big well. That's kind of what they're saying, right?
Yes.
Isn't that crazy? Like, people come in here calling us crazy for pointing out that observably and everything we experience is a flat, motionless Earth. Meanwhile, they're claiming that reality is a bunch of bowling balls thrown around a bed sheet with no evidence whatsoever.
Analogously.
Yeah, with no evidence whatsoever for any of that. Never even seen it in principle occurring on a smaller scale, other than bowling sheets on a bed sheet or bowling balls on a bed sheet.
I mean,
I think that's funny.
We have observed gravitational waves.
You haven't done shit, son.
Related.
Gravitational waves.
You haven't even come close to doing shit. Besides taking a shit.
No, so we did like what was it? The detector, the thing that detected them moved like half of the width of a proton.
Yeah, the super globe Earth detector 9000. It's totally real. Trust CNN, bros.
I want to see what a proton looks like and how you measured that to get how far that moved.
I think it was 1/10,000th the width of a proton.
Good lord. Yeah.
Yeah, so it's basically made up.
Lucky I just trusted that they have like precise machine.
Gravitational waves.
Predicted
bowling balls on bed sheets. Just remind yourself, whenever they're trying to tell you anything fancy, they're basically claiming that You're on a giant bowling ball flying around a bed sheet.
Analogously, yes.
Yeah, it's ludicrous. What on earth in reality have you ever experienced that would make you think that's even a possibility?
I mean, the universe has no reason to make sense to you, so like, just because it's weird does not mean it's not real.
Well, yeah, I mean, fair enough. I mean, you could say it could be anything, but in that case, you've got billions of possibilities, and you've just landed on this totally random one with no supporting evidence. And apparently, it's anathema to society to even question it.
Oh man, you know what's funny, brother? You just said the universe is not responsible in any way, shape, or form to make sense to you. Okay, let's say that's true. Did you know that guys in the evolutionary biology, psychology, and cosmogony fields have decided that not only is the universe not responsible to make sense, but your faculties that you possess because they evolved for survivability, not truth, can't even be trusted to arbitrate truth. So even if the universe could make sense, you have no reason to trust your faculties to make sense of it. So basically, we're all just living in one big retard land. Well, that's weird. That's weird.
Yeah, it's also weird that people come in here asking for models that make sense.
Okay, that's fair enough.
Could you imagine if we were coming out saying, hey, yeah, look, it's like this bed sheet, and we're this rock on this bed sheet? They would laugh.
I mean, if you just said that, then yeah, but if you had like the supporting math that everyone else...
Yeah, we can give you the math for the rock on the bed sheet. That's easy. But so what? So then it would have credibility?
Yeah, because math is like...
See, this is the
it's math.
problem. You think
I
just
don't need
because
analogy.
someone... But math is just a language. We've got the math for how Superman flies. You don't believe Superman flies because there's math supporting it. You understand that's not real. So just because they might have math for the bowling balls flying around the bed sheet, and we could come up with some math for a piece of rock on a bed sheet, doesn't give either of them inherent credibility.
Yeah, the bed sheet actually proves Earth is flat. In case you didn't know, I'll explain.
Yeah, that's the only bit that would have credibility. At least we have a flat surface to match the bed sheet.
Well, it's more practical than that. So check us out, brother. So when they do the bed sheet that they stretch over this big tub, and then they put the ball in the center, and then they put other balls, and they go towards the bigger ball. There's one explicit reason why they go towards the bigger ball only, and that is because when they put the ball on the bed sheet, they create an inclined plane. And everybody knows that when you place a ball on an inclined plane, it rolls down the plane, down, perpendicular to horizontal, which is the orientation of the Earth. Therefore, this demonstration proves the Earth is flat.
Wait, do that again slowly.
Right? You put the ball on the bed sheet.
Yes.
It makes the bed sheet deform, and it creates a diagonal conical shape. That's called an incline.
Yeah.
Okay. When you create an incline and you put a ball on the top of the incline, it rolls down. Correct?
Okay. Yes.
Right. So what they're demonstrating, they're only demonstrating one thing in that demonstration, and that is what we all already know. Things roll downhill. No duh. That's been our experience our entire lives. When we drop something, it falls down. When we put something at the top of the hill, it rolls down. So all they're just doing is demonstrating our common experience. They haven't shown us anything new at all. They've just proven what we already all know. Things go down. And down is perpendicular to horizontal, and horizontal is the attitudinal orientation of the Earth. Therefore, the Earth is flat.
Okay, I think you are so... Like I'm saying this, it sounds kind of... I was going to say that. Like, I think you're so sold on the idea of the flat Earth that you're biasing this towards proving the flat Earth.
No, brother, pay attention. Real simple.
How does that prove the flat Earth? Yeah,
it's simple, dude.
Things roll downhill.
Things roll down. Things roll down. Down is a particular direction, perpendicular to horizontal. Okay. Horizontal is the attitudinal orientation of the surface of the Earth. At all places, all things roll down everywhere you go. All things fall down everywhere you go. There's no place on the surface of the Earth where that doesn't happen.
Oh, right.
So
okay.
if down is ubiquitous across the entire surface of the entire known territory, and it's perpendicular to horizontal,
right,
then that means the surface is horizontal across the entire known territory.
Okay, I get
Now check this out, friend.
Yes.
A glober will say, no, you don't understand. Things don't fall down. They fall in to a giant ball. Okay, now you have a claim on the table. That's not commonly experienced. I experience down and horizontal and perpendicular and just vertical everywhere I go. No one has experienced inwards and outwards to the earth. Nobody, not you, not your mother, not your great-great-grandmother, and not your kids 10 generations from now. Nobody ever has, nobody ever will.
Okay.
Yeah, so up and down is flat Earth. You saying up and down? You're talking about horizontal. That's flat. Glober should have to be saying in and out, right?
Yeah, we only say up and down because that's like the human level. If we said in and out, we'd have to like.
That's reality, because that's reality.
Oh, yeah. Hold on, real quick, Cyclone. Yeah, brother, if you say in and out, you have to prove it.
Oh no, I wasn't gonna say prove it. I was just being like.
No, you have to prove it. No, friend, you don't understand. The common experience is up and down. We all experience up and down. We all experience horizontal. We all experience that they're perpendicular to each other. Nowhere do we experience that they're radial to each other. The radialness of them, which would create ins and outs towards the center of Earth, which isn't even true either, but towards the center of Earth. No one's proven that, dude. Nobody. All they've done is they've shown us down and then told us a story about how it's in and out. That's why they don't use the terms in and out, because if they use the terms in and out all the time, people would very quickly catch on that that's not what they experience. So quit hijacking our terms and get your own terms and be honest with your fake identity of these terms, bro.
Okay.
Now, what have you learned today, Bean?
Loki, I'm gonna need to be quizzed because obviously you guys know, like, remembering facts off the top of your head is kind of difficult. Being quizzed is easy to recall.
He just told you. He just told you in order for your world view to be true, his has to be true, and you know it.
Okay.
But yours can't be true. So yours can't be true.
Say that again. I'm bad.
He just adequately explained to you in order for your worldview to be true that things fall down, then his worldview has to be true, where down is perpendicular to horizontal, which means that your worldview is not true.
I feel like that's a messed up version of circular reasoning. You assume. Like,
all right, well, let's you can come back to that. Give me a second.
Okay.
I'm gonna head off. In a minute. But just on the bed sheet ball analogy, I mean, if you're swayed by that, do you not think it's wild that that's basically what they're telling you your situation is? You're on one of these balls flying around a bed sheet. And, you know, when you see those demonstrations, what the logical conclusion to that, the physical conclusion to that whole thing is that within a few seconds, all the balls just crash into each other in the middle. So by logical extension, that's what they're telling you is your situation. You're on a bunch of balls flying towards each other down some gravity well. Right? You think that's true?
Yes, I do think that is true.
Well, do you not think it's wild that they've got you to believe that whole story? And when we ask what evidence is there for any of that, there's like nothing at all. Like models, ideas.
Oh, I had a thought, I lost it.
You know, because your experience in reality, what part of that experience tells you anything about that scenario that they're painting? Like, what physically are you observing or experiencing that would give you the faintest impression that that story is true? Like, name one thing.
I need to lock in. I keep getting distracted.
Well, if you can't name one thing, just say I can't name one thing, and that's fine.
No, I don't want to say repeat that for like the third time, but I generally just keep getting distracted.
Right. Name one experience you have in physical reality that would tell you that this analogy of you flying around a bed sheet as a bowling ball would be remotely true or give you the faintest impression of it being true.
Oh, right. Like explanations from class, from people who studied this.
No, like an experience in reality that you
Oh,
have.
experience none, because again, gravity does not like operate on a human scale. You
Right.
need a lot of
So
mass.
so none. So there's no experience in your reality
No.
that speaks to this analogy at all.
No.
Right. Well, there you go. Think about that. You should really think about that. Anyway, good chance, guys. I'm gonna dip off, but good to hear you guys. Keep it cooking.
Peace. Bye.
Yeah, and I just want to apologize to you, Bean. I should not have assigned that as your worldview. That's their worldview. You don't, as I've heard so far, don't affirm it. So
affirm what?
Yep.
You just so far you just take on reality as far as I can tell.
I'm so sorry. What? Like what don't I affirm?
You don't appear to have a bias opinion towards the globe.
I mean, gravity I do affirm.
Yeah, but you haven't really even defined it. So I mean, some people would say like gravity is things falling down. So it's like, oh, there's a flat Earth thing. The thing doesn't fall down.
Hey, what's up, guys? Can I join the conversation?
I mean, I've defined it decently.
Another voice changer. What's up with that?
Yeah, I don't know.
It's not a voice changer. I was using my voice.
I think people do that like to rage bait because like, yeah, they just do it to rage bait basically.
That's fine.
This is my voice, man. I cannot change my voice. You know that.
Please.
Or not to rage bait, just because it's funny to themselves.
Stop using it at this particular moment in time. I think just wait your turn, please, sir. Thank you. So you've got a problem with gravity?
No, I don't. I don't.
Do you think that that's good proof that the Earth is a sphere?
Yes.
Okay. Is that because it's a good explanation for why things go down?
Yes.
Okay. So the only problem that you have is because they have an explanation as to why things go down. As long as you believe that the Earth is a sphere and getting to the center of mass, that seems to you. As long as they can explain to you why things go down, then the Earth is more than likely a sphere. But within the idea of the Earth being a sphere, they've got multiple ideas why things relative to your position on the Earth appear to go down. But that's just conceptual mathematics and ideas in the framework of the possibility that the Earth's a sphere, and this is the reason why we need to make things go down, because they do, right? You drop something, it goes down.
Yes.
It's circular reasoning anyway.
Pardon me?
It's circular reasoning. Right? Things go down because things go down. Things go down because the Earth is a ball because things go down. Things go down because things go down. Things go down because the Earth is flat because things go down. It's the exact same argument. What's the difference?
I mean, whatever causes things to go down, it's not going to necessitate the Earth being a sphere underneath it, right? Just because
even his own space-time bedsheet demonstration is appealing to down because it only works when you do it on the Earth and you have an inclined plane, which is just another demonstration of down. So the only thing you can demonstrate ad infinitum is down. None of that demonstrates the shape of the Earth. It just demonstrates that things fall to the Earth, which we all already know. So it's just one big circular reasoning.
Hey, baby, I can bend space-time with my bedsheet.
So, for example, Mr. Beans, when they put the space-time bedsheet demonstration, they put the big ball in the center and they put the other little balls. Why do the balls move at all?
They have momentum, I guess. Or no, because they're joined by gravity, mostly. Yeah, like the
Okay, so notice what you said. You said that in the space-time bedsheet application, the only reason the balls move because of gravity. And the only thing you're demonstrating in that is down. So you just proved that gravity is just simply down. That's all you said. You just said gravity is down, and the example of gravity being proven is things going down. That's circular reasoning, dude.
Not really. Down is the effect of gravity. Gravity is not down.
Yeah, okay. So the effect of gravity.
Downward motion is the effect of gravity.
Yeah, again, and there's multiple reasons that cause this effect. The phenomenon is still the same. You drop something.
Okay.
It's when you start adding phenomena together that might not even like add. So things go down for you. Things in the sky go round and round. And they're not even the same phenomena, right?
They are like the. Are you talking about orbitals? Like
Yeah.
orbitals only work. Orbitals only work because of gravity.
Yeah, again, because
go
of
round and
gravity.
round.
Yeah, because of these ideas that the reason why you can drop things is the same reason why things appear to go around and around. And maybe the mechanism is different. Maybe the reason why you drop something is different and the mechanism makes us. I'm not saying that's true. I'm just saying it might be worth you thinking about. Because ultimately, if you've got a problem with, you prefer the story about gravity, but within this story there's a ball within it, then you might need to try and step out of that framework and try and think outside that box.
Let's think outside the box right now. So, for example, is according to Beans, I'm going to ask you this question. Is your idea of whatever gravity is the only thing that can make an object go around another object without physically being connected to it? Is that the only thing that can do that?
From my understanding, yes.
Well, you're wrong. You're wrong, and you know you're wrong because you've seen in your life magnets doing that.
Oh, shoot, yeah.
Yeah, so there's not a single thing that can make something go around another thing. There's actually a few things.
Okay. Okay. So you could replace gravity with magnetism.
So I just very quickly want to say, just in case I'm getting that, nobody else is, that's not to say that magnetism is the reason why things go up and down. That's only a suggestion for things. And we spoke about this earlier, and I didn't want to get confused again. But
yeah, no, you're making the point that you could replace gravity with this model and like explain it this way.
No, I'm saying you could have the same apparent phenomenon, something going around something else, and it could have more than one reason why it's doing that. And you could create a model of why it's doing that, and another person could create a model of why it's doing that, and both models explain what's going on, and neither of you have proved anything.
Yeah, that's what I meant. Yeah. Okay.
So, for example, Beans, check this out, bro. Are you aware of the difference between Newtonian versions of gravity, which, by the way, are named after him against his will, because he did not want it named after him? In fact, he wrote, "Do not name this after me, because I don't want anybody to think I'm retarded." And then they named it after him after he died, to be dicks. But then in the future, you had Einsteinian versions of gravity, which we know as the bending and warping of space-time. But do you know the fundamental difference between the two?
What?
It has to do with the space-time bed sheets, bro. So one more time, real quick. Go back to the space-time bed sheets.
Yep, back.
You said that the only reason the balls moved is because you already knew they were going to fall down the hill that was created. So down. But the space-time bendy bed sheet itself didn't actually make the balls fall down at all. That didn't do anything. That didn't do any of the work, right? Because you said it was the gravity that pulled them down. So that means that the bending and warping of the space-time doesn't do any of the work in making an object move towards another object. And that is true. There is no force in the Einsteinian model. So here's the thing, bro.
Yeah.
If you have a Newtonian version of mass attracts mass by virtue of mass alone, so for example, you put a mass in, just imagine an empty space, you put a mass in it, one mass. Now you put another mass in it, and then you press play. The two masses will move towards each other if mass attracts mass by virtue of mass. Now take that, put it on the left side. Now make a new empty space. Put Einsteinian gravity only. Put your mass in the center. Now put another mass over to the right and press play. They won't move. They won't go towards each other. And the reason is because the bending warping of space-time only changes the direction of motion of something that's already in motion. So it has no cause of first motion.
Say that again.
What I'm saying is that the Einsteinian version has no cause of first motion. If you put two masses next to each other, they won't move. They have to be in motion, passing through a warped space-time, much like a train on a track. If the train isn't traveling down the track, it's not relocated.
Right. Okay.
Right. So this is why they have to trick people with the stupid space-time bedsheet demonstration, because they can only appeal to down, because down is the only thing that has first causal motion that you can experience in any way, shape, or form. And then they try to tell you that the space-time bedsheet idea is the truth, but they're just doing a bait and switch magic trick on you, bro.
What are you at, like 75? You're at 75% right now?
Still 80 actually.
It's got to be at least 79. After he hit you with the inclined plane, the necessary perpendicular relationship between horizontal and vertical, and the magic of bedtime sheets. You're telling me that didn't lower a single point?
Oh no, because I don't understand those arguments yet.
All right, so what's your last hang up then? Like, what is the one thing? There's got to be one thing you're thinking about right now.
No, again,
come on, you want to say like NASA and satellites and stuff, like, right? Like Earth from space.
Sorry, what?
It's got to be something like NASA, satellites, Earth from space.
No, it's the whole like conclusive model of like the solar system orbits, and like I can go away to a star and explain why that. But then you said I can make a multiple model, and the lunar model exists, and that. Okay.
So one of the things we actually specialize in is we find problems with these prevailing models, these descriptions. So it's almost like how people are paid to find bugs in software and then report them to the software developer. We're not paid for this, but we find bugs with the Globe software and we report it to the world. We've got hundreds of examples of issues. We haven't even talked about a single one yet with you, but.
Yes.
Yeah, like the fact that you can't predict eclipses with the globe in a heliocentric model.
You can't predict eclipses?
No. There are at least two kinds of eclipses that fail the geometry of the heliocentric model. One of them is the Selenelian lunar eclipse, and the other one includes sunrise and sunset solar eclipses. And this is just the tip of the iceberg, my friend.
I swear I can search up lunar eclipse times right now.
Okay.
Did you know that there's an actual extra day every 4 years and it's not due to a leap year?
Okay, why?
Why? I don't know, but if you were to pick any meteorological station that keeps track of the sunrises and sunsets throughout the year, any single one will do. And pick any single day. I would choose maybe an equinox or a solstice day. Now, what you do is you count the number of times the sun rises and the sun sets from that particular point. So you could even do this with a stick in the ground. You put a stick in the ground, you measure the shadow length and position, and then you count the number of sunrises and sunsets it takes for that shadow to return to that particular spot on the ground.
Yes.
Every 3 years, you'll have 365 sunrises and sunsets. And on the 4th year, you'll have 366.
Yeah, that's because the.
Okay.
That's because.
No, we are taught that there are 365.24 days every year.
25.
24 in a trailing decimal. And it's because of the difference between the sidereal year and the solar year.
Yes.
And this is explained with orbits. However, what you actually observe is not that at all. What you observe are sunrises and sunsets. And you can count them, and you can go through the spreadsheets of any data that you have from any city, any town that keeps track of the meteorological data, and you can count these yourself. And it's a cycle that repeats every 4 years.
actually have one extra day every 3 years, right? For every
Yeah,
3 nights.
the 4th. And what's even funnier is that year doesn't line up with the leap year on our calendar. It's off by 2 years.
Oh. Yeah, particular.
Yeah.
So what, they just
Yeah.
Sorry, so in the helios, if I'm getting this right, I hope I am. In the heliocentric model, right, they say that it takes an extra little bit of time every year, but actually what's happening is really within that model, the Earth is taking an extra day and rotation every year to complete a cycle.
Yeah. Yeah. So if you go 1 year and you count 365 days, the shadow that was marked by the stick before returns to its same spot. And then on the 4th year, at 365 days, the shadow's not quite where it returns to at that particular point. You have to wait an extra day, and then the shadow returns to that particular point in the ground. And this was actually noticed by the ancients. This is called the tropical year. This is what produces an analemma.
Hold on. This is what produces an. What do you mean by?
Well, the tropical year, the analemma shows you the furthest extent north and south that the sun wanders in the sky. And you take a picture of it every day and it pops up. But the funny thing is, if you do an analemma, but you do it if you do it for 3 years, and then you do it the 4th year, you need an extra sun in there. Like,
oh, yeah. Okay.
Yeah.
Yeah, you need an extra sun. That makes sense. Okay, but that's still, I don't know, maybe I've walked past this many times, just haven't noticed how interesting it is, but that is really, really interesting.
It's freaking weird. I went through the data myself. I did this once. I heard Antonio Subirats bring this up. He brought it up in one of his long form discussions, and then he brought in a guy from Russia who talked about it. This is like 7 years ago. And then I'm like, no, that's BS. You got to be kidding me. And the Russian guy was describing the data he was going through just like I described to you. And I'm like, no. So I did the same thing. I went through and I counted. I downloaded the sheets. I exported to a CSV and I started counting in Excel. And sure as shit, like, that's exactly what happens.
Yeah, explain that, Ben.
Yeah. No, but it's kind of in the way that it's described, right? Like, if you were to go into any AI and describe it the same way that I described it to you, the AI would be like, it's okay, but really what happens is you got extra, 0.245 days yeah, I'm not joking. And this is due to the sidereal time being different from the solar time. So I don't know. I mean, maybe there's a way to connect it to atomic clocks and precise timekeeping, but even then, like, there's a difference between UTC and UT1, which is this is where you get into the equation of time with the sun, accounted for with atomic clocks, that every year or even continuously now, atomic clocks are actually updated according to the sun's position, not the other way around. Did you know that?
Oh, wow, no. Okay.
Yeah, so they calibrate atomic clocks based off of the sun. Nature is always the true reference, guys, for time and for Earth, because water provides that nice horizontal level.
It's interesting, being right. Again, as we're speaking, the globe Earth doesn't make these predictions. Even like when the sun's can come up, that gets dealt with, like Yoga just said, the equation of time. That doesn't involve any geometry of a sphere. No sphere here. No prediction made by a ball in space for that one. So you understand that we've been post-dicting eclipses for thousands of years. I say post-dicting, right, because it always does the same thing, right? Over certain periods, the patterns that it produces repeat. So based on what it does before, we can say with a surety what it's going to do again in the future. We've done that for thousands of years. It's called the Saros cycle. NASA used that Saros cycle today. No globe Earth geometry involved there either. So the globe Earth geometry doesn't predict lunar eclipses, solar eclipses, doesn't predict when the sun's going to come up and when it's going to set. So what predictions about the night sky does it make?
Yeah, the beauty of the Saros-cycle is the Saros-cycle being developed by the Chaldeans from 3,000 plus years ago. They were flat earthers and they produced a table of timing and geometry that is so precise that NASA uses it today for their eclipse predictions.
Impressive.
There's a man named Dr. Fred Espanak, Espanak. He wrote a book called, the freaking cycle of eclipses or something, the multi-millennium cycle of eclipses based on the Saros cycle. It's like some title like that. You can find his book, but he describes his entire process of going through the research from the ancient Chaldeans and incorporating their data into NASA's space models. Isn't that interesting?
Very.
So again, if it's models that make predictions and the thing that's keeping you on the sphere is you think the geometry of the sphere is making those predictions, it isn't. So that can't be something that's keeping you on a sphere because it's irrelevant to the predictions being made. I get where you're coming from though, right? Because you can see in books, online and on the internet, where you've got a nice pretty picture of the sun, darkness, and there's Mercury that looks really, there's Venus, and there's the Earth with the moon around it, and you know, that looks relative, and that one over there, the red looking thing, that's Mars, and so on. Because this is the portrayal of this heliocentric way of explaining the night sky and why we observe the phenomena that we do from the Earth. Can be very easily mapped and explained geometries, like we pointed out with the moon. But there's no need for it to make any predictions. The predictions aren't made with that geometry involved. They're made on what they've already seen before happen in the night sky all the time. They're all postdictions. So, can't be that then.
Interesting history, though. The reason why it's called the Saros cycle, Sar, S-A-R, in Saros is a root word, and it means lord or king in ancient Babylonian. This word Tsar is where we get Caesar from, and like with the Russians, the Tsar of Russia. It's also a cognate of the word star, stars in the sky, stars and stars and Tsars and Caesars. It all comes from the same root. So the ancient Babylonian mystics used to say that every time there is an eclipse, a new king is born. It's the cycle of the kings.
Isn't President Trump born on an eclipse or something?
Yeah, and Christ was crucified during an eclipse.
Yeah. I've heard about some astronomical events that happen in the sky. It's a really interesting subject to me. They've lied about the sky because of what it really means. I don't want to get lost with beans.
Yeah.
It's just this idea of models, beans, right? Again, we all have, right, had this idea, the image of the Earth in orbit around the sun on TV, on the internet, books and subculture since you were born, since I've got here, and I'm 50 years old. I don't expect many people around to be that much older than me. So everyone's going to be younger and you've experienced the same thing. Right? It's the only thing that we got really given. It's hard to think outside that box. But really, if it's models and so on, because we have that image in our head and we think that that image that we get from textbooks is really what's predicting everything that's going on when it isn't. So if that's the thing that's keeping you on the sphere, dude, really that's a weak foundation. That's not a personal thing. I'm just saying that argumentation it hasn't got any grounds. It can't be that because it's not doing the predictions.
Whoever made the textbooks, are they dumb or are they lying on purpose?
No.
Like, do you think?
No, intelligent people write fanciful stuff all the time. That's stupid.
People really believe this shit, dude.
You're missing the whole point of the conversation, and I appreciate it. But we're talking about the Earth being a globe and it making predictions because of the model that is based about going about the sun and so on, about why we observe things in the sky, like sunrise and sunset, and why there's eclipses, both lunar and solar. The point of the conversation is the geometry of the sphere isn't even involved when making predictions because they're not even predictions. They're postdictions based upon what we've always seen happen before while standing on the Earth that's flat and stationary.
Who said Google
But can you
Earth?
please see that it's not
Who said Google Earth?
disproving the shape of the Earth?
Genshi's invoking Google
We have
Earth,
the Google
and
Earth,
You know,
and we're saying
Gen-
there's something missing here, like
Genshin,
a house or an
bro,
island. I'm talking
bro.
about the entire shape. Somewhere, the entire shape of
The
Google
Earth doesn't
would be
necessarily
fucked
have
up.
a form,
Not
dude.
like, oh, there's an island missing. No. The entire shape of it all would be fucked up. Where is that? Not an island. The entire shape of it.
Are you done talking, dude? We
Literally.
heard you. Let's stop his time, dude. Listen, Google Earth is a cylinder. Did you know that?
It's not a
Google
cylinder.
Earth uses something called the WebGL Mercator, which is a cylinder. That's its coordinate system. Just shut up.
Earth is a
Just
cylinder,
shut up,
according
dude.
to-
Let me finish my sentence. So just because they wrap it around the sphere and show you a graphic doesn't make it a sphere. They're just portraying it that way. If you played video games, you should know that you can map any texture to any 3D model, no matter what its shape.
I completely agree.
I work 3D, and no, you're wrong.
Oh, so I can't?
No,
you work
because
3D.
the sphere,
You know I'm wrong.
excuse me,
You want to
no,
bet
no,
like
you
1,000
asked me,
Bitcoin.
let me answer.
Now, so I'll bet you 1,000 Bitcoins that you can wrap any texture to any triangle-based 3D model.
You can wrap a texture, let's say a square texture, you can wrap it on a sphere, but you're going to have one problem.
What's
The
that?
points, the edge that connects, the two edges that connect on the side, you can wrap
It
around
won't be
easily.
continuous.
But the tip part, the top north and south, whatever of the sphere, right? You're gonna have a hard time wrapping it properly, so you have to wrap it in a certain way so that the texture doesn't, you need to squeeze it in a certain way so that the texture looks right.
KGB,
But you could do it, right?
unfortunately.
What do you mean looks
yeah.
right? What does that mean? Looks right. What is that? How do you know what it
That
looks
means
like?
it's not. That means it's almost near impossible to get a proper, good unwrap of a square.
What do
on
you
a
mean by
cylinder.
looks right? Compared to what?
Yeah, you have to squeeze the top and you have to fix it so it fits.
I think the word you're looking for is
Fix it to,
continuous.
what is your? Hold on, dude. What's your referent to fix it to?
My referent?
Yeah,
I don't need no
how do you know
referent.
it's wrong when you wrap it right?
The square.
When you wrap
I
this,
just
when you
wrap.
wrap.
Do you want
You
me
know
to do you want me to stream it in live
Okay.
in front of you
Yeah,
right
check
now?
it out. So, are you aware?
Do you want me
of
to stream it? I can
Archimedes?
prove what I'm saying. You're just fucking yapping at this point.
Yeah.
And by the way,
KGB,
you
that's
guys are
not how
muting me
Google
earlier.
Earth
That's
works,
clownish.
You guys and you this and you that. No one cares about what you think
I
about
can
it.
live. I can open live stream right now and do it in front of you.
Okay.
You were posting objectively CGI images of a
Jesus
globe.
fucking.
Sorry.
I'm gonna start muting people. Okay.
Well, do you have actual images of a flat Earth? I'd like to see, please.
From where?
Provide it. Do you
Taken
have
from
it?
where? Taken from where?
Okay, here's my position. All right, with respect to you guys.
You're going on mute, dude, because you're not answering questions. So you have a choice. Taken from where? You ask for something. You have to take a photograph from a place. Okay?
In order to
where?
take a photo. Yeah.
Taken from where?
Wherever you want. Just provide a photo
Okay,
for
I
flat
took it
Earth,
at the beach. I'll post the one I took at the beach. I took a photo of a flat Earth at the beach.
Okay, do you have a photo of a flat Earth from, I don't know, from really high up in the air so I can see the entire flat Earth?
Well, no,
As
you
high
couldn't
as
capture it.
possible.
You couldn't capture the
As high
entire
possible.
flat Earth in an image.
Why not? Why not?
Because you can't go far enough away from the Earth to take that image.
Why not?
Because rockets don't push off air. Rockets push off air. They don't push off vacuum.
What?
Rockets
do
don't
not push
cross
off of
in
vacuums.
vacuum.
You require air.
Did you do it? Did you build a
to work.
rocket yourself, and did you do it yourself? Do you
What
have
does that
a
mean?
source for that?
You're deflecting, dude.
Yeah.
No.
Do
This
you
is
know
a
how
legit question.
thermodynamics works,
Did
KGB?
you do this yourself
Triangle,
to come to
dude.
that conclusion?
Did he do this himself? What kind of fucking answer is that?
Yeah, where are you getting this from? This claim from? Where are you getting this claim from?
Because look, people have all these rockets. There's YouTube videos, right, of people putting a rocket in a pressurized vacuum.
Which people?
Shut up, dude. In an evacuated vacuum chamber where they ignite the rocket and the rocket doesn't move until the container pressurizes due to the exhaust of the rocket. That's where I'm getting it from. Experiments.
What does it have to do with the request?
Where did you get your information
I
from?
posted it for you. I posted it for you. You can see it goes all the way to the back of the wall and actually comes back, and it's actually pushing off the pressure wave that's reflecting off the wall.
What does this have to do with my request for a picture of your flat Earth
Because you can't
from the highest possible point?
Because there's no outer space. Because you want a picture from space, but you won't say it because you're a pussy. So you want a picture from space, and you can't take a picture from there because outer space vacuum doesn't exist.
Did you build a rocket yourself and do that experiment?
Yeah. Yeah, he just showed it.
Can you please show me a video of it so I can see it myself?
It's in the side chat. See, you're not listening, dude. So when you decide to listen, you can come off mute. So let's get back to the actual person that thinks Google Earth is a something.
Gench 29.
Yeah, dude. So why are you referring to Google Earth? Like, how would you even know if that's what the Earth actually is or looks like or anything like that? What are you comparing it to?
I'm not sure I want to debate with you. I would love to debate.
We're not. This isn't a debate, dude. You guys don't have any evidence. This isn't a debate. This hasn't been a debate in 5 years.
Kind of hostile, honestly.
Well, this hasn't been a debate because you guys, hold on. Okay, I'll stop being agitated. Dude was being a douchebag, so I'll stop being agitated. But you guys say stuff which is objectively untrue because you're ignorant of something. Okay. Google Maps is not Google Earth is not a sphere. It displays it as one, just like Grand Theft Auto displays hookers. Those aren't actually hookers. Okay.
Great game.
They look like hookers. They say, "Hey, big boy, you want a good time?" They act like hookers, but they're not hookers. Okay. So Google Earth shows you a ball, but
you have a lot of experience with that.
Programmatically, programmatically inside how it's not a ball. Is what I'm trying to tell you. So here's something you can do, right? Go on Google Earth, North Pole or South Pole, use the line tool and try to use the line tool to make a circle around the North Pole or South Pole. And what you'll end up seeing is it'll end up snapping back and giving you a half moon shape. Because it's a cylinder. Now, did you know any of this? Of course not. So I'm irritated because you guys say things out of ignorance and then try to tell us what's what. We've been looking into this for nearly a decade. You just got here. So the fact remains is you really don't know what you're talking about. And neither does the other guy.
I feel like you're kind of repeating yourself.
I don't care how you feel. It
I would love to talk with.
Why don't you actually address what I said of substance?
I would love to talk with Sny.
No, tell me.
It doesn't matter who you talk to, Gench, right? You can answer Indio's questions the same as mine, right?
What do you have to say about?
You just need to answer genuinely.
What do you have to say about your idea that Google Earth demonstrated somehow that the Earth is a globe, but now you've been shown, and you can just Google this, what projection does Google Earth use? And that map is a cylinder. Why did you think that it supported the globe? Why did you think that? Did somebody tell you that? Or did you just make it up in your mind?
Sly, do you have anything to add?
Yeah, that's right. You made it up in your mind. Nobody said
I believe Indio asked you a question.
What?
I said I believe Indio asked you
he
a
muted
question.
me. He's getting banned. So
No,
You
I
mute me,
haven't
Bill?
muted it.
Okay, dude.
I haven't muted anyone.
Okay.
I just don't. I feel like you're a bit hostile, actually.
I don't care how you feel.
That's true just because of your ignorance. Now, I'm just going to post Makeda projection as a cylinder in the side chat. You need to learn. You're in Earth School right now. Like I told you earlier, you were lucky to be having a conversation with me earlier. Now the big dogs are in here. You need to listen to Indio and what he has to say. He's been researching this for a long ass time, right?
Dude, literally, there's people in this topic who know more people than surveyors, right? Professional surveyors. I asked them questions about geodetic surveying. They don't even know. They don't know how any of this stuff was created, where it comes from, what coordinate systems are, how these maps are made. Did you know that there's 3 different sets of cardinal directions, for instance? You know, north, south, east, west. Did you know that there's 3 different sets of that? John, Jench, whatever your name is.
3 sets of
coordinates.
No,
cardinal directions.
I mean, in math, we usually have r, theta, and phi, if that's what you're referring to.
No, I'm talking about north, south, east, and west. There's 3 sets of north, south, east, and west. There's north, south, east, and west of the compass. And then there's north, south, east, and west as defined by where the sun rises on the equinox. And then there's north, south, east, and west in the latitude, longitude coordinate system. Okay, those are actually 3 different directions, and they only correspond to each other in certain places. Typically, people think that the compass points north and south at the poles. They don't. They actually just align to the magnetic field local to wherever you are. That could be 90 degrees from north that the compass will point. A lot of people don't know this. It's called magnetic declination. And then there's east is defined as which direction the sun rises on the equinox. So if you go on Google Earth and try to, you can take the compass tool and try to go 90 degrees from the north, and you'll see that it intersects at the equator every time you do it. It just goes toward the equator. It doesn't follow the latitude line, which it should, because the latitude line and the latitude longitude coordinate system is actually a circle. It's not a line. So these are just like little things that when people appeal to maps or they appeal to Google Earth or any one of these things are abstractions. They only represent the Earth for one particular purpose.
They are, sure, they're some kind of abstraction, but they have to be wrong at some point.
They are wrong. And are right.
Wait, what? They're wrong and right?
Yeah,
right,
that's
so
right.
They're right in a small region, right? Is that what you're saying?
No. It depends on the purpose you're using it for.
Yeah, so if I'm gonna find the closest store, then I would be able to use Google Earth.
Well, I mean, you wouldn't even need Google Earth. They freaking track your phones everywhere they go.
Okay.
So they could literally delete the map underneath your little GPS thing, and they would know based upon what all the other Android phones where they went.
Yes. But like, if I want to find a store and I don't know where the store is, I would be able to use Google Earth. And I think we both agree on that.
Yeah, because the car drove on the street, dude. The car drove around.
Yeah, but Google Earth has to be flawed somewhere.
It is flawed. I just told you how it's flawed. Try to draw a circle around Antarctica. They're the North Pole or the South Pole.
Yeah, I also think we're getting definitions confused as well. Google Earth and Google Maps aren't the same thing, and they don't work the same way.
They didn't see. Explain why they didn't see 7,000 islands.
I'm talking about the fundamental.
So, Jen, if Google Earth is so good, do you think that you could black out your windows, right, and drive just using your GPS and Google Earth, right? Take all the turns, negotiate the curves just by looking at the graphic instead of out your window?
I mean, there's some kind of delay.
Of course. Okay, no delay. We have zero latency.
Zero latency? Yeah. I mean,
why do you think that? Let me ask you why you think that. Can I ask you why you think that?
Yeah, absolutely. Because if you go onto, well, I sometimes use Google Maps when I need to navigate and I'm driving, and it seems to work fine. But
landmarks is different than a representation of the Earth that is accurate enough to drive on, right?
What could you say that again?
Just landmarks. You're just noting landmarks. It tells you like, hey, there's going to be a gas station up here. That's a landmark.
No, it actually tells you, like, it draws out the exact route.
Exactly.
Yeah.
I'm talking about, dude, you're conflating two different ideas, okay? The idea that, hey, this road is after that road if you're going in this direction on that road, this road. You know, we had, like, paper maps, and you could do that with a paper map. Nobody would say the paper map is the territory. So what I'm asking you is why you think that you could drive just looking at, if you had zero latency GPS, just in no traffic, looking at the screen, and that Google Maps is accurate enough to actually drive the road.
I believe I answered that question.
I asked you why, and you just said, hey, because there's landmarks, or whatever you said. But you know what? This has actually been, I'm just beating around the bush because this has actually been tested. Yeah, flat earthers have actually tested this by putting a camera on the freaking dashboard, showing Google Maps, and then driving and see if the road matches the map. And they don't match.
Okay, they don't match.
They do not match, as in the road, as in like the turns, and like, say I'm on a road and it turns, I'm on a slow curb and eventually it does like a 30-degree turn.
Yeah,
on Google Maps, it won't show anything. It'll show like a straightaway.
Okay, this is kind of what I have been fishing for the entire time. An example of where Google Earth does not match reality.
Okay, hold on.
Would you be able to send me like
I got you.
or something? Yeah,
I
thank
got
you,
bro. And I gave you an example already. The drawing a circle around the poles. Did you not hear that part?
Yeah, but that's kind of not what I'm getting at, because that's like a programming feature that they have. Sure, that could be fucked up.
But it's an inaccuracy. Jench, what you're failing to grasp here is this is how your application... Jench, let me finish. Come on, let's be nice.
I'm not really bothered by their...
Jench, this is how your application
features of
fails.
drawing lines.
You're not bothered by the features of the application that you're using in this, like, conversation? Why are you bringing it up then? Why are we on this topic? Right? We know it's inaccurate. Google Earth and Google Maps aren't the same thing. They work differently. Right? Do you know how Google Earth works?
No, I don't know the entire code base. No.
No, okay, so it takes a bunch of photos, right, of something, right, and then it adds them together, right, in their own way until they think it looks right, and then they upload it, right? That's sort of how it works in very simple terms, right? This starts it's called LOD rendering, right? Level of detail rendering, and this starts when you're zooming out. The terrain becomes progressively smoother, buildings become simplified and they disappear, and coastlines become less precise, right? So if you were to zoom out, you would have a hard time driving around, let's say, a coastal area, or driving around relying solely on your Google Earth, right? At 0 to 2 kilometers, you'll see 50 centimeters to 2 meters, right? And at 2 to 20 kilometers, you'll see 50 centimeters to every 2 meters per pixel, right? This means it's like throwing a bunch of pictures together, right? And then arranging them until it looks right, and then uploading it. Okay? So if you're curious on how they managed to get that curve, right, for the sphere, it's just them throwing things together, just like KGB was, just like the conversation that we had earlier on with KGB, talking about 3D wrapping layers around shapes, right, in video game design, right? It works exactly the same. You can design something and then upload it. It doesn't have to be true. It doesn't have to be accurate. Why are we talking about this? We should be talking about something that we can physically test, rather than a faulty piece of software, evidently, right? It's an inaccurate piece of software.
The fault in the software can be tested.
It's not a fault. They designed it that way. It's not a fault. Stop characterizing it as a fault. It's because they
fault,
used the cylindrical
whatever you wanna call
coordinate
it.
system and wrapped it on a sphere. It's not a fault. You want to see a ball, and they made the cylinder look like a ball.
No, but like you said,
Yeah, I know it's hard to comprehend.
Would you like
right?
to talk about something that you can test, Jench? Would you like to talk about
yeah, we are
something
talking
to do
about
with
that,
the physicality?
which is Google Earth.
You can't use an application to test reality.
You're reifying a piece
No,
of
I'm not
software as
using
if
the
the software is
I'm
real, bro.
using reality. I'm looking at the software saying, can this be real?
Okay, so I just
But the
posted
software
in the
isn't
chat.
real, so
Hold on, dude. He asked for something. It's in the chat. It's a 1-hour video of him testing the accuracy of Google Maps while driving. He drives 100 kilometers.
Yeah, I'm gonna look at this.
Okay, so until then, shelve it, dude, because you don't know what you're talking about. You're completely in conjecture land. You're just you're telling us what you believe to be true. You don't have any evidence it's actually true.
Okay, yeah, so this looks like, I haven't obviously watched the entire video, but it looks like he's basically driving, as you said, and then he says, oh shit, there's a deviation between Google Maps or Google Earth, whatever he uses, and reality.
Yeah.
And what I'm saying is that there will be a problem, but not like, oh, it deviates some couple of degrees. No. There will be like a massive fucking problem. Like,
what are you basing that on?
Exactly what we established
What are you basing
earlier.
that there will be a massive problem on? That is a prediction.
Exactly what we.
Okay. You're just saying stuff. When you say there would be a massive problem, stop interrupting me. I'm trying to clarify what you're saying, dude. No,
Dude,
you didn't let me finish the first time. Listen, when you're saying there would be a big fucking problem, what is the basis of that prediction?
Can I answer?
Yes.
Exactly what we established earlier. You cannot have a continuous mapping from something that's flat to something that's spheric. I'm feeling like I'm repeating myself. We established this earlier and we both agreed upon it.
Okay.
Jench,
yes,
you're
you
not
can.
listening to what I'm saying.
Yes,
bro.
you can. Yes, you can. Want to bet on it? See, you're confusing a projection with a. Hold on. You're confusing a projection of straight rays with a mapping. So, for instance, I want me to tell you how it's done. So they have something called the geoid, and what they do is they actually curve the verticals. So the verticals, like from the center of the Earth, right? So you have the surface of the Earth, right? And if you have a line, right, on a sphere, you're assuming that, hey, they're drawing straight lines through the sphere, and they're projecting those lines onto some flat surface. Yes, there will be a distortion if that's the case, okay? But that's not what they're doing. They're curving the lines. So they're doing a mapping function and not a projection. It's called a projection, but it's a second order projection, meaning you have the celestial sphere, which is the latitude, longitude coordinate system, right? That's what the actual coordinate system is, because you can't find them without the stars. You have no coordinate system. So that coordinate system is what the oblate spheroid is referencing, okay? So they make measurements on the surface of the Earth. But those measurements don't match the celestial sphere. So what they do is they say, hey, we have lumpy gravity, we have deflection of the vertical, and when I hang a plumb line, it's actually not pointing down, it's actually a curve. That's right. They say that a plumb line, meaning if you take a weight on a string and hang it, that line is actually curved and not straight, which is retarded, okay? Okay, but that's what they say when they map actual measurements of the surface of the Earth to what's called a reference ellipsoid, okay? But that reference ellipsoid is distorted by something called a geoid, which is the amount of deflection of the celestial sphere versus their reference ellipsoid, as in the actual measurements versus their idealized what they think is going on. And what they do is because you could possibly have distance errors, but because you have topology, you can interpolate the errors between the measurement locations, and you smooth out the error across the whole surface of the Earth. This is how it's done. Okay, how you think it's done isn't how it's actually done, and there are errors. Lots of errors all over the place. In fact, they use over 100 datums, right? So, for instance, Australia has their own datum. If you use the WGS84 reference ellipsoid datum, if you took Google Earth and went to fucking Australia, it would be way the fuck off because they're on their completely own datum that has nothing to do with the WGS84.
I'm gonna go
You're in what's called a
soon.
reification fallacy. You think the map is the territory. You're in a reification fallacy. You think the map is the territory.
Would you like to just? I understand you have your strong beliefs. Really,
this is your beliefs, dumb fuck.
Okay, please.
This is your beliefs. This is all mainstream geodetic surveying, mapping, cartography.
Bro,
this is your beliefs.
What are you on about? Why are you so
Exactly. You
angry?
don't even know your own beliefs. How Google Earth was constructed is I'm telling you how it was done.
Bro, I'm trying to give you a compliment and you're just going bananas.
Because
I respect that you
I don't need a compliment.
Your beliefs
it isn't my idea
and
here.
Done, okay, dude, I don't understand how anyone can talk to you. Like, I don't. How do you manage to find people to talk with?
Yeah, that's what happened in the last 5 years. Like 5 years ago, they made everybody super timid, and now they're afraid of everything and sensitive. And if you raise your voice to them,
really not trying to be
feel if you raise your voice to them, they think you're yelling at them.
Yeah,
it's
look,
really
bro,
it's really weird.
Weird, dude.
No, it's not. Just you're interrupting me. That's.
Because look, listen. If you start a sentence with a false premise, why should I let you continue? Why would we keep going? And we let you talk for 30 seconds so I can go back.
You wouldn't be able to say a word without me interrupting you. That wouldn't be nice for you either.
Did you listen to me? If you start your conversation with a false premise, right? You answer me, and then you start with this false premise or a straw man. Why would I let you continue and listen to you talk for a minute and a half just to go back to the very first sentence and go, well, this thing was a false premise, or it's a straw man, it's not what I actually said? Why waste time? Why just you just want to talk? Or do you want to get to the bottom of this?
If I apply that logic, I would be talking continuously while you are talking.
Name one false premise that I made. Or straw man. Go for it.
Oh, looks like this conversation's over. So, Jench, just to go over Theorema Egregium.
Yes. Yeah. Yes.
Right, that you posted in the side chat.
Yes.
First and foremost, do you know what one of the primary assumptions are for this? I mean, in this sort of a link that you're posting, do you know what one of the assumptions are?
I don't know what assumption you're talking about specifically.
Okay, one of the assumptions that were made when this was composed was that we are on a perfectly spherical surface. Okay?
Yes.
So we are not on a perfectly spherical surface. Your globe Earth model does not claim a perfectly spherical surface. Why are we discussing this?
Okay, first of all, I want to say thank you for actually reading some of the stuff I've sent. Second of all,
you're welcome.
This is not. I'm not saying that the Earth is perfectly shaped like a sphere. The only thing I am trying to demonstrate with this theorem is that it is impossible to create an isomorphism from a plane to a sphere without having a point or several points that is not continuous. I have also sent the definition of a continuous mapping, and what this implies in reality, or like the physical interpretation, would be that okay, I'm walking and oh shit, now I take one step and I'm on the other side of the Earth, or whatever shape you want to assume. That is the implication of not having something that is continuous.
Okay, and this is the problem of reification because you don't have a continuous surface. You have a bunch of discrete points. separated by some distance.
Right. That is actually. Have you taken quantum mechanics? Because it sounds almost like it.
Yeah, years ago.
Okay, yeah. So we do actually have.
That has nothing to do with quantum mechanics. What I'm saying is you have data
It
points.
Absolutely
right?
does. It absolutely does.
I'm not
You
talking
had
about
it right the first time. In space we have Planck lengths they are like super tiny, but we have them.
That's not what we're talking about. We're talking about in real life we've measured points. In the United States we call them geodetic control points, and we stamp a coordinate on those geodetic coordinates and control points. And all that means
I can barely hear you.
When I look at the select, look, we stamp a coordinate on we have geodetic control points in the United States. So we have points that are measured, but we don't have a continuous point. And we imagine what's in between those points. Right? And we can't use the theorem of Greggian for this purpose. Right? As far as a perfect sphere. And all Gauss was really trying to show
it's not a perfect sphere. I'm really just trying to communicate the idea that
so when it comes to communicating an idea like that
in Google Earth.
Okay, when it comes to communicating
like 5
like
fucking
that,
times, dude. Ask, repeat, ignore. Is that what you're on? Ask, repeat, ignore.
Gent, you can't use a perfectly spherical concept to determine anything on something that's not perfectly spherical, right? If the claim is that it's perfectly spherical and the the story is that it's an oblate spheroid, but our natural observation is stationary and flat, like what is what is, right? We need to figure out what we're actually on, Jench.
That's a good point. This theorem, you can extend this to any topological shape of a sphere. So do you know the common joke that a topologist, he wakes up and he has 2 cups of coffee for breakfast? The joke being that one is donut and another is cup of coffee, because you can you can morph them into each other. Now you can extend that theorem to be any 3D object.
None of that matters in the natural world, dude. None of it.
What does matter is that Donald Trump is a gay rapist pedophile.
Yeah, well, he's your boyfriend.
I don't know about all that.
You're the one that's fucking him. Like, how are you gonna call a guy out for being gay and then you're the one that's taking?
Anyway, moving on. None of that matters because in the real world we have to take measurements of actual. So where are you getting the variables for quantities that you're inserting into your abstract mathematical models? See, that's the point. You can have some theory or hypothesis, right? Some mathematical construct. But eventually, if you're going to apply it to the real world, you need real world data to insert into the variables, correct?
No.
It seems like you're lost in abstraction.
No, we don't. I'm simply trying to figure out, is a model reasonable or not? Right?
Depends on what you're trying to do with it.
What?
Depends on what you're trying to do.
Yeah, sure.
If you're trying to make yourself feel better, I guess you can just be a globe earther, make yourself feel better. Sleep better at night. Thinking you're just whizzing through the vacuum of space.
Yeah, so
nothing. Yeah, it makes me feel better. Being sarcastic, by the way.
If we look at, I mean, I think most of us use Google Earth, and it has to be flawed somewhere. Somewhere there has to be something.
Dude, ask,
massive.
Ignore, repeat. Why are you doing this?
Because I feel like you're not attacking my point.
I did. I gave you an example. It has to be flawed somewhere. I gave you an example. If you take Google Earth and you try to draw a line around the poles,
yeah,
it makes a moon shape because it's actually a cylinder and it's only being displayed as a sphere for entertainment purposes. Now, as far as driving, we know the relative locations. Google has been collecting data from its Android platform for, 2 decades now, where they track the positions of their freaking little Android devices using their location services. Okay? You don't need a map at all to know the relative locations. And in their software, here's Texaco gas station, here's the Museum of Science, here's freaking 210 freaking Martin Luther King Drive. That has nothing to do with anything. It's just being displayed as a globe.
Yeah, and it has to be really, really, really fucked up.
Okay, how do we determine what is inaccuracy? What would we do? How can we test its accuracy?
That's what I'm curious about. I'm guessing.
This would be a you problem, not a me problem.
Yeah.
You think that somehow
don't
this is going to be
interrupt
dispositive about
The first
how
step
we're
would
going to figure out whether the Earth is a globe. So tell us how we can use Google Earth to test and prove whether the Earth is a globe or not.
Dude,
I'll do
why
it.
are you interrupting me to then just ask the same question? Please stop it.
I want to be very specific
Here.
about what the question is.
Look at Google Earth. Say, here is something that would be a huge flaw. And sure, the gas station might be off by a meter or 2 meters or 10 meters. I'm not talking about that kind of flaw. I'm talking about a discontinuity. You will not have a continuous mapping. I'm talking about like something massive, like, oh shit, this map says that if I take a step over here, this will be something here, but it is actually like completely off, like on the other side of the.
Okay, now actually
I don't
be
want to say
specific.
globe.
Now actually be specific. Instead of these nonsense generalizations.
Specific? Okay,
Yeah,
so
a
you had this
specific
2D map
example.
that someone sent earlier in the chat. I'd forgotten the name. If I stand on the rightmost side of that map, I will see, oh shit, there's empty space on my right side, and there's water on the left side.
Are you being fucking retarded?
Please.
No. No.
Google
Shut the
Earth,
fuck up. Don't.
on Google
Now
Earth.
you're just taking the piss, bro.
Yep.
Bro, I don't understand.
The
why you
map
keep-
is a fucking goddamn rectangle on a piece of paper. Oh,
Yes,
oh my god, you
exactly.
could go off the map onto the table. Are you a fucking retard?
I really don't understand why you're using that
Because
kind
you're
of
talking
language.
about Google Earth. It's a fucking piece of software.
I think you need help. I think
And
you need help.
Yeah, no one cares what you think, dude. So you are talking. I asked how to test Google Earth to see if it matches, if we can prove the globe using Google Earth, and you started talking about fucking maps. Google Earth, dude, which is supposed to be a 3D ball that you can't step off of.
Okay, yeah. I don't understand what your problem.
There's a lot of shit you don't
honestly.
understand, obviously.
Okay, so your question is, how can we use Google Earth to determine that it is false? Right?
Yeah, there's a big error that you said must exist. How do we test for it?
You look at Google Earth.
You look at it,
and yeah, you
look at
Google
it.
Earth,
That's what it. That's what we're going to use as analytics. We're going to look at it.
Okay, dude, can you stop it, please?
No, what you remember I said about false premise? That's idiotic.
You look at Google Earth.
Is that how we do anything?
You look for something that is a jump in continuity. When you find that, you go.
What would that look like?
What would that?
What would that look like?
That is exactly what I said that earlier, and KGB. If you take a piece of paper and you try to wrap
No. Fuck your piece of paper. What would it look like on Google Earth? If I'm on Google Earth and I'm using it, and I go, hey, here's the discontinuity. What would that look like on Google Earth when I'm using the software? How do I know it's there by using the software?
Yeah, so this is the point.
Would I draw a
where-
line around one of the poles
Okay,
and then it
dude,
would turn
now
into a
you're
half
actually-
moon? Would that be it?
Yeah,
Would
so
that be a
this is
discontinuity?
this is okay, dude. You're just doing it for fun. This is the problem.
You're not listening.
Okay, dude.
You're
stop it.
stuck in your fucking gotcha. It failed. Get over it.
Dude, I can look at Google Earth and I can say I cannot find that problem.
The
Now,
argument
you
from
are
ignorance
assuming
is not an
that
actual
the Earth
argument.
is flat. That means
Okay.
that you should be able to
All
find
you're
that
doing is
massive
making an
problem.
argument from ignorance.
No, you're saying where's the
I
flaw in
can't
Google
find it,
Earth?
therefore it don't
I'm
exist.
saying there is no flaw, but you should be able.
How do you know
to
that?
find the
Have you
flaw.
looked?
You should be able to find the flaw.
I told you the flaw. Now you're just lying.
I'm not talking. Yeah, you showed me a guy who had driven a couple of miles. And
No.
then by a
The
meter.
flaw of drawing a line around one of the poles and it turning into a half moon. That's a flaw.
Dude, that is a fucking feature in their website. It's not a part of their. I
Okay,
don't
why
care
did
if
they
their feature is.
I don't want that feature.
So they have a line tool where you draw a path and it'll tell you the distance on the path. And when you draw that line tool and make a hexagon and try to make a hexagon around because you want to circumnavigate Antarctica.
You have a map
hold
and
on,
you have
don't
a
let me
tool,
finish.
And you say that the tool is fucked, so the map has to be fucked. You are
No,
just completely out
the
of the
tool
map, honestly.
is basing its distances on the coordinate reference system that the globe in Google Earth is using.
Dude, forget about the fucking tool. You have a tool and you say the tool is broken.
How does the tool? Where does the tool get its distances from?
The thing the tool is used on needs to be broken. The tool might be broken. I don't give a shit about the fucking tool. Do you understand
The
that?
tool's not broken. The map is broken.
Shut the fuck up about
the map is broken.
Yes.
You asked for a discontinuity. I just gave you one. And there's plenty of places you can zoom in on Google Earth where you'll see fucking lines.
We have where
you'll see lines where the textures don't align. There's plenty of them.
Fantastic. Give me a screenshot. Give me something.
The screenshot of the half moon? Is that what you want? Hold on.
What do you think?
I'm just waiting for your evidence that Google Earth is actually accurate.
No, but like this is my evidence is that you
your
don't
evidence
have
is a
any
claim.
Evidence.
Your evidence is
My
your claim.
evidence is that you don't have any evidence.
Your evidence
not
is that
real.
I can't fucking. That's a burden of proof reversal.
No, but it would be so easy for you if the Earth really was flat. It would be super easy for you to just say, Google Earth, here's a point where it's fucked up. It would be super easy for you.
I did. I want you to do it. I want you to fire up Google Earth and take the line tool, which measures distance on the surface of the Earth.
Again with the fucking tool. Stop.
Linear distance.
Tool.
You don't. Do you understand? Listen. How does the line tool measure distance in Google Earth?
I don't give a shit.
It uses the Haversine formula. Listen. It uses the Haversine formula, which is a calculation based upon the 2 points, right? The great circle route of latitude and longitude. That's right, great circle route. So if I draw a line and a line and a line and a line and a line, I should be able to get a full distance, right? Because it's a bunch of intersecting great circles. And I can get the arc segment at each one of those great circles and come up with a total distance. When you do this on Google Earth, if it was a fucking ball, you'd be able to do this and get a distance. But you can't, and it'll make a half moon because Google Earth's a fucking cylinder. So if you're trying to prove a cylinder, go right ahead.
Dude, I don't. The tool might be broken. I don't give a shit.
It's not the fucking tool. It's the map projection, you dumb fuck. Dude, you're dense, dude. You're fucking dense.
Why so much anger if you're correct? It sounds
Shut
really
up.
defensive.
Shut up, twat. Was that Athena again? Now our army of Simpsons are going to come in here. Why'd you talk to Athena like that? It's a fucking little game she plays. It's really simple. Google Earth is a cylinder. You asked for a flaw, a discontinuity. I gave you one at least 15 fucking times.
Okay.
If you're wondering why I'm screaming at you,
I'm sorry
it's
if I
because
missed something.
you won't
I'm so
acknowledge
sorry
the
if I
fact
missed
that
something.
what you asked
Where is
for,
the
I
discipline
provided.
cruelty?
What you asked for, I provided, and you can deny it all you want. Anybody in this chat, listen on YouTube,
Can you
Twitter,
show me a
X,
screenshot
can
or
fucking
something?
do it yourself, dude.
Okay, now you're
Do it
okay,
yourself. You can do it right there. You just appeal to Google Earth. Fire up fucking Google Earth and do it yourself.
I'm really convinced now.
I'm not trying to convince you. Where did you get that idea? I'm giving you information you didn't previously have. You, previous to this conversation, thought Google Earth was a ball when it's a fucking cylinder. So you just have information now that you didn't previously have. And you made a whole bunch of assumptions based upon your wrong assumption about how Google Earth works, et cetera, et cetera. But now you know you were all wrong. You made all that shit up in your head. And you don't want to cope with that. I'm sorry, dude. You filled in the blanks.
Send me something. Send me something that just something.
Do it yourself. I want you to do it yourself, dude, so you can't say I doctored it or I did something special. Go do it yourself.
You refuse to send me any evidence.
I want you to do it yourself. Are you on a cell phone? Or on a PC? Are you on a cell phone or a PC?
It's almost like he doesn't want to hear you.
He doesn't want to do it. He doesn't want to bust his own fucking bubble.
Literally.
I could look at Google Earth for ages and I wouldn't find any flaw.
That is bullshit, dude.
Then show me where it's bullshit. We're circling back to the
First of all,
same
that's
thing.
an argument from incredulity, okay, which I already pointed out is a logical fallacy. Your ignorance doesn't prove non-existence. Okay? This is the same problem of the black swan, white swan. All swans are white. As a theory, you don't look for white swans, you look for black swans, right? No matter how many black swans or white swans you find, it only takes one black swan to falsify the theory. Yes. And the reason you haven't found any flaws because you didn't try. Dude, I'm gonna listen. I'm gonna literally type in Google and I'm gonna type in mismatched textures on Google Earth, and I'm gonna get thousands of fucking. And I'm gonna get thousands of hits, thousands.
Well, I can point out an obvious flaw with Google Earth.
Yeah, it shows
it's not. Yeah, it shows it's a ball, and it's also a cylinder, a Mercator projection.
I've told him that 72 times already. It's not getting into his pea brain. So there we go. That took all of 15 seconds right there.
I think it's time you get some rest, Jench.
You know, yeah. Okay, I'm trying to.
Dude, just go.
Okay, there's another.
You're in Sweden, and it's 2 a.m. right now, right? 2:04.
Yeah. So the reason that those kind of deformities look like that is simply because you have a satellite picture, and the satellites keep circling around, and they're not updating all of the places at the same time. So some places will be sort of lagging behind, but there should be a way bigger flaw than that.
Shouldn't it be because it's a bunch of rectangles being pasted onto a sphere? Shouldn't that be the reason?
Yeah, I
You're
already
just
answered this.
full of shit, dude.
Jench, you got wrecked today, bro. It's okay. Lick your wounds, take a nap, come back.
Look, I didn't mean to yell at you, bro, but you're being dense. Like, you guys come in here with a gotcha, and you have no plan B. So you just dig in.
Gotcha.
You're digging to be.
Gotcha.
Dude.
Not anymore.
Globe busted.
Look, you're like, hey, man, Gauss's theorem of Grudgium says, hey, dude, you can't project a sphere without distortion onto a flat surface. Yeah, we know that.
Yes.
Yeah, you're not informing us. We know that. But that's not how it's being done. That is like a second order processing. Okay, it's a second order reduction. They're going celestial sphere, ground measurements, projected onto oblate ellipsoid. Then that referent oblate ellipsoid is then being projected onto a flat surface with rays, right? So they're going curved lines. They're going curved line mapping function filtered through the oblate. No, it's not, dude. You have perfect
you
sphere.
didn't even hear me finish. You didn't even hear me finish.
You said it's
if you
the
have
same.
Two
it's not the same.
Isomorphism, you can represent that as one isomorphism.
Oh my
it's pretty
God,
simple.
dude! You're not getting it. There's the celestial sphere, which is a perfect sphere. Then you have the oblate ellipse. You have the geoid, which is filtering the projection onto the reference ellipsoid, which is not a sphere, which is I don't even know what you call it, oblate spheroid, right? So then they're taking that and they're making a projection from that. It's a series of steps. It's not globe to projection. You understand?
Do you realize that a series of steps can be represented as one step? Isomorphisms that go into each other when you map F to G to H can be represented as one isomorphism from F to H.
Dude, no. Listen.
Yes,
the
that's
geoid.
not
The geoid. Look. Your normals are changing because
dude,
the geoid is an hold on, dude. Let me finish. The normals of the surface are changing because the geoid is an undulating surface. It's not continuous.
I feel like you said
is an undulating surface a continuous curve?
Mechanics.
It is an undulating surface a continuous curve. That's why I said lumpy gravity. It's an undulating surface. And I'm not talking about the topography. I'm talking about the direction of the normal. So doesn't the direction of the normal determine whether the surface is continuous or not?
The direction of the normal? No, not at all.
Oh, so you can have converging normals and then the fucking it's converging and then diverging normals
in
two different two adjacent segments, and then it's still continuous.
Actually mathematically terms, but sometimes you're just completely off. I really want to know, have you taken
so now you're talking about me instead of actually refuting what I said. That's crazy.
He wants to know if you're taking classes now, India. Now we're down to who's taking what kind of classes.
Dude,
you really want to get into classes? Dude, you really want to talk about classes?
Yeah, can you tell me about the coastline problem?
Yeah, the coastline problem. What do you want to know about it?
Does that apply? Does the coastline problem apply to undulating surfaces?
I don't know what an undulating surface is.
Meaning it's like a coastline. It's going back and forth.
Well, actually, it's impossible because we have in quantum mechanics we have something that's called h, little h.
Shut up, dude. Just shut up. Go to bed.
Oh, got little h, so that means now Earth is a globe. Dude, you are tired.
He just really wants to talk about quantum mechanics, I think. He don't even want to talk about this topic.
Yeah, well, good luck, because he's not going to be able to get away with it.
Dude, he was saying,
and the other one is...
He was like that chick one day at band camp, after fucking every goddamn line. So I'm going to unmute Kasari here. Yeah, because he wants to step up to Mark. Bro, go to bed. We're not talking about quantum mechanics. We're done with that shit. Go find out. An undulating surface is a surface that goes back and forth. The geoid, which is supposed to see the equipotential surface of gravity, that filters all the rays and curves them after the fact. So the coordinate system ends up being displaced in all sorts of different directions, but you can actually measure the difference between an undulating surface because the distance increases depending as the unit of measure gets smaller, which you should know. So it isn't working the way you think it's working. It's what I said way back when, almost fucking 45 minutes ago. You come in here with your mind thinking the globe Earth works like X, but that's not how it works. That's why if you look up the first books printed on geodesy, there's 1,600 fucking pages of mathematics. So anybody want to talk to Kajir here? Who had a bunch of social commentary?
You mean KGB?
Oh, yeah. Is that his name?
Yeah, KGB. Kagebe. That's his name, Kagebe.
Russian Bear, KGB. He's being a douche.
Hold on, where's these mathematicians that you were talking about, Sheepdog?
Yeah, where
they
are
were
they?
supposed to show up tonight.
Live streaming and all.
I know.
That's the only reason I even came in here.
I'm
that's
so
false
sorry,
advertising, man. I want my money back.
Hey, that was on, what was his name? Hold on, who was it? That's on T-Dub.
This dude had me crashing out, man. Fucking Europeans, man. They fucking drive me crazy.
Dude, he was doing it to me. I spoke to him for hours before you, and yeah, he started off with the same thing. Crazy.
What am I getting blamed for?
Yeah, it's like he won't take yes for an answer. It's like, what the fuck, bro?
Yeah, he started off by asking what would happen if you kept walking in a straight line. I said, no one's ever done that. All right, I said you'd hit the ocean. He's like, kept saying, oh, you're just avoiding my question. You're just avoiding my question. And then I answered his question, and I gave him the answer, and he just kept saying you're avoiding my question. And
glad it was
one thing.
me.
Yeah,
well, he was like,
felt bad.
He was doing it for everything. He was doing the same thing.
He was like, well, hypothetically, what would happen if you walked in a straight line? It's like, I have no idea, man.
Yeah.
You can walk on water, bro.
But he conceded to the John D observation measurement.
Oh, yeah, he did. Well, what
But he questions John D, didn't he? Or did I leave?
Then he questioned the credibility of the person and their ability to make measurements.
Yeah, he was saying that he has, pictures. NASA has pictures, right? So he can counter that by looking at the NASA pictures. And then I explained to him that we can't go and validate the NASA pictures, but you can go and validate the long distance observations. And yeah, he conceded. He did concede to that, but he quickly took it to a different place, right? And didn't want to talk about observations anymore.
T-Dub, where's the mathematicians, T-Dub?
Oh, they told me 5 hours, and that was probably
6 hours ago.
3 hours ago. Was it? No, it wasn't that long. Was
it? 2 o'clock on my time. It's 8 o'clock now.
Hang on, I've got the.
What do you want to talk to?
Screenshot.
Yeah, unmute him. Let's see what he's got.
Mathematician. He's just a troll, but I'll fuck with him for a minute. So KGB, you're unmuted.
What's going on, boys?
I'm sorry. Were you expecting?
Yeah, you said mathematician.
Yeah, KGB. You claimed what you said about me. Yeah, I claim the sun floats above the earth and moves. Listen, I go outside, the sun is above me, and it moves. It's my claim. Yeah, I see it above me, and it moves. Debunk me.
Fair enough. I guess you can't see bacteria and viruses. Do they exist?
I don't know. We're not talking about that.
What does that got to do with the sun?
Okay. There's no
What
reason.
does seeing something have to do with not seeing something? How do you make that connection? Are you mentally ill?
Well, if you base all your observations on observations alone with just your eyes, then therefore, bacteria and viruses shouldn't exist.
What should we base them on?
Do you believe in the bacteria theory?
Hold on. I want to get to the bottom of this. What should we base them on then? If we're not basing it upon observation, what should we use?
Here's a suggestion. Maybe, I don't know, for the last 500 years of all science and
so sociology
revolves. I'm just still talking.
Sociology is what we should use. We should run around and. So we should use sociology. That's what we should use to determine truth. We'll just run around and ask everybody.
Let my guy speak.
Hey,
Whoever the round-up guy is.
Maybe if you let me finish what I was going to say.
Well, because your answers are canned and they're really easy to figure out.
Let him speak. Let him cook.
Sociology.
500 years of evidential empirical evidence proving that the world is actually a spheroid, obloid, actually.
Okay. You just You just said observation is not to be used. What are you talking about? That's what empirical evidence is.
That's not what I said.
You said you think you just relying on observation. What do you? And then you said we shouldn't be doing that.
You
And I
weren't
said, what
listening.
should we use? And then you said thousands of years of observation. That's empirical evidence, which is observation.
Okay, maybe you have an issue with
The
hearing
Earth is
or
fucking
something.
flat
No, I don't have an
anyway.
issue with hearing. You have an issue with double speaking.
Here, I'll be specific. I said that you can't just base your claims on observation using your eyes alone, because if that were true, here I'll explain. Because if that were true, and if you just based all your observations on just your eyes, then therefore things like bacteria and viruses wouldn't exist in your worldview, correct?
No.
They're harmless.
How
You
so?
can see bacteria under a microscope.
They're harmless because
I tell people that all the time. You can see
Wonderful.
bacteria under a microscope. What are you talking about?
Yes.
Wonderful.
That's how they knew it was
What
there.
do they do astronomy with?
Okay. All right. Awesome. So
those
you used
pictures
a
from
tool.
space, those pictures you think were from space, what are you using to look at those globes? Your eyes?
So you use the tool microscope to see, to prove that the bacteria and viruses exist, right? Awesome. So
I can see
what's the
Saturn
problem
and
with all these
Jupiter
people
without a
using telescopes to prove the celestial objects, and the fact that the moon is not just a circle in the sky and it's actually a sphere? So if the moon
How
is a
did they
sphere,
prove
why
that?
isn't Earth a sphere?
Hold on. How did a telescope prove the Earth is a sphere? Can you tell us how?
Is the moon a
Or
sphere? Or not?
the moon is a sphere.
No, answer my
How did
question.
it tell
How
us
did
that
the
the moon is
telescope
a
prove
sphere?
the moon was a sphere?
When you observe the moon, it's a sphere, right?
When you observe the
No.
moon, it's a sphere. Did they use their eyes?
When you use a telescope,
It's
and
always
observe
the
through the
same
telescope
thing when
and
I
look
look at
the
it.
moon, it is a sphere, is it not?
How do you know that? How do you know you just don't have
Is it not
pareidolia?
a sphere? Yes or no?
No.
You can't tell.
Yes, you can. You can see the shadow around the moon. You can see the surface of the moon. You can
Yeah,
see
that's an inference, though. That's not seeing it as a sphere.
You can obviously see that the object is a spheroid.
No, it's not obvious. You're just saying it's obvious.
All right, then. Okay, fine. It's a circle.
Here's some things that are not obvious. Here's the things that are not obvious about why it's not a sphere, right? It's evenly lit. Does not have a speck or reflection. You always see the same side of it, so it's not rotating. So there's some things that indicate it's not a sphere. So what about those?
Okay, well, it's certainly not flat, is it?
Okay, so no, it could be.
It could be?
Well, you see the same side all the time, right?
All right, so if it could be, then why do eclipses happen?
Why are you asking me a fucking question?
Because it doesn't follow what you're saying.
No, you said, hey, here's some examples of why we think it's a sphere. I gave you counter examples, and you ignore them.
But there are eclipses.
Here's the counter. So what? And
so eclipse absolutely proves that it's a spheroid.
How?
What do you mean how? The way the moon moves, when the moon aligns with
Actually,
the sun, you can
I
obviously
don't
see
have
that
the
parts of
video
the
on it
moon
right
get
now,
shadowed
but
out.
the reason eclipses happen actually prove that the Earth is flat.
Yes, an eclipse. Yes,
a solar eclipse.
I said an eclipse.
Did you see the moon during the solar eclipse? So
yes,
a solar eclipse. I'm just trying to make sure you're talking about solar eclipse.
Yeah,
why are you talking to me all the time? Okay, so really simple. You fuck yourself up because you can't see the moon during a solar eclipse.
Dummy. Yes, you can. You can see the
you can see the black spot
there. Never seen the moon during a solar eclipse ever in the history of man.
Oh, you failed,
what causes the
KGB.
eclipse then?
Who cares?
Have you ever like
But
stared
no
at the sun for a little bit? Sun gazing.
That's not good enough.
Look, you said that you can tell the moon is a sphere because of a solar eclipse. Well, no one's ever seen the moon during a solar eclipse. You can't see the moon because solar eclipses only happen during a new moon.
Sorry, lunar eclipse to be specific.
Oh, that's why. Oh, now it's lunar eclipse. So how do you tell the moon?
The
lunar eclipse falsifies the moon being a sphere.
We're talking about the moon. We're talking about the moon, right?
Yeah. So the lunar eclipse falsifies. Yeah, that's great. Lunar eclipse falsifies the moon being a sphere.
I have something on solar eclipses.
No, it actually
being
falsifies it
proven
the moon
on
was a curved
a
surface,
flat Earth
and the Earth was a fucking sphere,
rather than the round Earth.
Right? It's a circle onto a flat surface, not a curved surface. Because curved surfaces, it would distort with the curve the same way that like the railing of next to stairs when the sun casts its shadow, that shadow looks zigzagged, right? Because it conforms to the surface. So if the shadow of the Earth being a circle conformed to the surface of the moon, which would be curved, it wouldn't form a circle. It would form some other shape.
Does the light and the shadow, or the shadow gradient around the moon?
Notice how you're not actually addressing what's being said to you?
Well, I'm
Let him
addressing.
fucking
You're
speak.
completely denying that the moon is a sphere, so therefore I have to provide.
No,
to counter that.
we're going over the evidence. That's what we're doing.
Yeah, the evidence, right? And the evidence proves otherwise, that the moon is a sphere.
Proves.
Because the
Then
shadow
how
and
do
sun.
you explain? Then how do you explain the things I said that are not sphere-like?
What are you?
No specular reflection like all spheres have, and they're.
I'm not even like a round earther, but why are you getting so mad over this guy? Why are you getting angry?
Correct. You can see the lighting and the shadowing on one side of the moon and the other side of the moon.
Do you always see the same face of the moon, dude?
And you can obviously tell that it's a.
Do you always see the same face of the moon?
Based off of how the light works around the.
No, that is an inference based upon how the light works. You're confusing the description with the explanation as usual.
Always the same face, I tell you that.
Okay.